Do you have
What do you want me to post?
yeah? So when you saw the curve, can you post that?
Well, he thinks that um, so he's just imagining that there's curvature because he's looking at a flat horizon, right? And he's just imagining that it's curving, and that on the other side of that horizon is water down lower. That's just imagination. He's not actually seeing any curvature, and he's imagining that there's curvature and there's a byproduct of the curvature being a geometric horizon. And then we would challenge you to say, do you have any evidence that there's such a thing as a geometric horizon? This is where you'll start to run into
Yes.
problems. Okay, what's the evidence
I
of the
don't run
geometric?
into a problem.
Okay, go ahead.
I mean, I just said yes. I don't run into a problem with that. I mean, I
Okay,
can go
so
high, I can go low. I can on any plane, I can elevate myself, and I can see farther over the curve than I would if I was low. There's, I mean, multiple things I can do. I don't have to imagine it. I can actually observe it with my own eyes.
right, so the same thing would happen on a flat surface as well. So do you have any evidence of an actual geometric horizon existing?
Yes.
Okay, what is it?
Post it.
What do you want? You want me to? What is it that you want to see?
Your validation that a geometric horizon exists as a byproduct of the curvature of the Earth. This is a you problem. You think that the horizon is a geometric byproduct of curvature, and I was just wondering if you have any evidence of that, rather than just inferring it.
Is it? Should I give you evidence like how you guys give evidence, like videos on YouTube, or like what would
Well,
be
we're
evidence?
testing. We're just testing. Okay, so you're the one making the specific claim. Okay, we just test your claim, and we can't find the curvature. We can't find the geometric horizon. So you're saying it exists, right? We can't find it. Okay, so cancel that out. Now, where did you find it? Who found it?
Okay, I'll try again.
Even the mainstream,
you're
right?
asking for proof.
Yeah. No, I'll restate the question. Right. So if the Earth's a globe, right, there should be a certain amount of curvature over the surface of water because of gravity and the size of the globe. Okay, and there should be a physical geometric horizon, and that should be a cutoff point. You shouldn't physically see any water past that geometric horizon. I mean, everything beyond the geometric horizon, right, that's lower than it, would be hidden behind it physically. Okay, but when we go and check it, we don't find any evidence that that's the case. We find that the horizon is just an apparent line in which the sky and the ground meets, which shifts all over the place due to all sorts of different weather conditions that can take place. And it's a byproduct of altitude, perspective, and conditions in the air, like the atmo. We can prove all of those things to be true.
Okay.
Yeah, all of those things are, that's exactly as it's defined. That's exactly what we all experience in the real world. But what you're claiming is that really it's a byproduct of Earth curvature. But I don't think that you have any evidence of that to be true.
What type of evidence would you like me to produce? Would you like, as if I just produce like the math, that's not going to be super compelling, right? If I just produce like if I draw something by hand, that's not proof. I show research papers. Does that work? I mean, what works?
No.
What
okay. Empirical. It's got to be so an actual physical validation of it, right? So this is a U problem. So obviously we're testing the math, right? So when we go out and do our tests, you guys are the ones presenting the math, and then we go out and test that math to see if the math matches reality, and it doesn't ever. Right, so you're saying that the math does match reality. So showing me the math that we already know, that's not going to help, right? Numbers on paper is not going to help either, right? You would have to actually validate that such a thing exists as curvature over the surface of water. And like I said before, this is where you're going to run into problems, because now you're throwing out like, you want to show me math, You want to show me a research paper or something like that. Show me something that's actually empirical.
DJ, you're probably one of the more honest people that I've interacted with the way that you interact. Did I say that I'm going to show you math? I said, what do you want? If I show you math, is that going to work? That's not going to work. If I showed you a research paper, is that going to work? That's not going to work. So let's be honest with each other.
If there's empirical evidence in the research paper, yeah, that'll work. Math doesn't mean anything until you have measurements to put into those variables.
Yeah, so we all agree math is not going to work.
Well, math alone doesn't do anything. It has no correlation to the natural world.
And this is why I'm not a flat earther. Math doesn't work? Are we serious?
No, it doesn't work to prove things about the natural world. Science is empirical. It's not based upon concepts, ideas, metaphysics, or anything like that. Math is an abstraction, a transcendental category. Science is empirical. So if you have a bunch of math, you have a model, you have predictions, how do you know whether that's correct? You go into the natural world, you do your measurements, you do your experiment, and you see if the natural world matches your prediction. And if it doesn't, then your prediction's wrong. Your theory's wrong. Your hypothesis is wrong. We can calculate anything. We can calculate the number of angels that are put on the head of a pin. So what? The only way to prove whether that's true or not is you need to calculate the angels. You need to count the angels.
Math doesn't work. Okay.
You can calculate anything you want.
You can calculate the number of angels on the head on a pin. I mean, I don't think I'm not going to take that literal.
That comes from Newton, by the way.
What's that?
That came from Newton, by the way. Newton coined that. The calculations in themselves don't really mean anything. Not in a scientific sense.
India isn't like that. What we like, the whole thing about the Earth curvature is like based on the radius. The Earth curvature should be 8 inches for every mile squared. That's the math. That should work. That works. When we go out there, it doesn't work because it doesn't what we measure. That's the example we're using. That's the example where you're saying though. That's why math itself doesn't work because you have to go measure it.
Yeah, exactly. Okay.
Yeah.
You're testing it. You have to test it in the natural world.
The math doesn't work because you have to go measure it, and
you can't make a scientific claim. Are you being intentionally obtuse?
No, I'm trying to understand. To me, this seems foreign.
Is math reality?
I'm trying to understand.
You think math is reality?
Math is a way of measuring realities.
Measurement's a way of measuring reality. Measurements are made with instruments. They're not measured with math.
What happens if you try to do math but you have bad data?
If you do math and you have bad data, then you get bad results.
Okay, so it's that's the point he's kind of making.
Well, he's telling me that measurements are not made using math.
Well, all you need to know is if you have bad data and you do math with that bad data, you're not going to get real real world results, right? It's not going to
straw man what I said, dude.
Okay, say it again. I don't have to straw man what you're
saying. What I just said is what he's explaining. Does that make sense to you? What I just said?
What you're saying makes sense to me, but then he's saying I'm straw manning it.
Okay, but
hey, Flatlander. Hey, Flatlander, hold on. Let Indio handle this.
Sorry.
Yeah. So, I didn't say you don't use math. If you quantify something, do a measurement, of course you're using math. You're summing values. So yes, you're counting. Or you're using geometry. But the math in and of itself outside of the real world doesn't mean anything.
It doesn't have any predictive qualities.
Predicting what?
So your claim is it does not have predictive qualities.
Predicting what?
Anything. I mean,
something in the natural world?
Sure, yeah.
Yeah, dude. But the arbiter is the natural world, not the math. Here's another thing Newton said. If it can't be settled by experiment, it's not worthy of debate. And what we're telling you is the math, the predictions that they make of what the globe is supposed to be and how it's supposed to exist. 8 inches per mile squared was just laid out. That doesn't exist in reality. And you go try to go measure this, that geometry in reality, it doesn't exist. See, I know it's inconceivable to you that all the things
I'm
they say
completely
about the
conceiving.
globe.
I'm completely conceiving my reality.
Well, there's only one reality, but I know it's inconceivable to you that the
I
globe
didn't say.
predictions
Did I say it
are
was
incorrect.
inconceivable, or do I have any?
No, dude, will you let me finish
You're
the
putting words
sentence?
in my mouth. I'm trying
Will
not
you
to
let me
put
finish
words
the
in your mouth.
sentence? You're jumping
Go
to
ahead.
conclusions.
Okay, go
I
ahead.
know it's inconceivable to you that the predictions of the globe, the mathematics, don't match the physical world, but they don't.
Every time I run, every time I check, they do.
Oh, give me an example. What did you check last?
Last things we were checking was last night we were doing quite a few of the different videos of we were trying to use ones that were impartial, like ones that weren't coming from somebody saying this disproves the flat Earth or proves the flat Earth. We were trying to find videos or images that were not coming from the angle, that were mainly, let's just say, just like a photographer who had put a lot of data into it, or someone who had taken videos. We were doing several of those.
Okay, that's very non-specific.
Oh, do you want to get specific? Would
You
you
said
rather
every
that
one, so I want yes. It's the specific one.
Okay. Well, then I'm going to put myself on mute. That doesn't mean I'm coping. That doesn't mean that I'm having some issue.
Yeah.
I'm going to go grab that information and bring it back. Okay.
Okay.
Is that
In the
fair?
Did it last
meantime,
night?
good.
Is that fair?
Yeah, I'm not in a hurry.
Okay.
In the meantime, I want one of these globies, flatties, playing how does PS work if the Earth is flat. Start now.
Like, how does PS work, you said?
How does GPS work on a flat Earth?
GPS, sorry.
From one of you flatties.
How does the same? What do you mean? How does it work? You have a receiver.
Like,
The receiver gets a bunch of time of flight from beacons, passive beacons. You know GPS is passive, right? It's not two-way communication.
GPS is passive.
Passive, yes, it's a passive. Your receiver just picks up a signal. Doesn't talk to a satellite.
Right, from a satellite.
It can be anywhere.
But the satellite is in space, right?
No.
Where is it?
Could be anywhere. Doesn't matter where it is. Could be on top of a tower. Could be down the street. Could be in your house on your roof. You know GPS can be spoofed, right?
Yeah.
Okay, so are they putting a satellite up to spoof it?
They're using the existing satellite.
No.
Yeah. They hack it.
No, they're not hacking the fucking GPS satellite. No, all they're doing is sending out a GPS signal that the receiver picks up, and it sees the transmission. All it does is pick up what's called a Rhinex message. It picks it up, and it just gets the time of flight. How far away is that? And you can spoof all that information. Doesn't work the way you think it does. This is another example. This is a good example of what I just brought up. The way it's inconceivable to you guys that the shit doesn't work the way you think it works. But the thing is, nobody told you that it works the way you think it works. GPS uses something called trilateration. Okay, so it measures the time of flight that the radio signal took to get there. And if you have a couple of them, you'll have or a few of them, you'll have overlapping circles that'll pinpoint your location. You're not talking to a satellite, you're just picking up a signal. Now, there's things called differential GPS, which are admitted to exist, that are admittedly ground-based. They're not in space. Your receiver can't tell where the signal comes from. It just knows the distance. Now, here's where it gets even weirder. It doesn't use a globe to even predict where that location is in the first place. They use a coordinate system called Earth-centered, Earth-fixed, and where it places you is on a tangent plane. Doesn't even use a globe at all. Now, you see it on your phone as latitude and longitude, but that is a coordinate transformation they do after the fact. That's not how the receiver as electronics see it. That's how you see it.
I see. So if the Earth is flat, how come you can see a boat go over the horizon and it disappears?
I've never seen that.
You've never seen that?
No, I've never seen that. Not in real life.
If this goes over the horizon, so you're standing at the edge of the beach, you're having a great old time, watching the little boatie sail away. It sails and it's out of your view. That means we shouldn't be able to grab any binoculars or any high-powered cameras and zoom it back in because it's gone. Obstruction.
The curve went
so
over
you're
the
saying
curve.
Yes, that is true. It's gone over the curve, therefore cannot be zoomed back in.
Yeah. There's no way you can zoom over that if it's
Excellent
around the curve.
Absolutely.
Absolutely.
That's all I wanted to know, brother. Now, what I want you to do, check in the side chat at 15 minutes past the hour. I've just posted up a video called The Empty Horizon. Can you please watch the first 20 seconds of that video?
Let's see. I'm playing it right now. CGI already. You can tell.
What?
Let's see. 20 seconds. There's the horizon.
Just watch the first 20 seconds. Don't jump to 20 seconds.
Yep. I'm watching. Mirror line.
So right at the start of the video, you saw no ships. So they are already beyond the horizon, as you claimed. Then they zoomed in, as you claimed would not happen. So, would you like to retract your statement?
Well, at the beginning of the video, I said it was CGI, and it looks CGI. So
you're a clown,
brother.
AI is pretty good nowadays.
Well, have you ever seen this with your own eyes?
See, my own eyes can't zoom in that far, so.
Have you ever seen ships go over the horizon with your own eyes, dude?
No.
Okay, then why do you think that this is what's seen?
Well, because, I mean, I've seen videos of it.
Oh.
A lot of videos of it.
You never seen any videos where it don't happen?
CGI or AI.
Like the one you just saw?
Like this one. Look at
CGI.
the AI.
So I did this test myself. Watched the ship go 30 miles away, and it never disappeared over the horizon. So, what now?
Well, that's your
So the problem with the horizon you're going to have is that the horizon's not the edge of the ball, dude. You know how we know that?
How do we know that?
Because the horizon moves around. You can stand there on the beach, staring at the horizon. If you watch it for 4, 5, 6 hours, you'll watch the horizon go further away and then come closer, further away and closer. You'll see it move up and down. You'll see it go all sorts
That's
of
because
places.
the Earth is spinning at all times.
So the horizon moves because the Earth is spinning.
Exactly. Why would the horizon not move if the Earth was?
Well, it doesn't.
spinning?
Okay, so it's
See?
not the edge of a ball.
It's not the edge of a ball, of course.
Well,
it's
I
the
mean,
edge
if the
of a ball.
horizon's moving, then what's the ship disappearing over?
The curve.
Well, how
So
can it
the
be the curve if
horizon,
it's
wait for
moving?
me.
How is the curve moving?
Well, let's take a step back.
No,
If I have a tennis
no, we're
ball,
right on point.
no.
How is the curve moving?
If I have a tennis ball and I'm moving it, it's not every part of the tennis ball going to be moving.
Yeah, but you're on the tennis ball, dude.
Exactly. It's moving though, so I'm moving.
Yeah, that's fantastic. But we want to know why the horizon's moving, even though you're standing still.
Well, let me move this goalpost. When I look in the sky, everything is round, so therefore the ground is round.
Yeah, that's a non sequitur. Doesn't logically follow from the premise.
Damn
I
it.
see trees, therefore I am a tree. It's as stupid as that.
Well, we are trees, kinda.
Okay, you just go on mute, dude. You're bricked.
MC, were you role playing as a fake Glober again? Is that what you're doing?
No, he's been normal now.
If that was an actual Glover, not the real one, I can't tell.
He's too good at playing the character.
Yeah, no, he was just laughing as a global.
Oh, I was about to say, I'm like, damn, that's pretty good, dude.
I don't know about that.
I'm like, dude, he was doing way better than me then.
Those responses were too natural.
Among Us.
Yo, can you be imagine LARPing so good you got muted?
I posted at 17 minutes past the hour. I'll be right back.
What did he post? Oh, did AI say that?
That video's an inferior mirage, dude. What are you doing?
Oh, did he show the Super Zoom video again, did he?
Hey,
Why would
Tenori,
you show an
stop.
inferior mirage?
So you think the refraction is over 0.5?
It's an inferior mirage.
That would be refraction over 0.5, right?
No, inferior mirage aren't necessarily created by refraction, dude.
Oh, it's not. Okay.
Something called total internal reflection. It's a reflection, right? It's a double image.
Why would it need to be a mirage or a reflection?
Why are we looking at the mirage to see if it matches the globe? You said that you were going to find something where the math matches the globe, and you showed an inferior mirage.
Okay. So at 14 kilometers, there's no way you could see it without it being an inferior mirage?
Shane, let's break it down to its basics. You need a discrete horizon line and some kind of demarcation to identify where the horizon is in relationship to that demarcation. For example, if I was to plonk a witch's hat at 10 miles, we could see the witch's hat, we could see the horizon after the witch's hat, and we could say we definitely know the horizon is beyond 10 miles. Is that nice and easy to follow?
So you want me to draw a line on the video? Like what is it you want to see?
Well, at the moment, what you've got is the water line, and then it breaks into TIR, and then a mirage. You don't know where the horizon is in your demonstration. So you claiming the horizon is somewhere particular is null and void because there isn't really one there. It's a blurred mass of nothingness.
if you have an inferior mirage and you can see, if you know that boat's 14 miles out on a globe and you know the observer height and it's not too high, that's a big, big problem for the globe, even though there's a mirage there.
That's a big problem for the globe.
Yeah, well, okay. So according to the mainstream definitions of what causes an inferior mirage, it's when light bends upward.
I don't see an inferior mirage. I look at the shapes of the top of it.
It's a textbook
what
definition.
Shape would things
inferior
be
mirage.
inferior mirage?
It's a textbook definition inferior mirage. It's a mirrored image. You can see it. It's a full blown inferior mirage. The whole bottom portion of that ship is just a mirror of the top portion. Mirrored image. You can look at it. It's a mirror.
So the bottom of that ship has stacks, and has that the radio tower, and has that winch and crane system. That's on the bottom of the ship.
17 minutes past the hour. AI has got a video cut there. It's probably the one that I posted for you last night. It's got a small image of what this ship actually looks like. There is no stacks at the bottom of the ship.
No, that's why I'm asking you, how is it an inferior mirage?
Because it's a reflection of the top to the bottom.
So you see that as upside down?
We see that as a reflection.
So you see it as upside down?
We see it as a reflection.
It's a double image with the bottoms touching. That's why they call it inferior mirage. If the tops were touching with a double image, that would be a superior mirage. And I just posted drawing a line right through it. So between the red line and the water, what's in there? Is that boat? If there was a rowboat out there, would you see it? Would you not see it?
I can't make an inference based on something I can't see. It's not in the image.
You did before. You assumed it was curved based on what you can't see. So why can't you do it now?
Because that's what I see.
So you could see curvature through that blurry mess where the red line is, but now you can't tell us where the horizon is or what's in that blurry mess.
No, you asked me. No, again, that's a big leap from what you said.
No, it's not. That's exactly what you're doing. Stage 1, I see curvature. Stage 2, I can't define the horizon. There is no difference of the picture. It is still identical. It's you that's changed, not me.
I did not change. You asked me about a rowboat, and I said I can't make a comment about something I can't see. And then you made some big leap to some other thing that I was saying that was not what I was saying.
Where's the horizon?
See a rowboat.
Where's the horizon?
I mean, let's use your red line. Let's use whatever line you want.
No. Where is the horizon in that image?
Do you not see it?
No, I don't.
You told me
there's
there was
a big
mirage,
blurry mess.
Taking the mirage. So let's say we'll take the mirage line. Sure, or we could take the line.
So you're going to accept the mirage line as the horizon?
I'll take either one because either one of them still.
Either one. What's the second option? Are you taking the red line as the horizon? Yes or no?
I am not going to answer your question yes or no because that's not the answer. Neither one, yes or no.
Okay then. So what you're saying now is you can't define what the horizon is, thus you don't have your balls hard. If you can't tell us what the horizon is in order to measure to it, you don't have anything.
Yeah, we're supposed to be confirming the math, man, for Deco.
Look up at my math right above that. Also at the 917.
Yeah, but which horizon are you using? The red one or the water?
Use either one. It's not going to make a big impact on what you actually see.
Well, it does for the measurement. That would be
the horizon
20 meters.
Like if when you hear horizon, do you think that means cliff? Do you think that means it just suddenly drops off? The horizon is like a how thick is a horizon from your view? Is it 1 millimeter? Is it 10 feet? Is it how thick is a horizon?
What are you talking about? The horizon is where the Earth appears to meet the sky. It doesn't have a thickness.
We can very easily recreate this same effect with this ship on a flat surface.
Okay.
Easily.
Can you show me the math for that? Oh, I'm sorry, math doesn't matter, right?
No, I can
to you it
Who
does.
cares if what do we need math for? We can recreate it on a flat surface.
Yeah, you want to see it on a flat surface?
Yeah, let's do it.
He's lowering the camera.
And your math is a joke. It's like, how do you know how much is hidden if you don't know where you're measuring from?
How do I know how much is hidden if I don't know what I'm measuring from?
Yeah, the red line or the frickin' or the water. Because the same amount isn't above the red line and above the water at the same time, right? Those are two different values.
So that what you see below the red line is the same amount that is above?
What are you talking about?
I repeated your statement and confusion, trying to understand.
No, it's not the same amount. Okay? Now, if the ship is hidden by the globe, the amount that would be hidden by the globe above the red line would be a lesser amount that would be hidden above the water. Right? They'd be two different values. One, it would be, say, 5 meters, and the other one would be 10 meters. How do you know what you can see if you don't even know where you're measuring up from?
How do I know what I would see if I don't know what I'm measuring up from?
Like, listen, stop that shit.
Ahead.
Okay? I know the gimmick where people repeat your questions to give themselves time to think. Okay? Just stop
I needed
it.
time
That's
to
like
think.
the 5th time
Okay?
you've done it.
Sorry, I won't think. My bad. My problem, I guess.
No, you're trying to come up with a bullshit excuse. This is horse shit and it insults my intelligence. That's why I'm getting aggravated. Okay. You said it matches the globe. Which one? The red line or the fucking water?
I mean, I would use the water. The red line is part of I.
But which one matches the globe? You quantified it.
Okay. I believe I've answered that question.
You quantified it. That means the number matches either the amount of ship above the red line or it matches the amount of ship above the water. Those are two different numerical values. It can't be both. Which one does it match?
I have the data right there. Zodiac also reposted.
There's no data.
There's no data? Okay.
Yeah, equations aren't data. Data is collected with instruments. It says visible, 10 meters. Is that 10 meters above the red line or the water?
That would be above the horizon, which is the water.
Okay, so there's 10 meters visible. Well, okay. So between the red line and the water, what's in there?
Right now you're seeing a mirage. You're seeing the...
But what's in there? There's something there behind it, right?
And I answer your question, and then you just repeat back to me the same question.
Well, I'm trying to nail you down. I didn't repeat back the same question.
Answer the question.
So there's something behind, right, that you can't see because of the mirage, right, because of the air. Is stopping the light from getting to the camera. That's why I asked you about a rowboat. There's a rowboat between the camera in the bottom of that boat, would you see the rowboat?
Again, I would not know. I don't see a rowboat in there in order to be
Okay,
able to make
but
any
there,
inferences on that.
but you know that that's not the ship between the red line and the water, right? Is the ship upside down?
No, I don't. I wasn't making that claim.
Okay, so it's not upside down. That means these features that we see are not the ship.
Which the ones between the red and the
between the red line and the top of the water. Between the red line and the water.
Okay.
That's not ship.
Okay. Cool. I mean, well.
Then what's there?
You're not looking at the same image I'm looking at. You can't see what's there. What are you asking me to tell you? I don't understand.
What's there in reality, dude? If you go poof and the mirage disappeared, what will we see? Would we see the bottom of the boat?
No, not enough distance. Not enough space between those two.
So that's cap, because if you look at the back, that's the top of the boat. That's the top of the aft part of the boat.
Yeah, on the right.
Yeah, that means you underneath that red line is boat. Is the hull of the boat.
Well, you're asking. Okay, sure. Yeah.
Yeah, so it's not hidden by the horizon.
Line, yes, there would be the hull of the boat.
Yeah, that's right. It's not hidden by the horizon. It's hidden by an inferior mirage. Why would you pick out of all the stuff that's on the internet an inferior mirage?
Give me something else. I'll do the same thing with it.
Black Swan.
I mean, Master Yoda posted one.
Oh, where's that one at?
It's up slightly. 10.10 miles.
The platform habitat?
Yeah.
Do we know what the elevation was for the observer?
8 feet. Furthest rig is 10 miles. The horizon should be 3.46 miles away. So how can the horizon be behind the last rig?
What height are we using for the platform habitat? Are we using the?
Doesn't matter. We're talking about the horizon.
The horizon it doesn't matter.
Zero.
No, it doesn't matter.
Zero.
It doesn't matter
Zero.
because the thing that's supposed to be blocking it is behind it.
The thing that's
So
supposed
it's
to be
zero.
blocking it.
That's the number you're after, Shane, is zero. This is why you were coming unstuck. You're assuming some elevation thing. It's nothing to do with it. The oil rigs are demarcation. If we could remove them and leave the traffic cone there, it would be so much better.
So we know the furthest rig is 10 miles away. We know the goal predicts the horizon should be 3.46 miles away. So how's the horizon behind the rig? Should be in front. This is about the horizon distance. It's not about whether the rig is blocked or not. You know it's not blocked because you can't be blocked by the horizon if it's behind you, obviously. Now, you were looking for that video. The horizon is not the physical edge of a ball that blocks things. And we know this because it moves around.
What video am I looking for?
No, the video you looked for earlier.
Yeah.
When you were looking for that video earlier, we were talking to somebody else. Okay. And I told him the same thing I'm telling you. The horizon's not the edge of the earth. It's not the edge of the ball where the curve starts. and we know this because you can go to the beach and you can watch the horizon for a few hours and watch the horizon move around, even though you aren't moving around. So, why is it 10 times too far? What globe does that match? 65,000 mile radius or something? So when you guys say, "Hey, man, the math matches reality," it doesn't. I know right off the bat you've never looked at anything. I never once.
Have you ever had show you that extreme that's over like Lake Pontchartrain with the bridge?
What about it? You think that's
it's just they're like, there's the curve, and then but the reality is, if the Earth was that curved, it would only be like a couple thousand miles around.
Oh yeah, you like 900-kilometer radius.
Yeah, something ridiculously small. Yeah.
Yeah, and as DJ was saying, we can demonstrate the whole ships over the horizon, things being cut out bottom first. We can demonstrate that on known flat surfaces. The whole argument behind the globe is, oh, the ship sails away. I don't see the bottom. It gets cut off first, and then the top, etc., etc. That can only happen on a curved surface. So the Earth's a globe. It's not true. We can demonstrate it. When we don't need math, we don't need an explanation. We can take a surface that we know is 100%. This surface is flat. We can replicate it. We don't need to know why. We don't need to know how, because we can just replicate it. So the scenario of impossible on a flat surface is not true. Radio transmissions, microwave transmissions, infrared transmissions, all impossible on a globe. Distances are way impossible. 800-mile radio transmissions to sea level, 870-mile NATO communication, microwave communication system, 10,000-mile radio communication between the UK and Australia, 6,000-mile radio communication between Washington D.C. and a plane in
but
the U.S.
satellites.
Secretary of State's plane over the. This is before satellites, buddy. Good try.
When was
before
this?
Before satellites existed.
Okay,
They didn't exist yet.
That you know of. The government's not gonna fucking tell you.
I don't think they existed in 1918. Do you think they existed in 1918? At the end of World War I?
No, but there's also other technologies like repeaters.
There was radio was brand new. There was no repeaters. You think there was repeaters between Cornwall, UK, and Australia?
There must have been. If
there must have been.
How far was
Why
that
must
distance?
there have been?
No. How many repeaters would be needed from those two locations?
How did you float them in the Indian Ocean?
Well, I'm going to retract that statement. I don't know if there must have been, but like, how do you know that it doesn't? Is it just impossible because in the flat or globe Earth, 100%, you know that for a fact.
Well, it's 10,000 miles. So if the globe has a circumference of 25,000 miles, that's half the distance, right? So this is almost like being on the North Pole and talking to the South Pole. There's a big ball in the way. How are you doing that? The radio waves don't go through the ball.
Let me add this to the list. You said...
So Marconi, 1918, and a guy named Arthur Fisk. It was Cornwall, United Kingdom to Sydney, Australia in 1918.
Okay. Australia.
I can post a plaque, dude. Post a picture of the plaque because there's a memorial plaque. And I can post links to it.
Yeah, that would help.
Yeah, it's very interesting because the way they discovered it was an amateur radio operator. He started hearing radio transmissions in German. And he was like, well, we're in Australia. There ain't no Germans here. And they were picking up radio broadcasts from Berlin in Australia. So they're like, oh, I got an idea. Why don't we try to do that on purpose? And they did.
Okay.
That's
So
a
the way
geometry of what the radio. I just posted in the chat a diagram of the geometry of what the radio transmission would have been.
they're saying they utilize ionospheric reflection, which is like something in the atmosphere or some shit.
Okay, that's a cool story. There's no evidence for any of that, dude. Do you know that they didn't that hypothesis didn't even exist when they did the transmission, right? So do you know how that went? That's an ex post facto claim, meaning they did the transmission, said, "Oh, how's that possible? Earth's the globe." Well, it must have bounced off the freaking ionosphere. We'll just make some shit up on how it worked on a globe. And it couldn't work on a globe like that anyway, because when you have an inner circle and an outer circle, because of the law of reflection, the angle of incidence equals the angle of reflection. The angle that the radio bounces off the outer circle, which would be the ionosphere.
Can we talk about something interesting?
In the inner circle, which would be the Earth. I am talking about something interesting. The transmission would flatten out and it would never get there, because you have the angle would keep tipping down, and you probably need like 300 fucking bounces to even bounce that far. And here's the other problem: is that long range transmission only happens at night. It doesn't happen during the daytime. They did these transmissions during the daytime. During the daytime, skywave ionospheric scattering only works for 500 to 700 miles. We've gone through all the objections. We've heard it all. Look, we've been doing this for quite a long time, just to be honest with you. We've heard all the objections. Like, that's why I can sit here, I just call and we talk to you, because I know there's literally nothing you could bring up. You could Google forever. We've already heard it all. We've already dealt with it all. We've already refuted it all. There's nothing. And the amazing thing is, every time, and this is like, the longer I'm in this topic, the more I'm convinced the Earth is flat, not less. Because every once in a while, a globe earther will bring something new that we've never heard before, and on the surface, it seems like it seems like it proves a globe, but then when you drill down into the details, it's not the case. Every time.
Well, I mean, I think you should adopt a different mindset. I mean, sure, you could be pretty sure about it, but don't fucking like be so sure that you can't.
Don't tell anybody.
No, that's not what I'm saying. It just sounds like nothing I say will change your minds, and that's not.
No, nothing you say will make the Earth bend.
Okay, yes, things you say could change my mind, but the only thing you can say that would change my mind is some proof that is globe exclusive, meaning it would be something that could only indicate the Earth is a globe. And there's only one thing that can do that. Want to know what that is? Measuring the surface to be curving. That's it. That's the only thing that is available. Everything else is theory-laden, fanciful imaginations about how they think the Earth might work if it was a globe. But we can also concoct some freaking bullshit imaginations, just those stories about how that same phenomenon could work on a flat Earth.
There is one way, but you guys are just gonna say like that's impossible to do. But I think it's the most
go to
feasible.
space.
No, it's more feasible than that.
okay.
You stay in our atmosphere or like in the air, and you just fly in one direction and see if you land in the same spot.
Okay. How would you do that, dude?
I know but it's more feasible. Maybe going to space is more feasible. I'll take that back. Build a fucking rocket, go to space, film this shit, and yeah.
Yeah, that's it. Look at it. So the thing that you're on, you have access to. You could measure it right when you're there. Instead, you're gonna go far away and look at it.
Yeah, that's because, like I said.
How does that make any sense?
Because, like
never
I said,
I hope no one ever hires you to build a house, because you'd be right at the 2x4 and you had your tape measure and you'd be like, let me walk across the street and look at it.
Even in math, right? We sometimes feel that we're at the global maxima, but you could just be in the local maxima. All I'm saying is, get a bird's eye view.
Did you just say that even in math we feel? What are you talking about?
Yeah, can you address what I said about you going to the other side of the street to tell how long a board is?
I'm giving you like some perspective. So locally, you can see something.
I didn't say see. I said measure. See, this is where you guys get fucked up. You think we're looking at it. We're measuring it, dude.
Settle down, Indio.
I am settled down. You guys conflate calculation and looking at things with measuring what it is. You can know directly what something is by measuring it directly. I can know if you were here and I took a tape measure and measured your height. Can anything change that? Any theory, any hypothesis, anybody being far away from you and looking at you, will that change the what the reading was on the tape measure? The answer is no. Okay. That's why we say measure it, because it's a definitive proof. Not because we like it, because it's absolute proof.
If I fly you to space and you see and you go,
didn't you just make the argument against your own senses? You literally observe the Earth flat every day and you reject it, but you're saying you should go to space and look at the ball and accept it.
So even if you were in the
so you're in a contradiction, bro.
Well, let me just ask you this.
You better go buy that vacuum chamber. You won't be talking about space anymore.
If you were in this, if you did it around, like you went around the Earth one time, you still wouldn't believe it. You would rather believe your calculations locally, like 30 miles.
They're not calculations, they're measurements.
Okay, your measurements, your local measurements, a 30-mile.
Well, does water conform into a sphere because of gravity?
I mean, if you actually see it, if you see that's the case, you wouldn't believe it.
Okay, so most of the surface of the Earth is water, right?
You're saying your standards are like, damn, bro.
Look, it's a logical progression. Most of the surface of the Earth is water. Whatever's water doing, the Earth is doing. So if the water is not curving, then the Earth is not a ball. It's simple logic. All those logical necessities of the previous premise. Right? You can't have a 75% flat ball. So if the water's flat, the Earth is flat. It's just really simple. If the water's curved, the Earth is curved. And if we went to space and saw the Earth as a ball, we should be able to come down here and measure it as a ball. It's odd that you guys are like these dual Earth theorists, man, that you guys think there's two Earths. One flat Earth that you're on and another one when you go to space.
And it changes somewhere while you're going high. It's always flat, and then poof, it turns into a ball somewhere.
Yeah, and then there's fucking machines flying around and comets and spacemen and aliens and all this magical shit. Look, you asked me, said I can't change your mind. You could if you had an actual logically sound and valid argument for the Earth being a ball. And since a ball is a claim about its geometry, you need geometric evidence. Okay? Looking at something can tell you about the geometry, but it's not the true geometry because of perspective. Railroad tracks appear to converge in the distance. That's not what they're actually doing. So, because of this, we use tools to directly measure things so that we actually know exactly what they are. Things like tape measures. So, using these instruments, we can tell whether the Earth is a ball or not, or whether it's curving or not, and then infer from that curvature and the theory of gravity, of forming things into balls, that if the Earth's not curving, then it's not a ball. And that theory's crap. It's wrong.
Guys, because they're just gonna say,
Sauce, if I told you a hill, where if I place you in a position on Earth, and I said in that direction, you see that hill over there? You say, yeah, I see that hill over there. That hill is 6 miles away. How do we know that that hill is 6 miles away?
Rangefinder.
Rangefinder. You can like walk it out, right?
Mm-hmm.
Like you basically go out and you make a measurement to the hill, right? To verify that it's 6 miles away, right?
Yep.
Right. So what we're doing is we're saying, hey, that object in the water is such and such miles away.
No, I get that. I'm just saying, like, even if I were to, they're just gonna say, yeah, it's the bending of the light, or it's.
You're gonna have to prove that.
Yeah, that's fine. But there's no justification for that.
We can demonstrate refraction on a flat surface. Can you demonstrate refraction on a curved surface?
Yeah, that's the crux of the problem. If you ask them, Sauce, what's the evidence for globe refraction? What's the actual evidence for it? Want to know what their evidence is? A flat-looking Earth.
I don't know about that.
Well, I mean, what else is it? They say the Earth looks flat. It's got to be refraction. What else is their evidence?
Let me look into that.
How do you know it's a globe?
It gets even worse. I mean, it gets even worse than that, because what causes this refraction? The gradient, the density gradient, right? Well, what causes the density gradient? Gravity. Well, what else does gravity do? It forms the Earth into a ball. So gravity conspires to make a ball that compresses the air in such a way that when a human being looks at it, it looks flat. It's the fucking stupidest idea in human history.
Bro, there's a lot of things that are stupid, right? Like fucking.
Well, this is the pinnacle, because you have to believe that you're living in an optical fucking illusion, in that you can't trust your senses, and that nothing is real, basically.
Before I was ever a flat earther, I used to fly. I would fly some more still. Just don't have the funds for it right now. But the 30 or so times that I flew prior to being a flat earther, every time I was in the air, I would say, "Oh my God, look how big the Earth is. It looks flat still. Can't believe how big the Earth is. I can't see curvature." Every single time.
I flew to Chicago a couple times, man, and the Great Lakes are flat as fuck, bro.
You know you've never seen curvature. You've never seen it, except in a picture, in a book somewhere, or on video on TV for your computer screen.
No, yeah, for sure. I that's your best point, right? That's the best case for flat earthers, 100%.
You know it's flat.
No, there is no best case. It's only flat. That's the only case.
I mean, I don't know. There's like you guys have trouble explaining satellites and
No, I don't.
So
They
you
don't
want us to
exist.
explain the
balloons?
There
TV
you go.
show?
Yeah,
You're
they don't
asking for-
exist.
You're asking us to explain the TV show, which you said was our best point, that you don't actually know any of that.
How does GPS work?
Not with a globe. It doesn't even use globe math. Did you know that?
Ground positioning work. It finds your position on the ground. It's ground positioning system.
Okay, so GPS doesn't use a globe.
No,
you on your phone, look, brother, when you look at your phone, it shows you latitude and longitude, and you go, hey, man, it's doing that on the globe. But the actual GPS receiver, the message it gets, it's called a Rhinex message. It comes down in 3 coordinates, not latitude and longitude. The X, Y, Z on a plane. That's what the math that the receiver actually does. This isn't a conspiracy theory. You can type in Rhinex message data, and you can look at the fucking message data yourself. Every receiver does this. And hold on, to get a latitude, longitude, it does a coordinate transformation and converts the coordinates into spherical coordinates. But it's not natively in that.
But why do we need spherical coordinates if it's just if it's flat? We don't.
Because our coordinate system is stars.
Okay, so you're not saying that.
Because this goes back to your other point about traveling in a straight line. Why you can't actually do that is because you need a spatial reference, right? That you see or you can detect.
You can just
from all the points on your from all the points on your route to know if you're going straight. Because we can't see a mountain from far away because of lots of reasons, mainly because of the air, but because we can't see a mountain from 400 miles away, we use the stars. We use the stars to navigate, and we create an entire coordinate system based upon the stars. They're not based upon a globe ground. You can't even find your latitude and longitude without using the sun and the stars. Longitude is a solar coordinate. Latitude is a celestial equator coordinate, meaning...
You guys don't even believe in the stars.
What are you talking about? We don't believe in the story of what they say they are. We see stars. Listen, just because we don't believe the story associated the story that they say associated with stars doesn't mean we don't believe in stars or that we think stars are fake. Stars are real. We can see them, but they're not made of fucking big balls of fucking gas in a vacuum burning at 1,000,000 fucking degrees. Okay? That's what they aren't.
What's the medium between us?
And the stars, we don't know.
The absolute medium, it's a variation.
Hey, Saucy, I put in the side chat a GIF.
I mean, I've heard one hypothesis of liquid helium-4.
That's a pretty cool. That was a pretty cool one too.
Yeah, I mean, it's not like really testable, but it's possible. It's feasible within the paradigm of physics. It could be helium-4.
Hey, Sauce. I put a video in the side chat of a satellite. Satellites are real, bro.
So exactly. Balloons, right?
Hey, Biden shot it down, bro. It's real.
Here, I posted one talking to another one and making an alignment with it, keeping it always in view, basically.
And as I just told you, we were doing 10,000-mile radio transmissions in 1918. Satellites were never necessary to exist because there's never been a ball in the way between radio transmissions.
I look up in the sky, man. I can find Regulus. I can find Polaris. I can find, the constellations. I understand those things, right? I can see Jupiter. I can see Mars. I can see Saturn. I can find them, those three personally, with the naked eye. And in certain days when Venus is in the sky, I can find that too when it's on the horizon. That doesn't make the Earth a ball, and that doesn't mean that you know what the planets or the stars are. You can see them in the sky, but what they're made out of, you have no fucking idea.
And the way celestial navigation works is you estimate how long it's going to take you to get to where you want to go. And then you read which star is going to be over that spot at that time. So
I'll give you an example of how you don't know.
Yeah, if you know that Orion's going to be over freaking wherever, Egypt, in 30 fucking days, and it takes you 30 days to hypothetically travel that far, all you have to do is follow fucking Orion, and you're going to end up in Egypt. You know that 30 days later, if the Orion's directly over your head, you're in Egypt. You know how we know that? Because that's the coordinate system we made. That's how we designated all this stuff.
Yeah, I don't know how to.
They say Polaris is 432 light years away. How do they know that?
That's changed so many times, man.
I know. You know how far a light year is?
How many times has that changed?
Yeah.
At least 3 times that I know.
Yeah.
How far away? How many miles?
I don't know. I can do the calculations real quick.
5.8 trillion miles. I'll save you the math.
Yeah, that's a lot.
Yeah. So imagine 432 times 5.8.
No, I know. I know space is stupid big according to.
How do they know that?
That's a good question. Let me see.
Yeah, so that's the question we ask. They make claims, right? And we ask, how do they know it, right? And we never get an answer, even when we talk to astronomers, astrophysicists, regular physicists, mathematical, like you name it, we've talked to them. And when we ask them how they know what they're saying, I mean, I had a mathematical physicist tell me he can't prove anything exists, and that like he might not have any hands and we all might be brains in a jar. That's where he had to go because he couldn't actually back up that the Earth was a globe. This is a academic man that was teaching physics at university. When pressed to prove the globe, had to say, "We can't prove anything. We could all be brains in a jar." The people that I believe you're relying on when you think that the Earth is a globe, these are the people that the average person comes and relies on. They say, what about the scientists? What about the academics? What about these people? They know the Earth is a globe. Well, we've talked to them, and they don't. They don't know anything more than you. They just heard the story in high school and just accepted it. They've never done any tests. They've never done any experiments. They've never done any measurements. They've never done anything.
Yeah, could be. It's tough.
There's a guy in here that he wrote his PhD dissertation on direct and indirect detection of dark matter. He didn't know anything. He's an astrophysicist.
For me, if I go to space and I see it,
yeah,
that's it, man. It's like there's without a doubt, like doing the calculations here on Earth.
Don't you understand how contradictory you're? How do you know it's actually a ball? I mean, you saw the Earth is flat and you didn't believe it. How come you're gonna believe it when you see it as a ball?
Let me finish. I have to make I have to orbit around this fucker.
Oh, okay. I mean, that's fair.
Space is fake, dude. You're gonna find out when you get your vacuum chamber. You're not gonna orbit anything.
Do you think an orbit has ever been actually observed by anybody?
30 people, apparently.
They saw something orbit? From where?
Are those people in the ISS right now? Right.
They only see 3% of the Earth.
What do you mean?
From the ISS's altitude, you would only see 3% of the Earth.
Yeah, but it doesn't matter. They're still traveling around the Earth.
How do you know? It's like being in an airplane, dude. It's like being in an airplane.
Yeah. They're just looking out the window, man. They can't tell if they're going around anything. They could be just going in a big circle. which would be the same thing. It's just a difference of the circle. So one circle flips upside down, one just goes left or right, right? So they could just be going in a circle. They can't tell from where they are. See, fundamental problem, I keep bringing up things that you go-overs have in common, is when you think about the world, you think about it from a third-person point of view and don't think about it from what people actually experience by looking out their eyes. Okay, from the viewpoint of someone on the ISS, they're only going to see 3% of the Earth, and they're going to have no fucking idea they're going in a circle, they're doing a loop-de-loop, or anything. Especially if they're in free fall. They can't feel which way the spaceship's going, right? They have no idea where they're going. And there's no way to tell visually. So,
here's my question to you, Saucy.
Yeah.
So, if you're waiting to go to space to prove the Earth is a globe, then why aren't you thinking the Earth is flat until proven otherwise?
Because I can't prove that it's not refraction or fucking whatever else they say.
You can't prove that it is refraction.
You can't demonstrate that refraction could even do that in the first place.
So we can just get rid of refraction now, so you don't even have to worry about it. So what's your next one?
Okay, let me ask him this.
Hang on. Why is he giving? I just wanted to know why he's giving the globe the benefit of the doubt observation of reality.
Yeah, because consensus means something to me. I know it.
Oh, okay. Yeah, no, got it. Thanks, religious.
Slurp. So, listen, what if they said electromagnetism made it look flat and not refraction? What if they just said some other physical law? Wouldn't they have to justify that in some way?
So, what would that look like to you for them to show you that it is refraction? What would that look like?
Measurements.
Okay.
Like measurements, but the measurements that have been done show that refraction of that type is not possible. That's the rub. See, this is why I'm asking you very simple questions, right? Because what they like to do, the people that the Goldbergers that debate this topic, they want to bring up a refraction. So you go down the rabbit hole of nonsense instead of tackling the fundamental premise in the first place. Is refraction even capable of doing what they say, making a curved surface look flat? Is it capable of doing that?
Right.
But also there's a caveat to this. The caveat is, and that has to be the only visual phenomenon that you see, meaning other effects associated with refraction, such as dispersion, vignetting, right? Magnification, shrinking, things looking smaller, things looking larger, things looking distorted. Those
you know why?
Hold on. Those things can't be there.
I know.
Only that
you're
one
right.
thing of a flattened globe. That's not
like I said. From my point of view right now, this is definitely the best case for it. Right, 100%. I'm just saying, for me to accept this one anomaly, if I can call it that, for a glober, everything else falls apart to me.
What anomaly? Which anomaly are you talking about?
Okay, I'm not gonna call it anomaly. I'm not gonna call it an anomaly. I'm just saying, if I were to accept that it is
exactly what you're talking about.
If it's a flat Earth, then I'm gonna have to like fucking contend with the idea that okay, somewhere around here there might be a fucking edge and water's just flowing into whatever or flowing down.
Why would that happen?
I don't know, because if it's. Are you saying that it's an infinite expanse?
Okay. Well, first of all, water. If you thought that there was an edge and water is going off into the vacuum, water evaporates.
No. You don't believe it. You don't believe in the vacuum.
Hold on. But that's what you're saying. That means water will evaporate as soon as
I'm not saying.
Vacuum.
I'm not saying that. I'm saying that if it's flat,
why would you think that there's an edge with water falling off of it?
Okay, fuck the water. I'm just saying there's got to be an edge. There's got to be an edge, right?
Why?
Okay, so it's infinite to you.
No, that's a false dichotomy, dude. Infinite is the act of counting. So this is a bad idea that people have, that infinite is something, dude. Infinite is the act of counting.
You'll walk in a circle before you find anything relevant.
So
why is that?
You can always count the number afterwards. That's said to be infinite, right? So an infinite set, an infinite series, an infinite enumeration. There's always something that comes after it. Okay.
Yeah. Okay. Fuck infinity.
Why would we?
You know what I mean. You know what I mean.
Well, no. This is very important because the choices here are finite or infinite, but those are actually not opposite things. They're used opposite in modern language, but they're actually not opposite things. So we're talking about spatial properties. So anything logically that is an object must be inside a greater space, right? So you have a beach ball is in a swimming pool, right? And the swimming pool's in the yard. And the yard's in the town. And the town's in the country. And the country's on the continent. And the continent's, surrounded by water, inside the water. And then the water's inside the earth, right?
And what's surrounding
And then the Earth's inside the solar. I'm just doing the globe one. The Earth's inside the solar system, and the solar system's inside the galaxy, and the galaxy's inside the great fucking void, and the great void's inside the universe. What's the universe inside?
Yeah, we haven't observed that. Yeah.
Well, if it was inside, anything that you could say exists, by definition, is inside the universe and can't be outside it, because the universe means everything.
All I'm asking you is, what do you think?
No running away, dude. Don't run away. This was your question.
You already answered the question, Indio. He said when Indio asked you the question, what was outside the universe, you said, I don't know, we haven't observed it yet.
Yes.
Okay.
That's the answer.
That's the answer.
Okay.
That's the answer about flat Earth. There's no evidence that there isn't outside. There is no evidence you can go outside. There's no evidence that there's some freaking limit or wall or boundary or edge or anything like that. There's no evidence of any of that stuff.
Yeah, which says something to me.
Yeah, that the Earth is the universe?
No.
Just because you can imagine you can go outside the Earth doesn't mean you actually can. It doesn't even mean that there is something outside the Earth. Can you go outside of your body?
Wish.
You wish. Probably not. You probably don't wish that wants to happen. But
you don't want to astral project, brother.
Well, I mean, that's what the globe Earth is. It's just literally, it's in the word, astral projection.
Dude, why do you got to do all this weird shit?
Well, I mean, yeah, it's exactly. The globe Earth is just a crazy occult religion, dude, if you want to boil it down.
So you guys always want to float, you want to fly, you want to astral project, you want to go to space. What is wrong with you people?
What's wrong with that?
They want to. The chains of gravity are like slavery holding us down. Swing low, sweet chariot.
I think that if you actually, if it was possible to live where there was no gravity and you just like floated around, they think that that would be fun. After about an hour of that, you would want to just be like, put me back down, because this is not going to work out for me.
How about when you get like 90 years old and can't control your bladder and like piss is like flying everywhere in little balls?
No, all you have to do is just get seasick and start puking. That's it. It just takes one day, and now you got 9 people puking all at the same time. Yeah, go clean that up with a mop.
Yeah, fucking lo mein floating around everywhere. Gross.
All up in the corners of the air vents and shit, getting sucked in. Gonna make myself throw up thinking about it.
All I'm saying is we don't have evidence of an edge, right?
That's right.
Why would we think there's an edge?
We don't have evidence of outer space making people float. You're going to find out with your vacuum chamber that water doesn't exist in a vacuum. So you can't have a ball Earth full of water floating in a vacuum.
I wondered how the thought would have finished. We don't find an edge, but we still measure the surface as flat. What was you going to say?
I'm just saying that's just another point on the graph. Yeah, I said already that it is pretty sus how we don't see a curve. It is pretty sus.
We don't
but
measure one either.
It's also pretty
the
sus
important
that we
part
can't
is we
find
don't
an edge.
measure one. That's the important part, is we don't measure one. Seeing is not dispositive, dude. Seeing is a subjective activity. Now, seeing a no curve is a good starting point, but that doesn't mean it's not proof. It's just evidence. The proof is the measurement.
Yeah, but the active, I know what you mean.
If I look at railroad tracks and they appear to converge, how do I prove they're parallel? By looking at them. You understand? Seeing
I get what you're
projection of the 3D world onto a 2D surface. Okay?
Sure.
So seeing has a fundamental flaw. You're missing a dimension. And it's only true from your fucking perspective. But from other perspectives, it's different. That's why we have this orthographic shit. Okay, we have
We're not really
drawings and all those things, right?
Our vision is not orthographic, but I see your point. Our depth perception is flawed and may vary from person to person. I get what you're saying.
No, it just gives it's a different. It's not that it's flawed. It's that we can say different things about the world than orthographically. So, but with vision, we can look at something and get the angular size, the visual size of something angularly. You can't get that orthographically unless you take a third point that's not part of the orthographic diagram and project part of the orthographic diagram out of it onto a point. Then you can get the angles of, say, the angular size of an object. But
no, I get what you're saying.
Just different. It's just different information. That's all it is. It's different information. It's not right or wrong. It's just different information. You're not getting the whole thing. You're getting part of it.
I know our vision is flawed. We have to measure it.
It's not flawed.
It is.
It's incomplete. What would perfect vision look like? Where you have like a 3D hologram in your brain of what the world is?
Superman vision.
Probably, yeah. Like, you know how in like video games you can just fucking you have like a fucking graph. You have like
third person.
Turn the video games off, dude.
Are you in a third person shooter or a first person shooter right now?
All I'm saying is if you knew where everything is in the XYZ, that would be perfect, right? I'm not even saying that's possible. I'm just saying you asked me what would perfect be. I'm telling you that is perfect. I could know something where it is in space relative to the origin with precise well, up to 32 bits or 64 bits. But yeah.
Okay. But you know what? If you had orthographic vision and I gave you a gun, you would never be able to shoot anything. Because you'd have no perspective. You'd have no idea what the angle of the object is out there in 3D space.
Let me think about that. No,
you don't have
that would be right. That would be right because you would direction is still going to be the same, but you're just not going to
what
you just can't you just don't have depth perception. That's what orthographic is. You lose the depth perception.
But it terminates at like your gun is a point, right? It has to terminate at that point, the barrel of your gun.
I'm not sure what you're saying.
The sights through the gun?
The sights of the gun, right? That's where the bullet goes?
Sure, I'm saying you're still pointing in that direction. You just don't know how far it is because you're now orthographically projecting, right? You don't have depth perception.
Yeah, but okay. I mean,
we're still going to be shooting in that direction.
Okay, but if you saw the world in an orthographic view, when you took your little gun and went to shoot somebody, you'd miss.
Not true. That's literally what I'm saying. You just don't know how far he is.
No, you don't know the direction.
Not true.
Yes, true. Okay, I'll tell you why it's true, because
bro, in my video game right now, my video game right now, I can have raycasts from my camera down to a point on the plane.
Still
even with
yeah, that's great, right? That's
in orthographic.
Fantastic. Orthographic is like a blueprint.
Have you ever played a video game like back in the day where everything looks like?
Dude, I played Pong. Okay, like
right.
Don't ask me if I played a video game back in the day. I played Pong when it came out.
Okay, but that's in 2D. It doesn't work.
We speak past each other. Do you know what orthographic is?
All your games are 2D too. They're just drawn like 3D.
You understand?
No, they're simulated in 3D. Yeah, that's a fair point. But
Can you give an example of an orthographic projected view? Okay. I don't think you know what's being said.
No, I do. An orthographic projection is where your camera, the frustum is it's a cube, right? Or it's a rectangle, or not? Yeah, it's a cube. It's not. They're parallel. These the borders. So everything appears to you like it's the same distance, right? It's not. It's what he said. It doesn't go to a point because you need.
That's right.
Yeah.
But you're the point.
But directions are still the same. The direction that you're pointing at is
not
still
from your viewpoint, though.
Yes, it is.
Okay. Look, you would have a bunch of parallel lines. You're going to be aligned with one of those parallel lines. That will only be your only. Like, you don't have a point of view. There is no such thing as a point of view. That's why it's not perspective. Perspective has a point of view, meaning there's a point which the whole 3D image is projected on, which converges.
Not true. Not true, because you can say.
Where does an orthographic projection converge?
There is no convergence, but you can say, okay. I want to shoot a ray. I want to shoot a ray from this XY, right, and then go straight.
Yeah, go straight to where?
Straight to whatever.
What do you see? I swear.
Yes, in that case, you're just gonna hit whatever.
I mean, I think I know what the problem here is. You know what what the hell is it called? A telecentric lens is?
No.
Okay, so it's a lens that they use in manufacturing that they'll like when they need to precisely measure the part.
Sure.
Okay, there's no perspective. It's an orthographic image with a camera lens, and the reason it works is because the camera lens is the size of the part. So it's a 5mm part. You have a 5mm lens, and it's a parallel projection because the lens is big enough. There is no point projection or near point projection. Like you said, frustum. Say you had a 10mm part and a 5mm lens, you would have a frustum with a back plane, front plane, right? Where the front plane would be the camera lens of 5mm, and the back plane would be the part of 10mm. Now, you could do a calculation and do some, computer-aided fucking correction, but you can just get the telecentric lens and
just gonna hit whatever.
I mean, I think I know what the problem here is. You know what what the hell is it called? A telecentric lens is?
No.
Okay, so it's a lens that they use in manufacturing that they'll like when they need to precisely measure the part.
Sure.
Okay, there's no perspective. It's an orthographic image with a camera lens, and the reason it works is because the camera lens is the size of the part. So it's a 5mm part. You have a 5mm lens, and it's a parallel projection because the lens is big enough. There is no point projection or near point projection. Like you said, frustum. Say you had a 10mm part and a 5mm lens, you would have a frustum with a back plane, front plane, right? where the front plane would be the camera lens of 5 millimeters and the back plane would be the part 10 millimeters. Now, you could do a calculation and do some, computer-aided fucking correction, but you can just get the telecentric lens and just make it the size of the part and not do any of that. Now, there's some videos on YouTube where people, they make a giant telecentric lens that's like, it's about, 10-inch diameter lens. And they run a train at it on train tracks, and it doesn't even look like it's coming at the camera, even though it is coming right at the camera, because it doesn't have a direction from the observer's point of view. There's no direction that like goes to the observer. Everything doesn't converge at the observer.
Sure, that's if your constraint is you can only shoot the ray from the middle or somewhere, but that's obviously not what I'm saying. I'm saying you can choose an XY. You can choose an XY on this square and go forward. That's what I'm saying. Yeah, if you're saying you can only shoot from fucking 0, let's say that's the middle of the screen, then yeah, you're never gonna hit. You're only gonna be.
Dude, you can't do any of that on a ball. You can only do all of that in a flat game.
Anyway, this is all like Western Pacific graveyard. We don't live in an orthographic. Well, hold on, dude, just one sec. I'm only gonna say this. We don't live in an orthographic world, though. We live in a world of perspective. That's what we see. When we model the sun, moon, earth, all these objects, right, that we see, right, they're supposed to be objects. The mathematics is an observer-centric perspective, all of it. They don't use a globe. They assume that you're a point at the origin of coordinates in astronomy and all these places. All these models are actually observer-centric models. And the only reason they use a sphere is because it's easier to calculate if they assume that you're just a point at the center of the sphere. Anyway, whoever had something to say, go ahead. Okay, then. Have a nice day. Be sure to tip your waitress. So, Radwin, what was the vacuum test he's going to do?
I'm going to drop two things.
First, you're gonna, before you ruin your vacuum chamber, first you're gonna put a half a shot glass of water in there, and you're gonna time how long it's gonna be till your vacuum chamber is completely dry. I was gonna say it's about an hour, is my guess.
How do I like? I need a humidity fucking sensor.
No, you'll see. Believe me, you'll see it. You'll see it all over the inside of the vacuum chamber. As soon as it hits a certain point, it goes poof and turns into a cloud. Because when there's no pressure, the water turns into gas. So that's why you can't have gas balls in a vacuum and water balls in a vacuum.
Yeah, it evaporates. So basically, it's going to condensate.
Yeah,
right,
so Earth can't be a water ball in a vacuum. That's correct.
It's actually sublimation. The water sublimates out of the air that's dissolved in.
The gears turning in his head.
You often see is there's two classes of argumentation. There's descriptions of what's actually happening, like what's actually observed. And then there's explanations. Okay? A lot of times people try to pass off the explanation as the description. For instance, solar eclipse. I saw the moon go in front of the sun. That's the explanation. But that's not an accurate description of what was actually seen, because you can't see the sun during the moon during a solar eclipse because it's a new moon. So they never saw the moon at all. This is something you'll see if you're engaged in this topic over and over again. Kohlbergers they'll say they're empiricists, and you'll ask them for evidence, and you'll ask them for data, you'll ask them for experiments, like the one Rabnin just said. Gas balls in a vacuum. And all you'll get is an explanation. You'll just get a story. You'll never get the actual data, the actual experiment to back up any of the claims. This happens repeatedly over and over and over and over and over ad nauseum. But science, as you should know, is based upon empirical meaning from experience, observation, or experiment. Technically, just pure observation is not science, but let's just put it under the broad term of science. Okay? Observation and experience, period. That's it.
Hold on. So explain to me why if I see like water droplets on the side of my vacuum chamber, why does that disprove gravity or whatever you're saying?
How come it was held down before you put it in there and removed the air pressure? It was held down by gravity then, but when you remove the air pressure, gravity gave up on it. So is it the air pressure holding it down, or is it gravity holding it down? You decide.
I don't see how that follows. Like, because if the water turns into gas, that's what we see even in non like.
Yeah, so gases are not pulled down by gravity, are they?
Okay, so if I had, let's say, if I had
your
like,
brain, didn't it?
Yeah, gears turn again.
Not really, but if I had
no gears are turning yet. Okay.
If the water is like blue or something, right, and I can see the gas, let's say, what you're saying the gas is gonna what's gonna happen to the gas? You're saying it's gonna rise?
You let your vacuum chamber run until it's dry. Yeah, you let it run until it's dry. You don't just turn it on for a second and say, "Oh, I pulled a vacuum." You let that thing go for about an hour.
Mm-hmm.
It'll be bone dry. If not, let it go a couple more minutes. It'll dry up.
Yeah, but there isn't an atmosphere around the container or inside of the container, but surrounding the gas. It doesn't follow.
What the hell does that mean, dude?
Is the atmosphere the container?
Are you telling me that the air turns into some kind of solid container that holds water around a ball then?
Are you saying the gas contains the gas?
I'm
Because
not
the
sure what I'm
atmosphere is
saying.
the gas.
Let me search.
I know. Now.
No, I'm just trying to follow a train of thought and see where that leads me. Let's see, like.
Okay, just go by the second law of thermodynamics. Gases have infinite degrees of freedom and try to reach thermodynamic equilibrium within their environment. If they're inside a vacuum and there's a barrier and you open the barrier, the gas will expand to fill the available volume and trying to reach thermodynamic equilibrium. Gravity has no effect on this process and is nowhere in the kinetic theory of gases or any gas laws. There's just no gravity in any of the formulas because it has no effect on gases. You would need to have gravity in the phase diagrams for the transitions of matter from phases. That gravity would create pressure, which would change, and temperature, which means it would be able to do work. It's like this. The gravity thing is like outside all the physics, dude. It's just its own special category of physics that somehow is immune to all the other physical laws we have.
Just remembered we needed the container for the vacuum.
And remember, do that first before you throw your vacuum chamber out your window and prove nothing by doing that, except you can prove that you're going to break shit.
Bro, I'm not gonna drop a bowling ball. I'll drop like maybe a feather or something else.
He thinks he's going to drop them inside his vacuum chamber, and that's going to prove if they fall at the same time somehow.
Okay, but that's not all elements, is it?
Relevant in the sense that there is something making it fall.
No, he said it's not all elements that do that.
Okay,
so
but yeah,
some
I
of these
don't buy that video.
Well, I mean, you don't buy into the video? What video?
The video that you guys showed, right? The Bremen
drop tower. He saw that and panicked. He saw that elements don't drop at the same rate in a vacuum. Now he's going to go buy a vacuum chamber and drop his vacuum chamber.
Oh, what I saw was one video.
Yeah, they kicked him out.
They wouldn't let him do anymore.
Yeah, what is his name? I want to search him up.
In the video description is a link to his website. He's a German guy.
Well,
there's English translations on the website of everything. He has research papers, all that stuff is on there. He's not the only one that's done this, or something like this. There's another guy who's currently doing it. His name is Sky Darnos. But he's done a different type of setup. So because of air resistance, and you have different elements, your elements would have different shapes. What his way around this was to take the elements and stick them inside a basically like a ping pong ball, but it's just a plastic ball with hemispherical cells that snap together. So now you have unified air resistance. The air resistance is the same for every single one. So he takes 1 gram of each element and measures what the rate of free fall is, and it's not the same. It varies by element, and from what he's deduced, that the more neutrons that are in the element, the faster the rate of fall. Now he has a whole theory behind this, but this is he's a physicist, PhD, all the math, all the crap. He's written 2 books on it. So the equivalence principle was never proven.
Sounds like neutrons are pretty heavy shooting for ground like that.
Like, you can't just have one video and say, "Oh, here."
I just gave you a YouTube channel. He posts his experiments.
But you said that it's not the exact same. Like, we were talking about repeatable.
It is listen. He takes an element, like say a gram of lead and a gram of iron and a gram of calcium. Because of their densities are different, they're not going to be identical shapes. So you can't just drop them the way they are as a gram, because they'll have different air resistance. So he solved this by taking them and putting them each in a ball. Now, because they're in the identical kind of ball, they have identical air resistances and identical weights.
This is very dependent on the state of matter. Solid, liquid, gas. Are we dropping gases in vacuums?
He controlled all the variables except for the element is what he varied, the element that's inside. Weight is the same, geometric form is the same, air resistance is the same. So everything's the same.
Somehow that... Okay. All right, let me think about this. You have a container that is the same.
Yes.
And it contains whatever it contains. Whether
it contains an element that weighs 1 gram.
Right. It doesn't matter if it's solid or whatever, because you have this outer shell anyways.
Yes. And he drops it, and he times how fast it takes to fall.
Okay, where is this video?
It's a bunch of videos, so I'll post a link in the side chat to his channel. Tons of videos. He also got talks that he's given at conferences, and you can watch them if you want.
Okay, so it shouldn't be too hard to find.
His theory is that inertia and gravity are not the same, right? So you had the equivalence principle, where inertial mass and gravitational mass are identical. He's saying that that's not true. That the so-called gravitational mass is based upon the number of neutrons, inside of an element. Technically, not the number of neutrons. It's a little more sophisticated than that. But the neutron count is the easiest way to tell what it is. But but it's an interaction between the neutrons and the protons. It's not specifically their binding energy, but it's like that.
Is it the neutron count, or isn't it the proton count? I don't want to. I'm not going to get too
according
technical,
to him, it's the neutron count.
Yeah, it's a convertible, and the seat doesn't appear. Everything seems to be fine. It's a car.
Yeah, that's the problem.
Yeah, no, I know. I'm just stating that is what I'm observing here.
Do you remember the event? Probably about 10, 15 years ago now, right?
Really? Wow. Nah, dude. What are you doing?
I think it was 7 years ago, maybe.
Oh wow.
We're not that old, dude. Please don't.
But yeah, time is going fast, man. Yeah, that's true.
There's your proof for time dilation.
Proof of time dilation is marshmallows in a vacuum chamber?
What?
I don't know. I just heard there's your proof of time dilation.
Well, that's me dilating 7 years into 10 to 15.
Oh, that was the time dilation? Isn't that time? Yeah. Well, I mean,
as you get older, time goes faster.
I was just giving him shit, bro.
Time is just an illusion, man. Want to buy some grass?
All right, it was nice chatting. I'm gonna take everything into consideration. I'll be back. I'll fucking yeah.
All right.
I'll be back. Peace.
Space is fake. Bye.
I mean, I'm sure you think it because you think everybody else thinks it, right?
Yeah, I guess there's a huge. Yeah, I mean, yeah, you're right. A lot of the things we are told is because a lot of the things we believe is because we've been told our entire lives. Like that's definitely true.
Yeah, well, I think this particular topic is different in some respects to just like the general things like, you know, the Roman Empire existed. There was a guy named Julius Caesar. This isn't like that. You say, fuck that, Julius Caesar never existed. No one's going to be in the chat freaking swearing out. Fucking Julius Caesar, he exists. You know, this is, they don't teach in kindergarten, right? That Earth's a ball, and if you don't think that, you're stupid. Right? People think flat earthers are stupid generally, right? Well, why do you think the Earth is flat? Oh, because they're too stupid to understand the globe, right? That's the situation that we're in. This is a different animal than just the run of the mill thing. I don't know. Have you ever been in this chat before?
Sorry, say that again.
Have you been in this chat before? Just what VC?
Yeah, I believe I was maybe a long time ago. I haven't been there for a while.
People's reaction to this topic is not normal.
Yeah, I mean, are you really surprised by that though? Like,
no, because I've been involved in other so-called controversial topics, Nobody acts like they act in this topic. Nobody. You could talk about 9/11, JFK, freaking Sandy Hook, whatever, and there'll be people that are detractors, right? That think you're a crazy conspiracy theorist, but they don't act like this, like the globe zealots act. It's completely different. And you can probably poll everybody, every flat earther in this chat, and they'll tell you the same thing. This topic, for some reason, is different. And that was a red flag to me, how people acted. Because if the title of this fucking room was 24/7 fucking unicorns, no one would give a shit. Right.
Matter of fact, they probably come in with some cool AI and drawings and everything, and everyone would have a happy pretend session. But yeah, it's true. Like when I first, before I even stumbled on the words flat Earth, I was thinking about the moon landing, and I just told people that I knew, hey, you ever see that old video of the moon landing? That shit looks trash. And they came at me like nobody's business. I didn't even know it was a thing to be that upset about that video of all things. But the bottom line is though, what I found is that most people really, for me specifically, they get turned off really fast when I talk about like simple technical things. Like they want to hear things like what's at the edge, what's under the earth, what's the universe, then what is this? What is the shape then? All of this stuff. But they don't like when I tell them, hey, do you know that the descent of a plane, uh, when it begins, that's all trigonometry, uh, for miles, which means that everything in that triangle is flat, the surface specifically, which means it's not a globe, and that's it right there. People, it just makes people, it just turns people off. Like they don't even want to engage it. They can't say it's retarded when I'm pulling shit up. You know.
In fact, that just reminded me of something. There's a particular type of landing. It's called like a blackout landing or something. So there's two angles that you can approach a runway that look visually the same. It's like 43 degrees or something, where the runway will be like 43 degrees in your field of view. One of those angles is too steep, and one of them is the right angle. But the thing is, if you're coming in at the too steep angle, visually it looks the same. So people will end up frickin' bouncing off the frickin' runway and dying because it just looks visually the same. But the math involved in figuring out what it is takes no account into it being a curved surface, because it's not a curved surface. Because we're talking about an airplane. They're trying to negotiate their landing from miles away.
I wonder how that works. Because, like, if they do it, then I wonder if there's like if there is a way, if they do account the fact that it's a globe, there's maybe some. I mean, I need to look into it. This is the thing. I don't know enough about like plane flights and stuff to understand that kind of thing. But you have to understand like the difference with saying the Earth is a globe and saying the Earth is flat.
No, listen, too much. That's too much. You're doing too much. Look, no, we're talking about a very specific.
Can I talk? I'm just
expanded it to like the whole Earth already with the flat or whether it's globe. Like, no, I just told you what I told you. There is no if they do account into the if it's a globe. I just told you straight up they don't. So did Indio. You could have said, that's interesting. You have any literature on that?
It's interesting. That's what I'm saying. That's why I want to find out more about it, and I don't have the knowledge to really talk about it. But I'm saying like,
so that's what I'm saying.
I want to find out. That's the kind of thing I want to find out, because you can. This is the thing, right? These kind of conversations are entirely based on you telling me stuff that's right. I don't know if you're an expert pilot or not. I don't know if you know anything about aviation stuff. I don't know. So like me being able to find and look at certain sources, or these people have done this, or these pilots have said this, like that's just something that I need to do myself. But I really appreciate the fact you brought it up. I'm not gonna just take your word for it. That's my point.
That's cool. You don't have to take my word for it. I just find it psychologically interesting that you have to figure out where the curve is and all of that. When we told you specifically, it has nothing to do with that. I just told you it's trigonometry, bro. So I just found it interesting that you were trying to find the curve in that. That's all.
Well, yeah, because that's what I'm
I
attuned to. That's what I'm saying. Like, I'm not gonna. Maybe they don't, and if they don't, cool, right? Like that's fine. That's interesting. That's something. Okay, that's something I need to look into a little bit more. But you know, I don't understand this kind of stuff. All right.
well, think you got the difference between a curved surface and a flat surface. So, say you're going to land at a spot 10 miles away. That spot is going to be 66 feet lower than a flat surface. That's a 6-story building. Okay, so they would need to take that into account to know their glide path to land on the runway.
True. Unless
Well,
there's
we're
certain
trying to
things
tell you they
with
don't. They don't, man. They don't have a curve calculator in the fucking airplane.
maybe they don't. It doesn't really help. I don't really. There's certain trig you can do even on a curved surface, like with tangents, for example. Like I'm saying, there's
Yeah.
certain things you could do that would work even on a curved surface. Like
Well,
that's my point.
yeah, they could do the math, but they don't do the math. That's the thing. If they
Well, that's
had
what I'm
to, like,
saying.
when we're trying to think, I want to come in at this angle, right? The angle that they're taking versus the angle they would have to take if it was a globe are different angles, and they're only calculating the angle for landing on a flat surface. They're just doing a triangle. Triangles don't have a curved side, which goes back to the original thing. The surface of the Earth, you can't do a triangle on the surface of the Earth.
Are you talking? I kind of understand what I think you mean now. Are you talking about like if I take a plane, like a 2D plane, and I cut through a sphere, that can't be two. Like for example, the base of it can't be curved, and then you have two straight lines. Is that what you're talking about?
No, if you're on the surface of the sphere, like say, well, all
If
depictions of
all
someone
three
on a
sides are on the surface of the sphere, that is possible. But if you're talking about like
yeah.
trigonometry with the base being curved,
Well,
that's
technically, a
very
sphere is only a surface. I mean, if you want to get super technical, a sphere is a 2D surface. That's it.
Yeah, yeah. I mean, it's kind
When
of
it's 3D, it's called a ball in mathematics, or 3-sphere.
surface of sphere. I guess you could turn it
No,
into.
the sphere in mathematics is the surface only.
Oh, really?
So because the property of a sphere is equidistant from the center, right? That means equal
I guess I
distance.
can't
All
use
points on the
coordinates.
sphere
Yeah.
are all points on the sphere are equal distance from the center, which is a radius. So the radius is equal in infinite directions, right? So it's the surface only. A sphere is technically a 2D surface. Now, when you go into the 3D, it's called a ball or a 3-sphere. Then they have 4 spheres, which are like 4-dimensional spheres, and 5 spheres, which are 5-dimensional spheres. But that's outside of the scope of this. The point is that on the surface of a sphere, you can't even have straight lines in the first place because it's axiomatic to non-Euclidean geometry, to spherical geometry. It's just an axiom. There are no straight lines. Now, looking at it from a certain point of view, it'll appear straight, but it's not a straight line, right? Because that's like a different thing, right? So that's actually the projection of a sphere. I'm looking at the projection of a sphere into my eyeball getting projected onto a flat surface. Yeah, that it traces a curved surface on my fucking retina, but it's not a fucking curve. It's not a straight line. Or I mean, it projects a straight line on my retina, but it's not a straight line. Anyway, that's like this is way outside. The point is that to just take an angle, I gotta descend at this rate, right? 5 feet. I gotta descend 5 feet per 500 feet. The rate of descent would be completely different if they're landing on the surface of the sphere because it's constantly sloping down away from them. and the angle's changing, so it's also turning, right? Because you're trying to land on the runway, your plane has to have a certain orientation, right? You don't want to be tilted up and scrape your tail. And I know you have to take what we're saying at face value, but you took the existence of satellites at face value.
Yeah, no, that's where my hypocrisy comes in. I do acknowledge that. I'm saying this conversation is kind of.
Well, I mean,
kind of makes me think a little bit.
Yeah. So the point I was trying to make earlier is that the globe. Everyone thinks the Earth's a globe. They believe it, but they don't know it. And we've talked to lots of people. We've talked to PhDs. You mentioned PhD Tony. We've talked to him. We've talked to you name it. All professions, all levels of academia, and what we've found in the past 8 years is that no matter who they are, they have the same answers that they heard in 9th grade.
Okay. You know what I'm gonna do? I'm gonna it is late for me. It's like 10 to 3 in the morning. So what I'm gonna do is I'm gonna go to bed. But I'm gonna think about it. I'm gonna digest what you've told me. And next time I come in, if you are here, I'll happily have another discussion with you with things I found. Maybe I end up a flat earther when I come back. I don't know.
I'm so glad you came in. I'm so glad you came in and talked to us. It's so much better to talk to you than try to talk to you in the chat. Yeah, because I just wanted to say before you go, because what Indio is trying to get at there, like people get really agitated about this topic. They don't get upset about unicorns, Bigfoot, Santa Claus, Loch Ness Monster, and so on, even though it's characterized as if this is the crazy thing, right? So just consider, Radiator, maybe the globe's the crazy thing, because probably deep down you realize, yeah, that's the unicorn, that's the Bigfoot, that's the Loch Ness Monster that's never been documented. There's no curve. That's what we're trying to tell you. That's the crazy claim. You live on the earth. It seems flat and stationary. That's how you've always experienced it. Someone told you from a young age that it was something else different than what you actually experienced, and you have to squint really hard and make a whole bunch of extra calculations on top of just the very simple geometry that we do not live on a sphere. That's all we're telling you. But yeah, I also appreciated earlier you said you might be interested in doing some observations, of your own, which I totally encourage you to do.
Oh, yeah,
and
definitely.
you sound like a person who, will actually be honest about looking into it. So yeah, come back anytime, and somebody's always here 24/7.
Definitely will. Nice talking to you guys.
Yeah, thanks for not losing your shit and being cordial, not an ass.
Well, we're trying to tell you they don't. They don't, man. They don't have a curve calculator in the fucking airplane.
Maybe they don't. It doesn't really help. I don't really. There's certain trig you can do even on a curved surface, like with tangents, for example. Like I'm saying, there's certain things that you could do that would work even on a curved surface. That's my point.
Well, yeah, they could do the math, but they don't do the math. That's the thing. If they had to, when we're trying to think, I want to come in at this angle, right? The angle that they're taking versus the angle they would have to take if it was a globe are different angles, and they're only calculating the angle for landing on a flat surface. They're just doing a triangle. Triangles don't have a curved side, which goes back to the original thing. The surface of the Earth, you can't do a triangle on the surface of the Earth.
Are you talking? I kind of understand what I think you mean now. Are you talking about if I take a plane, like a 2D plane, I cut through a sphere, that can't be for example, the base of it can't be curved, and then you have two straight lines. Is that what you're talking about?
Took the flight today. He
Heathrow to JFK, headed west-southwest, 'cause there ain't no better way. Gonna find that old Coriolis, they say she's hidden in the winds, but that just can't be if we rotate east, tangential gradient. Hidden in the winds, Coriolis must be hidden in the winds, but the Earth ain't moving faster with the further south we've been, and we never could land safely with that tangential gradient. We all know every pilot treats the Earth as motionless, so to think it must be moving is just insane, you must confess. But please don't get offended if this song makes too much sense. Just thank God that landing's easy with no tangential gradient in the winds. They said she'd just be hidden in the winds, but the Earth ain't moving faster with the further south we've been, and we never could land safely with that tangential gradient. So here's a lesson for who's listening. It's dynamics that are true. No kinematic concept could ever substitute. So the next time you are flying, no matter where you go, don't worry about rotation, 'cause we ain't on no damn globe. So here's a lesson for who's listening. It's dynamics that are true. No kinematic concept could ever substitute. So the next time you are flying, no matter where you go, don't worry about rotation, 'cause we ain't on no damn globe. Hidden in the winds, Coriolis just ain't hidden in these winds, and the Earth ain't moving faster with the further south we go. So thank God we won't be crashing when those wheels hit down below. Hidden in the winds, there ain't no Coriolis hidden in the winds, and thank God it's stationary, or we never safely land on a surface that is moving with a tangential gradient. Yes, here's a lesson for who's listening. It's dynamics that are true. No kinematic concept could ever substitute. So the next time you are flying, no matter where you go, don't worry about rotation, 'cause we ain't on no damn globe. Hidden in the winds, Coriolis just ain't hidden in these winds, and their Earth ain't moving faster with the further south we've been, and thank God we won't be crashing when we touch down at the end. And thank the Lord, Earth is stationary, or we never safely land on a surface that is moving. There's no tangential gradient.
I said on a globe model, you being on a certain point of it when it's tilted at a certain degree in a certain time of year, and the sun not setting, that works. What they see, as I said earlier, makes, with the stars around you, it makes perfect sense to what they are observing.
Making sense doesn't make it true.
You just like literally.
Right, but I'm just asking you, how does it make sense if the Earth is flat then, and what place do I stand, and how does it make sense that I see this phenomenon where the sun just basically rotates around me quite low in the sky?
Because the sun isn't an object, dude.
Okay, what is
it? It isn't a ball. It isn't a ball of stuff, dude.
What is it?
Fuck if I know.
You don't know. No one knows, dude. Get in line. You want to know? Get in line.
And there's a reason why I say it's not a ball of stuff. Because when we take this model that predicts the 24-hour sun, right, and we say we actually try to use it in a three-dimensional way on a three-dimensional globe, the lines of sight to the sun don't intersect at a common location, and If you use it on a flat Earth, they also don't. And when I say don't intersect at a common location is, let's say I'm in Johannesburg and I'm in frickin' Brussels, Belgium, and it's a certain time of day, we both decide to look at the sun. Right? We see the sun in the sky at the same time, mid-simultaneous time. I measure the azimuth and elevation angle. They measure their azimuth and elevation angle, and then we go, okay, let's map this. Let's model this onto the surface of the globe. Well, if you draw those lines of sight, they don't intersect in 3D space. Okay, so when I say, hey, the sun's not a physical object, physical objects, when more than one observer looks at them, their lines of sight intersect at the object. But the sun doesn't do this. Okay, and people, it doesn't even do it within the heliocentric model itself. This is what I'm talking about. The heliocentric model is a bunch of ad hoc shit because there's lots of observations that don't match, and people pretend they don't exist or they don't know about them.
And I assume that those observations, assuming they do, because I've not seen these observations take place, and human error.
I mean, several people have done it, right? Several people have done this,
human
right?
error, right? It can always be a thing here.
Well, no, they use the model. They use the time and date. They use SunCalc, and then they get Blender or AutoCAD.
Using a model doesn't eliminate human error. They take measurements themselves.
Well, no one observes the sun like that.
No, but anything where humans are taking measurements. I mean, are you saying that no measurements that have taken place does this model work, or in some does it not work? Because there's a big difference between the two. Because you would expect some measurements not to make sense because human error is always an element in any.
I'm talking about if they take SunCalc or time and date, which is what frickin' the final experiment used to predict whether they'd see a 24-hour sun or not. They use these models. You take them and you model them to the globe. Sun is not in a common location. Meaning there's a unique sun for each observer that you would map to the surface of a globe.
So if you was to get,
it has a unique position.
Yeah, so if you're on person A there, and let's call the other one person B, and then you get on a plane, and then you fly west to person B, and you go fast enough so that you see that, like, does it not remain the same sun all the way around? Like, it's just very confusing how you almost say.
I don't know.
You can do that. Like,
I don't know if anyone's ever done that shit. Chase the sun.
I mean, but I can get on a flight from California to Australia and effectively chase the sun. Like, you can be on the sunlight for the entire of that flight.
I don't know how any of what you just said adjusts what I said.
Because everything that I'm saying works on a globe model, like the 24-hour sun. The fact that you say these measurements don't work. I mean, firstly, like I don't know the sources of this.
Don't work? Time and date and SunCalc.
Yeah. Okay, so you
those are websites, right? And you can go on there, and you can take any place on Earth at any time, and it'll give you a value. Azimuth, elevation. Elevation would be how high is it above the horizon. Azimuth is it's the direction to north. So you can take this value and you can put it on a globe, right? A 3D model of a globe. Boom. And then you can take another one, second observer. Boom. And then you can take that angle. That's the direction the sun is supposed to be from that observer location. And extend the line out forever. And then you can take the other second observers and extend the line out forever. And see if those lines cross each other at some location. They don't. That's what I'm trying to tell you. They don't cross at 93 million miles. They don't cross at fucking 125 miles. They don't cross.
How when you do this every single time, like, are they completely off, or are they just by a little bit?
Some have ended up behind the person.
Behind,
yeah,
so like
behind
180
them.
degrees off.
Yeah, so like if you follow the lines, they're actually divergent, right? The viewpoints are divergent. So like when you join the lines converge behind the observer. On the other side of the globe, behind them. So they're looking at the sun, but the sun is triangulating to behind them, which makes no sense.
Yeah, of course it makes no sense. I would be really curious to see anything in more detail.
Okay, so I can give you another example. But a very specific one.
So, stick on that example. That's really interesting, though.
Well, it's just the same thing, but like you can easily check this yourself. You go on time and date, 2 locations, Tierra del Fuego in Chile, right?
I'm not in Chile, so I can't check it. There's no sun here.
Well, whatever, when at your convenience or never. Right. So Tierra del Fuego in Chile, Ushuaia, or Ushuaia and Tierra del Fuego, Chile or Peru, or Argentina, whatever the fuck it is down there. So that location. Now this is gonna be for the equinox, right? And we want another location on the same line of longitude, and because we want a simultaneous sunrise, and we're gonna get the direction of the sunrise. What direction does the sun rise?
East.
From these 2 locations, right? On the equinox. How many degrees?
Oh,
so you do Cont, Greenland, and Ushuaia, right? And if you look at the values, what direction the sun rises, in Ushuaia, the sun will rise at 91 degrees.
Right.
Okay, that's so 1 degree more than due east.
Yeah.
In Greenland, it'll rise at 86 degrees. So tell me, how can they both be looking at the sun, but they're looking in different directions?
Wait, so someone in the northern hemisphere is looking 86 degrees. Someone in the southern hemisphere is looking 91 degrees.
Yeah.
How do those? I mean, firstly,
yeah,
I don't know.
Those lines of sight don't converge.
Yeah, because one seems to go slightly north and one seems to go slightly south. Right? That's the point. Yeah. But what are those measurements from? You've just given me 2 numbers. I don't know like a source of it.
Well, the values you can go on time and date.
Okay. Can you
timeanddate.com.
Do this out of interest?
Yeah, I probably even got one, but probably from a couple of years ago. I mean, a link right to the.
Hello, Robert Utah just randomly messaged me and said, "Can't take down the spherical Earth, buddy. All flat Earths are doing is running up and down in blood pressure."
Be running up and down Jacob's ladder. That would be more fitting.
Okay, dude.
I'm trying to crack a screenshot, man. Okay, here's another thing, a topic with the sun. And this is going to seem obscure, but in 1597.
Right, you're linking me to time and date, but like I said, let's just concentrate on what you said there, where it would be Greenland at 86 degrees and Chile at 91 degrees.
Yeah, just go to the equinox date and look at the angle that the sun rises for each of those locations. I'm not going to do all, like, how fucking spoon-fed do you need to be?
No, that's okay. Now you've said that, right? I get what you're saying.
Anyway, so Barents in 1597, his ship was stuck in the Arctic, and it was the equinox, and the sun was supposed to rise, but it had already risen 2 weeks before that. And it rose every day in those 2 weeks before the equinox. And they knew where they were because they used celestial navigation, so they knew exactly where they were. But the sun rose 2 weeks too early. You have lots of instances like this. Like when they've actually examined and tested the accuracy of sunrise predictions and sunsets, they tested at 3 observatories, and the mean error is 5 minutes. And with some of the values are 14 minutes off. So when people say works perfectly, I have to call bullshit, dude. It don't work perfectly. It works good enough for practical purposes, and that's it. And if the sun doesn't rise, within fucking 15 minutes of when it was supposed to, no one calls the National Guard and says, "Oh my God, call the president. Something's wrong with the sun. It rose 15 minutes too late."
I don't know of any time that's happened though. I mean, I very occasionally.
I told you they studied it. I can find the paper if you really want. Where they actually measured the sunrises, right? So they said, here's the prediction of when the sun's supposed to rise based upon our models. Let's go actually do the observation and see if it matches the model.
Yeah, I'm interested.
The mean error, the mean value
the mean, the average value of the average precision of the model versus the observation was plus or minus 5 minutes. Now, I'm sure you've heard people say they predict eclipses down to the second. Well, how's that possible when they can't even predict sunrises to the minute? In the largest measured values they had was the sun rose something like 14 minutes too early, which is a large amount. That is a significant amount. See, this is what I'm talking about. This is an example. Like, how did we even get here, right? So always got to review. How did we get here? We got here because I said, hey, we went and checked. I don't know about everybody else. I went and checked.
Right, refraction. That's why, Indio. Come on.
Obviously refraction. When in doubt, refraction's like it's like you know how you got your secondary parachute when you jump out of an airplane, you got two parachutes, the backup chute. Refraction's like a backup chute. Fuck, I'm cooked. Pull the backup chute. My fucking chute wasn't open. Here, I'll try and find that sunrise paper. And if you go to like the U.S. Naval Observatory's website, they have a litigation section because often they're asked like for court cases like they need like sunrise and sunset times for some case, and they want like quote unquote authoritative value of what it was. And what it says is no agency in the United States government observes sunrise and sunset times. The times can be calculated to sufficient precision that are good enough for all practical purposes. That's what they say on their website. So they don't say it's 100% accurate. No one claims that. Only freaking goofball Glovers on the internet.
Oh, that's so good. That is a good one. You can imagine so many instances where someone, like you said, wants to hear from an authoritative source as evidence.
Yeah, dude, it's like it's not true unless they have a freaking shiny badge or something. It's freaking really weird. I mean, I was just brought up different or something. I was brought up like, it's doesn't matter who says it, it's what they say. That's where the truth is.
True. 2 + 2 is 4. Doesn't matter who says it. Unless it's a flat earther, of course. If they say it, they're wrong.
Yeah, automatically wrong. And not just wrong, we're going to freaking call you names because you're so.
Okay. But while I get that the answers to this seem to come down to atmospheric refraction, which you're saying is ad hoc, even though that's, from what I know, something that's been understood for a while, right? But you're saying that's ad hoc, no?
Actually, it is ad hoc.
Okay. But there is no answer for any of both of those phenomenons with the flat Earth model, right?
Well, I can tell you why it's ad hoc, because there's other things you would see with refraction that we don't see, right? So refraction is just not like this one-off phenomenon that just like moves shit up or down. And we know this because we design lenses, right?
But it specifically takes place in the lower atmosphere. But
there's other. Yeah. I know the story, but we should see other visual phenomenon other than things being moved around. It just doesn't displace things in space, right? Make things appear up higher or lower. Yeah, you get distortion. You get something called chromatic aberration.
Yeah,
meaning the colors of it will turn into a rainbow, right? So it'll appear more blue on top and more red on the bottom, because you're actually seeing a double image of the object, and not a double image in the sense of like an inferior or superior mirage. A double image as a blue image. You're seeing a blue image and a red image superimposed on each other, but they're displaced a little bit spatially because the blue light takes a different path than the red light. That's what happens when there's refraction. That's how a prism works. So if there's like this crazy extreme refraction, in the case of baryons, it said it's something like 4 degrees, dude, you would literally, so we see it, they compensate for it in astronomy. Just for some reason, there's no compensation terrestrially, even though it's the same thing, even though you're looking through arguably a worse condition. But nobody has dispersion correctors on their freaking, 400 millimeter zoom freaking cameras, zoom lenses, to take a picture across like some large distance to correct for chromatic aberration. You know what they actually do? They actually do the reverse of this.
They use epichromatic lenses, which correct at the lens to make sure the lens doesn't cause any chromatic aberration. But if the lens doesn't, that means whatever is out there in the air will be even more visible.
But the lens is a sharp boundary between those two medians, right?
What do you mean?
So, yeah, so the lens, yeah. So it's just, yeah, but whereas the atmosphere doesn't have that. It's like a gradual density, and the gradient changes slowly.
Doesn't matter. That would make it even worse.
Would it? That's not from my understanding.
Yeah, the longer the optical path, the greater the spatial separation is going to be, because it has more distance to do it in.
No, because an initial sharp change in boundary would result in the largest change, right?
No, it's continuous. It doesn't just stop. It's not just at the boundary where it happens. It happens through the entire medium. Refraction depends on the wavelength of the electromagnetic radiation. So blue light and red light will take a different path. In the medium itself, it's just not on entry. Yeah, but it's not just on exit. It's not like, I know you're thinking of a prism, showing the white light at the prism, and you see, when it leaves the prism, you see the rainbow. But it's actually being separated inside the prism.
Yeah, I mean, firstly,
it's not happening when it leaves; it's happening inside.
No, we're talking about a very minimal change here, for example, as well. Like, we're not talking about the amount of refraction that you see with a prism, because that's a large angle change.
Well, they see it in astronomy. They make something called a dispersion corrector for telescopes.
Yeah. I mean, you would, because when you're talking about something that's that far away, surely you're going to have to make some correction there to get anything that attempts to be accurate. But the sun is, orders of magnitude.
What do you mean, that far away? Is it being refracted in space?
No, it's being refracted through the atmosphere, but your accuracy when you're talking about multiple orders of magnitude further away that astronomical other suns and stuff are from our sun. I would imagine that would be the reason why they have some science there to adjust that.
But when you're looking horizontally across the surface of the Earth, that's where the greatest temperature gradient is, right at the surface.
What Indio's explaining is, for practical reasons, when people shoot long range, and these observations have been recorded, you can find them on YouTube, there are multiple effects, multiple temperatures, multiple temperatures, humidity zones over the distance of the shot, including multiple directions of air movement, which also affect things as the bullet is traveling, and all they can do is make their best estimate. It's dynamic.
And when you say we expect to see some diffraction, we do see some diffraction. Like the sun rising is perfect.
Dispersion, not diffraction, dispersion.
Okay,
what I'm trying to tell you is, if there is a significant refraction present in the air, you will observe dispersion, period. It can't be avoided. This isn't like an option.
Right, but when you look at the sun, you said you would expect, just to stick on this 1 second, you said you would expect to see some distortion with the light, due to this atmospheric effect.
Dispersion, yes.
Mediums.
Dispersion, yes. We don't see it.
But you do. I mean, that's not a perfect sun. That's distorted. Like
I'm not talking about distortion. I'm talking about dispersion, the separation of the colors of the white light.
Yeah. And again, there's some separation of the colors, but it's minimal between the two. Like it's so minimal because it's over such a small amount of distance.
You've seen the separation of the colors of the sun. You've seen a blue sun on top and freaking red sun on the bottom.
I said it's minimal. It is red on the bottom and it's white on the top. Like it's a minimal distortion.
Yeah, which demonstrates there's no refraction, dude. You don't understand, dude. The more refraction you claim, the more dispersion there has to be. It has to exist.
Right.
They are intrinsically linked to each other. So the more there's a refractive gradient, right? So there's a gradient of refractive index. The more of this there is, the greater the separation are going to be of the colors. Because each one takes a different path. Dude, in anything, refraction itself depends on the wavelength.
But what I'm saying here is it's a very small amount. So in a very small amount of refraction,
I know.
Complete separation between the colors, right? That's from my.
Well, a very small amount of refraction. Yes, exactly. If there's a large amount of refraction, less dispersion. If there's a low amount of refraction, you'd have little dispersion. If you have a large amount of refraction, there'd be less dispersion. But these observations we have where we hear, well, there was extreme refraction in that case, there's no corresponding dispersion to it. But that's why it's ad hoc. I'm trying to tell you, to start it with, you asked me, it's ad hoc. You'll say it's ad hoc. I said, yeah. And this is the reason it's ad hoc, because there's no actual evidence for it, right? It's ad hoc to stop the globe from being falsified. It's like, oh, shit, if this observation is geometrically correct, it's falsified. Oh, let's have an ad hoc hypothesis that saves the previous hypothesis from being falsified. But without the evidence, corresponding evidence. It's not like they found refraction evidence first, and then we're like, let's apply it to this globe we measured. It's like, we know it's a globe. This observation would show it's not a globe. How can we explain this away with some phenomenon? We'll just say the problem, we know that that's light. Let's say it's refraction, bending the light and flattening everything out. That's what makes it ad hoc, because there's no corresponding other evidence.
Okay, so
but we know this other corresponding evidence does exist in nature because of astronomically we observe it.
Yeah, I don't quite think the two.
No one's ever taken a picture of a red blue mountain, dude. Sorry, it's never happened. But they have taken red blue Saturn pictures, red blue star pictures, red blue fucking sun pictures. I don't know about the sun. I don't think the sun has. The sun might wash it out, so it might not be visible.
Okay, so you're saying we see those refractions within other planetary bodies, but we don't within earthly bodies that are here like a mountain, because it goes through such a small amount.
What I'm saying is, for astronomical objects, we do observe this effect, the dispersion effect. Not necessarily the sun. I don't think I've ever seen it with the moon, but I've seen it with Saturn, Jupiter, stars. Right? They make something called a dispersion corrector, where it'll you basically turn a mirror and it'll merge the double image. So what it does is the light comes into the telescope. Inside it splits the image into two images, right? And then those images, they have a mirror, and it's reflected onto another lens. But then you can manipulate each mirror to merge the two mirrored images into one image, right? So you can take the blue image that's off a little bit from the red image and overlap them so that you get a single image without this dispersion. This is not necessary with any terrestrial observation. I've never ever seen, but the thing is, what's the point? The point is that this is just saying, hey, you made a terrestrial observation. This is caused by extreme refraction. This allows you to do this. But the extreme refraction condition would have other things that we'd observe. When there's extreme refraction to the astronomical bodies, we observe this red-blue freaking dispersion. We don't see it with terrestrial bodies ever.
Would you have some photos of this red-blue? I can't seem to find this with planetary.
Yeah, I'll show you. Hold on.
I just Googled it. I Googled dispersion corrector telescope, and it showed them in the AI's first response, explained it exactly as Indio explained it. I go to Google Images, and they show thousands of examples before and after using the corrector.
That's okay. That's okay. I just want to see it. I'm
not being a dick. I'm just saying, so it's quick and easy for anybody listening to also do this.
I apparently Googled the wrong thing. It took me into redshift and blueshift, which I don't think we're talking about here.
Well, the only reason I'm saying, because red and blue are at the different ends of the spectrum, of the visible spectrum.
I get that, yeah.
So they're going to appear
come back to the boat.
So there's dispersion with Saturn right there, right?
Yeah, I see that.
That's pretty easy to see. It's fucked up. Now, we observe this in regular lenses too. So we have lenses have to be corrected for this, and this is why we don't. This is the main reason we don't use refractor telescopes over a certain size, because we have a big thick glass lens, and we'd have to correct, like when it came out of the first thick ass lens, like say you have a fucking, what is it, a 10-inch lens at Mount Wilson or whatever the fuck it is. When the light comes out of the lens, you're gonna have a double red blue image, and then you're gonna have to recombine the image. But then you get, like, because you're going through a whole bunch of other lenses, the quality of your image starts getting degraded. So we get to like a maximum size, we're going to use what's called a refractor telescope, and then like after that we use mirror telescopes where you don't have this problem because the light's being reflected, not refracted. So we do this, right? A lot of terrestrial observations, they make things called apochromatic telescopes. Dude, what are you doing? So okay, so one of the long distance observations from Canada to called Bars Day Cranes or something. It's 200 and what is it off the top of my head? I can't remember. It's 253 miles, right? 412 kilometers. They use an apochromatic telescope. That means at the telescope itself, the telescope is corrected so that the telescope, because you could always say, hey, I took this picture. I see this, what do you call it? I see this dispersion. Someone can go, well, that's the camera. That's just a shitty camera. They have crappy chromatic aberration. But this particular picture has an apochromatic telescope. So it's specifically designed so that you won't have any chromatic aberration in your photographs. The photographs taken with this show that they're out there in the world. There is no chromatic aberration of any image, of the shot, like 412 kilometer shot. Because often we do these, like I said, these long distance observations, and people go, hey, there's a refraction, extreme refraction, that all these things. And like, There's no actual evidence for any of it. That's the point. And the reason I even got alerted to this is because they did this test. They did a laser test. They used 3 lasers across the Hawaiian Islands, and they shot it from one Hawaiian island top to the other. And they were trying to measure turbulence. They shine the laser. They have one telescope. They pick up all 3 lasers in the telescope at the same time. Well, these lasers are all different wavelengths. And then someone did their master's thesis on it, and they modeled it all out, and they said, well, because refraction, this telescope is beyond the diffraction limit, this experiment should have never worked.
Right. So just to summarize,
because each laser should have been separated by a total of 20 meters, but the telescope itself that they picked the light up in was only 4 meters wide. So how, if the light is separate, if there's refraction and the light's separated by 20 meters, how do they pick it up in the telescope that's only 3 meters wide at the same time and do measurements?
Right. So like, yeah. So why do we see full chromatic aberration like to red blue with planetary objects, but not the sun?
Yeah. Well, and in this laser test that I just mentioned, they didn't see it in that either, which was done by the Air Force and the University of Dayton and fucking Boeing and like, you know what I mean?
Yeah.
It was like a giant fucking grant for them to do this test. They weren't looking for this. They were doing an experiment on something completely different. But a guy that was part of the experiment, right? So like he took place in the experiment because you need the research to get your master's, right? You need something to write your master's about. So he participated in the research, and then after he got the research, now he has his experimental data to write his master's. He writes his master's, and he did the model for refraction, right? Standard refraction. This is what we should see based upon the lasers we use. And this should not have worked based upon the lasers we use.
Oh, let me read that.
I'll post it in the chat. It's called the multi-wavelength laser. I'll just get it. Characterization of atmospheric turbulence effects over 149 kilometer propagation path using multi-wavelength lasers and beacons. So that was the experiment, and I'll give you the fucking master's thesis.
I'll be honest, I would love to sit here and read a full study. It's probably just going to be the abstract.
You don't have to read that, okay? The only thing you need to know about that is that they did it. The fact that they did it demonstrates there's no refraction. Because this experiment should not have happened. It should never have worked. Dude, if you have a 20-foot fucking pole, can you get it through a 3 fucking foot door? Without turning it sideways?
Yeah, you can turn it sideways. That's fantastic.
Yeah, you know what I mean? Like,
yeah. No, let me like. I get you're asking a lot of questions. You got to like give me a chance to read some of these things. But yeah, fair enough. It's so
there's a graph. There's a graph that shows this is how much distance between rays. Like these are the distance between the beams that should have been if there was refraction. The telescope is wide, is narrower than this distance, but they measured in. So they took in all these lasers into the telescope at the same time, separated them in fiber optic cables, and measured the speckle path at the same time, which they shouldn't have been able to do if refraction exists the way Goldberg to say exists. There's no evidence it does. It's just something that's just repeated over and over.
Wait, so refraction doesn't exist as globe Earth say it exists? Is that what you just said?
Exactly. It doesn't exist the way that they think exists.
So how does how does it exist then? How does refraction exist? Because you've given me some examples of refraction.
It's more complex. It's way more complex. It's not deterministic. The fact of the matter is,
it just happens.
The air is not a continuous stricken medium, right? So there's pockets and bubbles and pockets of different changes of temperature, density, motion, you name it, right?
No one denies that. I mean, yeah, there's difference in pressure and temperature across.
Yeah, but it's not just horizontal. It's not just vertical. It's horizontal.
Oh, you think because the atmosphere continues up further than what we understand that goes?
Well, no. What I'm saying is horizontally, it's not one temperature.
Yeah, I get
so
it.
when they do these, when they model it, right? They use a spherically symmetric model where the temperature is the same at a certain elevation, all the way across the line of sight.
Everyone understands that temperature changes as you go up within altitude, though. I don't get what you're saying there when you say horizontal.
Yeah, that's not necessarily true. Temperature goes up for the first 1 kilometer, and then it starts going down. Yeah, this has been measured by like weather balloons and shit.
Temperature goes down as you go up. Okay, this is
not for the first kilometer.
I mean, I'll just give you an example. I walked.
The only difference is
I walked up Snowdon like 2 weeks ago, and one definitely got colder the further it went up, and that's about 1,000 meters.
Yeah, but was it windier too?
No, yeah, it's again, it's anecdotal, but the general rule from what I've always known is that roughly 100 meters is 1 degree change in temperature in a reduction. Wind difference aside, and it was fortunately not that windy of a day. It was quite good weather.
Well, that's anecdotal. I have it. I can show it to you.
No, my example is anecdotal, but from what I have always been taught and understood within science, like it isn't just quite as simple as temperature goes down as you go up. There are changes of that. From what I know, it then at a certain point starts to go up and then it goes back down again. That's from what I thought I knew, but I'm not gonna quote that as an expert there. But that was my understanding, was that it goes down and then back up again and then down again. But I could be wrong there.
Yeah. Hold on, I'm trying to find it. I've looked at this in a long time. I haven't even talked about this one. There's a guy who did a bunch of freaking.
Well, refraction throughout these. I mean,
he did a bunch of balloon flights, and it showed that the temperature actually goes up for the first kilometer, and then it starts going down.
Okay. I mean,
anyway, that's not the important part. The important part is
different topic there. Yeah. Okay.
Well, that's not the important. The important part is that the say like I have a spot 6 feet off the ground, and then a spot a mile away. How the light travels through that is the temperature isn't going to be like it's 50 degrees at me and 51 degrees at them, and then just like this smooth gradient. There's going to be pockets of air, right? There's going to be this pocket could be freaking 10 degrees warmer than the pocket, right? It's almost like the way they describe it are like beer bubbles.
He's imperfect.
Bubbles in beer, right? So there's like bubbles in beer. That's like there's pockets of different air temperatures and density between you and any line of sight, and how large they are changes. They could be bubbles that are freaking half a kilometer in size. They could be tiny where they're like a meter in size, right? So every time the light passes through one of these pockets, right, it gets moved around, right? Refracted up, refracted down. Goes in, refracted up, comes out, refracted down. Goes in, refracted up, goes out, refracted down. And this will just happen. So why we see like the scintillation of the stars and shit shimmer around and things
I get always see shimmer and light to the distance. It's flicker. Yeah.
So this it's a complex phenomenon. It's not some simplified spherical symmetric model where shit just gets lifted up and down. It's way more complex than that.
Yeah, but that doesn't disagree with when we go back to our original point we were on about way earlier, where
it disagrees with the whole fucking gradient. It disagrees with the whole gradient of shit up crap because there is no gradient.
Gentlemen, sorry to interrupt, but
okay. So here's where we get to where we clearly you don't think there's a gradient of the atmosphere. Is that what you're saying? There's no gradient.
Look, there's not a uniform gradient. It's not like that. It's not how it really is.
All right, but I think we've got to the crux of the problem there, because the model works with a uniform gradient, from what I know.
Yeah, and that's why it's a model. The 1976 U.S. atmosphere model is pretty much what everybody uses. But that's just a model, but that's not how the world really is.
But then we've got to the source problem. So you say there's not a uniform gradient, and that's why it shouldn't make sense.
Yeah, it's not. You could have a gradient for the first like 100, say 400 meters away from you, and then the next 400 meters it's inverted, and then the next one there's
some differences. Yeah, fair enough. When we say uniform gradient, we're talking in a general term there. So when you look at pressures, when you go up in altitude, that those pressures are going to vary, but there's going to be a degree of error within those variations, right?
Yeah, but that's not the claim. The claim is the general rule is shit is being refracted over the horizon because it's a fucking gradient. There's no evidence for that.
There's no evidence for.
There's no evidence for that.
Observations and.
There's no evidence of refraction in a fucking spherically symmetric atmosphere is curving shit up and lifting up over the horizon. There's no evidence for that shit. There isn't even a shred of evidence for it. Let me get to you. Okay. Has anyone ever observed this? You don't even have a model that actually predicts.
I've not done the science myself. But from what I've read, I wouldn't say there's no evidence on it. I mean, I can.
Well, I'd say from what I've read, I've seen that they admit there's no evidence for it.
I'd say Indio's been doing hold on. I'd say Indio's been doing a pretty damn good job over the last hour explaining everything he says, backs it up, and post shit in the chat. And Andy, come on. You are assuming this should be the way, but you haven't really proven anything. Indio has.
No, he's posted some sources and I'm asking some questions. That's fine.
No, I get it. I'm just saying that you got to think about it that way. Indio has been doing this
I don't deny for 1 second. He's been doing a very good job of discussing this and explaining some things. Yeah.
Well, I mean, why do you think? Let me ask you, Andy. Why do you even think it's the case that this happens? It isn't obviously based upon the academic literature that you've read and your extensive knowledge of it. So why do you believe it? That isn't meant to be an insult. It's only meant to point out that you have an idea in your head, but there's actually no evidence for the idea.
It's because the observations don't match the idea of us being on a ball.
Yeah, no. I mean, my idea of us being on a ball isn't just from one observation. It's a multitude of different things that make sense with that model. So it's
the point is the observations don't match us being on a ball of claimed dimensions. That's why these other things must be the case.
But when we get to the things where I don't think that your observations match it, like you just seem to give the answer.
And then you can turn the observation right into proof of the globe, because that's how it must be if I live on a globe. It's this continuous fucking circular reasoning.
No, it's like everything that I understand. So it's not. There's multiple points I can go.
That's a statement about you, dude. That's not a statement about reality. That's a statement about your own mind.
We'll talk about my own beliefs. Yeah, but I'm relating to this back to my own beliefs, so it would be about my own mind.
Well, think about what you did, Andy. Like, it's almost like you guys have goldfish fucking memory. You posted Jaren's fucking whole fucking flashlight experiment in the chat, thinking it was evidence for a globe, but it was evidence against the globe.
No, I posted that really briefly.
Have you actually accepted that in your head yet? That was actually evidence against the globe. Because
I accept what's going on there. I admittedly said when I posted it, I've watched some videos and I don't have much of an understanding of them. At the same time, you told me to post the video, and I was like, I'm sure you guys all know the video, but yeah, I'll post it anyway. And you admittedly know more about it. I don't think from what you said, like I get the fact that the reflection there. Oh, sorry, no.
You're not giving it, dude. You keep saying you've seen observations that match the globe, but none of your observations match the globe. And when they don't match, you bring up. I'm not making it personal. When I say you, it's the fucking royal you. So you guys. Okay, all observations match the globe. Okay, here's one that don't. Oh, we have a hog explanation for that. Still matches the globe. Every observation, that's what T-Dub was saying, every observation will match the globe because you have a Band-Aid to make it match the globe, because you just add something. You're making it unfalsifiable. Like, what can falsify the globe, Andy? Like, tell me, what observation can we do? Where you can't add a Band-Aid, you can't add something at the end and say, well, the globe explains that it has some fucking widget.
Go into space and you can see
every fucking time, dude. Every single fucking time.
How is that so much of every time?
Because it's not falsifiable then.
Right, but is the idea of like, how can you falsify it? Well, you can go high enough up where you can see the whole thing. Oh, well, that's there you go there. Like,
it's not falsifiable. Well, that means it's not falsifiable.
Right. But
so was the globe like first proven, like when they first went to? Was the globe first proven when they went to space, or was it proven before that?
It was understood and believed before then. There were other elements.
Okay, so like prior to Sputnik, right? Nobody could even falsify the globe. It wasn't even possible. So at least prior to Sputnik, the globe was a pseudoscience. Hold on, dude. So the globe prior to Sputnik. Now Sputnik like went to orbit or whatever, right? So prior to Sputnik, the globe was not falsifiable.
Yeah, so we talked about other methods today, how you could do it, and I get you said there are some inaccuracies within those. So looking at planetary bodies and stuff like that would be the way that I would say.
Well, one second.
So if we saw square planets, would that prove the Earth is not a globe?
It would certainly question our understanding.
Oh, Jesus fucking Christ, dude! You're making me want to fucking drink.
It's like it'd be crazy. That'd be nuts, right? But we don't see square planets. So
how are these squares? We must be a square, dude.
Yeah. Would that not just question our whole understanding of physics and the fact that we never, ever see that? Does that not say anything to you? Like,
well, you see it in Star Trek, the Borg cube, man. Maybe it's just a fucking Borg cube.
Exactly.
Hey, do you take over for a second, dude? I got to do.
Well, what about that huge ass piece of whatever it was that they said passed by Earth there a few years ago? What did they call it? Some Hawaiian name or something? It was like really misshapen and really long and not a sphere, right?
Yeah.
What happened there? What happened with physics there? Why didn't gravity kick in and turn that into a sphere? You know. But I wanted to ask you, right?
Well, let me answer the question. You asked me a question, and then you're moving on to something else. So let me just answer really quick. So what I know of this, I assume you're talking about a meteorite that's not in a perfect spherical sort of form, which
it's not anything. It's just
because of the way that they're formed. So meteorites aren't formed from where you have a massive amount of gas. That we talked about the protoplanet.
Yeah. How do you know that? Can you prove it?
What y'all do? Let me finish my answer. I get that I haven't stood there and watched this phenomenon, but on this model of them doing this, like
what model?
Meteorites.
What model?
Yeah,
what model?
Protoplanet model we discussed.
You have a working model?
Yes.
How about you put the ball with gas pressure inside the vacuum chamber?
Can I just finish my point, please? Of why? So meteorites on that are formed from other things, such as impacts between planetary bodies and stuff like that would form more jagged and distorted rock bodies.
You never saw that. It's a fairy tale story.
I haven't seen that.
But I wanted to ask you, Andy, like, okay, because you said what would falsify the globe? Is this like being able to go to space and see it, right? Is this the standard that you have set for yourself?
I guess
I would only accept any claim about the nature of the shape of the Earth if I myself could go to space and see it. So that means like nobody else's claim first-hand experience of that. Right.
Yeah.
So is that just applicable? What I'm asking is that just applicable to flat Earth, or will you accept somebody else's like a second hand?
I would. So yeah. Right. So let's say the general consensus within science shifted to the fact that we were wrong all this time. The Earth is absolutely flat. All these models we had were entirely incorrect. New science completely disproves that. Here are many peer-reviewed studies, and the consensus within science shifted.
No, I'm not talking about that. We were putting that aside. It's just the standard that you gave for falsifying, like the globe, right? So
okay, I thought you were talking about what would shift my mind.
So because that would be looking at what it falsifies, right? Like as in. It would be falsifying one thing or another thing or a multitude of things, right? So that's the standard that you've set for yourself. I'm only going to accept, right, claims about the nature of the Earth, which I have first-hand experience of by going to space far enough away from the Earth to see it, right? So you're not going to accept globe Earth, you're not going to accept flat Earth, you're not going to accept donut Earth or pyramid Earth or any other Earth unless you can get far enough away from it and see it for yourself, right?
No.
No. See, this is the problem. That should be, if that's your standard for one thing, it should be a standard for all things, for all claims about the shape of the Earth.
But does everything else not work on this model that we live in today? I get you guys disagree with that model, but let's talk about like GPS systems, satellite communication.
We are not living inside the model. And you talk about satellites. Yeah, what's your problem? We have a guy. He's a flat Earth guy, but the guy was a global. He went to Antarctica, and now he is working with the satellite companies. One of those companies are working with microsatellites. Yeah, and they are using cameras with flat lenses. No more fisheye lens. So they are pointing down, and you see it's flat. Interesting. Isn't interesting talking about technology?
I don't get your point. Sorry.
And you want to talk about satellites? You want to talk about satellites? We have an ex-NASA technical that did work with satellites, and in his papers he had to account. He was doing programmation. He had to account a flat stationary Earth. Very interesting.
You have so there's one NASA technician who's come out and said the Earth is flat. Is that what you're saying?
No, he did work with satellites.
He worked
with satellites, yes. Yeah. And in his papers, he's saying that he has to account like a flat stationary Earth.
Okay.
So he has to do the programmation according to a flat stationary Earth. Why is that?
So, but essentially, what you're saying is like one guy that works in the industry has come out and said within.
We have more people that did work to NASA, and they are talking about flat Earth. Thank you.
Okay. Is it many? Because I don't know many.
It is many. Also aircraft. Related with NASA.
Like aircraft pilots, okay. Related with NASA or just because general
NASA?
I mean, like commercial aircraft pilots would surely be in on this as well, right?
No, it's NASA Origin.
Can I ask how many is enough? Is it 51%? Is it like 50.1?
If 51% of all these people that work within the industries were saying that the Earth is flat, then hands down, I would be like, well, this is really suspicious and questionable for me. Yeah, like I would very much be questioning my own beliefs.
Well, hold on, you're broadening his example. His example were designers, creators, not users and people that just work on airplanes and stuff like. No, the design.
And by the way, you've never communicated with a satellite in your entire life. You never will.
So when my GPS, Google Maps,
you're not communicating with the satellite. You're not communicating with. Do you think you're talking to the satellite?
I think talking is an incorrect term there. I think it's sending data.
Communicating. Are you communicating with the satellite?
Yes. Yeah, I think it's bouncing signals.
What does your GPS say to it?
No, that's it's not giving individual data to it. It's sending it. It's getting measurement.
Yeah, so it's not communication.
Yeah. Although it's a very base element of communication. So from what I know, it's basically working out where it is using the time it takes to send.
Okay, when your girlfriend is screaming at you, not letting you talk, is that communication?
Dude, I'm on the internet at 9:30 on a Monday. I don't have a girlfriend.
I'm just saying, if we just screamed at you and then while you're muted, would you consider that communication?
Technically, yeah, sure. Why not? It's really bad.
No, not really, dude. You wouldn't consider that communication. It's not communicating with anything. It's passive beacon. Passive means you are just passively accepting a signal. and it doesn't use a globe either. So,
but it's two-way though, right? Because even if the basis
not two-way.
back, no, but it gets back the time that it takes for that communication to get there, and
that's embedded in it.
But that's a two-way street. Like it wouldn't know that time if it didn't have a confirmation that came back to it, because otherwise, then how would it know that time?
Do you think your freaking phone is syncing up to atomic clocks, dude? What?
No, the atomic clock is on the satellite, from what I know. I don't think my phone has an
Yeah, but you need to be synced with it to know the time of flight, right?
No, my phone is synced with the time on Earth. The satellite has the atomic clock, so there's a constant time that's being updated through internet that itself is based.
How did you sync with the satellite? Your clock, dude, on your phone.
I just explained to you. My phone is synced through the internet to.
How did your phone do it?
Through a constant 5G signal, 4G signal, whatever signal it's getting through internet connection. Yeah, so there's an atomic clock on Earth measuring that. That updates many devices around it. Those devices communicate with the satellite. The satellite has the atomic clock. Those two differentials help work out the distance.
You don't know how it works. You're making shit up on the fly. Your phone
like I said from the top, that's my base understanding of it. But yeah.
Yeah, your phone's using something called network time protocol. And say you have, I don't know what your phone service is. They're using their own freaking network times. It's not synced to anything. They might sync it to somebody, like someone upstream, their clocks. But whether it's synced to an atomic clock, like on a Windows computer, it automatically gets your time. Now, typically, the time will come from Microsoft, but you can actually set it so that it gets it from the atomic clock at the University of Colorado, or you can get the one at Lawrence Livermore Labs. So you can choose what network time protocol server that you access in the first place. Like, you're not syncing to atomic clocks. The time is in the message.
Right, again, but this doesn't differentiate too much from what I said. Okay, so fair enough.
But the funny thing is, it doesn't use a globe either. So that's the funny thing. The coordinate system of GPS isn't in latitude and longitude. It's converted to that. It's actually the actual raw data message is only the time of flight in what's called Earth Center, Earth fixed coordinates, which is actually a plane called up, down, and easting. Those are the three Cartesian coordinates that it uses.
How does it work if it's not a satellite? How does it calculate my position?
Because the time of flight uses trilateration.
So it just works from what time of flight from the signal of the.
Yeah, and it has it has something called a pseudo range.
Yeah, it does that as well to a certain amount of accuracy. That's what it calculates my position from when it can't get satellite.
Well, I doubt your phone ever used GPS. Your phone probably uses network location services.
But network location services are they have a really large degree of uncertainty to them, so it gives quite a vast area. It shows you.
How would you tell the uncertainty, dude? Like, oh my God, my GPS, I'm actually a meter off. You'd never know.
I mean,
if I fire up the GPS in my phone right now, it's going to show I'm not even inside the building I'm in.
Yeah, that's not. I mean, my GPS does, so I don't know what your GPS is saying.
Yeah,
but
well,
if it's communicating with satellites within the building that you're in, then it can show it.
You're not using a satellite, bro. You're using network location service.
Yeah. Okay. So yeah, when you're on a Wi-Fi within a building, and then it has it can use
cell phone network
within that cell phone network.
The cell phone network. The cell phone network. You're using the cell phone.
So explain one thing to me. When you're outside of where there's any cell phone network, you can still use GPS satellites. How does that work?
Well, if you have it turned on, then you'll use GPS.
Yes, so I can download my map, and I do this regularly because I go hiking in the wilderness where there's absolutely no signal. I can download the maps from Google, and I can use my GPS to accurately tell me exactly where I am within those locations. So how does that make sense?
Yeah, because they have on-the-ground GPS transmitters. They're called differential GPS, or WAS, or there's a whole bunch of other systems too. They broadcast this exact same signal.
So you're saying that the conspiracy goes so far where they're broadcasting signals. Well, okay. So the lie goes so far where there's no actual 4G, 5G signal in the wilderness of the UK. Out in the Lake District, the Snowdonia Mountains, the up in Scotland, where pretty much all of it gets no fucking signal.
They're sending out. You think there's a ball in the way?
Let me finish my point because you're saying that in all those locations where when I go hiking there, I download the map and I track myself very accurately, and I can see that it's accurate because I have this map downloaded and it's within a meter. It's very impressive of the path that I'm on. So in all of those locations, how is that telling me that I'm right there, right exactly where I am? Is it okay. Are the satellites, are the signals or maps?
Because radio signals, because the GPS signal travels a lot farther than you think because there's no ball in the way.
Right. So really, my phone is getting signal, but it's telling me I'm not getting signal.
From transmitters that are on the ground. Yes, it's getting signals from that.
Yeah. But
not a cell phone tower, because a cell phone tower is a different band, right? Okay. So different bands have different penetration strengths in the air. Also, depending on the antenna, they also use different powers. Typically, things like cell phone telecommunications signals. GPS is like 2 point. Can't remember off the top of my head. Frequency.
It doesn't use the same exact signal as the internet or the calls on your phone.
Yeah, it's a different frequency, man. It's a different chip. It's a different frequency. It's completely separate.
And Andy, he did say it was ground-based. You just didn't listen to him. He repeated himself twice.
No, I got the idea. I get the idea that what you're, because of course from your idea it has to be ground-based. I'm not denying that you're saying that. The sort of bewilderment that I have is that out in all these places where there's, I can be in a location where I'm just literally just surrounded by large mountain bodies that are blocking out any signal. I have zero phone signal, literally no data. I can't even make emergency calls, which is run off 3G networks. But I can get GPS data. It connects to, and it can, on my drone, it tells me how many.
So look, check this out.
So you're saying that this is taking place on a different.
No, you heard what he said. You heard what he said. It's like I hate when you say something and he's like, so you're saying, yeah, that's what the fuck he's saying. Like, chop the conversation time down a little further. Second of all, it's like I've been listening for a minute, and it's like, it's like they never actually claim. They just have incredulity, and then they're like, are you making a claim as to how this is working? Are you saying that because you live on a ball, this GPS is working in the way that you're saying it does? Or are you just here to be like, I'm saying I don't know how else this could happen, because if I got mountains around me, it can't be what you're saying it is, and I'm not necessarily making a claim, but I am saying
no, I'm making
kind of odd.
Yeah, no,
so make the claim. So make the claim.
Because this claim works everywhere on Earth.
So make the claim. Let me hear it. Make the claim.
You can tell me to make the claim. I'm trying to talk. So the claim is that when I'm in place, when I have absolutely no communication with satellite, with anything other than satellite. So this can be in the middle of the ocean. This can be, when I'm on a plane flying to somewhere. This can be when I'm in the middle of a wilderness, for example, Scotland or any other place. I have a location data on my phone that tells me exactly, very accurately, where I am. And there's no way it can do that from communicating with satellites.
It's a very vague claim. That's a very vague claim.
No, it's fine. But is that all you're saying?
I mean, that's the basis of the claim.
Well, okay. So there are things above the Earth. So, do you have anything further to that?
Okay, so you're saying there aren't things, or you admit that there are those satellites?
No, I'm asking you, right? Aren't I? Isn't it your claim? I said,
very basis. I mean, sure, we can go into more detail. They orbit the Earth, but yeah, my base claim here, and it's
okay. Orbit is in a circle, or what do you mean exactly?
Yeah, orbit would be a circle. Yeah.
Around a globe, you mean?
Yeah.
So that's the claim. All right. How do you know that?
Well, that's very part of the claim. But we're talking about how they give me information compared to where I am on Earth. I'm not getting into the detail of how the orbital mechanics.
You made huge big logic. Huge.
Okay.
I go to the woods. I downloaded
let's
a map.
go back to the base claim.
I saw a little crosshair, and I can't make a phone call. Therefore, there's satellites in space orbiting the fucking Earth, and I'm on a ball.
Well, it's not just I'm in the wilderness. It's literally in the middle of the ocean. Nothing else around.
When have you done that?
Presumably.
I've done it on a cruise ship. I've done it on a plane.
And you're assuming. It's a presupposition that there's nothing else could possibly communicate with your little handheld phone. That's what you're relying on. That's why I said it's a vague claim. Because you're not listing any locations.
The devices that are on these bodies that I'm on, the plane or the cruise ship, or maybe there's devices out here in the wilderness that are falsely telling me, or not falsely, sorry, but telling me where I am from other devices, and then masking how they're doing that. Is that?
Do you understand how that works though? When you download the map, do you understand how the equipment that you have, let's say your phone, do you understand that inside of it, like if your GPS part of your phone was broken, it would still use the accelerometer, the gyroscope, the magnetometer, or magnetometer.
I get how those are the things,
but here's the point, though. Here's the point. When you take your phone, okay, and you download the map, and you have a signal, and you're like, okay, and it's using the towers to triangulate your position on the ground, okay. Then let's say you break the GPS part of it. You're like, okay, now I'm going to be lost. No, as long as you download the map, and you can even lose your internet signal and your cell signal. But it knows if you take 100 steps to the left, it's a mathematical thing in the app, and it's using the phone sensors. And in the map that's on your phone, it will move you. It will know that you will know that. It's not going to be exactly precise, because they do say that it's still off a little, but it's not using in this junction. It's not. I'm saying it's not necessarily using the satellite.
It's called, hold on. Just to clarify, it's called inertial navigation.
Right.
Right.
I get the inertial navigation.
It calculates how far you move based upon the accelerometers in your.
Yes. Right. Yes. So that has so as you move further, right, that's going to have a knock-on effect of the inaccuracies, because you give one inaccuracy and then that's going to multiply every time with that inaccuracy. So if you want to use that for something like a missile, all right, which goes in a very sort of straight trajectory over time and also takes information from other data, it can be a very effective tool for when other data is unavailable to it. But if you're going to use that for a phone going through a wilderness where you're not going to get any communication with other devices for a long time, it's going to be a terrible thing, because those little small inaccuracies are going to multiply over time into such a high magnitude where that data is just completely unusable. But that's exactly what we don't see when you use GPS data. I could be in the wilderness for 1-2 days. Let's say I'm doing Mount Sully in Scotland, for example, where you have to basically wild camp to get to it because it's so far away from any road even. Like the GPS data is accurate to like a meter while I'm at the top of that mountain, and even when I get to the bottom of it and I'm in the valley again, it's accurate to like within a meter. It's so perfectly accurate. So that just doesn't make sense from what you're saying there.
So do you think you'd be able to get that with the ground-based system? Does it have to be?
I think if you set up a network of ground-based systems around the globe in every wilderness and everywhere, then you could give someone that system to do that. Absolutely. I think the idea. Let me finish my point. I think the idea that will be done to mask the fact that it's getting done from satellites is a ridiculous claim.
It's already done. I already told you. It's called differential GPS, dude. It's already done.
So all these ground masts are set up around the globe, and
you keep saying
they had a system called differential GPS, which is undisputedly ground-based GPS that will appear on your phone as a satellite and will give you your location.
You're saying this is placed
all over the place. They're all over America. I know that.
Right, you're right. But you get the GPS works everywhere. Like it's not.
I just. So for example, let me give you one example. I think you're making that up, Andy.
I recently went to Morocco and climbed Mount Toubkal.
Once is not a trend.
So I was going to make my point anyway.
No, it's not. Once is not a trend. I know where I live. GPS is fucked up, dude. Where I live, it don't work very well.
That's fine for you. It's never. I've never had. Sorry, someone's hot micing me. I can hear my voice going through. Which I love it to a certain extent. It's a bit off-putting.
Hey, Andy, why don't you just Google what differential GPS is? And the definitions, hold on, just shut up. It says transmits correctional signals to GPS navigation equipment on board vessels. So you are of the belief, the assumption, that GPS is the shit when differential GPS corrects the navigational equipment.
Here's what I think's happening here. I think there's a system, the GPS that works, and you're being like, no, there's something else. And that's differential GPS. And just because that exists too, it doesn't disprove anything that I've said. Differential GPS isn't going to explain. You can use this as an addition to the GPS system, and you can use it to make readings more accurate, and that's absolutely fine. I have no doubt that it does within that GPS system. But it doesn't disprove anything that I've said. Differential GPS isn't set up worldwide. Okay, there'll be no sense of that. It just doesn't, from the basis of it. That's a crazy.
But you were just making the primary argument that it was stack tolerances and little discrepancies over another discrepancy makes it inaccurate, where in fact it makes it GPS accurate.
No, you really misunderstand my two arguments there. So if you're working, firstly, the initial argument was like using gyro data of a phone, and that's where I specifically said, if you're going to use gyro data that has an inherent inaccuracy over a long period of time, those inherent inaccuracies are going to multiply to such an inaccuracy where there's just no point using that data. So if you use differential GPS, which has a constant communication with some other source, then that inherent accuracy, or that inaccuracy from whatever you get from GPS or differential GPS, would just keep to what it wouldn't multiply. It's just its own inaccuracy. So like that's not what I was saying.
I'm just trying to understand one thing. When Indio told you about that the GPS signal that we can have from ground-based towers or transmitters, yeah, it's really that, because it will be easy to understand if you just distinguish between the two signals, the GPS signal and we can have both transmitters and receivers in the same tower, GSM and GPS. You just have to know the GSM, you won't have that data or signal on your mobile phone when you are in a dead zone, because the GSM signal will just cover a short distance, like few kilometers, 5 kilometers for 4G or 3G. So it's just small distances. while GPS is able to cover huge, enormous distances
everywhere,
by
almost.
thousands of miles. By thousands of miles. Yeah.
Yeah, pretty much everywhere. I'm sure you can go to some, I don't know how GPS works if you get to the Arctic and the Antarctic. I know that, satellites around there, there's going to be less due to the orbit of them, but effectively everywhere that I've been, and this, like I said, multiple places, but most recently, around 6 months ago, in Morocco, to Mount Toubkal, where there is absolutely no phone signal. You're up in the Atlas Mountains there. GPS works perfectly. Absolutely perfectly.
It doesn't need to surprise you, because that GPS signal is able to cover hundreds and thousands of miles. So it's so easy to understand that, yeah, you can, if you are on a flat plane, let's say you are in the center of the north, the towers are, the nearest one is in Svalbard, the next one is in Alaska, and the other one is in Russia or something like that. Yeah, you can have triangulation with those towers, even if they are hundreds of miles away from you, because you are using not cell phone signal, not GSM signal, but GPS signal, L5 bands that are 1,000 something hertz.
Right. Yeah. Okay. So it's using such a high frequency that it's communicating with places that are all around the globe. Is essentially what you're saying. That's how that works.
Correct. If you have some questions about ocean,
and when I am in the valley and I have no clear sight, and by the way, let's keep in mind that high frequencies don't transmit well through solid bodies. Low frequencies do because of the high wavelength. You could potentially say, look, it's such a low wavelength that it manages to travel over that body. But GPS still works in valleys and places where you only have sight of the sky. How does that make sense?
Yeah, because GPS and those cell towers, they are not on low elevation. You can find them on low elevation only in ocean on some buoys.
That mathematically doesn't make sense. They would have to be so high that they're in orbit. I mean, I'm talking when I'm in a valley, there are mountains on either side of me, climbing up, thousands of meters on the left and the right. I'm in a valley. I can literally, I just see sky. And if I was to have a direct view to anything there, you're not even talking in orbit. You understand the maths of this, right? These things to my left, to my right, to my front, to my back, climbing up escalating, at a steep degree. How does that make sense?
It won't make
sense. Well, it has to be in orbit. Number one, on a globe, which we know it's measured and practically used as an oriented horizontal plane. And two, your claim also includes rotation of Earth, and then the satellite would absolutely have geostationary, meaning orbiting. No, what I'm saying is this would have to be the case, and we don't have any proof that the Earth is spinning or that it's a globe. No, it is correct that we don't have proof that the Earth is spinning or is a globe. In fact, we have evidence of the contrary.
You said that what I inserted would have geosynchronous, which satellites aren't. GPS satellites, should I say, there are geosynchronous satellites, but most satellites, you have communication with them over short amount of time, but you're constantly communicating with different satellites. They know their position, they know their exact time. That's how GPS works.
Yeah, just like my friend Neiman used to say. That's not true, I think. Sorry.
You think all GPS satellites are geosynchronous?
It's odd that when he's driving through parts of
geostationary, same thing, but it's
especially going over. Oh, yeah. So let me go ahead and do that first, and then let me unimpeded say what I want to say. So just like my friend Neiman used to say, he'd be driving through some parts, some places, and we get like no signal. He used to test the GPS and is getting no signal at all. Just communication just drops.
I was trying to get a better understanding. I think we've probably covered it before, but I still don't get the flat Earth sort of explanation for the celestial sphere. That still just doesn't make sense to me.
So the celestial sphere is I mean, there is different constructs of the celestial sphere. You know that, right? Because there is the one from your perspective that you do like a dome perspective, and then
I
there
mean,
is the
it's a full sphere. We see only part of it, but you know, at different times you can see the whole thing.
You cannot see the whole thing. Your eyes cannot perceive the whole thing, can it? I mean,
not at one position on the Earth. You'd have to go to different latitudes and wait for a whole year to go by. Because the during the daytime the sun blocks, being able to see all the stars, so You have to wait for a whole year in order to get every part of the celestial sphere. But that makes sense. Like, you understand the standard model of it, right?
That is a projection of the sky into a sphere. Doesn't mean that the sky looks like a sphere. It's a projection. Do you get that?
Yeah. I think that word does a lot of work. I mean, it looks like a hemisphere to me above my head. Like, I think that just the way our vision works, we see it's just a three-dimensional world, right? So if you look from one point in all the directions you can look, that the easiest way to describe that is a sphere, right? Like a camera has a certain, every pixel is a particular angular resolution. So like if you turn around in a circle and you look up and down, you pretty much describe a sphere. So yeah, it's the way that our eyes work in a way, but we map the stars to a sphere.
Yes.
So
Yeah.
that's
That
what I'm talking
makes
about.
sense.
It's like
But
it's an
is the
enclosed.
sphere? Yeah. Is the sphere of the sky, bro? Like when you're looking at it, what you're looking at, it's the sky doing that. The sphere projection that you are mapping is off the sky. The ground is not affecting that projection.
Right. So how does the sphere work on a flat Earth? Like, have you ever used the Google Sky Map?
I've Google Sky Map. Yes, I've used it. I've used it, yeah, a few times.
So with that, you can like look at the whole sphere, even underneath the Earth. It's better than like Stellarium or some of the other tools because the phone allows you to just point it at any constellation or star and see what you want to see. But you can also
You
like
asking something.
kind of
I
like
like your
turn it
question.
around.
Yeah, I like your question, but I gotta tell you this, right? When you try to add the mechanisms of the celestial to a description of a surface of the Earth, that there's not a full answer to that because the celestial realm, there's a lot of unknowns to that. A lot of information that you don't have, I don't have, and probably nobody has because there's limitations of knowledge about that stuff up there. We do observe a phenomena and we chart that phenomena, write it down on paper, project it into a sphere. But you asking about how is that being observed the way it's observed from the floor that we're standing on, and what is the mechanism that operates all that and causes the effect that we observe, and we don't have the cause of the effect in a sense, but I could give you some ideas. Have you ever heard of that you can combine there's probably a lot of things happening at the same time that are causing the phenomena that we observe, and some of that stuff we can speculate about, but I don't think we have every variable to add up into the equation to have a full answer.
That's fair. There could be multiple explanations for things, but I can't understand. I can't seem to think of one explanation. Like not saying that you guys uh stick to a model or claim a model, but I have seen flat Earth models where you have like the AE map and the sun is like going around in a circle, and the sky is necessarily going around in a circle. So you have sort of a hemisphere of stars over a flat Earth, um, but that doesn't account
Le-
for the full sphere of stars.
Let me tell you this, right? Let me tell you this. There is a celestial sphere that you spoke about before. You kind of talking about it right now. Is the grid of stars that is charted for the longitudes and, and latitudes and locations on GPS on the ground, right? That are used to give you kind of like a ground position. There is that celestial sphere, an imaginary, like an imaginary reference from the sky that you kind of like reference into the ground to tell positions. Does that? I mean, I know I'm not, bro. I'm not an expert on this either, so I'm not making all the claims. Okay, I'm just trying to communicate with you.
Right. There's a spherical coordinate system similar to Latin long that we use for the sky.
And depending that
It's very similar.
that star. There's stars that tell you that it's gonna be at a certain position, a certain time of the year, and you can do an angle to the location, the position that you are, and if you have the North Star available or the Sun available at a certain time, you can kind of tell ground positions on. You can tell your ground position. I know there's a lot of different ways of doing it, but it's kind of specific at the same time. But this is navigation purposes, celestial sphere, right? But there is
Hey,
also
Dylan.
another thing that. Oh, go ahead.
Yeah, I don't want to cut you off, but I do want to follow up on something you said earlier about how we have the observed phenomenon and then we make a model to try to explain the mechanism that gives rise to that phenomenon, right? And so far, I agree with you on that framing. I understand you personally reject the globe model, but can you at least admit that the globe model does provide an explanation for the observed phenomenon of counter-rotating celestial poles?
No, no. Well, an explanation, yes, an explanation. There is an explanation. I agree, but explanations, I could give you explanations as well, though, and that's not gonna determine, because like
And
I'm
I
trying
think
to
that's
tell you
exactly
guys.
what Dylan is asking.
Yeah,
That's
yeah, there
exactly what
is
he's
an
asking for.
explanation.
We have okay. So explain
Bro,
how
okay.
those observations are possible on a flat plane.
That is the
Like
separation that we have to make because the mechanisms of the sky are incomplete.
Okay, so what is the mechanism that produces counter-rotating celestial poles on a flat plane?
What is the explanation? Okay, I will give you an explanation. The city of God up in heaven at the center of the sky is rotating, and that is causing the movement of the sky. And as God is sitting on the throne at the center, and all the luminaries are following God's commands at the center. God is at the center, the Most High, and He's the one operating the mechanisms of the sky. That's an explanation. You know that, right?
Okay, can you provide any evidence for the existence of God?
I mean, bro, you don't have an explanation. Okay, the antecedent. I could make the antecedent argument that you cannot deny, but this is even superior to the globe explanation
No,
because
I can deny the existence
my
of God.
explanation is that will be foolish. I mean, a creator, a designer, because there's a design in place, and a design requires a designer. So
Is this a
what
flat Earth
God
debate
is,
or a creationism
what is?
debate?
Yeah, but
Yeah,
I was talking
I
to
don't
Dylan.
have a
You're taking it
problem.
somewhere else.
I think there's God. It's not the issue, but when you just your explanation was a single center. It doesn't. It's not a sphere, right? I'm looking for.
Dylan. I can tell you this. I was trying to take you there because the observation that is observed from many regions of the world. I'm talking about Canada. I'm talking about Texas. There's observatories that have these observations that I'm gonna talk to you about, right? From the CMOR, the Canadian Meteorological Observatory research. They have observations of celestial north and the radiance that are observable from Canada. That is called the. Have you ever heard of the radiant sources? The radiance. The 6
The radiant?
radiants. Have you heard of this? Yeah, the 6 radiant sources.
No.
So okay, let me just, because since we were talking about the celestial sphere, I'm just gonna post for something for you. I have the documents and everything, and obviously people can have different conclusions about it because the observation is one thing and then the conclusions is another one. But the 6 radiants from different points of the world, different observatories. Oh, look at this one. This one is talking about the celestial sphere. I'm posting it in the chat, right? Radiant distribution of meteoroids impacting the moon for 4 different lunar phases to the preferred solution during the first illumination in our model. And our model, different colors represent the mass flux impacting the lunar surface from radiant directions. The radiance, because the sporadic meteors, they all come from a specific directions, which that directions are what is called the radiant sources. So units in each of 2 times 2 in kilometer per day. Here the observer position at the moon's location, right? At the moon's location, the moon and Earth are removed, and the whole celestial sphere is visible. So there is a celestial sphere that has nothing to do with navigation. Okay, and that's what I'm trying to tell you, that the navigation is one thing. It's like a tool that you use to move from positions, and you can project a sphere, a celestial sphere, based on that grid to navigate from location to location. And then there is an observation of the sky that can also be projected as a sphere, but it has nothing to do with navigation. So we can make these celestial spheres and use it for different purposes, not just navigation. We can also talk about it about how the sky, you talk about the tilt of the earth or whatever, but the sky is the one tilting. That's what we observe, and the position of the sky kind of like changes within the year. And that celestial sphere that is projected, it's the observed phenomena that is projected on paper, like here in this model. You see, it says the model of the celestial sphere right here. It's just a projection. It's not what is observed. Is what is the data that is gathered together and put into a model and labeled a celestial sphere, depending on the use, on what you're going to be using it for. In this case that I show you is about sporadic meteor activity and from the locations that it comes from. In this event, it comes from the radiance and it's hitting the moon area. The moon area where the moon is at. When the moon is doing a transit across the sky, depending on the full moon or the new moon, it changes like a difference in activity of the sporadic meteor activity. And they looked where are the meteors coming from. They say it's from the radiance, which is 6 areas of the sky called the 6 radiants, and then the moon is moving through these areas of the sky, and it's also in a different phase. So there's stories about that. And on that story, that has nothing to do with navigation, we use a celestial sphere model. That has nothing to do with the Earth. You see right here, we remove the Earth and we remove the moon, and we can see the celestial sphere.
Right. I'm just wondering, like, how the celestial sphere can fit on a flat Earth. Like, it seems like we're inside the celestial sphere. So, like, on the flat Earth models that I have seen, not that you're claiming one, there's like essentially it's a flat or hemispherical.
Oh, you're driving, Dylan. You're not looking to what I showed, right? You're driving. You're not looking to the stuff that I'm gonna post, right? You're driving at the moment.
No, I'm not driving. I looked at what you posted, and I think I understand.
Okay, let
What
me
you mean
give you
by?
something. Let me give you more. I'm just gonna feed
Let
you
me make
more
sure I
stuff.
understand. Are you saying that the most of the meteorites are coming from particular directions of the sky?
Yeah, I'm gonna give you the 6 radiant sources right here. Look, these are the 6 radiant sources. It's
Yeah, hold on, Dylan. Dylan, just to clarify, your original question was that about counter rotating celestial poles? Like when you're in the north hemisphere and you look up, the stars are rotating one way,
We're
and then when
moving
you're in
on.
the southern hemisphere,
Yeah,
like was that what your question was about?
Yeah, like basically those observations that we would have on the globe, like the southern pole. I mean, you can explain the circling of the stars in the northern hemisphere if you just have like half of the celestial sphere, but you can't really represent
When
the
but when you go
second
to the
pole.
other hemisphere, yeah, in the other hemisphere they're rotating the other way. So basically, so
It's not
Gen
so
Z,
much
Basically, you want to, I'm trying to have a conversation to present what we observe of the sky without needing you to interject or anything. That's basically what
well,
it
no, it's
is.
because you're talking about
You mean, what do you mean? No,
some
no,
other
no. Why you
thing. It's
saying no,
not what
not
the
what I
original
said?
question you
No, no,
were.
no. Why you that doesn't matter. I'm having a conversation with him because he's asking me about what I think about it, and I'm gonna show him the information that I've come across and show him my perspective about it. And that's what I'm gonna do without
Okay, so
you
after you're done with
interrupting.
that, you can answer my question about how it's possible on a flat plate.
No, I don't
So
need
that's
that.
fine.
I
Go
don't
ahead and
need you
finish
to
that.
interject. If you interject again one more time, I'm gonna mute you indefinitely.
Oh, indefinitely. Okay.
Indefinitely, because you keep. I'm getting annoyed by you at the moment.
No, okay. I'm the annoying one. I
Because I'm
gotcha.
trying to talk to Dylan was kind enough to just ask me a question. We just chilling. I'm not trying to reply to him and just show him the extra information so he can himself like look at it and maybe find an answer because I don't have all the answers. I'm just giving him what
But
I
his
have.
question was about
But
celestial.
you are with bought and this and bought that. I don't want to hear your buts. I don't want to hear your yapping about anything. Can you mute yourself, dude? So I don't have to do it. Thanks. Okay, Dylan, going back. So you see the 6 radiant sources that I posted for you?
Yeah, these represent the locations in the sky where the meteorites are coming from most often.
Where all the meteors come from. All of them. I mean, what is called sporadic meteors, because of the sky, there are different phenomena. The sporadic meteors is a phenomena that happens in a timely manner. Like all the luminary, like the sun moves in a timely manner. The moon, the sun, the moon, the stars do all that. The radiants also have their cycles, and the sporadic meteor showers have like a cycle as well. They're part of the this is our more pieces of the celestial sphere that I'm trying to add to what you're asking about what is the celestial sphere, right? This is more pieces of the puzzle that I'm trying just to add for you.
Okay.
So
I mean,
from
that makes sense.
this, listen. Okay, from this, what they did, these circles are observed. They're called the radians, and what is built from the observation is like the celestial sphere of the sky. Look, this is in relation to 365 days of photography, right? I'm gonna show you they call them they do this in infrared, active infrared, which is electro opticals, and they do it in thermal. They do it in radio surveys as well. Okay, so different spectrums of light, different observations, different camera equipments that they do all of this. Infrared, thermal, all of those things. So you see what I'm posting you? This is what is projected into what they call the celestial sphere. And these 6 areas or the 6 radiants are called the north toroidal. You know the north, the celestial north that you talk about. NT, NT. You get it? the north
Yeah.
of the sky, celestial north. Okay, that's NT. Celestial north is the radiant that is around celestial north, where sporadic meteors source from that one. Then ST is the south aurorial. Is a region of the sky around celestial south. That's the other radiant. Above that, above the south one is the south apex, and then between the other one above is the north apex. Between those two, the north apex and the south apex is what we call the celestial equator, right? That's the celestial equator with that line that is between those two. And when you see as H, you see H. H is helion, where there is like an area of the sky where the sun is positioned. You see the sun, and then this circle is following the sun, moving with the sun, and that's called the helion radiant. And then the AH is at the other side of the sky, in the night sky, and it's called the anti-helion, which is antipodal to the position of the sun in the sky. There is the north aurorial, south aurorial, north apex, south apex, helion, and anti-helion. And this is like a graphic that is put for you in this manner so you can see it as the celestial sphere. Okay?
Yeah, that makes sense.
Okay. So this is just models. They tell you themselves this is models. Okay? These observations are done from Canada, the United States, from Peru, Ascension Island in the Atlantic, from Tierra del Fuego in Argentina, from Rocha observatories. These observations are just put together from a bunch of observatories, and you get the imagery that you get basically of a celestial sphere, right? So what I'm trying just to add you a few things about this. I'm not gonna add too much because I don't want to go too deep into this. But this is the observable phenomena. Look at this next one. We observe from the sky. We see these images, right? And this is kind of like a reference of the radiance when you're actually looking at them. When you want to see meteor showers, or you want to see where the meteors are coming from. This is how it looks from your perspective, like a smaller perspective. Have you ever been like meteor showering, observing the meteor showers that meteor shower tonight in this area, around this area? You gotta follow the radiant to see the meteor shower. That's where they come
Yeah,
from.
usually you'll get a particular part of the sky. There used to be they used to announce it on the news sometimes, like with the weather, when there was going to be a meteor shower, and they would tell you, oh, it's going to be at this time and in this part of the sky. Yeah, no, it makes sense. I mean, there in the globe model, like in the solar system, you have kind of a flat plane, and the sun is attracting all these objects, so it would make sense that you get objects coming from the plane
From six specific areas of the sky, from six window. Let's say these objects only come from these six specific areas. Does that make sense when the globe is just going through the vacuum of space, spinning at multiple vectors, multiple speeds all at the same time, and it's so specific to this detail that I'm giving you that this stuff. There's six areas of the sky. They come from only these six areas. Come on, bro. There's no like.
I mean,
mistakes
it
here.
kind of makes sense. It makes sense.
So yeah, but the shape of the ground, you cannot add
But
the
your
globe to
analogy,
this.
with
So
all
listen,
of that,
I'm
your
gonna just give you this
analogy.
one. The last one that I posted is this one is 365 days of observation of the celestial sphere. You see this? This is 5 days by 5 days by 5 days in the from documents. They looking at this in the infrared and in radio surveys. 5 days at a time. This is the chart that you get, and you're looking at 365 days of the sky rotating. the sky rotating. You see? This is the observable phenomena. This is what we see as the phenomena, and we project it as the celestial sphere or whatever. Now, what is the cause of the effects? That's a good question, right? What is causing this phenomena to happen? Now you're gonna say because we're standing on a globe, but that is not the causal mechanism, bro. Because you don't have any evidence for the curvature of the Earth. You don't have any evidence of the rotation of the ground that we're standing on. What we have is observable phenomena.
Right.
That there is an observable phenomena that we project into a model, and we label it the celestial sphere. Doesn't mean that it's a. It doesn't mean that is a sphere. We model it like that.
Right. That's when we look out in different directions, we can map the stars and we can use a spherical coordinate system, and the stars seem to hold their positions in that coordinate system such that a particular constellation is always going to have the same celestial latitude and longitude. Right?
Let me give you something extra, so you know. I'm just adding stuff in here. I'm just talking to you about this. I'm not gonna make any claims about shape of the Earth. How does a flat Earth or whatever? This is happening above our heads. This is what's happening above our heads. The Earth doesn't measure curving. Like we already know all the argument. I'm just giving you extra data, extra information about the sky, the celestial sphere that we label it as, right? And I'm gonna add something called Snell's window. Let me just find it real quick. That
I'm asking a simpler question, really. I'm
What is it?
asking like how does the flat Earth fit in the celestial sphere? Like to me, a sphere is
So
this enclosed space.
the flatter will
that would
be
mean that the stars are going underneath the flat Earth.
Okay, let me show you this, right? Let me show you this
Do
real
you
quick. Let
think
me
that
see if
the
you get
stars
this
are
one.
going underneath the flat Earth?
Let me show you this one, okay? Maybe Snell window comes into this one for you, okay? Maybe Snell's window comes to you. Maybe this makes sense to you. Maybe. Let me just show it to you real quick. Snell's window. Snell's window. Probably. I'm just gonna find general information about it. You probably can do more research about it. I'm not an expert on any of this. I'm just giving you extra information, okay? If you're gonna look at Snell's window, look at this. This. Snell's window, also known as fisheye view or optical manhole, is a fascinating optical phenomena that occurs underwater, right? When you look up from beneath the surface, the entire above water world, from horizon to horizon, is compressed into a single bright circular cone of light, approximately 97 degrees across, right? So you could be inside a medium, and you could be looking at another medium, and that medium is gonna look different from what it is. You get that? You're looking from one medium to another one. So I think this is one variable that probably have to be added into this observation.
Hey, so are you, James B, are you saying kind of like when you're underwater looking up at the sky, or when you're in the air looking down in the water, you're talking about that kind of view?
Yeah. Something like that. I'm not an expert on this, but I remember the first person I ever heard mentioning this was Indio, and I was like, wow, yeah, if the optics of the medium, one medium to the other one, yeah, there is something there. I'm just saying that we are in this medium, looking across this medium, then looking at that medium up there, and he's asking, what is a celestial sphere? It looks like a sphere. maybe it looks like a sphere to your eyes. There's a lot of variables that can cause something that is not a sphere look like a sphere, including this variable right here, or like a circle or whatever.
So are you saying that because of this lensing effect that water has? I mean, this is essentially like refraction, though, right? You
This is
know
Snell's
that
window. Yeah. That there's
this is
something.
why,
There's some.
like,
Yeah.
when you do celestial navigation, you're not supposed to take sights of stars close to the horizon because of that refraction issue. Like, you want to take them higher up in the sky because there is some distortion, but the the phenomenon of there being this total sphere shape still seems to be established.
You just refuted.
Yeah, but
They're not
You
saying
just refuted
refraction.
that yourself.
Hold on,
You just
hold on. They're
refuted
not.
that yourself,
Hold
dude.
on, hold on, hold on. You're making a prejudgment on this thing. They're not saying that as it gets closer to the horizon, refraction makes it difficult to determine the star location. No, you're looking for the thickness of the air. That's the problem with it. It's not about refraction. There's just a thickness of the air, and that thickness makes it unreliable. Has nothing to do with refraction. Refraction could be a part of it, but it doesn't mean refraction is everything that's going on there. There's a whole lot more going on there than just refraction.
Right, but
No.
the effect is that you don't observe the star exactly where it should be when it's close to the horizon. I think refraction's the biggest issue there.
What do you mean where it should be? How do you know where that is?
Well, when you want to get an accurate,
Oh, it should be a sphere. So if it's not there, it's where it shouldn't be.
right?
So
If you
it
if
only
you take
follows.
a sight
Hold on.
closer, if the star isn't where it appears to be, then you're not going to get an accurate sight. You're not going to calculate your
know?
position accurately.
How do you know that's not accurate?
This is just the recommendation for when you're doing celestial navigation. When you use a sextant, you're not supposed to take sights close.
Yeah, I get it
because it won't give you
the
accurate.
math, the math of celestial navigation assumes a sphere. But if the sky does not actually obey that rule, there's going to be an error. That doesn't mean the sky is not that is wrong. It means that your model is only accurate within a certain field of observation, and we know what that is: 30 degrees above the horizon to 70 to 20 degrees to zenith. So it's basically like a ring in the sky is where these linear angle relationships hold, and the rest of the sky they don't. Now, but I only jumped in because of you brought up Snell's window, and I want to explain this to you. This the U.S. Navy has actually tested this phenomenon from underwater. Now remember, it said underwater. If you look straight up and you're the right distance away from the surface of the water, you can see the horizon. You can see trucks. That's what they did. They were taking pictures of trucks on shore from underwater. Think about that for a second. Right? So you can see things because of the way the refracting medium is. The air.
Right. We know that the boundary between the air and the water, the speed of light is very different in those two mediums, so you're going to get significant refraction across that boundary layer.
Yeah, and we know we're in a refractive medium of air, so to draw conclusions that, hey, this part of the sky is no refraction and this other part is distorted because it is refraction, there's kind of really no justification for that. Basically, we look up, we can only use a portion of the sky to do celestial navigation, basically like a donut ring around you.
Right, that's where you get the most accurate measurements, but that doesn't mean that it's not a celestial
Useful
sphere. Though.
measurement.
Like when you map the whole stars, when you
I'm
map
not
the
saying
whole sky, you get the, we have this enclosed volume of a sphere. We use these spherical coordinates to represent
but
the
what
positions of
what
all
are you mapping?
stars. the whole sky, all of the observable stars.
Yeah, from where? Where's the origin of coordinates?
From any point,
Exactly.
the
It's
reference of
the model is a
celestial sphere is not dependent on
the celestial
where
sphere.
I'm drifting.
And the celestial sphere is a sphere of infinite radius. Okay, and the model is an observer-centric model emanating from a point which is your eyeball, not the surface of the Earth. It could be on any surface. It could be anywhere. You're making like leaps of logic, and things like the so-called southern star rotation. Stars, they don't rotate. The stars take arcs in the sky, and because they go into the lines of other stars, they appear in circles. But in the heliocentric model, they should appear in spiral, in orbit. So you should never actually see a circle at all. If you're one
You
star,
can see
one star
in
can never make
in
a
the
circle.
north, for example, you see the Big Dipper makes a big circle around Polaris. Like there's the stars that are close to the North Pole seem to circle the North Pole.
Yeah, but it should be a spiral in the heliocentric model. Otherwise, how would Big Dipper handle be pointing at Polaris from the west, and then 6 months later be pointing from the east? If it was just making circles, that wouldn't be possible.
It circles every day.
No, what you're seeing is star trails overlap into other star trails. These aren't 24-hour time lapses, right? They're doing something like a 10-hour time lapse because there's a lot of stars in the sky. They overlap into each other.
And the night is only so long.
Well, I mean, I guess you could go to the Arctic and take a freaking 3-month one. But this visual effect, you could actually just replicate, which I got a video with a guy that does game programming and design. Okay, so what he does, he demonstrates this same type of quote star trail effect by just using random dots on a piece of paper and another set of random dots on a transparency with dots on it, and just shifting it makes them appear a circle. I'll post the video in the chat. It's interesting.
Yo, thanks for that, Indio. Good thing that I said Indio and you popped in. I was just saying that you see all these effects that he's saying that that's what I was trying to bring to him. Like he's making assertions about the ground being a sphere because the sky looks a certain way. I say, bro, there's so many effects that you're not taking into account to just consider what's happening. Go ahead.
That's what I'm asking: is how in your model do you reconcile the flat Earth with the celestial sphere?
It's an observer-centric model. Some people call it personal dome of vision. That the mistake you're making is there's like you can apply some universal rule to the whole thing. No, and think about the world in a third-person, outside perspective type of reality, like a blueprint. But there's no evidence that's the way the world works. The evidence is everything we experience about the world is from a first-person point of view. And the way the geometry works with a third-person point of view is projective. It's not what they would call orthographic. So I'll give you an example. If you painted a parabola on the ground, right? Say the ground's flat, extends to the horizon. You're at the peak of the arc of the parabola, and you painted that on the ground where the arms of the parabola go all the way to the horizon. Now, if you looked at that in a diagram, you'd see a parabola on graph paper, right? But the way that would look to you is it would look like an ellipse. It would look like there's an oval painted on the ground. where you're at one end of the oval. Now, if you just look at the formula for an ellipse, right, and a parabola, they're completely unrelated. They have nothing to do with each other in Euclidean geometry. But they're obviously related because they look the same. Well, one looks like what the other would look like in Euclidean geometry. In Euclidean geometry, the thing looks like in projective geometry that same thing. So you're making all these conclusions, not just you. Don't think I'm finger pointing at you. You've been raised this way to think about that somehow you've astral projected yourself outside the world and are looking back at it. That's not the way you've experienced the world, and that's not the way the world works. Like I said, there's this personal dome. It follows you around, and the reason it looks like this, the main reason is you can't tell the distance to anything in the sky by looking at it because you don't have any distance cues. So when everything looks the same distance when you're looking at something, everything in your field of view looks like the identical distance, but you can't tell the distance, right? So in your perception, it's either infinitely far away or infinitely close. You can't tell. You have no distance cue. Like when we look at the world, we have distance cues, right? We can see the ground ramp up. We can see things get smaller as they go further away. We have all these other distance cues. We don't have any of them with looking at the sky. So you draw conclusions about, some orthographic relationship between the ground and the sky. To even know whether that actually is true, that relationship between the ground and the sky is this angular spherical relationship, you have to measure the ground. That's the only way to know. You just don't get to jump and say, yes, the ground is like the sky. No, you actually have to tie them together somehow. And when that's tried to be done in surveying or any of those endeavors, it can only be correlated in a very bulky, loose way. But when you get into like particulars, it starts falling apart. And they have to do things like have curved plumb lines and geoid models and reference ellipsoids. Why is there a reference ellipsoid if they measure the Earth to be a ball? Why does that even exist? Why don't you just go with the measurements and say, hey, we measured it, here it is? Why do you have to have some imaginary mathematical object that you put the measurements on? Why would
If
you
you're
do that?
asking me, it's because the Earth is not perfectly a sphere, right? The reference ellipsoid is.
Well, then just measure it, right?
Right, I
You
think that
shouldn't
they
need it
did
at all,
that
right?
in order to
Like
get
if I
in order to
said,
get to the reference ellipsoid, they must have made some measurements. And I mean, how do you think they came up with it, right?
look,
Like
if I
based
had
on
like if I had a box, and I said I didn't know what it was, and I said, hey, dude, here's some money. I want you to go measure that object in the other room and tell me what it is. You'd come back and be like, yeah, I measured it. It's a box. You wouldn't need a fucking reference box on a piece of paper to which to map your measurements onto. You wouldn't need anything external. Now, there's a reason they need something external, because they don't measure the Earth to be a sphere. And in fact, it doesn't even match the reference ellipsoid. They need another fudge factor called the geoid. And they don't actually, contrary to popular belief, people think that like they do projections. They're not doing projection. They do what's called a mapping function, using the geoid as kind of like this curved ray filter. In surveying, geodetic surveying, plumb lines. If you know what a plumb line is, you got to wait. You hang it from a string, points toward the ground. Everybody thinks, yeah, it points perpendicular to the earth. It points straight down. Not in geodetic surveying. That plumb line is supposed to be curving. something no one's ever measured, ever seen, doesn't exist. It's purely a mathematical object used to turn a flat surface and match it to the celestial sphere.
Right, but if there is a celestial sphere, how does the flat Earth fit inside of it? Like,
Because they're unrelated. They're not contingent on each other. It's observer centric. The only thing it needs is an eyeball. Did you understand when I say the way you're thinking about reality is like from some external philosophical viewpoint? That somehow you can go outside of everything and look at the geometric relationships of things and that they have to be like that. Maybe that's not the way the world is, and that the geometric relationship of things is based upon an observer, and everything emanates from the observer and comes to the observer, and that is the
well, no, I
origin of
think
it.
that, we have this subjective experience of the world, but there is an objective reality. Like, I don't think that we're all just seeing our own personal sky. I think if that were true,
I
celestial
know,
navigation
but we
wouldn't
are.
work.
But we are, even within the globe model. We are.
Well, you're seeing the sky relative to your position on the Earth, but
Yeah, and
if I'm standing next to somebody and I point at the
no,
sky, like I
because
can
of
point at a
refraction,
star
remember?
and they
Because of
same star.
refraction, remember? Say the stars that I see on the horizon that don't follow the spherical relationship are directly over your head, or nearly directly over your head. Why the fuck did it just do that? And they do follow the spherical relationship.
You're a
You
nigga.
can't.
India,
Yeah,
you're
great. Yeah, that's great.
Fuck your computer science degree.
Yeah, even if
nigga.
even if that was true, the Earth is still flat. So anyway, even if one person is seeing this linear spherical relationship and the other person is not, they're not looking at the same sky.
Right. I'm trying to make sure we agree on the same observables. Like, to me,
But that universality don't hold.
it's
It
imaginary
doesn't
to
even
say
exist.
it's here, and it's based on what we observe because we don't have the
No,
depth for each star. Like,
you're just
even
saying
I'm
that.
sure.
It doesn't. Only part of the sky obeys that mathematical relationship. Part of it.
Right, but the sky shifts so that that ring of where you can make those accurate observations, that the sky is rotating through that, so all of the stars are in that position at some point.
Great. Yes, there will always be stars from the viewpoint of the observer that have that spherical linear angle relationship. Yes, part of the sky, but it's observer centric. It's based upon the observer and some other observer. Say their views overlap. Part of his view is not going to have that linear relationship, so they're not looking at the same thing. And I'm not just like whistling Dixie. You can do something. You can go on Time and Date or SunCalc, right? They have sunrise, sunset, the sun angle, so the sun azimuth and elevation angle. The elevation angle is its angle above the ground, and the angle elevation above the ground, and the azimuth is the direction you're pointed. Now, if you take two observers and put them on a quote unquote model globe in 3D Studio Max, AutoCAD, Blender, pick one, and you tried to take their lines of sight, right? I got that on my azimuth. I know which way they're looking. I got the elevation angle. So now you know the direction of the sun from that viewpoint, that observer. So you take the other observer. Now, in the orthographic thinking, those lines of sight should intersect at the sun somewhere outside of the Earth, 93 million miles away. Now, I'll say, hey, dude, it's not accurate enough you're going to get an error when the angle's that small and it's all that far away, even though it's AutoCAD and you shouldn't. Let's just say you do. But you're not going to get an error as large as they get when they actually do it. because they get negative parallax angles, meaning when you do the calculation, the sun is behind the observers that are looking at it. If you intersect the lines of sight, behind them. So people make all these assumptions about what's happening, about where the stars are. I see the star, you see the star, we're both looking in the same direction because we both see it at the same time. That's how things work terrestrially. You're just, and I'm not saying it's not a justified conclusion to think that this is some universal thing, that when, I look at a building and you look at a building, we're both looking at in the same direction, it's the same thing. But that doesn't hold with objects in the sky. It just doesn't. And I know that's hard to take, probably. But this is why they say things like, well, the stars, it's all parallel rays.
The only thing that could explain something like that is it's like we're looking at something that's not there, like a projection, like a hologram or like a video screen. Like if we're all looking at different TV screens.
Your assumptions are wrong. That's what explains it.
Dylan, you gotta admit this logic you have to follow. It's sound logic though. I mean, and your side at the moment that you're trying to, it's baseless. What you're trying to push when you follow the logic, bro. Come on.
Yeah, it's fundamentally let me say this. There's a philosophical paradigm underpinning your viewpoint, right? There's some assumptions there, and are those assumptions actually, well, they can't be proven, but are they actually justifiable, or is there contrary information which might say, hey, my assumptions are wrong? And there's plenty of it.
Dylan, make sure you go to the live stream and what India just gave you for the past 10 minutes, bro. Just listen to it again, please. Listen to it again, bro.
The whole viewpoint of the heliocentric model incorporates a lot of philosophical ideas. Assume that the Earth is not unique and that it's just like everything else. That we can't prove it, but we're just going to assume it. And from that assumption, we're going to say, I look and I see the planets, therefore Earth is a planet. Because everything's the same, right? Or because I can make a blueprint of a house and show the blueprint to a bunch of people, and we can use this and use these spatial dimensions to build something which follows in a mathematical way the blueprint, but the house don't look like the blueprint at all. If you drew railroad tracks orthographically on a grid, they would be two parallel lines that stay apart forever. But if you went to the railroad tracks and looked at them, it converged at the horizon. And I'm not talking about that, like it's just like a subjective interpretation of reality. No, it's just the way we experience reality is based upon the observer. And if you wanted to get really, if I wanted to be a total fucking asshole and science nerd, I could make an argument from the viewpoint of quantum mechanics, which says all of reality is based upon the observer, down to fundamental particles, and that a particle doesn't even exist until you look at it. Now, I don't actually agree with that, but I could make that argument to support the philosophical argument.
Dylan, you gotta acknowledge some of this, bro. Come on, please do it. Come on, Dylan.
No, I'm
You've
not.
been asking the
I
same
can
question for weeks.
try. It sound it. I'm trying to keep it relatively simple, and like you showed maps of the celestial sphere where the 6 radiant points or the meteorites are coming through. Like it seems like you agreed that there is a celestial sphere, and so we were
Not an
getting back to
actual
like
sphere,
the
though.
question of like
I told
It's
him
not
this
an actual
issue of
sphere.
it being like not an actual sphere, or that I'm trying to
the point
understand
the point that gave
that are
you
being made.
what Indio just gave you, it's like to the point exactly the whole point of what you've been asking. And are you listening to what he's saying, bro? Like that's what I thought, that you have to go back and repeat it to yourself and listen to this again. I'm pretty sure you probably have to do it 1 or 3 times. Because this is to the point of what you asked.
So when you say celestial sphere, when they say celestial sphere, what they mean is that the stars, right, the relationship of the stars, the spacing, follows an angular relationship, a linear angular relationship. That's what they mean. That is the quote celestial sphere. That's it. It's not that it's an actual sphere. It's a relationship of the angles.
It's a map. Like have you ever used Google Sky Map or something like that? Like when you observe the celestial sphere with a sky map, it's literally a sphere around the observer, and so
Exactly.
you can see part of it, and most of it is occluded by or half of it is occluded by the ground and what other objects you have around it. But you still see a hemisphere of the
How do you know it's occluded by the ground? That's the thing. You're
like
making an assumption.
you can point your phone at different directions. You can line up like, okay, this constellation over here corresponds to the constellation on the sky map, and everywhere you look, you can see, oh, this is this part of the sky, this is that part of the sky, and you can.
It's not the sky if it's
and
under
it
you.
corresponds, huh?
It's not the sky if it's under you.
Right. On the sky map, though, it's a sphere and it goes all the way around you. So there's.
Okay. That's fine.
So that's what I'm saying. Like, how does that work? If there is a celestial sphere
It
on the
doesn't
globe,
actually
that
do
makes
that,
sense.
though. Yeah, if you turn the celestial sphere, the Earth into the celestial sphere.
Right. It makes sense on a globe because we'd be inside the sphere. But I'm just wondering, like, how you can how that works on a flat Earth. Like,
I'll tell you, brother. You answered your own question. If the celestial sphere goes around you, then that means there are 8 billion celestial spheres. I rest my case.
Those are rookie numbers. We need to have more babies.
they say there's a lot more people than that, actually. That we've been undercounting people for a long time.
Oh, I'm
Because
sure.
people that are
The
living
point
in
is,
rural
Dylan,
areas.
the point I'm making with that is that the celestial sphere is observer centric. The celestial sphere that you imagine is centered on the center of the Earth. That's not how it's experienced. It's only experienced observer centric. That's reality.
Right. You have to put in a particular position on the Earth. If you're using one of these applications,
It's not on the. It's not in Earth.
they're gonna use your latitude and longitude in order to
Those are not on the
represent the
ground.
sky accurately.
Those are not on the ground. See, this is where you're. This is a mistake that people make. You guys think that latitude and longitude are on the ground. They are not. You know how I know this?
There is a particular latitude and longitude and on the ground, like
Yeah. Okay.
like
how do I
I'm
find
on the
it?
ground
How do
and
I find
have
it?
a latitude and longitude.
How would I find it? Using just the ground, not the sky.
Well,
if it's a ground position, I should be able to use the ground to find it. Yeah, you can't. The coordinate system is in the sky. All it does is demark a case of a section of the sky that you see that you're under.
right, but it doesn't rotate with the sky. Like a particular location on the Earth has that particular latitude and longitude, and it
Well,
doesn't
we've
change.
decided on
Like
that by
if you
convention. Well, yeah, it doesn't
if
change
you're
because
navigating somewhere,
yeah, it does. Any particular, say, New York City has a particular latitude and longitude, but that's agreed on by convention. They even say it in
right?
the International Terrestrial Reference System that we just agree on any particular latitude and longitude that this is where it is. Because the sky,
Right.
this so-called celestial sphere, moves around. It doesn't have fixed locations. The only fixed locations is where's the celestial equator and where's the sun, and that's the whole basis of latitude and longitude. Okay, that's it. Where's the celestial equator above the horizon? Where's the sun? What time is it? And with that,
Most of those
we've taken
choices
places on Earth.
are
Well,
pretty straightforward. Like we didn't choose arbitrarily where the North and South Pole are or where the equator are. We chose arbitrarily where the prime meridian is that goes through Greenwich, England, like the observatory there.
no one
But
said it was arbitrary, but it's not based upon the ground. How would I know if I'm at the North Pole?
you would see the stars circling directly above
Exactly.
overhead.
So exactly, the ground could be fucking invisible. And if
So
Polaris
isn't
is over
there
my head,
where's
we
the
would
South
say,
Pole to you then?
well, if the Earth was fucking completely invisible, if I saw Polaris over our head, by convention, human convention, we would say I'm at the North Pole,
Right.
even though the
So
ground doesn't
is
exist.
there a South Pole?
Oh my God, it's not a location on Earth. No, there is not. You are under these things, dude. Well, aren't you understanding? You're under it. You're not on it.
Is there a point on the Earth where you would see the celestial South Pole circling overhead?
I do not know. I've never seen evidence of this. I've never seen evidence of a point on Earth having being a North Pole, being under the so-called northern celestial pole. Never seen any evidence of that. National Geographic tried, but they got there coincidentally on the first day of the equinox, and it wasn't dark anymore. Because you got to go there at night, right? So the Arctic Ocean is water, but it's frozen in the winter. But you can't. You have to start traveling before winter kicks in. So they started traveling and traverse, northern Canada, try to get to the North Pole, the so-called North Pole, to find it.
National Geographic couldn't got it right. Come on.
Yeah, well, I mean, like they just looked at their Garmin and said, "Yeah, we're here," even though there's no GPSs in a polar orbit around the North Pole, so I don't even know how their Garmin picked up anything. But another bullshit from National Geographic out of their loads of just fraud. National Geographic is just fraudulent at this point. The point is that they could have gotten evidence that there's a North Pole on Earth, well, someplace on Earth under the northern celestial pole, by just pointing their camera up and snapping a picture. But they didn't get there in time. It was light out. So I don't know anybody who's ever. You can't go there with a ship. You can't break the ice. So I don't know what the evidence. I've never seen evidence that there is a place on Earth that would correspond to the globe North Pole, or any North Pole, even on Gleason's map North Pole. I don't see. We don't go on imagination as flat earthers generally. Some do. I would say our group does not go on imagination. We go, what's the evidence for that? That's our thing. There's lots of claims. What's the evidence for the claim? North Pole? There's a North Pole on Earth? Okay. What's the evidence for that? How do I know when I got there? And that thing, right, that you probably 20 minutes ago, you thought was as fucking sure as shit, as sure as the sun's going to rise tomorrow, there's the fucking North Pole. And now you know there's no fucking evidence for its existence at all. Well, what's the evidence? Other than someone claiming there's a place on Earth that corresponds to the northern celestial fucking pole, and there's a place you can go stand and you're under it. Nothing. No videos, there's no photos.
I've
there's
never
nothing.
been there, but I've definitely
Nobody's
seen.
ever been there. Not just you,
It seems
dude.
like
I've looked for this very hard. And that's what I'm trying to tell you, Dylan.
I
gave
feel
you
like
the
I've
only
heard
piece.
stories of people navigating to the North Pole.
Through ice?
Yeah, they like use sled dogs and shit to get there. Like the first people that went up there, like they got close, and I don't know. There's these like harrowing stories, people getting stuck up there, like trying to get there.
Kind of like a big fish story. Hey, Indio, has there ever been anybody to stand underneath the North Pole or the South Pole at night?
Not that I know of.
That's what I've always been wondering. Everybody keeps claiming you can go to the North Pole and South Pole, but the only way to find it is at night. So how has anybody ever gone to the North Pole or South Pole?
If you can't know you're at one of these poles, unless you make an observation of the sky, and you've never been and seen the sky look the way it's supposed to look, then you can't say it exists.
Because you will have to draw an angle, and the North Star, let's say, it has to be 90 degrees above your head, right? Yeah, I'm 90
nearly.
degrees under the North Star. Or
Yeah, nearly. It would be off a little bit, but
yeah.
But if they didn't see that, they'd just make up some bullshit excuse. Because when you start getting into the colder regions, those rules, especially your celestial sphere rules, they really stop applying. So, for instance, Barents, who the Bering Strait is named after, they got stuck in the Arctic, in what would be the Arctic Circle. Their boat got stuck, and they couldn't get out. And so they're waiting for spring to happen so they can leave. Well, spring started 2 weeks too early. Now, why would that happen? Why would spring start 2 weeks too early? Meaning they saw the sun 2 weeks before it should have rose, and every day in those 2 weeks. Now, when Barents got back to the Netherlands, they tried. He had because back then he had a royal commission to go, map the world, go explore, do all these things. When the academics saw his logs, they were so mad they tried to get his commission taken away. And the only reason it wasn't taken away is because they also plotted. They also weren't supposed to be able to see Jupiter and the moon, but they recorded their positions as well. There's all sorts of anomalous observations that don't conform. The Canary Islands, you can see the entire Southern Cross from the Canary Islands, which is like 28 north, which you should only be able to see a portion of it. You should never be able to see the whole thing. It's photographs of the whole thing being recorded. So the thing about the globe is it's a Herculean effort in fucking cherry picking and confirmation bias, and little more than that.
Some of that trust me, bro stuff.
Well, you just ignore the falsifying information, pretend it doesn't exist, or come up with some ad hoc explanation to stop your hypothesis from being falsified, and just keep adding band-aids forever. There's a video the other
Right.
day.
Yeah.
Fucking everything about galaxies is wrong. Remember? Did you see that one?
Yep.
I don't know if I posted that
Yeah,
one. Yeah.
absolutely. Yeah, your idea of being wrong by new evidence isn't that it's wrong. It's just that you just discovered a new exotic form of matter.
Think about like the motion of the Earth. That's a classic one, right? They went so far as to say, freaking, there's no such thing as distance or time. Is that it's relative, right? There's no absolute space. Why? Because they couldn't detect the motion of the Earth.
Hey, guess what?
I'm gonna have to catch you guys on the next one.
Oh,
but thanks, I guess.
Yeah, you can fact check everything I said. I don't make up shit ever. Everything I said, you can find. Like, I mean, Barron's. Everything I said about Barron's is whole academic articles on it.
Wait, so AI, the point of your example, just confirm if this is what I'm saying is wrong. It's to illustrate how absurd it would be to have even though you know that the known territory is not curving, to assume that beyond 50,000 miles beyond the parallel, it would start dropping. The point of the example is to illustrate how absurd it would be, because you would still go down. Like everything would still be.
Oh no! There's nothing absurd about it. The only thing absurd about it would be for somebody to be making universal claims about that territory that they can't possibly know dogmatically. You follow? So you got to watch yourself on universal claims in the realms of unknowns, and you have to watch yourself on mixing models. Okay. So the majority of what we did there is just demonstrate how people are critiquing something by mixing a model, and Globers do that to us all the time, right? Like we'll say to them, oh, so they'll ask us, so you think the Earth is flat? We'll go, we know the Earth is flat, and they'll be like, oh, so it's just the only flat planet in the heliocentric cosmology, right? So they're imagining the flat Earth in their model, right? So it's the third flat disk from the sun.
Yeah, the entire thing versus just the known territory.
Right, and we have to deconstruct.
Well, the problem, AI, is that flat earthers. The problem is flat earthers never provide their own model in which to imagine the flat Earth. So we're forced to use pre-existing models to try to make sense of it.
No, you're not forced. You could just not try to do it, dude. You're not. There's no force involved.
So a model is just a functional explanation of observed phenomenon that is internally coherent. That's all it is, right? But like, you guys have no model to actually explain things. Yeah, you can't explain the day-night cycle. You can't explain the seasons. You can't explain lunar eclipses.
No,
you can't explain the movement of celestial bodies. The most you can say about the sky is like, whenever anybody brings up like observations of Jupiter and its moons, or we can observe eclipses. We can observe solar and lunar eclipses on Jupiter. Exactly. You guys just say, oh, well, you can't look at the sky to make conclusions about the ground. So it's like, because you can't account for it. And like, I agree.
Are you done? Are you done? Like, seriously, are you done on your soapbox? Like, seriously? You can't even define model. You should just close your mouth.
I did. That was literally the first thing I said. A model is
and
a
that's
functional
wrong.
explanation.
That's wrong.
Yeah.
That's wrong. Models
Okay, what
describe.
was
They
wrong
don't
about it?
explain. They describe. Describe. They don't explain. They describe.
Yeah, they describe relationships between observed observations.
Observed observations.
Yeah, observed phenomenon.
Brought to you by the Ministry of Redundant Ministry.
All right. See, the only thing you're good at, Indio, is playing word games, man. Actually respond. What are the seasons? What causes them? The best you can say is, oh, I don't know. It's impossible to know.
You don't know.
I do know. Seasons are caused by the tilt of the Earth. It makes logical sense.
that?
We can explain it and predict it.
How do you know that? How do you know that? What's the evidence?
The sun.
Yeah, what's the evidence?
Oh man.
Yeah,
Dude, we can observe that the sun. We can observe that when we orbit the sun, it's on a different axis than when we're rotating. Yeah.
It doesn't tell you the cause, though. You're just asserting that's the cause. How do you know that's the cause? Yeah, like
Okay,
I said.
well, what causes the seasons? Come on, man.
You don't know.
Anything. Yeah, no, but all you can say, dude, all you can say is, oh, you don't know, and nobody knows, and it's impossible to know. So therefore, I'm going to stick to my little conclusion of the Earth is flat. Like, it's not intellectual rigor. It's nothing.
No, like listen. All you can do is correlate. Okay, you can correlate. You can't know the cause.
Yeah, we can know the cause. When we look at Jupiter and we observe that it's round, and we observe that when we look at Jupiter and we see that the moons are orbiting Jupiter, and we see that Jupiter is a sphere.
No one's ever seen that.
Dude, yes, you can see amateur astronomers, people who just buy telescopes online, and they take photos of Jupiter, time-lapse photos. You can see the moons orbiting. What are you talking about?
No one's ever seen a full orbit, dude, in the history of man. Okay, period.
A full orbit of what? A full orbit of what?
Anything, ever.
So now you know he's never taken like college level statistics or even high school level. Like now you can totally size up his education, Indio. It's completely deficient.
Wait, what are you talking about statistics? What?
Yeah, because you think you can determine causation from a correlation from an R squared. Like you can't get that from an R squared.
From an R squared? What the fuck are you talking about, dude? Use English.
Yeah, probably something beyond your ken, so I'm sorry.
An R squared value? Like you're talking about like statistical, like some statistical term? Some niche technical term from statistics?
Some niche?
What exactly?
Some niche? Something that's taught in like first week of stats? Yeah, that kind of niche.
Okay, well explain how it's relevant to the current conversation.
Well, you apparently don't know how to differentiate correlation from causation, like Indio pointed out, so.
Okay, if I can point my telescope and look with my own eyes and see the moons orbiting, and they're following the Newtonian gravitational model, that is sufficient reason to conclude, or it is reasonable to assume, not even assume, it is a reasonable conclusion from those observations that the Newtonian model corresponds to gravity, corresponds to reality.
If A then B, B therefore A. Great, you just completely laid out a very clear path of affirming the consequent formal logical fallacy. Awesome, good for you. You just engage in circular reasoning, also called putting the cart before the horse. You just did that for everybody. Good for you.
No, in science, we work on an evidentiary model. You never prove anything.
As in you're in science? Are you a scientist? Oh my gosh, really?
Yeah, I am. As a matter of fact, when I say
you are. What field? Okay, great. What discipline? Because I am too.
I don't care. I'm a physicist, and when I say we,
you're a physicist. So you never had stats, but you're a physicist. That's freaking amazing. How does that happen?
Get over yourself and your little fucking ego and your little fucking credential fallacy bullshit, dude. It doesn't matter what I do or who I am. When I say we, I'm talking about humanity as a whole. Okay?
No, you said we as in we are scientists. You weren't referring to humanity as a whole.
You twisted my words.
You're resetting the frame of this because you're dishonest.
I'm not dishonest, dude. You're just
you're resetting the frame of this. When you said we, you were referring to yourself as a scientist, not all of humanity. And you just did a complete bait and switch, dude, on the audience. And audience, if you're listening, I hope you caught the bait and switch that this guy did. Anyway, continue. I'm going to just step back for a bit and let you start yapping your pie hole.
There's like 12 people watching on YouTube, dude. I don't know why you guys have to grandstand about,
Oh,
the
you think
audience
so?
on
Yeah.
YouTube.
Why don't you convince yourself? Well, you wish there were only 12 people.
I'm literally looking at. I was looking at the stream right before I joined. There was like
You
20.
believe everything you see on the internet, don't you?
Okay, how many people are watching the live stream then? And what?
Dude, these
and
get
Rodriguez,
clipped.
what's the
These get clipped. These conversations get clipped, especially ones like this, and they get put on TikTok and Facebook and Instagram, and they get
and also,
hundreds of thousands of views.
We're also streaming in 2 places at once. Well, 3 places. No, 4 places.
Honestly, I don't even care about the fucking audience. You think that's why I'm here? Is that why you're here? To convince yourself that you're famous?
No, we're here to talk to the audience, and we're here to grandstand in front of you to demonstrate to the audience how much of a numpty you are.
Guys, you only have 12 of the thing I don't care about.
Only 12?
Again, okay. Let's not get locked away in the bullshit. So the problem is
Now
that
you admit,
we can
your
observe.
whole point was crap. Good point. Go ahead.
No, again, word games. You guys just love playing word games. It's pathetic. We can observe
words mean
attracting matter directly in the Cavendish experiment, and just because you refuse to accept evidence that contradicts your position doesn't mean it's not real.
Okay. So the Cavendish, you say, is an experiment. What was the hypothesis?
You're playing word games.
I'm not gonna. It doesn't look. What like exactly? You're just going down irrelevant, pointless avenues of argumentation. It's not going to lead anywhere. When you put two masses next to each other, they attract each other with a measurable force. That's it.
You're just making shit up. You don't even know what happens in the Cavendish experiment. You have no idea what's being observed.
It's a fucking. Yes, it's
okay,
you observe a deflection of the wire.
Nope.
Due to the masses being closer together.
Nope. Nope. Nope.
The Cavendish, no, it literally is. It literally is two masses. It's a bar with masses at the end, suspended from its center with a wire, and then you place. Yes, two masses suspended from a wire.
What is that?
And then you place.
Yeah, mass.
Mass. Two massive objects, like two lead weights, suspended from a bar.
Weight isn't mass.
My God.
Oh my God! You know what?
Yeah, weight isn't mass, dude. Have you ever had mass in a weightless environment? You've ever heard of mass in a weightless environment before?
You know damn well if I go to the gym and I lift weights, you know what the fuck I'm talking about, dude.
Yeah, not mass.
Two chunks, pieces, portions of lead.
Chunks. So chunks. We're talking about chunks. He's a physicist talking about chunks of matter.
Two collections of lead atoms. What the fuck?
No, dude, you need $1 million word for this. You got an advanced degree. You're not going to get away with chunks. Listen, dude, you've got an advanced degree. I want to hear $1 million word from you, not something like chunks. You're a physicist. Stop using chunks.
Fuck you, dude. I don't care what you call me, dude. You know what the fuck I mean.
No, I don't. I really don't. Because mass has no meaning.
You're not this. Stop acting
mass
dumb,
has no meaning. You know, I can pull up some quotes from like Max Born or somebody else in here who can describe for you how mass has no meaning.
What you guys doing?
What the fuck are you talking about? What the fuck
figured you might say that because you're not really a physicist, are you?
It doesn't fucking matter. It doesn't
yes, it does matter because this is absolutely central to your entire argument. It does matter for you.
My argument has nothing to do with my background. My argument is that if you two objects with mass are attracted to each other through gravity.
All right, good. So your claim betrays your background, which means you're a pretender clown poser.
Why don't you just address what he's talking about with the experiment instead of just trying to assassinate?
Yeah, okay, I'll address what he's talking about. Go ahead and define mass. What is
totally
mass?
Irrelevant. This is why
good. No, this is relevant. This is relevant. This is relevant right now. I need you to define what mass is. I need you to define what mass is because this is absolutely central to your argument. What is mass?
Mass is the fundamental property of matter that it can have, much like electric charge or much like atomic spin. These are fundamental properties.
Spin is mass? Lord have mercy.
Fundamental property of mass.
What they do every time, they try to just like debunk, like derail everything.
No.
The problem is that you
Well,
guys
this guy's not a
demand
physicist.
fucking.
It's so
You
over.
guys demand hyper-technical jargon language, and then the moment you're provided with it, you go like, "Oh, that doesn't make any sense."
No,
That's
no,
not
this
what
is not
it is."
hyper-technical. You provided us hyper-technical jargon language. You absolutely did not.
No, I'm saying that's what you've been demanding, right?
You provided us with you provided us a handful of broken crayons that you spat out after eating them.
Mass is a property of matter. Matter can also have an electric charge. Matter can also have a quantum spin.
No, I'm asking about mass, not matter. We're to define mass. Come on, stick with the program.
Mass is a property of matter. That's what it is.
Good. Okay, that's so descriptive. Can you be any more vague?
I can tell you how that property, like what it means to have mass.
What does it mean?
If you have mass, then that means that when you have a force applied to you, you undergo acceleration.
Bro, high school physics is not it.
Mass is defined as a resistance to acceleration due to external forces.
Yep. It can't attract things. Thanks.
What is mass?
It also, yes, it does.
Oh, so a unit
Why are
of
you guys
measure
arguing about
attracts
mass?
things. Congratulations.
No, just because we use a unit of measurement to measure it doesn't mean that it can't do other
No,
things.
it is a unit of measure. Mass is a unit of measure.
No, we can measure something's mass via its resistance to acceleration.
That is its mass. That's the same thing, dude.
No, that's how we measure it.
Dude, resistance to acceleration is defined as mass. They're the same thing.
Well,
yes, as in if you want to measure how much mass something has, you can apply a force to it and see how much it accelerates.
It's the same thing.
It's how we can measure it. Yeah.
This is no. It's the same thing.
Yeah.
It's an identity.
That's
mass
okay.
is the
No.
Mass is the unit of measure.
No, what you're saying is if I have a photodetector and it receives, and I'm measuring the output of that photodetector, when a photon hits the photodetector, it emits a pulse of current. Okay, and then what you're saying is, oh well, a photon is a pulse of current coming out of a photodetector. That's how it's defined. No, that's how we measure
That's not what I'm saying at all.
They're two. Yes, that is exactly what you're saying. You're equivocating.
Mass is not a unit measure.
Mass is resistance to acceleration. That's its defined. That makes it an equality. That means
that's how we measure it. I can write an
equation.
I can write an equation saying
unit.
I can write an equation for a photodetector that is photons per amp.
Has nothing to do with
I measure the amps, and I can calculate that from photons with an equation. But that doesn't mean that photons are current in a wire. It means that the current in the wire is produced by the photons, and that's how we detect them. The way that we detect mass, the way that we measure it, is by applying a force to something and then measuring how much it accelerates. And then the mass of it is defined as the ratio between the force and the acceleration.
Okay. That is the mass. It's the same thing. No, there's no way around it, dude.
No, I just gave
a unit of measure. It's like feet or inches, dude.
Understand it.
It's like feet or inches. It's like saying distance causes something.
But it's
Dude,
also a property.
You're
though,
too
right?
dumb,
Like,
dude. You're just too
'cause
dumb.
Everything has mass, right? So you could say it's a property.
No.
No?
No, not everything has mass because photons don't have mass. Neutrinos don't have a measurable mass.
Yes, they do.
Sure?
No,
Yes,
no,
they
they
do.
don't. Photons don't have mass.
How much money do you want to bet?
A photon is an oscillation in the electric field. How do oscillations in the electric field have mass?
And it has a mass.
No, it doesn't. No, they have momentum, but they don't have mass.
Dude, this dude is bro.
Yeah, he says he's a quantum mechanic.
E equals mc squared, remember?
Yeah.
No, that's not right. It's E squared is equal to the square root of mc squared plus.
Did you ever take quantum physics in college?
Mass, energy, equivalence, dummy.
Yes, but that's an incomplete expression. The full expression is E squared is equal to the square root of mc squared plus pc squared, where P is the momentum. You should, because you're misquoting the equation.
Energy has mass. This is not debatable, dude.
Yeah, but is light even matter?
No, it's not matter, but it has
Yeah.
mass.
So you could
Because
say
it has a radiation
It
pressure
doesn't
and a
have
momentum.
mass. It doesn't have
Okay.
mass.
Okay, then how come if I shine a laser at a piece of aluminum foil, the laser will push the foil?
Because they have momentum.
I'm gonna push it though.
Okay? No.
Wait, hold on.
If you actually want to understand this, I can explain it in 30 seconds.
And how do we calculate the momentum?
If you actually,
Do we use the
I can explain it to you in 30 seconds.
Do we use the rest
I can
mass?
explain it to you in 30 seconds.
Do we use the bro? No, shut up. Do we use the rest mass? Do we use the
You don't
rest
use the rest mass of a photon. Doesn't make any sense. I can explain it to you. You want me to explain it to you in 30 seconds?
No,
you want me to explain it to you or not? Your question doesn't make any sense.
Shut the fuck up. Do we use the rest mass of the photon? Yes or no?
Photons don't have rest mass.
It's zero.
He's cooked. You're cooked, dude. Shut up, dude. Shut up.
Does a firefly have mass?
Photons have zero rest
The
mass.
firefly with the light on it.
Okay, so here's the explanation. Here's the explanation. You have an oscillation in the electric field. What's going to happen because of that? You're also going to have an oscillating magnetic field along with it that's being co-induced by the wave, right? You have light is a magnetic field and an electric field oscillating together. Now, whenever you have an electric field and a magnetic field inhabiting the same space, you can take the cross product of the two and figure out a momentum tensor. Okay, it's called a fucking Maxwell tensor, and it tells you the exact forces that an electron or a charged object would feel in that region due both to the magnetic field and the electric field. And if you actually do the math and take the cross product and like see what forces are there, then that basically you can see that there is a momentum flux within that space anytime you have overlapping electric fields and magnetic fields. I can do the math for you if you're familiar with vector calculus.
Look, how about this? How about you just go on Google and Google, do photons have mass?
You need to Google Maxwell tensor. Okay, we'll both do that. Go on Google and Google Maxwell tensor. Tell me what comes up. I want you to read the AI overview.
Photons have
No.
mass.
Yeah. You don't know what a Maxwell tensor is. Maxwell tensor.
I don't give a fuck. I don't give a fuck. It's a red herring. You're trying to distract from
It's not a red herring.
Photons have mass.
The question you asked me,
Dude,
they
photons
don't.
have
The
mass.
question you asked me was how do they have momentum? The answer is Maxwell tensor.
That's not an answer.
That's one formulation.
Yes, it is. The Maxwell tensor is literally.
That's one formulation.
The Maxwell tensor are literally momentum.
And that's just, bro, that's just one formulation. There's others.
Oh, okay. Give me one more. Give me one other. Go ahead. I'm waiting.
Hold on. There's an ambulance, a truck going by. Now, what was that? Say that again.
You said there was another formulation of the Maxwell tensor that what doesn't include momentum?
No, there's other formulations.
What are you even saying?
There's other calculations to formulate the momentum of a photon.
Okay, like what? Give me an example. I give you an example. Give me an example.
I think it's H bar over H bar times V equals M times F. So F would
There's
be
a
the
pointing vector.
I have to look it up. I don't know from memory, but it'll give you the energy of a photon, which will spit out its momentum.
And how do you calculate the momentum from the photon, from the energy of the photon?
Does the binding does the binding energy?
You use E equals PC squared.
Does the binding energy of an atom have mass?
That's where most of the mass of an atom comes from.
Oh, so not the particles.
That's right.
Oh,
that doesn't mean that. But that doesn't mean that all the mass comes from the binding energy. No, there is still independent mass that the particles themselves have. A proton is not a fundamental particle.
Yeah, so Indio described for you the de Broglie relation.
Yes, the de Broglie relation, H.
Yeah, that's what Indio responded with, okay? So yeah, you agree with that. Awesome.
E equals HF. Okay, so that means you can start with the frequency of a photon, and then you can convert that into the energy of a photon. Now you want to find out the momentum of the photon. What are you going to use? The same exact equation I described earlier, E equals PC squared, where P is the momentum.
Yeah. So now you invoke kinematics through Minkowski space. Awesome for you.
Dude, throwing around big words isn't going to prove that I'm wrong about anything.
You guys like worship vocabulary like the world is some kind of like magic law room where if you say the right combination
It's
of words, you
pretty
can deny
mysterious.
reality.
Look, nobody has
Don't
it
be
all
dumb.
figured out.
Words
Neither
mean
do
stuff.
you.
Yeah, and all you can do is appeal to ignorance, saying, "Oh, the things that scientists claim to know are
Ignorance. Who's
impossible to know.
appealing to
Therefore, they must
ignorance
be
around
lying."
here? Who's appealing to ignorance? How about we're appealing to humility? The fact that you don't know shit is absolutely true.
I know more than everybody here combined, bro.
All right, Dunning and Kruger, why don't you go take your Dunning and Kruger bowling balls and go play with yourself?
Has anybody bothered to Google Maxwell tensor to educate themselves at all? Because that's a real thing. You think I don't know about that?
So now you're going to be a proponent of ether theory, which I thought was debunked by Einstein.
What the fuck are you talking about ether theory? I'm talking about Maxwell tensors. What does that have to do with the ether? Just because Maxwell believed in something that was wrong doesn't have anything to do with just because we use equations that he wrote down.
Right, all models are wrong, right? Yeah, Maxwell tensor and the ether model are absolutely interlinked with one another.
No, they are not.
Yes, they
Tensors
are.
didn't exist during Maxwell's lifetime. So just shut up, dude. Stop embarrassing yourself.
That's
What
a good
didn't
point.
exist?
The stress tensor from relativity.
This isn't relativity, dude. This is pure electrodynamics. This is classical electromagnetism.
Stolen.
Has anybody just bothered Google typing 2 words into Google? Maxwell tensor. Tell me what comes up. Seriously. It's not that fucking hard. Just type 2 words into Google. We could advance this conversation for 2 hours by now.
Is that what you're doing right now?
He really wants us to talk about the one thing he knows about. That should be fun.
No, that was the question. Somebody asked me, how does a photon have momentum? The answer is you can calculate it using the Maxwell tensor, which is directly from the amplitudes and directions of the coupled electrical and magnetic fields.
So if something's moving really fast and it has momentum, but it has really no weight or, in your case, mass, whatever that is, would it move anything no matter how fast it went?
What something are we talking about?
Well, earlier we mentioned that if you shine a tinfoil, it'll move. So what is moving the foil? Is it stuff that's moving really fast but doesn't have any substance?
So what's happening is that the electrons in the foil are interacting with the electric field of the light, and the electric field of the light is and the EM field of the light is an electric field and a magnetic field that are propagating together, and the cumulative effect when it interacts with that sheet of the metal is that it pushes it away, and you can calculate how much momentum is being transferred from the electric magnetic field into the metal using the Maxwell tensor.
Oh yeah. How does that momentum get transferred through nothing?
Doesn't it just heat it up or what?
Yeah, so you're proposing ether theory.
It has nothing to do with ether theory. Just because you say the word ether theory doesn't mean that
how's it propagating, dude?
Irrelevant.
Yeah, no, it's absolutely relevant here. How's it propagating?
How's it propagating? Because space is has physical properties such as and it can sustain electric fields and magnetic fields.
You sound like that blonde bimbo from like the Miss Universe freaking show. He's like Iran and Iraq and SOAS and yeah, we're gonna feed all the homeless kids.
Just because you don't understand the words coming out of my mouth.
I do understand. You don't understand what you're talking about.
Can you repeat anything back to me that I said?
I do want to ask
because it's a bunch of mumbo jumbo.
Yeah, exactly. You're not even going to.
What are the physical properties of space?
Well, you have things like the permittivity of empty space, which it's a constant called epsilon naught, and it basically describes how quickly an electric field can change through empty vacuum. Same thing with permeability of empty space. It's called mu naught, and the speed of light is 1 over the square root of mu naught epsilon naught.
You're describing not the space, but the field.
So, yeah, you can use that equation to describe refraction around a globe now?
Yeah, actually you can. Because
yes, wonderful.
Field.
Okay. I would love for you to integrate for you to integrate gravity with that within Einstein's framework. Go ahead.
Bro. Einstein? You mean general relativity?
No, I meant Maxwell's equations when I reference Einstein. No, dude, Einstein.
So you're just jumping around? You're pivoting now?
Well, yeah, you seem to be jumping from Maxwell to Einstein to whoever you want. You're picking and
At no
choosing from the
point did I
entire
even mention
buffet
Einstein, dude.
of quantum physics
I've been
and
talking about
relativity to
classical
support your freaking
electrodynamics.
agenda, and that's just freaking beautiful, isn't it?
I've been talking about classical electromagnetism this whole time. I've never mentioned Einstein. You did.
Okay, so you're not an Einstein lover?
It does. I'm saying it's totally irrelevant to what we're talking about right now. We're talking about just electromagnetic waves.
Really? So you're a proponent of the ether theory then?
No. Why do you keep
Well, that's
insisting?
what Maxwell was supporting. That's what Maxwell's equations
It
describes
doesn't
an
fucking
ether model.
matter. Just because his
Maxwell
name is on it
described an
doesn't
ether
mean that
model, right?
It's funny because
just
Holy
because
shit, I
his
thought
name
Maxwell
was on
described
it.
an ether model. Maybe I'm smoking crack here, but I'm pretty sure Maxwell described an ether model.
It doesn't fucking matter what Maxwell believed.
Oh, no, it
Just
doesn't
because
fucking
some of his
matter. Great.
Just because some of his equations happen to be correct doesn't mean that his entire field of work and entire personal beliefs is relevant at all. It doesn't. It would make no difference if it was called the fucking Chandrasekhar tensor
Wait, so
or the
which
fucking
came first, his
Einsteinian
beliefs or
tensor.
his
It doesn't
equations?
fucking matter. It's just a label. Get it out of your head.
yeah, what's the
Erase
M in the
ego from your
tensor?
head.
Okay.
Just a label.
What's the M on the tensor?
You mean like mass?
Yeah.
Yes, basically, mass is just a label that we place on one of the fundamental characteristics of one of the fundamental properties of mass.
Do you get to quantize that or not, or is it not quantized?
Yeah, mass is quantized.
All right, so you're throwing Einstein under the bus. Good for you.
Just because
Maybe you'll be a
Einstein
flat
didn't
earther.
accept quantum mechanics doesn't mean quantum mechanics isn't real. Just because Einstein was right about some things that he wrote down, dude. Like here's the thing. You guys think that that science is some kind of religion where we like reify people, but we don't give a fuck if you're right or wrong. Yeah, seriously. You think that we like worship Einstein or Darwin or freaking Maxwell, and that if they believe these things, we have to believe them, blah, 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 blah. Like, you guys, like, it's a fucking, you guys think science is a cult because flat earth is a cult.
Dude, you're projecting. You don't know any science.
I have a bachelor's degree and I'm getting my master's in the fall.
Well, I mean, they must have been giving them out.
Okay, how many degrees do you have, Indio? Oh, nothing?
No, I have one.
Oh, I don't give a fuck. Because it's irrelevant, because it doesn't fucking matter, does it?
Yeah, that's right. That's why we're talking about how wrong you are based upon facts. Based upon what you know.
Why are you guys fucking bringing up my background as if it has anything to do with what I'm saying?
You said you're a physicist.
After you asked me.
You opened the door.
No, you fucking asked me.
You could have said it was irrelevant. Now it's completely relevant because we're discussing physics
multiple times. From the beginning, I was saying that my background is totally irrelevant.
Well, but then you said you're a physicist, so now guess what we get to make fun of?
Because you fucking asked me. I never once presented my background.
Well, guess what? You just completely threw your own credibility under the bus. Like,
no,
sorry, dude.
What you want? No. What you're trying to do?
You're so smart. You took the freaking bait.
What you're trying to paint it as is that I'm saying that I have a background in physics, therefore everything I say is correct.
No, you said you had a background in physics. I didn't say you did. You said you did. You said you had a background in physics, and that's what we're making fun of right now.
Well, it doesn't fucking matter if you make fun of me for having a small dick. It doesn't have anything to do with the cogency of the arguments at hand, and you know that. This is just bullshit, pedantic, ad hominem, irrelevant crap, and you know it.
Bruh. Emotional damage.
Amazing.
Fact of the matter is, mass has no ontology. Doesn't exist. It's not a thing. Okay? Doesn't attract things. It's like saying distance attracts things or feet attracts things. Silly.
How did you guys even get to arguing about fucking?
Well, the point is, he's using like Newton. He's trying to use Newton's definition of mass, which has been struck down.
By what? Okay, what is the new definition then?
General
Tell
relativity.
me.
Resistance to acceleration.
What does that have to do with flat Earth, though?
During Newton's time, it was a quantity of matter.
It has to do with flat Earth because mass attracts other mass, and the logical extension from that is that large masses in space would collapse to spheres.
Yeah, well, no. Well, wait till you find out how general relativity actually provides a framework for flat Earth, and we can point to a university paper on that.
Do it now.
Yeah, okay. AC Tort. Let me go get that, or unless somebody else wants to, because it's a popular paper. I'm surprised you never came across this. Yeah,
Wait,
hold on one second.
Okay, hey, cut the bullshit and just present the paper, and we'll talk about it after I read it. How about that?
Okay. All right, great. So I'll post it. And how much time do you need to read it? Like a couple days?
Well, I'm doing something right now, so I'm not gonna fucking drop everything for it.
Yeah, right. So I mean, we can revisit this in a couple days. I have no problem waiting a week or two, even. So let me go get the paper unless somebody else
post
posts
the paper and then tell me what you claim it says and why it bolsters your argument. And then I'll read it. And then if I disagree with what it says and whether or not it bolsters your argument in the way that you claim it does, then that would be the point of contention, right? Once we agree what the paper says, then we can talk about which side it supports, so to speak, right? That would be the logical way to go about this.
It's a pedagogical exercise. There's no debate about what it says or what it means.
There is definitely a debate about what it means.
Nope.
We can agree on the words on the page. That is objective reality, what the words on the page are. But what the intended meaning or the interpretation of that, of course that's open to debate.
There's no interpretation, dude. It's just the math.
Well, I mean, to be honest, right? Relativity is just a gigantic mathematical framework to begin with. It's just a coordinate reference system with different reference frames. All right, hold on.
That's what mathematical models are. They're a framework to help us describe and predict behaviors in the real world. Like the electric field, like a vector is not something physical that I can hold and interact with, but I can describe the electric field mathematically as a vector field filling 3D space, and that allows me to make predictions and calculations about stuff in the real world.
Yeah. So you know what else you can produce from vector models in 3D space that's observer centric? A flat Earth cosmology and your view of the stars.
Oh, hey, I thought observations of the sky were irrelevant to the ground. Thrown out, dismissed.
Well, yeah, they are absolutely irrelevant because this vector model works on any topology of Earth.
What vector model are you talking about?
Well, this one is actually used in star trackers for drones, for satellites. It's called Gaia.
What the fuck are you talking about? What vector topology? What are you talking about? Vector topology of what?
The vector
doesn't make any fucking sense.
The vector math for an observer-centric view of the stars is independent of the topology of Earth, and this has been produced in the Gaia star tracker, which is used in modern systems governing drones and satellites.
How are they using drones though?
You can apply any coordinate reference system. You can apply any coordinate reference system to it, and it's going to work.
Are you talking about celestial coordinates like right ascension and declination?
For example, yeah.
Those are in reference to a celestial sphere, you dumbass. Of course,
a celestial sphere with an infinite radius. With an infinite radius. Therefore, they are vectors.
These are the same people.
What about that conflicts with the round Earth, dude? Yes, we have a celestial sphere, okay?
Yeah,
and
well, what conflicts is you don't
flat
assign.
Earthers is asking them is gravity a sector or a vector. That's what gets
you don't need. Listen, with this, you don't. Your angular displacement with distance traveled is completely dependent on the topology on the ground. You can apply any coordinate reference system on the ground, and it will update accordingly. So right now, what you believe is happening with the globe is basically a 69-to-1 rule, where every degree of angular displacement in the sky affords 69 degrees traveled along the ground. The problem is that relationship has never been measured, never been demonstrable in reality. And in fact, when people actually go to measure this out, it's actually variable.
Where's the have you posted the fucking paper you promised me?
Yeah, I did.
Yet?
I posted it already. Yep.
Okay, what's the timestamp on it? I'm looking through the chat. I don't see it.
30 minutes past the hour, AC Tort.
AC tort. Oh,
Do you not realize there's an infinite number of mathematical models for any arbitrary data set? You're the one
somebody sent me
saying
this
we
before.
have a model, and the model that we have is physically real.
Yeah, the only one that works.
Yeah, I looked it up. The Gaia system is still based on like modern mainstream astrophysics. It's not.
Oh yeah, based on modern mainstream astrophysics. No shit, astrophysics.
No, the whole
Really?
Gaia model stuff is
Really? So do they
that's
assign
not
mass?
an
Do
argument
they
for your
assign
side,
mass
dude.
quantities to the celestial bodies?
You're just making word salad and calling it.
No, like you said, it's based on astrophysics. So I'm asking if they assign mass values to the celestial bodies in the Gaia model.
You said that
The
you
answer
would
is
use
no,
it on
they
a
don't.
flat
It's a
model.
kinematic model, dude.
What I was refuting was your claim that it uses a flat model, and it doesn't.
I said it works on any topological framework as well as a flat one, or dinosaur nugget, or banana, or anything you want. Donuts, we get all this kind of stuff in here. Just like a theodolite, if you have to know, like your theodolite that surveyors use and you think they're measuring a globe, yeah, they can actually pop up any horizontal reference frame that they want, and to include non-Cartesian frames that bend and contort into donuts or dinosaur nuggets, and you're able to take positions and site values and relate them doing horizontal reductions to any coordinate reference system. Because everything you guys are discussing are models. You don't have any actual real physical dynamic relationships between the variables.
Type shit.
Tough shit. Are coordinate reference systems arbitrary?
Yeah, pretty much.
Yep. How do you know if the coordinate reference system that you applied is actually relating to the real world?
Well, you can make calculations in whatever mathematical model you're doing to make predictions, and then you can make measurements and see if they agree.
Excellent. So we measure the surface flat where it should be curving at 8 inches per mile squared. We now have a topological mismatch, don't we?
It's like you can't resist using words that are shorter than 2 syllables.
No, it's absolutely, it's just not words. I'm actually
It's
relating
just
to
sophistry,
specific
man.
concepts.
It's cargo cool.
One's getting upset.
Yeah, can you preserve a standard unit of measuring a Cartesian frame with against a non-Cartesian frame?
Yeah, you can do translations between different coordinate systems.
Great. So you need like a scaling vector value, right? Right. So when we measure the surface to be flat,
you can just do a coordinate conversion. All right, all right. Hey, I pulled up the paper. All right, I'm reading it. Okay.
Right. So they basically modeled it over a developable surface of a cylinder. That's the flat part, right? And they extended the surface
when
down.
I said that I'm reading it, I said I meant that I can't fucking read it and then listen and respond to you at the same time.
Okay, well, I can give you a quick. The part that I glommed onto is the part where they describe a cylinder of basically infinite depth, extremely long depth, such that the vectors of gravity are going to be effectively parallel to one another. See what I mean? You can model this stuff however you like. The limitation's your own creativity. Einstein provides a framework that suits both flat and globe cosmologies. Because coordinate reference systems are arbitrary.
All right, dude. The thing is like 4 pages, but if you don't shut up, or if you want me to respond, I'm not going to be able to read it.
Okay, I'm trying to help clarify my position.
Well, we can do that after I read it.
All right, good. I'm going to go take a shit.
I thought that was what you were doing when you posted this fucking paper in the chat.
No, I shit all over you before I gave you the paper. Now I need some more Taco Bell. I'm about to drop another deuce all over you, so hold on.
Wow. So the physicist was complaining because Yoda was using big words, and now he's making baby noises into the microphone.
I'm sorry when you can't recognize you being mocked to your face, dude.
We have a Glober reading a scientific paper. That's a first.
Yo, what's going on?
Hey, Peter, welcome back to the chat.
It's good to be back. It's finally I see adults are in the room. It was crazy before.
So, have you guys identified like the constitution of the dome?
Nice deflection, man. No, we haven't.
Yeah, like, listen, I know you have a mom.
What is holding in the
but I don't know if your
pressure?
mom's fat or not, right? But I still know if you had a mom.
So we have a Walmart bag like over the flat Earth or some shit. It's keeping the pressure.
Oh, what?
You guys are saying it's pressurized by, a dome.
Yeah, just as much as I know you had a mom, I think your mom might have been super fat too.
Whoa, guys!
Yeah, there's two.
Talking about
Akuma,
flat Earth. You
there's
guys
two.
are way off topic.
Dude, there's
What
two.
is the moon?
Akuma, there's
What is
two
the moon?
claims. Like there's the positive assertion, right? That there's no need for container. Like no need for containment. We have gas pressure. That's the obvious thing. We all agree. We have gas pressure. Now there's two claims,
so
right?
there's
Like
no
so the two
gravity.
claims
You guys
are.
don't believe in gravity. So what is making?
He's just showing you that it was irrelevant for you to ask what is it made out of, knowing that you have a mom. We don't need to know what your mom is made of. But so there's two. There's two.
You
Oh, you
guys
do want to
have
fight?
no
Oh, you
idea
just want to
what's
fight?
going on.
Then
You think it's just magic? Then the universe is just magic, man.
you win, dude. You just won. You dropped the M word and you win. I appreciate your contribution.
It's actually an M word.
Akuma.
Yeah, the M word, magic.
Brother.
Well, the M
There's a
word I
room
was
at
thinking
the-
of was mongoloid for your intelligence levels, honestly.
There's a room at the
Oh,
bottom
what's
of
wrong
the
with
server
Mongols, man?
where they use crayons. That's where you need to go.
Can I share my drawings when I'm done?
Oh, absolutely. I'm an art teacher. I'll give you a grade.
Aren't you the guy that like
muted your dumbass? Yeah, you're right. I am.
My favorite guy right now.
I still will grade your artwork after you make it, of course.
Hi. Hello.
Hello.
Hi.
Who believes the Earth is flat?
I guess everybody but you probably here is on that
Okay,
side.
you guys super retards, actually.
Oh,
Okay.
yeah,
Well,
what's
that's
your
another
evidence? Look, bro, we could be retarded. The Earth is still flat.
He dropped the mic, and that's another win for the globe. This is how they do it. This is their argument. It's a great argument, and that's what they do. I don't know how we're gonna or you or me. I don't know how any of us are going to fare against these intellectual giants who jump in here and say these things like, what is it made of, and you're stupid. There's no rebuttal to that. They're killing it on the internet. These guys.
I went into Flat Earth VC, and I proved the Earth's a globe by calling them retarded.
What did they say? What did they say? Well, nothing, because I left real quick. But it was epic. Yeah, I won. It's crazy.
And if we were retarded, why would you be in here punching down on us? What's that say about you?
Yeah, that's right. I try to tell that to the Globe guys. Like, listen, man, don't get mad at us. You have everything. You have, according to your understanding, you have history, you have science, you have metaphor, you have philosophy, you have everything on your side. It should be easy. You have the internet. You got everything you need. You should be relaxed, calm, and decisive in your dissemination of the flat Earth. but they're not. They're freaking out.
Yeah, it should be easy for them to prove the globe. If you really think about it.
I mean,
but it's not.
Yeah, the reason why we're frustrated is because we were told our entire lives that it was easy, and we went to go check, and we're disillusioned. Like, some of us are going on 10 years of looking for that evidence and proof, and we're still empty-handed, so.
Yeah.
But there's a selection bias problem here, guys.
What's that? I mean, as a glober, I had a selection bias towards the globe initially.
Yeah, let me explain. The people that come here, notice there's a very strong pattern with the globers that come here. 8 out of 10 never thought about the shape of the Earth for more than 3 minutes. Out of the other 2 have gone to some kind of school where they, for a minute were interested, so they remember the memes, Eratosthenes, what about eclipses, and so on. So you have 2 types, pretty much. Don't expect high-level, sophisticated engagement with people like that. Maybe some of them stay for longer, and then they, after a few weeks or months, they get over their initial disbelief. And you
Yeah,
can
like
have a
you did, Peter.
with...
Thank you for joining us.
Yeah. But that's like 1 in 100, right?
Yeah.
8 out of 10 never thought about it. They just come in, troll, throw a few things, disappear. 2 out of 10, they'll go like, did you ever hear about that Greek guy? Right?
Yeah.
So it is what it is. That's the selection
That's
bias.
a good point.
The powerful globers, the gatekeepers of the model, so to speak, they don't come here. They never will.
You're wrong. It's not 8 out of 10. It's 4 out of 5. You're wrong.
Right, dude, I hope. Yeah.
You need to increase your sample size. 8 out of 10.
I get triggered too easily these days. But yes, you got my point, right? Yoder.
I got your point, Peter. That's a good point.
Charles,
you know what? And our community really wants to reach out and find the influencers, the intellectual class that we know is upstream from culture and everything else.
I don't think they'll ever.
Oh, you mean like Jeranism?
No, dude.
Flat Earth influencers like Jeranism?
No, I'm talking about some of my fellow Padres who work in places like Johns Hopkins Applied Physics Lab.
Neil deGrasse Tyson, that's an intellectual guy.
Okay, so is the AC Torque guy in here? The guy who sent the AC Torque paper?
What's up, man? What don't you like about the AC Torque paper?
So here's what they did in the paper. They said, hey, flat earthers say that the Earth is flat. How big or what dimensions would that flat Earth need to be in order to reproduce the same gravitational effects that we observe on the real world? Let's use Gauss's law. So here's what. So here's. And the vacuum. I'm in the middle. I'm in the middle of recapping what the paper said. Okay, I'm not even making any claims at this point. I'm just repeating.
So far
what the paper
so good.
Said. Okay. So what they did was they said, okay, let's use Gauss's law. Let's take the average density of rock, whatever. They have a value, 5,515 kilograms per square meter. That's the average density of the Earth. And let's assume an infinite plane. And how thick would that plane need to be in order to reproduce the same surface gravity? And then they use Gauss's law. They use a Gaussian cylinder, and then they calculated a number. And then that's it. So they said that if the Earth was an infinite plane with the same average density as the planet Earth, then it would need to be 4,000 kilometers thick in order to reproduce the gravity at the center. But the big issue there is that they literally say on, on the second paragraph on page 5, they say, in order to take full advantage of Gauss's law, we have considered in practice unlimited planar mass distributions, which that means an infinite plane. And if the models were finite, then you wouldn't observe. Yeah, you would observe this at the very center, but as you move towards the edge and you were somewhere like in Australia, gravity would be at an angle to the ground, which is not what we observe.
Okay, you nailed it. Now check this out. Let me ask you a few quick questions. These are not tricky questions.
I'll answer your questions. I'll answer your questions. I'll just say a closing sentence.
Dude,
okay.
I created this model.
Just let me say a closing sentence on this. This paper provides nothing for the flat Earth. Like this is not any kind of evidence at all.
You nailed it. All right. Is the sun infinite distance away from the Earth?
No, it is a finite distance.
Okay. Are the light rays coming from the sun assumed to be roughly parallel?
They're not assumed, they're measured to be.
Yeah, are they exactly parallel?
Good job, Peter.
Not exactly, but it's pretty close.
They cannot be, right? Because it's not infinite distance. So we know it's half a degree difference, like edge to edge, so to speak. Okay, cool. So now, if the Earth were flat and extremely vast compared to the size that we explored so far, which is 40,000 kilometers, 80,000 kilometers. Doesn't matter. Let's say the Earth is 1 million kilometers.
Okay,
wide,
so
right? Hold on.
Okay.
Jesus, hold on.
That's the assumption necessary to make this work.
Would then the gravity vectors pointing downwards, as long as we stay within that radius of exploration or that area, would then they be roughly parallel, analogous to sun rays being roughly parallel?
In that hypothetical that you presented, that would be the case. Now I need to ask a very important question in response.
Please do.
Do you or anybody else in this room, are you willing to, figuratively stand up right now and claim that the Earth is, that the actual surface area that we live on a flat plane, and that plane is many, many times larger than the measured size of the Earth?
Yes, I am.
Okay, that is the most I've had any flat earther ever commit to some kind of model or real world prediction.
You're welcome.
Why wouldn't we be open to
it? It's called rigid flat Earth, and it does assume a vast Earth, not infinite, but vast in relation to the area we've explored.
Does that mean that you accept that mass attracts other mass through gravity?
No, I accept that general relativity can be applied to a flat framework.
I'm asking Peter. I'm asking Peter.
Okay, fine. You can talk to. You were talking to me before, Peter. Fine. Hey, Peter, you did a great job with that. I respect what you did. Okay,
hey,
continue.
You're the one who posted the paper. That's fine. I want to talk to you too, but he's the one who responded right now. I mean, honestly, I view all you flat earthers the same.
Let me quickly respond, and I will yield.
We view you guys all the same too, like basically pieces of crap too.
So yes, I accept mass attracting mass for other reasons. I think it has been demonstrated in laboratory settings, but that's why I have been working on a model that I call the rigid flat Earth. Rigid meaning there's a rigid structure inside of the Earth that prevents gravitational collapse. And in this model, the Earth has to be vast for gravity vectors to be roughly parallel in the area that we inhabit.
I agree. If you have such a massive disk, you would need to invoke some other structure that's like not on
any shape, but yes.
Well, so if you have such a massive flat, planar object, you would need to invoke some other structure or mechanism to avoid it from collapsing. So at least that part, I can be like, hey, you know what?
We know that
Good for you.
exists, right? The coffee cup.
Okay, what is that structure?
No. We know that such mechanism exists because the reason why my coffee cup does not become a black hole is the internal rigidity of the coffee cup. Same is true for asteroids. We don't know.
What evidence do we have to show that the Earth is being held by such a structure?
I don't have direct measurement or evidence for that structure. I just have a logical conclusion. I measure the Earth to be flat. I measure that mass attracts mass. Therefore, Earth being quite massive, that we know because we've dug 8 miles, 7.6 miles, but we know that times the surface area that we have discovered so far, that's a lot of material. So we know that there is gravitational attraction between those particles, and it's not forming a sphere because we measure it to be flat. Therefore, there must be something inside or some unknown physical interaction, but let's not invoke that just yet. There must be some structure that resists a collapse.
So let me ask you a question. We agree that the North Pole is a point that someone could theoretically stand on, right?
I agree that there's a point around which the things in the sky rotate, and we call that the North Celestial Pole.
Okay, but is there a point on the surface of the Earth that I could stand when I look up, it appears that celestial pole is rotating around me? Okay. And now I'm asking, so you accept the existence of a North Celestial Pole. Do you also accept the existence of a South Celestial Pole?
Yes, there is another point on Earth where you stand and stars also rotate around it.
Okay, and so the South Pole is a point much like the North Pole is?
In the sense that when you stand there, the things in the sky rotate around that point, yes.
Okay, and so both of these points exist on the same plane?
Yes, they do.
Okay, so you don't believe in the Antarctic ice wall with the North Pole in the center. You believe in some other warped.
I have no reason.
All right. And I will do everyone else the courtesy of only ascribing that specific model and belief to you, because I know how flat earthers are touchy about their models. So that's fine.
Yes, many people do not acknowledge mass attracting mass, and they have their own reasons. I'm different that way.
Okay, that's fine. Because I mean, the model honestly, so far you're my favorite because you've actually conveyed a coherent model that I can draw on a paper, which is so much more than any other flat earther has given me. This also has major issues, but at least they're direct and specific that I can address directly. But at this point, I'll definitely come revisit this with you, Peter, because you've given me a lot to work with here.
You're welcome.
This is just one interpretive framework, dude.
Exactly, and like I said, I'm only ascribing it to him, so I'm only going to debate it with him out of courtesy for everybody else.
All right, well, guess what? I mean, I brought it up, but I mean, if you want to discuss it with Peter, that's fine. Peter, you got this.
No, okay, so basically, I guess I'll ask you the same questions. You gave me this paper, right? So the conclusion from this paper is that in order for, so first of all, do you accept that mass attracts other mass?
I will challenge it actively, but I have no problem with it fundamentally.
Okay, so because this entire framework of this paper is built around the idea that mass attracts other mass, right? So if you don't even accept that starting point,
well, I mean,
then this entire paper is worthless.
I mean, okay, yeah, I get what you're saying, but yeah, it is built around that. Listen, this is what's called an internal critique. So whether or not you personally agree with relativity, what this paper is doing is it's taking that framework and subjecting it to an internal critical evaluation to see whether or not that this framework can be applied to other points of view, to other perspectives.
Well, no, that's the thing. Gauss's law can be applied to any and all distributions of mass. So you take some big mass, you mold it like a potter into some random shape, you can calculate the gravitational field produced by that shape.
Right, and mass, as we know, is basically a constant and has no actual bearing in any physical, tangible reality.
Wait.
Just like a coordinate reference system is arbitrary.
Yeah, but if you have what are you talking about? It has no bearing or meaning in reality. At that point, that doesn't make any sense. It's just because mass is a constant. Okay, so you have some amount of mass, right? Some number
all
of
physical constants are basically physical constants in reality are basically like plugs that accountants use whenever the balance sheet doesn't quite match, and they stick a number in, and whenever they try to reconcile balance sheets again and again and again, the same hole ends up, and they plug it with the same number over and over again. All right, so that's what gravitational acceleration is. That's what the Boltzmann constant is. That's what all these constants are in physics.
Yeah, what you're describing is a constant of proportionality. So basically, you know that there is a relationship between the amount of force that you push on something and the amount of acceleration. And if you push on it with more force, you push on it it gets more acceleration. And if you plot that out, then you can measure the slope of that line. So before you just have input is F and output is some kind of A, right? But when you actually add in mass, you go from a proportionality where you're saying force is proportional to acceleration. Then you can actually get a constant of proportionality, and then you can say force is equal to mass times acceleration, where mass is the constant of proportionality in that equation. But that doesn't mean that it's not real. It just means that in order to use this equation in real life is not some perfect mathematical field with no properties, right? Like if you wanted to calculate a wave moving through the vacuum of space, you have to take into account the permittivity and permeability of space. So you actually have to include that in your equations. But in like just some abstract wave equation that's pure math, you don't have to include things like you can say like the wave on a string is described by a cosine function. In pure math, that'd be enough. But if you're talking about a real string, you need to consider things like the thickness of the string, the density, the density of the air around the string, the temperature, right? All these things are going to work their way into their equation. At the core, it's still going to be that same cosine relation, but it's also going to have a lot of other bits and pieces that are necessitated by actually applying this to reality.
Yeah.
But that doesn't mean that
Indio described. Listen. The point of this paper was, as Indio said, a pedagogical exercise. The point of this was we can use Einstein's framework and we can apply it to this kind of object in an embedding space, and it will work. The point is also to show that the models are basically dependent on whether or not that the elements that go into them are actually bearing any relation to reality. So the question I posed to you earlier is, when we measure the surface not to be curving at 8 inches per mile squared, then why couldn't we apply a model such as this to account for what we experience in reality?
So basically, the only takeaway from this paper that you could possibly make is like when somebody says, "Hey, mass attracting mass precludes the existence of a flat Earth," the only thing you can respond to that is, well, if mass attracts mass, a flat Earth is still possible, assuming an Earth plane that is many times the actual diameter of the territory we've explored.
Nobody listen. You think you know how big the Earth is? Like if we've mapped all the territory on Earth?
No, what I'm saying is that you would have to make the claim that the true size of the Earth is many times larger than all those territories combined.
No, I don't. I just have to say I don't think that you've mapped the entire surface of Earth.
What the paper is saying is that in order for a flat plane to produce the same gravity, it would need to be many, many times larger than the actual
right, because it's a pedagogical exercise. Right. So what we're saying is, like, here's one potential model of a potentially infinite number of models we can come up with. And as long as the grand, like, lambda CDM model of the entire cosmos allows for dark energy and dark matter, then we have an infinite number of plugs that we can use in order to rectify the situation. No. And the god of the gap suddenly appears in gravitation.
No. Listen, I think Peter honestly nailed it on the head, and I disagree with him as a flat earther, but I agree with his approach. It's very coherent. If you accept that mass attracts other mass, and you assert a flat Earth, you must then claim, like, those two claims necessarily lead to a flat Earth whose true size is much larger than the area that's currently been explored. So at the very least, he's intellectually honest about that. So you should talk to him about that.
Well, I mean, I'm supposing that could be the case too, but there could also be other interpretations.
Well, this is the only other one that you've given me, and so if you're saying that, like,
right, so I can give you others. How many of these do you want to see?
Only the one that you personally believe, dude.
I don't believe anything about this. I'm just going with what's empirical fact. And the empirical fact is we've measured the Earth to not curve. And that's a huge problem. That's a huge problem for the globe cosmology.
The empirical fact is that we measure a gravitational acceleration at Earth of 9.81 meters per second squared.
Yeah, so what if that's happening perpendicular to a flat plane?
If that's happening perpendicular to a flat plane, then that necessitates a flat plane that is many times larger than the current known area of all the territories on Earth.
Only according to this particular instance, and this is not the only limitation of that.
No, it is a limitation of that, because what they're literally saying that in order to get these results, they had to assume a unlimited planar mass distribution, which means either an infinite plane or a plane so large that whatever part of it you're perceiving is very small compared to the whole.
Exactly what I said.
No, that's exactly what Peter said.
I agree.
So is that what you believe? That's what Peter
it doesn't
believes.
matter. Listen, I don't have any beliefs about this. I'm telling you what's possible, okay?
Well, what you described is only possible if the plane is that large.
Wait a second. Yoder's point is different than my point. I am actively developing a model that I hope one day can go head to head with the Glober model, at least for Newtonian gravity. Okay? Now, Yoder's telling you something different. He stated that several times. He's trying to make you realize that models are like assholes, right? Everybody has one, including me, my working model, and they don't necessarily reflect physical realities, right? Even physicists, good physicists, will admit that. They will say that, we've constructed very sophisticated models,
I don't really
entire vocabulary of talking about these models, but we don't really know what physical reality looks like in quantum physics, for example. We just have words and equations to reason over it.
Why were you talking about
we have experimental observations.
Yeah. But these observations are not direct. Anyways, it doesn't matter. His point is different than mine, so stop challenging. Okay, don't worry about it.
We have direct observations of quantum phenomenon, yes.
Yeah, but we don't have... Dude, I'm pretty advanced on this topic, so let's not go there, okay?
Let's go there. We have experimentational observations of quantum effects.
I'm not denying quantum physics. I'm a big fan of it. Has nothing to do with the shape of the Earth and gravity at this moment. So it's completely a separate domain. Yeah, I just used it as an example because in that domain, the word particle is used as a mental shortcut. But any good physicist or science communicator will tell you that it's not really a particle. That a field excitement is not what intuitively you would call a particle. We just call it a particle because what else are we going to say? Shambandambab, invent new words? These are not things you experience in daily life, so there are no good words for those things. Anyways, it doesn't matter.
A quantum particle isn't a particle as in like a piece of dust is a particle.
Right, exactly. But a model, but the linguistic model, for example, not mathematical, but linguistic model in quantum mechanics uses words. They're descriptive that kind of intuitively give you a hint, but it recognizes it doesn't describe the actual physical reality. So that's Yoder's point. And let's not talk about quantum stuff anymore because it's distracting. I shouldn't have used that analogy.
Well, Yoder,
his point is different than mine, so don't challenge him with what I told you because I am actively working on a model. He is not. He doesn't care about models.
Yeah, he doesn't believe anything, apparently. And the thing is, Yoder...
No, he doesn't care about models.
This paper is using Gauss's law. Gauss's law is part of the classical physics globe model thing, right? So
Gauss's law is a mathematical law, and it's used in physics as. By the way, the only application of Gauss's law in physics for gravity is purely educational because no such objects exist. Gaussian surfaces don't exist in reality. So the Earth does not have an even distribution. It's not a sphere. It's full of, you've seen those claimed measurements of gravitational kind of discrepancies across the surface.
It doesn't need to have. It doesn't have an even distribution.
Correcting you on your statement, Gauss's law is a mathematical law, and it is used as a crude approximation in entry-level physics in college.
No, so Gauss's law always works with any distribution of mass. The thing is, it's only most convenient to use when there's a high degree of symmetry. But you can always use it. It's just a pain in the ass because you might have to be combining some kind of
you can do calculus over it. Yes, I get it. But so the Earth. Anyways, it's a mathematical law that has application in physics, in mathematically modeling some things. Yes. So what?
So it doesn't make any sense to use classical physics in order to try to describe. Okay, no. So the problem is, right? You guys are kind of talking about the same thing. Okay, so you both well, I don't know, Yoder. He seems to be ambivalent, or at least okay with saying that mass attracts other mass.
Listen, I'm not trying to develop a model. Okay, Peter is, and I respect him for that.
So if you're saying that, if you accept that mass attracts other mass, the logical conclusion from that is that either the Earth, like every other planet we observe, is a ball, or the Earth is a very, very large flat plane, many times larger than the known area.
You have no evidence that planets have mass. Any mass that you
Jupiter,
can potentially measure or obtain, at least through any relational mechanic.
Let's not invoke that. Let's not invoke that, because now we're gonna spurg out, all of us. All right.
No, that's how we covered Neptune.
Whether planets, don't worry about it. Whether planets have mass or not has nothing to do with the shape of the Earth. That we can agree on, because planets have nothing to do with the shape of the Earth.
No.
Why invoke that?
Well, I would say that they are relevant in the same way that you yourself, Peter, acknowledge that without some load-bearing structure or other mechanism, mass attracting mass would lead to a ball.
Yes, but you see, one thing many globers don't understand, that us flat earthers, we're very humble. We're trying to first bring attention to the observable and measurable fact that the Earth is flat. Then some of us are trying to develop a very basic, crude model describing that Earth and what's going on it to compete with the globe. We're not trying to even attempting to touch anything related to the so-called solar system or beyond. So my thing that I described to you is very much focused on just what's going on the Earth. I'm not even attempting to think about how to explain the motions of the celestial bodies. It's not within scope of my research work right now. I'm not. It comes from humility. We have centuries, if not millennia, of globe-skewed science development in academia, and we got to start somewhere. We're not going to catch up. We're not going to catch up in a week. So we start with the Earth.
It's because the classical gravitational model is what explains the shape of the Earth, the shape of the planets, and the movement of the planets.
I was a glober too for a long time, okay, and not a bad one either. So I understand all that.
Somebody asked me what evidence is there of planets having mass. Well,
I'll give you an evidence.
No. I was the one who was asked. In 1846, the existence of Neptune was predicted by analyzing the orbital movements of the other planets, and they observed that they were not orbiting in the way we would expect them to.
It's a very weak evidence. I'll give you better evidence.
It's not weak because we use the orbital disturbances to predict. Okay,
can I suggest something?
No, let me finish. In order for these orbits to look the way they do, it would necessitate a new mass, and that new mass should be positioned.
We've heard this 100 times before.
And then they pointed the telescopes to that point in the sky, and they found Neptune.
I know, we've heard this 100 times before. Here's a better evidence.
So how is that not evidence for mass of a planet?
Well, because it assumes heliocentric model. Can I give you one that does not depend on the heliocentric model?
Okay,
would you like one?
No, hang on. It assumes the heliocentric model. It used the heliocentric model to make a prediction, and then that prediction was verified by observation. Therefore, suggesting that the heliocentric model is correct.
Yo, why don't I get chat?
It's an argument for the heliocentric model. The heliocentric model and the globe model are very sophisticated models, and they, over centuries, were tweaked to explain a lot of observations. We all agree Neptune is out there. Now listen, here's a better argument. We send vehicles to Mars and other moons, and there are rocks there, and rocks have mass. Therefore, planets have mass. So what?
So do you believe that we've sent things to other planets?
I do.
So you don't believe in the firmament?
I believe in a container. Gas pressure needs a container. I don't claim any particular size of that container. I think planets are within that container.
Or modality of the container too. I mean, it's just a container.
Wait. So how does Mars have its own atmosphere?
Local density gradients. Local density gradients exist within the container. We have one on Earth. There's much lower density. You will suffocate when you go 10 kilometers up due to low density of the air.
Okay, and what
That's an interesting take, Peter.
Yeah, you're the most fascinating flat earther I've not gonna lie.
Yeah, but like, what? Ask me 100 questions, like.
Well, because your position is unique among flat earthers. Like, I think you have a unique position.
I know, but even if other people have different positions, the point is that you should take out of this is that planets have nothing to do with its shape, whether they have mass or don't have mass, and what the reasons may be behind their motion. So we are here, it's called 24/7 flat Earth, not 24/7 alternative universe model, right? That's not
Okay,
the title of this,
but here's what's blowing my mind, Peter, right? You accept that entities like NASA have sent robots to other planets, and they have taken photos of those planets and those surfaces, and when you like see those photos and you accept that they're real, I'm presuming, I don't know, you can respond.
I do, because we can observe these planets from Earth. I have a telescope.
But the
if I
problem
got good
is,
at using, can I finish a sentence? Yeah, I could use a telescope. Any one of us, some of us have, looked at Mars, look at the moon. It's kind of obvious that there are rocky objects in the sky. So when people show me a photograph from the moon landing, do you have HD? Do you have like impulse control? When people show me a photograph of the surface of the moon, and it roughly looks like what I see from much further out through a telescope, no alarm bells ring in my head. Same for Mars. But when people show me a photograph of the Earth as a rotating sphere, and I don't see the Earth as being a sphere and rotating while on Earth, then alarm bells do come on.
Okay, so let me ask you a question. When that rover is on the surface of Mars, does it look flat or does it look round?
No, the Earth Mars is obviously round.
No. I'm talking about the view of the camera when it's on the surface of Mars. Does it look round or does it look like a flat surface?
I didn't look at that many, but there are a lot of fisheye lens views of the Earth that show exaggerated curvature.
No, I'm not talking. I'm answer the question I asked you. I asked when those rovers are on the surface of Mars.
I didn't see such photographs. Honest answer.
Well, I can tell you that they look pretty much the same as what we see on the surface, and that would be evidence to say that.
Because guess what? Mars should be curving at 3 times the rate of the globe. And that's funny because we don't have any evidence from that, from all the gigapanned photos of the Martian horizon in infrared.
Wait, so Yoder, do you believe that we've sent spacecraft up into space and landed on other planets?
That's irrelevant. I can tell you that the Martian images that were shown do not depict any curvature rate that would be commensurate with the Martian landscape that requires 3 times the rate of drop over distance.
What does it matter what they show if you're just going to claim they're all CGI?
I'm not claiming they're CGI. Listen, they could have been made inside a warehouse with miniature scale models. They could have been made on Devon Island in Greenland using an infrared filter.
Right?
I have no idea how they were made. And you know what? They could have also actually launched them up into a space rock that you call Mars. Either way, it doesn't matter. What the images show provide absolutely no empirical evidence that they're on a curving rock that has 3 times the drop over distance rate as Earth.
Yeah, okay, so Peter, what really blows my mind is that you're being like, okay, when the camera is pointed at Mars, everything I'm seeing is accurate to the way it really is in reality. But when that camera turns around 180 degrees and shows the Earth, oh, that's fake. That's definitely like not
Well,
real.
you're missing the point. If you truly want to understand, then reason with me. I told you there are things that we can verify. I can verify the shape of Mars by looking at it. I can even verify what it's made of if I used a little bit more advanced scientific tooling measurements to its composition. So when I see photos from the claimed rover on Mars, these things seem consistent to me. The fact that I don't see curvature in photos, we don't base our claim or conviction that the Earth is flat based on photos. We've seen photos of curving Earth taken from the surface of the Earth with an exaggerated curve due to the lens and whatever phenomena. So that's not why we claim the Earth is flat. They're like, oh, looks flat in a photo. There people have done measurements. People have done tests.
No, okay, so it's basically it basically.
And we don't have the ability. If most of us had the ability to go up really high, like to the surface of the moon, and look back at the Earth, all of us, other than those crazy two guys earlier today, would accept that the Earth is a globe if we saw a globe. But we can't do that. Mars, we can look at all we want.
You're just trying to get a free ticket to the moon, bro.
No. What I'm telling you is, at Mars, we can look all we want. We can look at the moon all we want. We cannot look at the Earth, but we can measure the Earth from the position of being on Earth, which is not what we can do with those other objects. That's fine.
So basically, it just boils down to special pleading, saying that
there's no special pleading here at all.
Yes, there is. You're making a special case for like the Earth. You're saying like, oh,
it's not special. It's just a fact of life. No.
You're saying the mass of Mars allows it to contain an atmosphere close to its surface. The mass of Mars allows it to collapse to a sphere, but not Earth. Earth is special. Earth has some special structure that we have no evidence for.
That's not stating a fact that most people do not have the ability to leave the surface of the Earth is not special pleading. You know how many people have gone to the moon? Like what, 20? 15? I don't know. How about the 8 billion people on Earth?
Go to the moon and they report what they say and they live stream their entire journey. You just don't believe it.
Hey, bro, let's be clear. Nobody here witnessed Mars collapsing into a ball, brother. It's pure speculation.
Okay, but we did witness a 24-hour live stream of the Artemis mission showing every step of their launch and going into orbit and going around the moon.
You know what you never witnessed? Your mass attracts mass, forming giant ball planets. You never witnessed that. Not a day in your life. Nobody ever has. Period. End of story. Thanks.
You know what requires special pleading is if you accept that the globe exists with a radius of a certain size, then you get the entire cosmic distance ladder out to the furthest reaches of the universe that can be observed by the James Webb Telescope. But if you challenge that fundamental premise, the first rung on the cosmic distance ladder, the radius of Earth, the very existence of a radius itself, and if you can refute that, then the entire cosmological framework collapses. And that's what we've done. So I'm not going to give anyone a special plea to grant me this one exception that if Earth is a globe, then all this gobbledygook makes sense. Because we have completely destroyed the first rung on your cosmic distance ladder, which means everything else that follows, by necessity, is completely debunked.
Maybe eventually someday this kid will talk about something that has to do with the shape of the Earth.
Yeah, it'd be nice.
I mean, I guess alleged photos from space is, talking about it.
Not gonna lie, I think photos from space are quite beautiful. I like to think too is like a flat earther. You'll reach a point where you can appreciate astronomy, and you're not shoving in all the explanations into a framework that somebody else has presented to you, but you get to appreciate the aesthetic value itself of what it is you're looking at based off of its own merits. That's completely fine. I love astronomy.
Oh my goodness, dude. Dylan's coping, bro.
You can feel it, right? Just like your weenus.
Hey, if the Earth is flat, how is there things that aren't the Earth?
I don't know. Maybe they got a weenus problem. I wouldn't know because I'm focused on the Earth.
The Earth being flat isn't making claims about whether there's objects other than the Earth that may or may not exist, or that may or may not be able to be traveled to. These globers, they're so model afflicted, like they can't comprehend that people actually have differing views than trying to shoehorn everything into a cosmological model where everything's orbiting around each other in a cosmic void.
I've never seen this behavior anywhere else but in this discussion. And honestly, it's that crazy.
Well,
I should caveat that, but not to this extent.
We did a little exercise earlier, and we got to witness some of it from some flat earthers. So it's just part of the human condition, really. It's hard to truly like empty your mind and just be like taking what people say and not trying to, filter it through. You have
that's true.
Idea. It's hard. It takes work.
I'll grant that. Yeah, I mean, we've all been afflicted like this with the problem of underdeterminism in our own lives. In some ways, some of us are blind to it, right? Unconscious bias. Instructions say 2 teaspoons olive oil or butter.
Wait, did homie or what?
I don't know. I mean, I said my thing and then it was silent. And I'm like, holy crap, was that a mic drop? Was that like a mic drop, guys? Did I get a mic drop moment? Yeah, he's gone.
What did you say though?
I forgot, but it was really good.
I told him no one's ever witnessed a planet form from gravity squeezing it into a ball. Then I don't know if you said something after that, but then the next thing I remember, he was gone.
Cosmological ladder, that's true. Text chat, that's true.
Oh yeah. Oh yeah, the first rung of the Cosmo distance ladder.
Yeah, basically we broke it, but yeah. Shoot, man, I'm sitting here like trying to cook some dinner and I missed my own mic drop.
Isn't all the orbital mass interpretations taken from the cosmic distance ladder?
Yeah. Yeah, Keplerian orbital elements. All the distances require it. But it's scalable to any distance. Because at the end of the day, it's based on ratios of periodicity. Just like the equation of time is based off of observations of the sun over periods of time. just like all these relationships, right? What globies want and seem to need are distance measurements, some kind of distance values. And they don't have it. They don't have 69 miles to 1 degree of declination or elevation of a star. They don't really have that, but they want that. They need that for the globe. They don't have an astronomical unit, which is based off of an assumed radius of Earth and an orbital radius around the sun. But they get all that once they back in these values into the relational mechanics they see of the various ratios of the periodicity of these things in their circuits over time. And what's funny is they're able to scale these things up and down. It's like when Ole Romer witnessed the eclipse of Jupiter's nearest moons, and from that deduced that the sunlight takes 8.5 minutes to come to Earth. His conception of stellar distances within the solar system was completely off from what they are today, but the ratios were preserved within the system. And so they scaled it down. He actually thought the solar system distances, I think, were much bigger than what they're said to be today. But it doesn't matter. He's still given credit for assuming the speed of light and the distance to Earth from the sun based off of that ratio. And his ratio, based off of the actual distance that he had at the time to apply, was completely wrong, but he's given the credit for being correct anyway. And you can take all of these observations and you can transform them into any kind of relationship you want. You can put satellites around a ball, or you can put them into freaking spirograph loop-de-loops over a flat surface. Or you can have them actually be a no determined distance whatsoever and use one of these vector models where these things have absolutely no triangulatable position in 3D space because they're based off of an observer dependent relationship. And honestly, this latter edition kind of reflects what we actually experience. Just saying, just like when you and a friend can witness a rainbow, and you and your friend could be miles away from each other but see the same rainbow, but you can't triangulate the origin of that rainbow because it's all observer dependent. Well, there's lots of things in the sky that seem to be observer dependent in the same fashion, and nobody's actually been able to triangulate distances to them either. So. But you know what? If we grant the one special plea for a globe and a radius and all this other stuff and the curvature, then you get your ability to pretend you can triangulate these distances. You can calculate them because now you have a framework of calculation. All right. Anyway,
he was
I'm rambling.
critiquing that paper. He just focused on the last paragraph where it had that one sentence where it says, the Gaussian is more accurate by a planar distribution of like infinitude.
Right.
You focused on that phrase?
I know. I gave that to him. I wanted to argue that, but I let him have it for the sake of discussion. Go ahead.
Yeah, but that's not all it says. It just says it's not goes away from accurate calculations if you don't do that, right? And then you have to augment your calculations with other things. And keep in mind what he said is you could have a variable distribution of mass, but you'd have to it'd be harder to work with. You'd have to augment it with other things,
which is the Earth gravitation model, the geoid. What's funny is like the EGM 96 or EGM 2003 model.
I'm talking about.
I was.
I'm talking about this idea that you can't have a flat surface with gravity pulling you down. It's like they're so broken, this idea that gravity is radial.
That's where I was going with this.
All you have to have is a variable distribution of mass.
Right, which can be projected on a flat surface too. And you got lumpy gravity on a flat surface instead of a curving one around a globe. Right, and because gravitational dislocation is based off of an assumption that gravity is moving starlight, Well, what if there's actually no variation in the strength of a gravitational field other than a variation in the displacement of starlight? You know, what if that's actually what we observe is what's happening, and that you don't have a lumpy gravitational ground field, but you actually have a lumpy star field instead?
Oh man, Peter had to go.
Sorry if that's like too much.
Peter had to go smoke a cigarette. We'll give him the bill later.
Yeah, leave the change on the wardrobe. You ever heard of the Sari Gulch?
No.
Oh man, it was a. I think it's still around.
Show.
Okay, never mind. It's a non-family establishment outside of Fort Huachuca.
Hey AI, how do you one second, yeah,
How do I sound so sexy?
I was trying to get rid of a troll and I accidentally banned Travis. How do I undo that? I thought it was a toggle, but it doesn't seem to.
Just /unban.
It doesn't. No, there's nothing for
or
that.
Dot unban. Unban.
Oh yeah, maybe that. Yeah. Right, I'll get him to test it. Oh yeah, looks good.
All right, so Tyson makes these breaded stuffed chickens. I'm having a couple of these chicken Kiev. It's like a chicken cordon bleu, but with like garlic butter and parsley inside instead of blue cheese. I'm gonna make this with some couscous.
That sounds awesome.
They're better than cordon bleu.
Oh yeah, you think so? All right, I'm in for a treat. Normally on nights like this, I like to do a bit more involved cooking and stuff. You know, like I'll take like a fresh salmon fillet and but in this case, I've had a hell of a day. What is happening? I thought that was a great interaction we had with Quantum Mechanic. Man, so he left and Peter did, huh?
I mean, it kind of. You know, he had
Yeah,
he had to take a nap. You know, he's getting older. He's got gray hair.
Yeah. Maybe they were.
Listen, I'm trying to create a new word. Okay.
Oh yeah.
Yeah. Latin roots are failing me at the moment, though. They're not that great.
I took 6 semesters of that in high school. Ask me if I remember much.
I mean, dude, how absurd even is this entire dialogue anyway?
Well, you brought it up. You already tried that gambit.
I mean, just
failed
you now.
miserably. You already tried the absurdity gambit. and it was you making the absurd claim.
The absurdity gambit. I mean, look, I'm
The
not.
absurdity gamut that seeing a drone is more absurd than seeing the ISS.
To me, yeah, I said to me, in my opinion.
That's crazy, dude. You did it
The
again.
drones are way easier to see than the ISS.
No, it's that. It's that it just never lands. Then no one's ever seen it land. Like if it were a drone, it would have to get refueled, wouldn't it?
Do you see it go out of your field of view? Are you seeing it 24/7, or are you just seeing it and
My God,
seeing it disappear?
That's
what I mean. See it land. See what land?
The drone, the supposed drone that is the ISS.
Drones and airplanes land all the time.
Yeah, exactly. So why would show me it landing if it happens all the time?
Show me orbiting the Earth.
I mean, it is. It's in that video I linked to.
It is because I said so.
No, it's in the video.
Oh, so the full orbit's in this video. You can see it go around the Earth.
No, you said orbiting. You didn't say completing a full orbit.
Okay. What can I see? What does the video show before I look at it? What does it show?
It shows a guy with a telescope looking at the ISS.
You can't see if it's fucking orbiting the Earth from a telescope.
Okay, dude. I mean, okay.
Just say what it is, tourist. It's a light. It's a light moving across the sky.
I mean, it's more than a light. Like I said,
It's a guy. It's a, as you called it. It's a white rectangle moving across the sky.
The shape of the ISS.
You gave the game away, and Gemsy pointed it out. You already believed it, and you proved it yourself that you already believed it when you made a sociological argument that about the Soviets or the Russians in the United States, and that the Russians would have ratted out the United States, which is just your subjective opinion about it's your subjective opinion about social matters, about what this group of people would do to that group of people. It's just nonsense. You don't know what these people would do. You don't know any of them.
I grow bored of your just endless contrarianism. I'd love to hear
It has nothing to do with contrarianism. It's pointing out you have no knowledge.
Yeah, sure.
Let's say that you characterize your lack of knowledge as my contrarianism.
You know, I just find I get it, radical contrarianism, but
there's nothing. That's a shtick, dude. Your little narrative shtick isn't going to work.
That's your shtick. What do you mean? I'm not a contrarian. I actually believe certain things.
Yeah, you believe things that there's no basis for, other than your feelings.
At least I believe certain things. Like, there's no basis for God. I believe in God. There's no basis for Jesus' divinity.
There's a basis for believing in God. There's plenty of basis for that.
Fine, but I believe in these things anyway, right? You don't believe in fuck all. You're just contrarian.
You're talking about. You're saying that you can predict the behavior of what people would and wouldn't do of complete fucking strangers. Yeah, they would do this.
Yeah, dude. I mean, look, it's okay. Like, my brother's
is that an educated guess?
Contrarianizing, like,
what is your opinion based upon about what they would or wouldn't do?
I feel like I could say,
what is their opinion based on about what they would or wouldn't do? You have a real hard time answering questions, don't you?
Who? Is someone possessed by now? Who?
Well, let me ask you, are you here to figure out what the truth is, or are you here to just try and win an argument?
No, I would love to hear your own thoughts and opinions on the flat Earth. Genuinely,
the Earth is measures flat, and it's not moving.
Me. That's what I find more mentally gripping from the flat Earth.
How is that mentally gripping? The Earth looks flat because it is flat. It's tough. I know.
Look, hold on. Sorry for over talking you there, but I understand the kind of essential argument that pretty much most things that you do in life are a leap of faith, and you assume based on structures of authority, right? People will assume a scientist is right without really reading the paper they wrote. And we do this every single day. If you sit down in a chair, you're assuming based on your own senses that it's not made of cake, right? And that it's actually made of what it looks like. I understand this sort of the radical skepticism. I do understand.
It's way worse than that. Most people believe in some scientific crap, right, that they heard, which isn't based upon anything a scientist ever said, B, not based upon any actual science, scientific experiments, scientific observations, or anything. It's just a narrative. They think that there's my magic science guy out there that proved all the things that some newspaper claimed the scientists proved. But when you look deeper into it, no scientist ever said that. No scientist ever did anything. It's your credulity that's the problem.
There
Why are you
scientists
interrupting, dude?
The ISS is real. Like, let's be real. There's scientists who have thought the Earth was round, right? Yeah. I mean, dude, like Newton, Einstein, like any scientist on the ISS, they're all PhD.
Newton wrote more about alchemy than any other subject. Newton died from drinking mercury. He also played with dolls.
Okay.
And died a virgin.
Look, the Roman Empire was constantly lead poisoning themselves. Does that mean that like everything they did can just be completely written off?
No, it doesn't. But you're like making these appeals as if somehow these people have some special knowledge. Newton didn't know if the Earth was a ball. He had no way to know that.
You just said like there's no scientist who said that. I'm just saying, what about this one?
He said Einstein. Can you post Einstein doing like a scientific? My bad. Einstein was Einstein a scientist?
You missed the key part. The evidence part. The evidence. Newton had no evidence the Earth was a ball. He can believe whatever he wants. What was his evidence that the Earth was a ball?
I mean, he wrote a few papers on the subject. I don't think he just like based it on vibe.
Great, he wrote papers. Who cares? What was his evidence?
I mean, dude.
See, this is exactly what I just illustrated.
Determine, like,
is that
light refraction and gravity? You literally like designed different methods to, conduct light refraction tests. Like he wasn't just out there like vibe checking.
How is that evidence the Earth is a ball? Taurus, you just literally proved my point.
This is just the endless contrarianism. Like, I get it.
There's nothing I'm saying that's contrarian at all.
I understand it doesn't. Like
that is just spin. You're just trying to salvage. You're getting cooked.
You can say that, right? Like, I'm not even really trying to argue with you. Like, I see the argument. That's hyper-skepticism.
Nothing I said is skeptical. I asked you a question. You have no answer.
Sure, it doesn't, bro. It doesn't. There is no, like, you can't independently verify it. There's your answer. What do you say to that?
No, you don't even know what that... Taurus, what I say. I said the problem isn't that...
You said,
the problem is that people don't know anything about science. They don't know anything that any scientist did. They don't know anything about the evidence that was gathered for the scientists to reach the conclusion they did. I asked you, what's the evidence that Newton had? Because you brought him up as an example of that the Earth was a ball. And you are proving my point by not providing the evidence that he used. You just believe a narrative, have no idea what the information is that supports that narrative. Not whether you looked and found it yourself, even what it is at all.
All right, dude. All right. Like, I know if I do go out my way to go find some Newton shit, you're not going to believe it anyway, so...
Oh, shut the fuck up, bro.
Hilarious. He's saying Newton.
It's genuinely true.
India points out you don't even know what you mean when you say Newton did this or did that. You don't even know what he did, and you just saying Newton did something.
Yeah,
you don't even know what it is.
I can find.
You don't even know what I referenced, bro. Like, you think Newton didn't come up with an equation that scientists to this day?
An equation. Science is empirical. It's based upon evidence in the natural world, not equations.
Oh my fucking god, dude.
Is science not based on experiments? Taurus?
Taurus, did you just learn that?
They just write down an equation and just go, hey, we have an equation.
What do
you don't need to do anything else.
Squared is, bro? Like, that's a fucking equation. You know that, right?
Does that equation, whether it's true or false, or whether it models reality, does it have to be validated by experiment or observation?
Yeah. Do you think he just vibe checked the second law of motion, or do you think he actually had some basis?
Oh my god! How does the second law of motion prove the Earth is a globe?
No, you just said
I just said
we're
what?
not trying to prove the Earth is a globe. We're trying to prove that Isaac Newton employed the scientific method. That's what we're currently arguing.
He didn't employ the scientific method, and he admitted it.
Let's get to the proof the Earth is a globe. Then let's move on. So go do. Let's get to that.
Well, that's what I say, dude. You keep trying to bring it back. Like, forget that. Like, I would love to hear an actual.
What's the proof the Earth is a globe? What's the proof the Earth is a globe?
Zodiac, forget it. Let's say I acknowledge the skepticist argument and I take in radical.
It's not skeptical. There's no evidence to be skeptical of.
No, but like honestly, in good faith, let's
there's
say.
There's no evidence to be skeptical of. You're trying to get a free one that there's evidence that's being denied. There's no evidence.
Okay,
you deny. No, because this is just narrative bullshit. Sitting there listening to you say you're skeptical of the evidence. There is no evidence to be skeptical of.
I'm
never presented any evidence. You present a narrative. Claims are not evidence.
I'm not trying to make
I'll be skeptical of that.
I'm agnostic right now. Like, I'm fully agnostic.
Do you have any evidence to be skeptical of that you can present?
Yeah, you yapping about what you believe is not evidence for what you believe.
Yeah, you're right. I'm completely agnostic, and I'm aware of that.
It's evidence about your mental state. That's all it is.
You're agnostic, so you're not a globe earther?
And believe me, I am not skeptical about your mental state.
That's what I'm saying, Zodiac. That's what I'm saying.
So you're not a globe earther?
Yes, that's what I mean when I say, let's say I'm being agnostic and I voice the skepticist argument.
So can you say out loud that you do not believe the Earth is a globe?
Yeah, I think it's a globe, bro. I think it's flat as a disc, right? Like, let's move on. What do you think about that?
A disc? Nobody said it was.
Oh my god, dude! I'm trying to agree with you. Like, I'm trying to get what are your own belief on the subject.
So you do not believe the Earth is a sphere?
Nope.
Based. Honestly, based.
Yeah, the Earth's flat, Jack.
I mean, just look outside your window. Do you see a globe?
Flatter than a flapjack. I'm about to flat smack Globers. Get your bags packed.
Finally, bro.
Yeah.
What took you so long?
Yeah, lesson one. Bro. No curvature to be found. How can it be a ball if nothing about it is round? Lesson two. Have the Earth covered in flat water.
Why are we just letting this guy go on like this? Like, really?
Yeah, what happened, dude?
Oh, he's finally telling the truth.
Lesson three. Take a look at the stars you see.
I don't think I've heard one bit of truth from this guy's mouth the entire time I've been listening. I haven't heard one bit of truth come from this guy's mouth the entire time I was listening.
Wow, that's a freaking harsh indictment, dude, because Mick is very diplomatic and forgiving.
Wow. I've gained the ire of Mick.
No, he's not the ire, the evaluation that you're dishonest, dude. he of all people is very he gives the benefit of the doubt to people saying things and just presuming they're fucking honest.
And they do. You know the worst part? I was asleep half the time.
You're wrong every time?
No. I was asleep half the time, but I could still suss it out. Alright?
You are asleep.
It's like I'm a psychic or some shit. Like, dude, you're full of shit, bro. Quit with this fucking rambling nonsense, man.
Look in a mirror, genuinely.
Look in the mirror.
I mean, yeah, genuinely.
What am I going to see? What am I going to see?
Say those words to your fucking self.
Yeah, dude, exactly. Yeah, I don't want to look at myself in the mirror, dude. My fucking beard's all messy and shit.
I didn't need to know that.
Is there a silver lining?
Like, if they had any value to what I'm saying.
You can ask.
Right?
Like, genuinely.
What I've heard come from your fucking pie hole, okay, this entire time is nothing but weaselly nonsense.
Okay. Weaseling out of things is what separates us from the animals, except maybe the weasels.
You see what I mean, right?
Okay, we can't access the ISS, so give us something that we can actually test that prove the Earth is a sphere.
No, I'm agnostic, bro. I think it's flat as a disc. Like,
no, even better, tourists. Can you just come to your senses, be honest, and admit that you don't know what you're talking about? Can you just admit that you don't know what you're talking about, tourist?
Sure, dude.
And he contradicted himself.
There you go.
So there you go, a concession. He doesn't. All this time, he doesn't know what he's been talking about.
Sure, dude, I'll concede immediately. But like, what's your opinion? Like, any opinion, any real belief at all? I'm excited to hear it.
Okay, when you go outside. Go ahead, sir. Go ahead. Whoever talking.
I was saying. I mean, like, what's the point, man? Like, not 10 seconds ago, he contradicts himself, and now he concedes. Like, where's he going? Is it over yet?
I understand the skeptic argument. I do get it.
Why do you keep calling it a skeptical argument, man?
It's a type of philosophy.
Not a skeptical argument. You have no evidence to be skeptical of.
No, I mean your argument. Hold on. I mean your argument that the Earth is flat. I understand the skepticism of that argument, which is like the hyper skeptic. You can't trust any source of authority. You can only independently verify.
Yeah, straw man. Keep piling it up. No one said that. No one said any of those things.
Okay, well, let's hear anything you believe then, if that's the case.
I don't believe things.
Exactly. So you're a contrarian, like I said, like a hyper skeptic.
No, I'm a direct realist. Meaning,
a direct realist.
Yeah, that means I go out, I make observations, and that's how the world is.
So hold on,
when I go out and I see the Earth is flat, and I detect that it's motionless, I just assume that's what it is.
Okay, so you do
It
believe
looks
so.
flat because it is flat, and it's motionless, feels motionless because it's not moving.
Okay, great. So you believe it's motionless. You believe it's flat.
Believe? That's what I
There's a
experience.
tree outside your house. Yeah.
That's what I experience.
That's what we experience. Yeah.
What do you mean believe? I know it's that way.
Well, no, you believe it to be that way.
I feel it.
Yeah.
Taurus, when do you experience the globe in real life?
When do you experience anything, dude? You're locked inside your brain.
When do you experience everything? You're real. Brain in the jar, Zodiac. In 10, 9, 8.
What?
Taurus, when you look outside your window, can you describe the shape of the floor without, obviously be generic, don't dox yourself. But when you look outside, can you describe the shape of the Earth that you see?
I mean, dude, I'm in London. Like, I'll just say that. But like, so I can't see shit because it's like a metropolis. So I don't see a horizon line or anything.
You can't see the floor, the streets or anything. You can't see the ground at all?
He can see all the buildings that are parallel to each other, level, flat, horizontal, according to water levels and the orientation of the whole city. Is evidence that it's not a sphere because there's no curvature between the buildings. It's all parallel.
Let's put this dude on ice and deal with Eskimo Greg because he's talking nonsense in the chat. Eskimo Greg.
What up?
Okay, you said. How do you think GPS works? How do you think it works?
Positioning. Satellites rotating around the Earth.
Yeah, but that doesn't tell me how it works, dude. How does it work?
As they ping your location.
Nope.
Like tower.
That was a rage quit.
You have no idea how it works. You've made up something in your head about how it works.
All right, I'll go.
So that's very funny.
I'll
that you're sitting here calling us science deniers when you don't know the first fucking thing about what you're talking about. GPS uses a technology called trilateration. It's not two-way communication. Your GPS receiver doesn't talk to satellites. It gets there's a Rhinex message that has a timestamp in it, and it takes that timestamp and gives you the time of flight and tells you the distance to wherever the transmitter is. And if you have four of these, you have overlapping circles, then you have overlapping circles, and that will give you a position. The grid, which that puts you on, is something called Earth-centered, Earth-fixed coordinate reference system, which puts you on a tangent
nothing about
plane.
what you're talking about.
I'm describing GPS in detail of how it works. Technologically.
He doesn't want to hear it. He doesn't want to hear it. He doesn't know how it works, but he doesn't want to hear how it works.
The thing is that you do believe that there's a tree outside your house. You believe there's a tree outside your house.
We move on from you. Tourist, just mute yourself, Tourist, for now. Thank you.
Shut up, dude. Eskimo. What is differential GPS, and where are those beacons located? You have no idea how any of this shit works. Like I said, you made up in your head how you think it works. But it's literally just made up.
You're just making up shit in your head.
You can fact check everything I just said. You can fact check everything I just said. While you Google it. And try to figure out what you believe, why you believe it, ex post facto. You know what Earth-centered, Earth-fixed is? It's how your GPS receiver, that's your coordinates. Earth-centered, Earth-fixed. You know what that's not on a globe? You know that's on a plane? because the coordinate is up, down, east. When you see it, after coordinate conversion, it'll display it in latitude and longitude. Oh, he bolted.
He's gone with the wind.
Tell us, Eskimo. Tell us, Eskimo Greg. Tell us more. But I want to hear more about how we don't understand science and how all the scientists agree and how this and that and the other thing.
Sounds like
here goes. Brown Recluse is going to be a fucking retard too.
A short version of
let's not get insulting, Indio. Let's be nice.
Yeah, well, stop being a dummy, dude.
I'm just trying to talk with that guys about the scientist claim that the other guy was talking about, man.
There's no such thing as a globe Earth scientist or a flat Earth scientist. That qualifier is just arbitrary nonsense, dude.
What would you call a scientist that believes in the flat Earth and a scientist that believes in the globe Earth?
Their beliefs are irrelevant.
But that's what we're talking about in chat. How is it irrelevant if that's what we're talking about?
It's irrelevant.
But that's what we're talking about.
To what they believe.
How are their beliefs irrelevant to what they believe?
Dude.
No, the Earth being flat is not determined by beliefs.
There's no such thing as a flat Earth scientist.
A scientist who believes in the flat Earth would then be a flat Earth scientist.
There's scientists that are flat Earthers. Yes,
I did.
Okay, then why are we talking about it?
Because that's what was being discussed in chat. I joined into a conversation.
Why is it? But why does it? What's the point?
What do you want me to like get into?
Brown, you don't get it. There's
point
also
of the
mechanics.
existence or non-existence of so-called flat Earth scientists?
Again, regardless,
what does that tell us about the world?
That the scientist's beliefs does not dictate the shape of the Earth, right? I agree with that. That was never my claim. I was only engaging with what was happening in chat. I didn't create the topic. I was simply
look. If 99% of the scientists in the world thought the Earth was flat, would you become a flat Earther?
No.
Okay, then it's irrelevant.
So I'm just engaging with what's happening in chat. I didn't make the topic, guys.
Okay.
Any other Globers want to step up? Who's ready? Who's ready to defend this?
You said it more than once. The guy said you have no science. And then you went to scientists. Scientist isn't science. Scientist is a human practice. It's a systematic study of the natural world and the things in it. Just because someone's a scientist doesn't mean they are doing science. So think about a geneticist. He's doing science in a particular field. But if he says the Earth is a globe, that isn't a scientific claim. And even if it was, but that being said, the Earth is a globe is not a scientific claim in the first instance, because it's a claim about the shape of something. That is geometry. So when you claim the Earth is a globe and that's based upon science, that's a category error and it's nonsense. The reason you guys do this is, see, what I'm doing right now is exposing propaganda. The reason you do this is because science in the modern day has taken down this whole other meaning, where it doesn't mean the systematic study of the natural world and the things in it. It means truth. It means we can't debate this. It means this is an unquestionable truth. That's why you guys use that word when you say Earth is a globe is proven by science. You don't want to provide evidence that the Earth is a globe. You just want to say the magic word science. And then all else falls to the wayside.
Exiting through the back door. 1, 2, 3.
India, what science do you use to measure a 2x4?
You don't. I use a tape measure.
Why are they so hung up on science if it's a question of measure?
Exactly.
All right. Is there anyone else here that?
Like I said, the reason they use that terminology is the propaganda. That's all it is. It's just a rhetorical technique.
What was the quote from, what was it, Tesla? Somebody said that basically science has become mathematicians just figuring out equation after equation.
Or something.
Yeah. Can't remember the quote directly.
Go ahead, Zodiac. You go ahead. Sorry.
I was just gonna say, is there anyone here that is believes in the globe? Okay, never mind. Carry on, guys. Go ahead.
I believe it was something like modern scientists have foregone the scientific method and built mathematical equation on top of equation and are left with no relation to reality. Something like that.
Yeah. Yep.
Isn't that why there's a word called pseudoscientists? Like, there's a confusion. I mean, not a confusion, but
I don't know. I was listening to that guy earlier, but I couldn't come off mute. It was kind of funny. It made me think about how easily millions of people were convinced by the broadcast on radio of War of the Worlds that we were being attacked by aliens when he was talking about the ISS. I'm like, people can be shown the propaganda and the pomp and circumstance from a source in which they believe is an authority and can believe something that's complete fiction. I was just thinking about that when the guy was talking about the ISS and all of his claims.
know, that's funny. It's like stuff like that got memory hold. All that stuff is just it's like it's lost. So like people in their 20s and 30s, they don't know anything about that, and it's not taught to them. They don't even know it even that those events ever happened in the first place. It's like it's like modern society is more like, oh, just pay attention to what's happening right now. Don't think about the past, right? So, the particulars of how we got to where we are, they just like pretend that they never happened in the first place. But I want to read something from Albert Abbe's Electromagnetic Theory, which I think is quite funny. It's a quote from there. It says, "It was once told as a..." Now, this is a person that invented calculus, vector calculus. So he knew a lot about mathematics. "It was once told as a good joke upon a mathematician that the poor man went mad, and he mistook the symbols for realities as M for the moon and S for the sun." And that's how these guys are. They think the variables in the equations are actual physical things that exist in reality.
Way to put it, and pretty simplified. Yeah. Thanks for that.
Yeah, the Globers often conflate math and science. I mean, those are two completely different categories, especially even in education, right? They don't conflate the two. It's math and science. It's not one in and of the same. But going back to the War of the Worlds broadcast, I feel like that was one of the first litmus tests for once they started to get into space exploration, right? Like, what would people believe? Would people believe that this is even possible? Have we convinced them enough that it's a globe that we can move forward with the next step in the operation? I feel like there's a lot of litmus tests that they do. The pandemic being one of them.
Oh my God, that was a crazy one.
Yeah.
Look, if the Russians invaded the United States and were like, and took over our airwaves and were like, "We're invading, we're declaring martial law, everybody stay in their houses and don't go to work," nobody would have listened, right? Fuck you, I'm grabbing my gun, I'm going to work. Like, who the hell are you? I don't care if you're invading army, I don't give a shit about martial law. You can't tell me what to do, I'm free. But Donald Trump gets on TV and says, "Don't go to work, stay in your house. Flatten the curve." And everybody's like, okay.
Yep, it's a great way to usher in the new economy, right? Shift everybody to working from home, right? The new normal. Everybody's in the new normal. We're all stuck in our little boxes that we live in, and we're working from home, and now they're trying to push everybody back to office. So when people become complacent in the 6 years that they've spent in their home, in their workplace, that they had to uproot themselves and change their whole routine because they were told that the pandemic was happening, now they're being told to shift back to the office. And if you don't comply, then guess what? Don't worry. We've already replaced you with AI. You don't want to play the game? That's cool. You don't want to come back into the office 5 days a week? Guess what? You can just see yourself out the door. It's an easy way to get people out of the workforce, contemplate whether or not AI can actually replace them, and the people that remain are just stuck there building the AI that's going to eventually replace their jobs.
It also injected billions of dollars into the industries of biometrics and all that stuff, and really, it took off running. It was a good reason to really develop those systems further.
Contact tracing. Snitch on your neighbor. Take this test to prove that you can function in this society. A lot of things implemented for sure.
All I know is our ancestors are rolling in their fucking graves calling us pussies.
I remember when it first happened, and there was like the great toilet paper shortage, and I thought to myself, I was like, so this is when the 3 seashells get invented.
That's funny. I didn't listen to any of that crap. Now, I would put on a mask if I had to go in the store because they wouldn't let you in otherwise, and I didn't feel like starving to death. So just out of necessity, I did that. But I didn't do any. I've never been tested for COVID or any of that crap. Didn't play that game.
You have to put the mask. You don't want to be arguing with. You don't want to be arguing with every Karen, every corner.
Yeah, the toilet paper thing's hilarious,
especially
right?
in Boston.
Well, if you were in I was in small town, America, and if you didn't have your TV or your internet on, like you wouldn't even known anything was different.
I know that
because all the toilet paper was gone. Of all the necessities in life, people go for the toilet paper. You can literally just spray your ass and wipe it off with the washable washcloth.
It's funny though, to a degree. It's like, out of all the things I really need to think about, because I'm never working again and never leaving the house again because some idiot on the TV said not to, and I just decided I'm going to do what they say and ruin my own life because of a talking stranger. But I can go out for a little while. What should I get? Toilet paper. It's crazy, dude. Like, out of all the things, that's what you grab?
India, not
probably still people right now with like a warehouse of toilet paper going, I'll use it eventually.
Yeah, India, not the food that would then lead you to eventually need the toilet paper. No, not that.
Come on, they think about food.
You can replace the toilet paper shortage with a bidet and a washcloth. Problem solved.
You could do what they do in like Somalia and just drag your ass on the ground.
Yeah, that's what dogs do.
That's what dogs do.
Somalia do. I'm not making that up. My friend was stationed there in the army, and he said, "Oh, they just drag their ass on the ground and throw sand up there." Like, okay.
I was recently in the Philippines, and they have little sprayers by every single toilet, everywhere that you go. Little bidet sprayer things. Little handheld ones like you used to have on the sink back in the day.
Yeah. That's convenient. No, I mean, the whole thing with the pandemic thing is like how little they had to do. I think of it like this, right? You have a horse, and you couldn't control a horse with just your arms, no matter how strong you are. But if you have reins, right? Little bit of pressure on the reins, you can make it go in any direction. You can make it pull thousands of pounds or climb a steep hill. And that's how they were, a little teeny tug. And they made the whole society make a radical change that was against its own, which should have been against their own survival instinct.
But that's a domesticated horse, because if you get the wild one, that stuff is not gonna work until you break his soul.
Yeah, true. Well, I mean, that was probably the same thing with the pandemic.
It's wild how this relates, you know. It wasn't just strangers saying this thing. It was a man with the label of scientist in a lab coat. It's this belief, this unquestionable belief in things given that label that allows these sorts of things to happen.
Yeah, but I don't think it was like Fauci or any of those guys that the public was like, oh, Fauci said it, I better do it. I think it was like the government, when the government said it. I think it was when the public officials were like, you really got to do this. I think that was kind of like, it was like what actually motivated them to listen. And I don't think it was like a thing where like, I'll get in trouble if I don't. I don't think that was like the motivation, the penalty. I think the motivation was just conformity. I have to do what everybody else is doing. I don't want to be the odd man out.
Yeah, the suggestion that they will say, if you don't do this, you are like a grandma killer, you know, like an old people killer. They say that they use that wording, and the people are like, if I don't do that, then I'm gonna affect my loved ones or whatever, right? So people convince themselves, basically.
Well, I remember people
that type of argument.
I remember people not even doing it to kneel down to the government, but to do it in to obey the WHO. They said the World Health Organization said so. I must do this. It's like, hey, we're in the United States. Yeah, it's crazy.
Hey, Brown Recluse, you got any evidence of lasers magically bending around a sphere? Or just bending down at all over a large distance?
Lasers going straight over large distances without begging the question?
Yeah, we've got footage of it.
Right, so
plenty of footage of lasers going straight.
The footage is what we're talking about, so that's begging the question. You're providing the evidence. The evidence the evidence in question is the laser test videos. So you can't use the laser test videos as evidence for the laser test videos being valid. So what's your evidence that lasers do not bend over large distances?
Wait, what? Okay, the footage of the lasers going straight over large distances is not.
How did? That's the whole thing that's happening.
Really?
How are you verifying that it's straight?
Because we can see it going straight. We can take side views of the. Yeah, we can. We have side views of some of the laser tests, right, using rectilinear lenses.
The longest side view you have is 6 miles, exactly. But the laser test we're talking about is 20-something miles, right? So you don't have a side view from 20-something miles. We're talking about large distances.
Wait, why didn't? Okay, so.
Yeah.
Yeah, it's ostensibly straight at the horizontal or what is it?
There's no evidence that exists of a laser.
It's over.
Yeah, so this is the thing. The lasers hit the target, and you don't have any. So if it's hitting the target, shut up, shush. Yes, it hits the target, right? The beam goes directly into the sensor of the camera, or it hits the target if there's a physical target set up, right? Like an actual
physical target. You said it goes to the center.
Yeah, there is in some. You can't see it at all. You can't see it at all until the center of the beam hits the sensor of the camera. Until then, you can't see it at all.
Nigger.
Upwards in one
you
shot.
Fucking dirty nigger. Porch monkey, nigger.
We can both hopefully agree that you can see the laser without it pointing directly into the camera. Can we both agree to that?
No, you can't see. Okay, so it shouldn't hit the target because there's a giant hump. There's hundreds of feet of Earth curvature that should be blocking it.
Right, but I just explained that you can see the laser without it going directly into the camera, correct?
You would see it 100 meters up in the air.
Let's address my question. Can you see the laser without it going directly into the camera?
No, because it would have to be 100 meters up in the air, and there's you don't see a laser 100 meters up in the air. The only way you could see it, right, is if it's going over the horizon, which should be at less than 3 miles, right? And then the hidden height would be over 100 meters.
All right, listen. If you saw the laser going above your head, could you see it without it going directly into the camera?
Probably not, unless you did long exposure or over a shorter distance.
So if the claim is that if the Earth is a globe, you should see the laser going above your head. How are you going to see the laser if the laser, if the camera can't see the laser?
It's a direct hit. It's a direct hit. It hits the target. We also have side views where we get long exposure and we can see the entire transit of the beam.
The claim
to 3
is that if the Earth was curved, the laser would go several hundred feet above your head. Correct?
Yeah. But
would
that's
the
not
camera
what's
be
observed.
able? Oh, sure, but would the camera be able to see that laser?
It wouldn't be a direct hit. And
okay, so answer my question. Could the camera see that laser going above your hypothetical head?
Yeah, it should be able to.
Okay, wonderful. So we agree that the camera could see the laser and it's not a direct hit, correct?
That's seeing the laser is different to it being a direct hit directly into the sensor of the camera.
I agree. I agree that those are two separate things, right? But do we agree that the camera could see the laser while not being a direct hit?
Yes.
Okay, wonderful. How are we verifying that it's a direct hit?
Because the only way you can get that level of brightness is you can't see it until it hits that sensor of the camera. Till it goes right into the lens. If you right, so what you should do is you should watch Dr. John Dee's videos on how lasers work. Okay, learn how lasers work.
Post them, please. I'll take a look at
it. Just go to YouTube, type in Dr. John D.
I type in Dr. John D. Like, what I get is Bob the Science Guy, Dr. John D, and the fallacy of flat derp, right? That's what comes up when I look up Dr. John D on YouTube, right? So if you would like to provide what you want me to look at, otherwise I'm just going to watch this guy.
Just go to his channel. It comes up if you type in Dr. John D.
Dr. John D. All right. Is it, does he have 55,000 subscribers?
No, he has 5.41 thousand.
It's 5,000. Okay, wonderful. All right. Is there anything specifically you want me to look at?
Yes. Go to the search, type in laser.
All right. Laser divergence, laser observation, lowest laser point, error lies and deceptions of West.
Yeah, that's a good one. Right. So he goes over
which I said like lasers. 6 of them. Which one? I said like 6 of them.
All right. So the ones that says errors, lies, and deceptions of West, I think he goes over.
So none of the things that say laser. Okay.
What comes up when you type in laser, right? So I typed in laser and it came up.
All right. It's a 22-minute video, so it's going to take me a while to go through.
Why are you being such a bitch, dude?
Why are you throwing insults around?
Well, it's the way you're talking. It's basically like an insult. It's like this weird little like passive aggressive behavior. You can't just have a normal conversation.
I'm frustrated with you specifically because you were a bitch when we were chatting in the other server, right? So I'm frustrated with you specifically and your ignorance.
That's only because you were being the same as what you're being now, right?
I was in chat. I was typing in text. How are my text messages sassy? And just to clarify, your claim in chat when you texted me was saying you said I was clogging up the feed. So are you changing the reason that you banned me 2 days ago?
No, I never said
I was clogging up the feed.
That's not what I said.
Absolutely. Let's go to our texts. Let's see. You're wasting time. Go whine. You're wasting time. Stop muddying up the main text with cope. That's what you said.
Yeah, that's what you were doing.
Okay, wonderful. So are you claiming that I was being sassy or was I muddying up the main text?
Yeah, you were being pathetic from what I remember.
Okay, you're just saying shit, dude. I think you're pathetic. So we both think each other are pathetic. So where do we go from here?
Where's your globe evidence?
Where's your fucking globe evidence, bro?
That's what we want to hear, guys.
Show us it. This is what you need to do. Find us a laser bending downward, right? So that's what you would need for the laser to hit the target in all of these laser tests that hit the target.
They don't hit the target. They just are seen by a camera. I made this point earlier.
None of them hit the target?
They're seen by a camera. If you could show me one that hits a target where a target is not a camera, right? Then I would love to see it. But I have not seen any evidence of that claim specifically. So if you want to say that it hits a camera,
the target was the camera.
That's what I'm saying. Again, if you want to say the target is something other than the camera, feel free to. But if we could just say camera instead of target.
Yeah. Right. So you can't see the laser at all until it's aligned in such a way that it actually hits directly into the. You would, if what you were saying was correct, you would be able to see the laser the entire time.
Where's one point you can't see the laser?
In every single laser test video, you don't see the laser until you get the direct hit into the target.
No, again, I just addressed how I can show you one where the laser points upwards and then you can see the laser, but we agreed that if the laser was going above your head, you could still see the laser without it making a direct hit. We already went over this point.
Brown, hang on a second, dude. To be clear, I mean, DJ, is it not the case what you mean by when you're saying see the laser? You're talking about the source of the laser, right? Not like a little like lightsaber like thing. Like the beam of it. We're not looking at fucking Star Wars and shit, right? Talking about the source of the laser.
Again, that's what's in contention.
Okay, when you
I'll show him the difference.
Yeah.
You're just gonna show me
light
and then
when
brighter
you use that
light.
term, Brian, it sounds like you're talking about seeing the beam, like zip up in the air or not.
But what's the laser if not the beam?
The source of it. That's why I specified the source.
Right. So, but again, how are we?
I'm going to show you the difference.
The source.
Yeah. This is the difference. Okay. So this is being able. Look in the side chat. Okay. This is being able to see the beam of the laser. Now that's not hitting the camera. Obviously, you can see the laser beam, right? But that's not a direct hit into the camera.
I agree. So we're seeing the laser. We both agree that we're seeing the laser, correct?
Right. So that's not what any of the tests are saying as a direct hit, right? So it's not just seeing the laser is different to actually going into the camera sensor, right? I can show you what it looks like when it goes into the camera sensor. When it actually hits the target, it's completely different. It doesn't look like this.
Goes into the camera. We both completely agree that is what happens. That the light from the laser goes into the camera. But you're claiming that the laser does not bend or diffract or diffuse at all, right? In that 20-something mile distance, correct?
I'm saying that there's no evidence that a laser bends downward over a large distance observation
towards denser mediums. Does light bend towards denser mediums?
Yeah, it does.
Is laser light?
It's interesting. Yes.
There we go.
How come with all of the laser tests that have been done, we've never seen any footage of a laser bending down? Even Dr. John D said after 350 plus hours of laser tests, right, using different spectrums of laser, different weather conditions throughout different times of the year of it, all sorts of different places and distances, he's seen lasers bending upwards, right? He's seen lasers going straight. He's never once seen a laser bending downward. No globe earther has been able to provide us a laser bending downward over a long distance observation, over a body of water or land.
Right.
That's
so
kind of crazy.
You're claiming that the light doesn't bend, right? And therefore the laser isn't bending.
I didn't say light doesn't bend.
No, you say the laser isn't bending.
No, I said what Dr. John D said, that it goes in a straight line.
Right, so that's straight line is not.
No one's ever provided footage of a laser bending downward.
Stop me.
Brown, calm down, bro.
The claim, again, I keep saying the same. The claim is that the laser is going straight, right?
No, the claim is that the laser is hitting the target, and there's no evidence of Earth curvature.
You said direct hit. What does that imply?
See the laser beam directly hitting the sensor of the camera, right? It means you're not seeing a beam of light up in the air like I showed you in the previous pictures from Dr. John D. You don't see that, okay? You see the laser actually hitting the sensor of the camera. You don't see the beam, you just see the direct hit.
Right, so again, you see the light from the laser. Like I said, we both agree to that. The claim, right, is that it's straight line. It's a direct hit from the source of the laser to the camera, right? And the claim is that it hasn't been shown to bend downward because this is a straight view.
Yeah, there's no evidence of it bending downward.
Right,
right?
so
We see evidence of it going
straight. What do you mean? It's clearly supposed to be a straight line. Why are you fighting that?
This is what I'm saying. The camera is getting a direct hit from the laser. In order for that to happen, it would have to bend downward over hundreds and hundreds of feet of curvature to hit the target, you don't have any evidence of that curvature in the first place. What we're seeing is just direct hit after direct hit, dozens and dozens of different tests.
Right.
You don't have any evidence of a globe.
Again, we both agree that there's plenty of given evidence for the globe that you would contest as real. Obviously, there's alleged pictures from space, so you can't say there's no evidence for the globe, right? We're
referring to this specific evidence. CGI. You can't tell the difference between CGI and the real thing when it comes to your space pictures. I could prove that right now if you want.
Again, I am not an expert on CGI, right? Again, I agree to that. But to claim that you're claiming that all of them are CGI. Again, I'm not claiming to be an expert. The claim
didn't
has
claim
to be.
It's all CGI.
Then
lie.
Okay,
why you gotta lie?
1 second. I'm talking about space pictures provided, right? What is your refutation to those?
My refutation is that you can't validate them, and you just have to have faith in those. Right. That's my refutation.
Again, they are validated by other space agencies, right? So, but why are those not real?
How do you verify the other space agencies?
Again, they corroborate each other, obviously. Again,
how do you test them? How do you test the other space agencies? What have you done to test them in real life?
Again, I haven't proven any scientific method, right? But I've observed the ISS, right? Like, again, I've seen the light from the ISS travel across the sky.
So you've seen it a bunch. So you saw something in the sky with the telescope.
You're asking what test I did, right? I'm simply talking about that clearly evidence for the globe has been provided, right? That is in contention. His claim was that no evidence has been provided for the globe because us globe.
Hold on a second. When you saw something in the sky through your telescope, which you claim is the ISS,
I didn't see it through my telescope. I just saw it.
Okay, with your own eyes, when you saw that thing in the sky, how do you know it was the ISS?
Because it's in the exact spot purported that the ISS is purported to be in, right? And then I would look up other evidences of
wait.
Please let me finish. Other evidences of other people looking at the same object, zooming in, seeing the exact shape that the ISS is purported to be, right? And then traveling to other locations where it can also be seen from other perspectives with the exact same shape and relative distance from the Earth.
What spot was it in?
What spot was it in? It's in the sky. What do you mean?
You said that there was a purported spot that it was supposed to be in. What was the spot?
Okay, I can give you the live tracking for the ISS.
But you do see how like other people seeing that, even if they're in a different position, doesn't verify what it is.
Again, I agree that doesn't necessarily guarantee what it is, right? But I'm saying that the purported position, the given position of the ISS at any given moment, right, can be verified from the ground.
Give me the position.
It's a leap of faith.
Give us the position. Stop. Everyone stop talking. Give us the position.
Again, it's a ridiculous thing, but I will look up the ISS tracker for you.
Yes. Give us an exact position. Exactly.
Well, Zodiac, this guy, what he's done, dude, he's just managed to take the conversation away from the Earth back into sky magic that we can't validate.
Yeah,
I'm just answering your guys' questions. I didn't take it to the space, dude.
All right, fine. Let's get back to the
what
lasers.
test I did was.
Fine.
Let me just show you this. Let me give you the current position of the ISS. Here we go. 1 second.
Okay.
This is the purported current position of the ISS. It's above it's ground point 27.79 north and 123 east, right? It's ridiculous to claim that people don't claim. How
did you measure that?
I didn't measure this. I corroborated it. I corroborated it with my actual location. It's purported to be above near where I was at the time. I looked where it was purported to be and saw a light. Right, that's what I'm claiming happened.
So above anywhere in the sky, that's what it said. Like above where you're supposed to be, but it didn't give you like a distance or anything.
It gives you an altitude. What do you mean? It doesn't give you a distance. It gives you a ground point coordinate plus an altitude. Okay, that gives you an exact location relative to Earth.
How do you know the altitude?
It provides the altitude. I didn't say I knew the altitude. I said given the purported position. Okay. I saw a light in the sky where the purported position was supposed to be.
So you never verified the altitude. You don't know.
How am I to verify that? How am I to verify that from the ground?
That's my question to you.
Right. So again, I never claimed I did.
Okay, then you just have faith. Let's go back to the laser test. Go back. You have faith.
You have faith that the lasers are straight because there's no evidence to claim that lasers don't bend.
We have faith that the lasers are hitting the target, dude. We don't need to have faith.
We can show you the
but we can confirm that the lasers.
The question is, if
no, the laser.
distances.
Okay, how does the laser hit the target?
The laser diffuses, diffracts, and refracts.
Okay, so you're claiming, diffuses. What the hell?
Did you really say that?
Do lasers diffuse? Do lasers diffuse?
Do you know what light diffusion is?
Yes, yeah.
Okay, tell me.
I'll give you an exact definition.
You guys, man.
The scattering of light rays as they pass through translucent mediums.
Yeah.
Or bounce off uneven surfaces.
Yeah.
There we go. So do you think that lasers
going through a diffuser?
Do lasers diffuse in the atmosphere?
No.
They don't.
No, the air is not translucent.
They're absolutely translucent, but okay.
It's not translucent, it's transparent. Clown.
I can give you the AI overview, but yes, lasers do diffuse in the atmosphere, or more accurately, spread out and scatter as they travel through the atmosphere. But again,
scattering is not diffusion.
Well, then what is diffusion?
Dude,
I just gave you the definition. One second, dude. I gave you the definition.
Dude. Stop.
I defined
dude. Just stop, dude, with your fucking Texas sharpshooter bullshit.
I defined it as a scattering of light rays, and you did not contest that. Why did you not contest that?
Look.
Do you contest that definition?
Look. So.
Okay.
If you wanna, so they make things called light diffusers. You put them in front of a light.
Yeah.
So that the light becomes smooth and doesn't have a hot spot. Okay? The air is not doing that.
What happens when a light ray hits an air molecule?
Why are you asking me a question, dude? The light does not do that.
You're claiming that the light doesn't diffuse in the atmosphere. That's the claim. I'm saying that's
under
wrong.
Certain conditions like fog or something like that, yeah, it can.
What is fog? It's just
water vapor.
Atmosphere. Right. And is there water vapor always present in the atmosphere?
Not to the point that makes the air translucent. That's why we have a separate. That's why we have a separate word to describe when it's translucent. It's called fog.
No, again, it just increases in opacity.
You're the most dishonest motherfucker that comes in this chat. You know that?
No.
No, you are.
All right, man. We agree to disagree. I think that you guys are all
this
pretty.
This isn't an agree or disagree thing.
Okay, well, it's your opinion that I'm the most. So again, if other people could disagree.
Yes, that is my opinion. I think born out by evidence.
Then how is it not an agree or disagree if that's your opinion?
Dude.
What?
You're going down a dead end right now.
Okay, I agree. The whole Flat Earth channel is a dead end. I agree. But again, you're just saying things to try and put me down.
Seems to have controlled your life.
It does. I love it here. I'm addicted to you guys, and I hate it.
Yeah, here you are.
I'm addicted to you guys. I admit it. I love you guys more than I love a lot of my real friends.
Yeah, well, watch how you act, dude, because you're close to getting banned. I'm going to tell you that now.
You banned me yesterday, DJ, or 2 days ago. Again, I get it. You guys don't like it. But ban me if you'd like.
We like honest people. You're not one of them.
I would say the same thing about you, Indio.
Yeah, but you'd have no basis for what you said, whereas I do.
Okay, well, I defined diffusion as light scattering, and then you said and then you didn't contend it, and then immediately after you said scattering is not diffusion, or diffusion rather.
All scattering is not caused by the same thing.
I agree.
All scattering is not the same.
I agree.
So you're just using you're just using a word context fallacy.
Both you niggas are retarded. The Earth doesn't even exist. You guys are fucking stupid, nigga. My God.
Yeah, you're gonna.
Am I still the most
out of the Hold on, you're gonna get kicked out of the server now. All right, okay. I want you to know that for saying the N-word. I'm going to report you right now, and you're going to get kicked out of the server. So congratulations. I hope it was worth it. Is it still your
opinion that I'm the most dishonest, given that All Right Son is in here?
Yeah, that guy's just a Todd, right? Like you're actually
he's ridiculous.
Yeah, you're still more ridiculous than him, just with the way that you're acting and your dishonest.
The question was
passive aggressiveness and that kind of thing. Hey, just quickly, dude. I just looked up a video for you. I'm going to put it in the side chat, and I want to show you what the difference is when the laser directly hits into the lens, right? So this laser test was actually done during the daytime. You can't see the beam, right? And you can see a bit of a light in the distance where the laser is, but it's not until it directly hits right into the sensor of the camera and you'll see it lights up. All of a sudden, it lights up like crazy. So it's at 6 minutes 53 in the video. I'll just grab the video. And this is what I'm talking about a direct hit of the laser into the camera.
For sure. I agree. The light gets brighter, but that's not
only when it goes. Yeah, when this okay, so laser beams are much brighter right in the centroid or center of the beam, whatever it's called. Right, it's not until that part hits into the camera lens that it illuminates it. You see like a big bright green light all of a sudden just appear instantly into the camera. It's not like you can see it the whole time. It's only when it hits right into the directly into the sensor of the camera that you can see it.
Laser beams are collimated light that follow a Gaussian profile that extends radially from the center. There's a centroid of the beam where the beam is most intense. It exponentially, so from the edges, the external edges to the center, the brightness increases exponentially.
I agree. The center of a laser is brighter than the outer bits of a laser. I agree.
It's exponentially greater.
It's not an infinite amount of brightness, right? So
okay, who said the word infinite?
I agree.
Who said the word infinite?
I misspoke.
Nigger.
Ugh, these fucking people. I agree. I misspoke.
Well, in your case, he was right.
What? You're saying that I'm
moving on? Moving on, dude.
Moving on. I don't want to move on from that.
Well, you're the one. You're the one that's like these people. Crazy. Now you want to? Yeah, just these people are idiots.
You're saying me saying these people is equivalent to what idiot said. That's what you're saying. You're making that claim. Those are equivalent.
These people.
What was my reference? What did I say?
Come on.
Was it a hateful slur?
Are you? Can I ask? Wait. Let me just ask them this question. Have you ever questioned if the Earth was actually a sphere?
Yeah. When I first came in here, you guys almost got me for sure.
Have you ever had doubts? No, before that. Yeah. I mean, before you knew about us. Have you had doubts about
before that? No, once I came in here, you guys introduced doubts, like you tend to, and then I doubted, and then I realized you're wrong, and then I came back to the same.
So before that, you were 100% convinced.
I had no reason to doubt it. Yeah.
Okay.
Yeah.
You realize we're wrong by being willfully ignorant about the subject you're talking about. So your ignorance is what propels. No, bro.
Okay.
I actually went to university.
I would say no to you.
I actually went to university and took physics and passed the courses.
For sure.
You didn't even take it in high school. Okay. You have no idea what you're talking about.
How is gravity?
Come in here and sit there, talk out your ass, and just randomly pick sentences out of ChatGPT, trying to pretend you know what you're talking about. You don't have a fucking clue, even a little bit, of what you're talking about. You don't.
Those claims.
You're not even at the level of pretender clown.
So what am I then?
Trash.
All right. If that makes you feel better, call me trash all you want, I suppose.
It's not about whether I feel better.
Okay.
Clearly, what is it about then? What is calling me trash?
Yeah, your little fucking psychological analysis don't mean anything to me. This is very simple.
Insults mean nothing to me either.
You don't know what you're talking about.
No.
This subject. You know nothing about the behavior of light at all.
I think you know nothing.
Hey,
that's because you're ignorant.
I think you're ignorant.
Everything I say, you can fact check. Everything you say is just going to end up being wrong.
Okay, I disagree. What is one thing I said?
I disagree. Doesn't mean anything.
What was one thing I said?
I'm saying it's objectively true. You're just saying no.
What is one thing I said that was wrong?
Everything.
What is one thing? Name one thing. If everything was wrong, you can name one thing. What's one thing I said?
At least.
That diffusion is scattering.
What is diffusion then?
Oh my God.
Is diffusion scattering? What's the definition of diffusion? Then what's the definition of diffusion? Enlighten me, please.
If you had a laser and a laser was being diffused, the beam would have no centroid. It would be smoothed out so that the intensity would be uniform radially across the center to the edges. It would be the same. It would be diffused. That means that it's spreading it out and smearing it so that the energy is uniform per unit area. Okay? Lasers, if you see the beam centroid and it's more intense in the center, then it's not being diffused.
I don't think you have any evidence of that claim, but if you have it, I'm happy to look at it.
What do you mean evidence of that claim? All you have to do is go onto Google, type in laser beam profile, okay, and it will show you. And click Google Images, and there'll be lots of diagrams of Gaussian profiles of laser beams with an equation.
I'll look up that. You look up do lasers diffuse. You look up that, and I'll look up yours.
Lasers can be diffused. Okay,
wonderful, wonderful. So then, what is diffusion?
Dude, you're looping, dude.
No.
Okay, you're going to ask, ignore, repeat. You will be banned for that, dude. I will not play with that. Ask, ignore, repeat is not going to work, Brown Recluse.
Then why does it work for you?
Ask, ignore. Bye.
Okay. You can ask the same question over and over again, but I can't. Again, diffusion, as far as I'm concerned, is scattering.
Ask, ignore, repeat. So now you're going to straw man what I said. Bye.
All right. I miss you. Goodbye, guys.
Catch you on the flat side.
Love you guys.
It's flat, by the way. You should.
I believe
you. Loser. Piss off. Shut your hole. He should not even be entertained.
Yeah. Any other Globers ready?
That dude is here is only to obfuscate the conversation, the truth, trying to make sure that no information is passed, that everything is a fucking shit show, that nothing makes sense. His whole purpose is to just muddy water. Which, I don't know how you guys feel about that, but this is how I feel about it. That is contrary, I guess, to our purpose. It's contrary to my purpose. I want people to understand more when they come in here, not understand less.
Yeah, he's a waste of time.
People will, like, say you don't know anything about this topic, and you come in here and you listen to us and him, because he's all over the place, gish galloping, contradicting himself, saying random crap that's unrelated, and then when you say, hey, that's wrong, him just saying, no, I think you're wrong, you don't understand it. As if that's some sort of valid refutation, and then you ask him again, and then you ask him to substantiate what he says, and then he just does the exact same thing again. Random crap, gish gallop, throwing it all together, and then you saying, no, that is wrong too. That doesn't substantiate what I said. Yeah, it does. You don't know what you're talking about. And just doing that over and over and over and over and looping. Anybody that doesn't know about this topic or the issues of this topic or the particulars of what we talk about is going to leave here more confused and more ignorant than when they came in. Now, you guys can do what you want. I think that's contrary to our purpose. I don't think we're trying to have conversations in here that confuse people. Because what's going to happen? They go, oh man, this is just fucking confusing. I don't know what the truth is. I'll just believe the earth is a globe. It's just fucking simpler.
Probably his whole purpose.
Exactly. Exactly. That is the purpose. It's called obscurantism.
That alone says so much about the subject. They got to come here and do that.
It's crazy they even cared to fight that hard. Yeah.
He's been doing it a long time. And there's two others that are part of his little clique, obscurantism clique, that all associate together. JJ Fish, whatever his fucking name is. And there's another one. What the hell's his name? I haven't seen him in a while.
Oh, there's a bunch of them. There's probably about 10 at least of these characters.
Yeah, that's the same shtick, the same song and dance, the gimmicks.
When you guys used to believe in the globe, did you ever dude, I've never done anything like that. You know?
Of course not. Why would anybody do that for any reason on any topic?
Yeah.
unless you have something to hide. You know, if my girlfriend, if I've been cheating on my girlfriend and she asks me, hey, dude, what'd you do last night? Yeah, I'm going to obscure the truth. I'm going to try and make everything, my rendition of events so confusing that she can't figure out what really happened. Yeah. I'm not saying it's justified. I'm saying that's a legitimate use of obscurantism, of why you would do that. Why you would do it in relation to this, to like a, you know, an informational topic. There is no reason for that. Other than
it's the difference of trying to affirm your bias or actually searching for the truth. That's the difference.
Yeah. I mean, but no, he's not. He's also trying to hide it from others. Not just him. It's not. This isn't even just about him. It's that he's trying so that people that are listening, either in this chat or on YouTube, also are become more confused.
Yeah, you know, I actually remember he did say that he agreed there was a 6-mile laser that went straight, and he actually said, "Oh yeah," like, and he just like kind of skipped past that, like
he doesn't believe what he's saying.
Yeah,
he doesn't actually believe that lasers don't go straight. You know, he don't believe that.
Yeah.
They don't care to know. That's the thing. There's a whole group of young people who fancy themselves intellectuals because they can quickly GPT a topic and regurgitate it back and then not answer questions, completely divert, and play a whole nuh-uh game, right? They tend to have this argumentation almost in the fashion of my dad can beat up your dad. It's very childish. And it's back and forth, rapid fire, quick talking, fast with the tongue, but never actually answering anything and only Googling through a GPT or Claude or whatever spits them back their answers. And they'll repeat that, regurgitate it, not actually learning what they're talking about because they don't care to know the truth. They're just here to act as though they're an intellectual, even though I wouldn't even call them pseudo-intellectuals that think that they're winning some sort of debate online.
Yeah, that's why I said he doesn't even rise to the level of pretender clown.
And then you called him a piece of garbage.
He is garbage, dude. Awesome. That's garbage, dude. I don't like this. I mean, if nobody figured out my I mean, you can call it personality flaw. I don't like dishonesty. There's no point in talking about this topic and being dishonest about it. I don't understand the point of lying, making stuff up, just filling in the blanks, and hey, I don't know the answer to that, so just make something up and say it.
Well, I feel like nowadays the internet is ripe with these kind of individuals. They are children, in my opinion, and they've grown up behind headphones on video games, talking smack to their friends. Now they've got AI to help assist them in what they're doing online, and they care not about the truth. They want to fancy themselves intellectuals, act as though they're some sort of influencer. They're some sort of huge debater when they don't actually understand what they're talking about. If you took away their computer and you sat them in front of somebody face to face, first of all, most people would have to restrain themselves from socking these kids in the face because I don't think they've actually been on the playground and had conversations enough to feel what it's like to get 5 fingers to the face.
Oh, dude. Yeah. So lucky you can't stab people over the internet, dude.
Yeah, he's just not taking it seriously. That's it. That's honestly the only.
I think he does take it seriously.
He does?
Dude, he's been doing this for like a year and a half of this identical, rhetorical gimmick, and has put in a lot of effort into it, to the fact where he's actually researched this topic, and just to have little blurbs, right? Oh, I'll pull one sentence out of this fucking paper and mischaracterize it and just say it. And then people will think because I said this sentence that I have knowledge about this topic. So I'll say the sentence and then claim the other person is wrong as a refutation of what they said. Where they don't actually refute, he doesn't refute it with anything of substance. Hey, what you said is incorrect because X, Y, and Z. You just say some random red herring thing that has nothing to do with it, and then say, I don't think you understand it. Right? To give the illusion that somehow they know what they're talking about, that somehow you're on equal footing about the subject, in this particular place, the behavior of light, that like he knows as much as we know, and that this is just a disagreement about what the consequences are. No, he knows nothing. Literally nothing.
Oh, okay. So
he knows what to type into Google to have some output from which he's going to read one sentence, and he's going to pick what's the biggest fucking 50-cent word in this paragraph. I'll say that one, and then it'll give people the idea that I know what I'm talking about, because I'm going to say a word, I'm going to say a sentence they don't understand. So I think, oh my God, he's freaking must know what he's talking about. He said diffusion. Because they don't know what diffusion means. They think because he used it, he must know what it means. But he used it in the wrong context, in the wrong application, and has nothing to do with, like I said, if it was diffused, then the intensity of the fucking light would be spread out. That's the point of diffusion. It diffuses it. That's what diffusion is.
Yeah, to be fair, diffusion is a subcategory of scattering, but it's not the same thing. It's not like atmospheric scattering of light.
Yeah, right? It's not Rayleigh scattering or Compton scattering or any of that type of scattering.
Exactly.
It's not that.
It's like light
that's why you brought up fog, though.
Like
and then he had to. You brought up fog, and he had to go back to the same thing, even though you'd already brought up. That's why you almost agreed with the scattering thing, because air can, when there is fog, cause that, right?
Yeah, there's types of scattering, and fog, right, turns the air translucent. But it's not just the air; it's the water vapor that's translucent. But that's a very specific, particular circumstance, right? So we have fog lights, right, in your car or in a truck, fog lights. And even though, like, if there wasn't fog, the beam would be very bright, blinding in your face. But when there is a fog, it diffuses, right? So you see the bright lights, but it's spread out, smeared out.
But I think all of that was just his ultra defensive, like being shown that he's wrong, basically, in that sense. Which was, for me, what was more telling was him thinking that he can corroborate where the light in the sky is, right? And him thinking that was somehow verification. Like,
yeah, well, he's like a usual suspect. I mean, garbage human.
What do you guys think about the north, the Arctic area where all the polarity is like has like a vortex of some kind up in the sky, and it like towers over it?
I never heard
the
about
polarity of
that.
What?
It's like a magnetic shield of some sort that like kind of, this is the flat earth theory, is that there's like the polarity shift has made the top area of the dome. Yeah, the dome area, like the top of it has the what do you
like
call
a giant glass, basically.
electromagnetic whatever.
Yeah, like a giant glass blocking you from going out of space.
Yeah, possibly.
It's better not to make claims that you can't verify. So
no.
whenever because then you're believing in a religion. That's why.
It's just a theory. Started after the moon landing.
Oh, you said flat Earth. You said theory. Oh, sorry, my bad.
Yeah, it's a theory.
I thought you said it was fact. Continue.
No, not a fact.
It could be that it's just a shift. I think when the moon phase comes in, that there's an actual shift that happens where the black hole like immerses into it and it comes on the outside. So it's like an inside outside, like a funnel.
You mean eclipse?
No, it's like a funnel. It comes out of one side and it shows up in the other side in the daytime. This is essentially like Helheim or the Hell realm.
Too crazy.
In Norse mythology.
Brother, what?
He's explaining.
So Helheim is the place of the dead. I think it exists before like time starts or whatever, or it's like part of eternity or one of the realms or something. I don't know.
Helheim.
Yeah.
Okay, it's the afterlife.
Wait, this is what you believe?
Yeah.
There's a black hole passing through the moon.
No, I don't believe in it. It's just that so in Christian terms, I'm Catholic, so in Christian terms, it's just what do you call like Abraham's bosom in as part of hell. Like that's where it's at. Which is like
what's the best evidence for it?
What's the best evidence for it? Yeah,
for what you just said, yeah.
Probably no one except that one guy, that black metal artist Carl, who like talks about like Norse stuff and talks about like Odin and shit, and no one understands what he's saying on YouTube. That guy will probably have some answers, but Gaal, 2 A's and HL.
Okay.
So he's a black metal vocalist, and so this is very similar to the Christian idea of eternity. So it's that eternity sourced in being becomes like this amalgamation of realms or whatever.
I gotta be honest with you. I don't know what you just said. I'm not fully comprehending anything you just said.
What is the point? Basically, you cannot get out of Earth. What is the point of this theory?
No, it's once you get into Helheim realm, like your if you see it, then you know, like you probably died, like you're in an undead state or whatever, and like the aspect or like the outside world, like whatever it is, the dream aspect that holds you just like dissipates into the outside.
Let me get this straight. You can only prove this if you're dead.
Yeah, you can if you're dead.
So you can't talk to dead people, right?
No, but I went through it, so like I'm pretty sure like where like
you went through this thing.
Yeah, I did. And
you went. You're here talking to us. You're not dead.
Did you die and they brought you back up? Like your heart stopped for a few minutes?
Something like that. Yeah, it was a weird experience. It was sort of like like those movies where you have that like one teenager just like stuck in like a room, and like everything's like black outside. Sort of like that.
Wait, so you went to hell? That's what you're saying.
Well, it's not hell exactly. So I think there's parts of it. So there's one that's hellfire, and there's one place that is like Abraham's bosom or the netherworld. And there's one place that is like regular hell, which is like lost souls kind of thing. So yeah, it's.
So you didn't go to heaven, no.
It's not. It's like a purgatory realm basically, and you just land up here at like when you die or whatever. I don't know where it's placed in like the spectrum of time, but I'd say it's probably like part of eternity, right? So yeah, eternity itself it collides with whatever else.
Right,
so in this realm, you're all connected to the realm anyway at some point.
Wait, so what does this have to do with the ground, the earth?
Yeah, the flat Earth. How is it relevant to flat Earth?
How is it relevant to flat Earth? Because it's sort of like the part of you that is the part of you attribute to yourself. Like, you know, you when you grow up, you're kind of like, I am what I am, and then you have that moment of premonition where you have to like decrease yourself, or whatever stage you go through, like when you're dying, like you have that kind of feeling, that premonition that you're sort of like
Wait, bro,
you're
what?
living a life. You know, you're living a life, and you're sort of like not.
Sounds like bullshit, dude. He's asked you what it's got to do with flat Earth and stuff.
Yeah, hold on. So it's just your own suspension of disbelief of yourself. That's basically what creates doesn't create it, but you get tossed into it. So some of us get tossed in earlier. I think I was like the first person or whatever.
It's believing. But if you just go outside, you don't have to believe anything to notice that the Earth is not a sphere if there's no globe. Like if you go outside and you see the Earth, there's no evidence of a globe.
Yeah.
Wait, this phenomena you're talking about could happen on either flat or globe. So why don't you talk about something that proves one or the other?
Well, it definitely happens on a kind of flat Earth, I guess, because the only explanation would be
You guess.
no,
You can't
the
link
only
it to the flat Earth. Wait, stop talking.
No, it's only
You
the
can't
realm
link
that
it to the flat Earth. Again, it's going to talk. You can't link it to the flat Earth. You just said you guess. It's not relevant to the flat Earth. Just admit it, dude, and let's try and talk about the flat Earth. Don't try and cobble your idea into the flat Earth. It's got nothing to do with it.
All right, cool. So that's about it. Like, I'm happy you questioned me on that.
Are you a flat earther?
I'm not like involved. I live in Mumbai. Like, this stuff is all foreign to most people here, so I don't bother like thinking about it or anything.
Are you okay? But you don't believe the Earth is a globe, right?
You probably believe it.
I have reason to believe that it's like a disc that changes, that breaks at a certain point.
Someone's talking.
And what about?
Why do you think it's a disc?
Not a disc.
Hold on, now I'm intrigued. Why do you think it's a disc?
Because it breaks at a certain point, and then you get the opposite of the realm. Like it's sort of like a frequent mirror reflection realm. It's the same realm, but
we got a disc earther.
Wait, how do you know it breaks? How do you know it breaks?
It breaks because it goes from sun to moon.
That's not the Earth. That's the sky. You mean daylight breaks? You mean what do you mean by what is breaking physically? Like what is breaking?
It's like moving. It's like moving 180 degrees the other side, and then just like or whatever 360 degrees, and then it.
Wait,
just,
how do you know the Earth is moving?
appears.
How do you know the Earth is moving?
It's not the Earth. It's not a sphere. It's like a disc that it just changes. It breaks. Then
It's like a disc that changes and breaks. That doesn't make any sense to me, sir.
Yeah, that doesn't
well,
make sense.
It goes through the damn fucking black hole or whatever, and then it comes out the other side.
Oh my god,
this is silly.
This sounds like bullshit to me.
Why are you trolling? That's weird.
I'm actually not trolling.
Do you have evidence of a black hole?
I have evidence that there's nothing like the sun's not like the sun projects itself on like a circumference.
No, I'm asking, do you have evidence of the black hole? Yes or no? Just answer yes or no.
I have evidence of the black hole. Yes.
Okay, post it. Let's see it. Demonstrate it.
I don't have it right now, but I have evidence from what I've learned. That's about it
right now. If I told you Santa Claus was real and you asked me for evidence and I told you I didn't have it right now, would you believe me?
No, I wouldn't.
Okay.
But that's a different story, I guess, out of context.
Or you're just telling us a story right now.
You're telling us a story, yeah.
Okay, I'm out of here. I'll see you guys later. If you meet Not Foxy, I'm part of this cult, Christian cult.
Catch you on the flat side.
Yeah, catch you on the flip side or whatever.
The flat side, flat Earth. Get it?
The flip side, get it?
No, not the flip side. The flat side.
Oh yeah, cool.
Yeah, I get it.
I get it. Yeah.
All right.
You know your joke's not that good when you have to hold somebody down and make you get it. Do you get it? Do you?
But otherwise, nobody ever. Okay. All right. Is there anyone else that believes the spinning ball space monkey religion globe? Anybody else? Moment of silence. All right. Moment of silence for the globe, guys. Moment of silence.
What's that? What's that?
Hello. Do you believe you are on a sphere?
I don't believe. I know.
Okay. What's the best evidence you got that you're on a sphere?
Sorry, you know first-hand personal knowledge. What's that?
Multi-location consistency.
What is that?
Multiple location consistency. Sorry, you said you know. Can you explain how you know?
Okay, so basically, you can have an observation from 1 point or 2 points, and sure, that can work on a flat or a globe Earth. But if you have observations with 3 or more points, and I'm going to go even up to 1,000 points, 1,000 different cities, and let's say far enough apart, like kind of spread apart. So 1,000 different cities at the same time, and matching one observation with all 1,000 observations is only working with the globe model.
Sorry, sorry, I'm sorry, Indio. I thought he said he knew. You know the Earth is flat.
Yes.
He said he knows the Earth is a globe.
The globe.
Sorry, my apologies. I've only been up half hour. He knows the Earth is a globe. I do apologise. It's
and then he started
1,000
talking about
measurements from different
people.
cities to what?
So 1,000 different cities. Let's say the sun and moon positions at the same time for all 1,000 cities.
But that's the sky.
So?
But we're asking you how you know the Earth is a sphere.
Okay. How
you understand what knowledge is, don't you?
All 1,000.
No, don't ask me to imagine. So you said you had first-hand knowledge.
You're not going to let me answer or explain. So, how is it, that you can match 1,000 observations with one single observation on a model, but you can't with any
on a model?
Yeah. This isn't knowledge, dude. You just asked us a question. We're asking you how you know because you claimed you know,
how I know
the Earth is a sphere.
How we know is because that we have 1,000 different observations at the same time, which show us that we are on a sphere.
How?
Okay,
because for the positions to be consistent with all 1,000 observations, the sun and moon has to be in a specific position to which that only works if you are on a sphere. If you change that in any shape, way, or form, you will not have the same observations for all 1,000 cities.
And if it's observer dependent.
An absolutely basis claim.
Sure, buddy.
The sky does not determine the floor.
Yeah, sure, buddy.
See, that's a straw man.
Just finding 1,000 people, it's not a straw man. Learn what that word means.
Yes, it's a misrepresentation of the arguments of the person. So saying the sky has nothing to do with the ground, that doesn't address the argument.
You can't prove the shape of the ground by looking at the sky.
That
is a logical impossibility.
That is false.
Okay, so tell me how you can make an inductive inference and reach a deductive conclusion.
What kind of question is that?
Because you know that proof has to be deduced logically, deductively. Now, when you look at the thing that's not the thing, look, ask you a question, I'm going to answer. So when you look at the thing that's not the thing, namely the sky, to reach conclusions about the ground, you're making an inference from looking at something that is not the thing you're concerned about. Okay.
So you're trying to smuggle in that we're making an inference
Yes, it's an inference. It's not smuggling it in. That's what it is.
Based on what? So what if it's not?
Because you're not looking at the thing in question. You're looking at something that's not the thing.
Okay. So you're telling me that if I'm inside a car, I can't know that I'm inside a car by looking at what's going on outside the windows?
No. Could be in a plane.
Really, it's not. Yeah, that's an assumption.
Could be in a truck. Could be riding the back of a bird.
Mm-hmm.
If you're only looking out the windows and you're not doing anything else, you don't know if you're in a train. You don't know it. Yeah, that's true. You could be.
Oh, we don't look at anything on the ground either, huh? We don't compare with the ground. We don't have the observation of like where in perspective and in relation to the ground these things are and etc.
Well, then present that. Well, then present that.
Okay. For instance, in Sydney, Australia, you will have a sunrise at the same time. In California, you're going to have a sunset.
Okay, and
that's on two. That's just two locations. But at the same time, between that, you're going to be at high noon, and people in Argentina will see the sun and moon positions according to this as well. But if you make the Earth flat, then the people in Argentina would have to look in a different direction to see the sun and moon where they actually see it, for it to be sun rising and sun setting for the two other locations. And the more locations you add, the more complications like that are added as well.
First of all, you went back to not looking at the Earth.
Why are you interrupting me? I'm not done speaking.
Because you went back to the first thing, dude. You went back to looking at not the Earth.
No, you're just interrupting me because you don't like the argument I'm making.
Because your argument is the same as your first argument. It's an inductive inference about the sky. And reaching a conclusion about the ground by looking at the sky. Is the sun in the sky? Is the sun in the sky? Is the sun in the sky?
The positions in relation to the ground.
How do you know that?
You look at them.
Oh, okay. You're looking at the positions on the ground.
Yeah, you're on the ground. They're okay. And you see, is the sun at the west or at the east?
You stop looking at the ground.
First question.
Now look back at the ground again.
To the west from where I am.
Now look back at the ground again.
I am on the ground. I'm looking at my ground here, and now I'm looking. Okay, the moon is at the east.
Back to the sky.
At the west. All right.
Back to the sky.
Now apply that on 1,000 different cities at the same time.
Okay, you're still making an inductive inference because you're not looking at the ground.
Did you
You're looking at the sun and assuming there's some geometric relationship between the observers.
I am looking at my ground position. I am looking at the ground now. I'm looking at the ground.
How did you find your ground position?
And in relation, I am on it. I'm here.
Okay, how did you determine what the relative positions of the observers are?
So I determine with a compass where north is. Okay, and I'm looking.
Okay, that won't work.
And I'm looking at the ground.
Okay, it won't work.
Oh, really?
That won't work. Compasses are aligned with the magnetic field.
It won't tell me if where east and west is at the same time.
No, it will not.
Okay, so compasses don't work anymore. Okay.
They work in some places.
I'm going to rest my case on that one. Compasses doesn't work.
Okay, Google magnetic declination. On every military navigation map, it'll have a magnetic declination, which shows you the magnetic north versus the geographic north. You don't know what you're talking about.
No, you're just making red herrings and like.
It's not a red herring.
You're not even addressing anything I'm saying. You're not addressing anything I'm saying.
Directly what you're saying. You said use a compass. I said the compass won't work. You tried to scoff at that. And then I demonstrated that why it won't work.
The compass won't work. Oh, this tool won't work. Oh, your lighter doesn't work
because
your computer doesn't work. Your processor doesn't work. Your brain doesn't work.
Yeah, straw man. So now there's the straw man. This is actual straw man.
Joe, maybe ask him what magnetic declination is.
Yeah, what is magnetic declination? Well, I just explained it to him.
Yeah, I know. I know he didn't listen, but let's see if he knows or it rings a bell in his head. Do you know what magnetic declination is, sir? I assume not. Probably.
I mean, it's an angle, but why are you asking me petty semantic questions that have nothing to do with my argument?
They do, because you said find where you are by using the compass.
Mm-hmm. Compasses work. I'm sorry.
They follow, sir. Compasses follow magnetic field lines, don't they?
Sure.
Okay. Magnetic field lines don't go from straight north to straight south in a 180-degree line. Have you ever studied a magnetic field line map? Do you understand that sometimes magnetic field lines can be 90 degrees off of north and south? This is why Injo brought up the correction, the calculation, the declination that you would use on a map, for example, because your compass won't always be pointing the true way that you think it is. You'd have to do a correction. Only by doing the correction will you actually be able to ascertain true north. You understand this, right?
Well, I mean, if my declination is at, let's say, 15 degrees west, my compass...
Okay, so you understand that we are now going to use declination.
If the declination is at my location.
Okay, but as long as we understand that declination is a thing.
Can I speak a sentence, please?
No, because you're not going to turn around to me and start using declination when I'm just trying to get you to agree that it exists.
I never denied that it exists.
Okay, good. So it exists. So we
I'm
can
just
pass it
saying
back to
that it
Indio.
doesn't make
Stop
compasses
talking.
magically not work.
Dude.
Because,
excuse me. No, you don't need to explain.
Okay, so
we brought this, or Injo brought this information to you.
Ask me a question when you want the answer.
Don't need an answer. I just need you to understand that declination exists and not turn around to me like you already knew it.
Okay, and declination exists, but compasses still work.
If you use them correctly.
Duh. The compass is already wired to, if the declination at my location is 15 degrees west, my compass will point at 15 degrees west of true north. Duh!
You won't know that, though, unless you know what the declination correction is for your location. Duh. Please don't turn around and start educating us about declination, sir.
Petty semantics that have nothing to do with the argument.
Dude, stop that. Okay,
I have to look
your little rhetorical gimmick of claiming things are semantics is not going to work.
Well, I mean,
it's not going to last long. It's not semantics. It's being particular and exact in our language and being rigorous. I know you want to be sloppy, okay, but we're not sloppy thinkers here.
You are, because it is a red herring to shift the topic of conversation away from the original argument and into the semantics of getting your city location, the latitude, the longitude to get the declination.
What does semantics mean?
To make sure that the compass works. How about we say this? If I have a compass and I accounted for declination and I have all the information necessary and my compass is pointing to the right north direction, Therefore, I can have actual sun and moon positions in west, east, south, and north accurately from my ground position. But no, you don't want me. You don't want to
ground position.
You don't want to let me say this.
You don't know your ground position.
Flat Earth.
No, you don't know your ground position. That's what you're trying to figure out. And you said use the compass. But if you knew the declination at that place, you would already know your position. So then what do you need the compass for?
So, okay, so
you're a fucking idiot.
We do have the ground position. So we do have the ground. So we are using the ground.
Where'd you get that from? Where'd you get it from?
There you go. That's what I was trying to argue.
Where'd you get it from?
We are using our ground position.
Where'd you get it from? Where'd you get it from?
Okay, you get it from by, let's say, I have my city name, and then I can get my latitude and longitude.
Okay, how do you find that?
I have my declination, and with that, etc.
How do you find that?
Semantics. Again, it has nothing to do with the argument.
Not semantics. You're talking about coordinates. And those coordinates, there's a whole system of coordinates called an arbitrary coordinate reference system. You say latitude and longitude, they mean specific things. They're not ready. You're getting banned, okay? Not dealing with this shit, dude. You're a child.
Your whole argument is a red herring.
He doesn't have an argument. He has a bunch of fucking smirking and fucking gimmicks.
We're trying to argue that the sun and the moon is telling him that the earth is curved.
Yeah, that sky does not determine the floor. It's over. GG.
Yeah, but if you take 1,000 measurements...
If I look at my ceiling 1,000 times in a different place and I record it.
He said, the funny thing is he started, just take 1,000 observations. Of what? He didn't even say observations of what you're even looking at.
Yeah, that was my first question.
Dude, man, politics is slipping, dude. The people in here, the last 2 days I've been in here, they're really, like, TikTok is looking good, dude. Like, the people on TikTok are looking like freaking rocket scientists compared to the people that have been in this chat from this server. It's like they can't even follow what you're saying. Now, you can chalk that up to maybe they're not listening. That's a possibility. But I think that you start saying words and they just don't understand them, and they just go blank and go right into narrative mode. And that I don't know how many times today, just today, that it's like, oh, I don't understand what's being said. I'll just say whatever they're saying is a logical fallacy. There's even nothing to do. I'll say it's semantics. If you know your latitude and longitude, well, how'd you find that? That's semantics. Well, you're finding the position. What do you just want it for free?
Like the Indian kids with the broken English on the English server, like, do better than this, you know?
That's what I'm saying, man. That's what I'm saying. I was saying that this morning. Like, English Hub is making these guys look bad. And that's like high school kids in foreign countries. They can't even speak English. They comprehend more of what you're saying and are more coherent in their responses.
These cats only wish they had the excuse of language barrier.
Look, we're trying to demonstrate the relationship, saying, hey, look at the sky. Okay. How do we know the relationship of positions on the ground in the sky? Look at the compass. Okay, that isn't going to tell you where you are relative to some other person when they look at their compass. Even know the declination, that means you already know their position. And you wouldn't need to look at the compass. How'd you find position in the first place? Oh, use latitude and longitude. Oh, how do you find that? That's semantics. No, that's what we're trying to figure out. We're trying to figure out the Earth, its relationship of these 1,000 observers to each other, so that when they look in the sky, we can draw a conclusion about the direction they're looking, where they're looking at it from, the distance apart from each other, the geometric relationship between them, their lines of sight, and the fucking things in the sky. Now, would that take me a minute and a half to explain that? It's not complicated. It's very simple.
I'm looking for it, but essentially, like I said, it's a correction. So they're both measuring it and they're calculating it out again. But that's
and
my
what
point.
are they comparing this correction to in order to know that it's right and or wrong?
You can say that they're just wrapping it around a ball or something, but
yeah, that's not what I said. Start listening. What are they comparing it to in order to understand they are right or wrong? They need to compare it to something. We've gone out, we've taken our measurement. You've got your 5-degree angle. Now, what are you going to compare it to know that you're either right or that you're wrong? Exactly.
It's a
This is
different
completely a pedagogical mental exercise that has nothing to do with any actual surveying. Nothing to do with it.
He asked me to look up something, so I'm trying to get an actual surveying site.
Okay. Yeah, no worries. Take your time. Just send me the DM after.
Yeah, retroactively find your evidence after you already believe it. if you read any of the surveys that have been done, like the North American Datum or any of them, in the beginning, they tell the procedure for what they do. You could just read that.
Right. So this is the National Geodetic Survey NOAA manual for geodetic leveling. I think this is going to be a good enough resource.
DM it to me. Yeah, DM it to me.
I like how he says he thinks. That's the problem why you're here, boy, because it don't.
2.0, dude. We already dealt with Brown Recluse and this fucking random nonsense obscurantism bullshit. You're literally on here to make people more confused. You're here to prevent information from being transferred.
Should we move on? Just really quick before we move, before we continue with Dylan, is there any other Globers in here? Any new people that believe in the?
You got that geodetic? I bet you it's a fucking website too.
Oh yeah, he just DM'd. Okay, let me paste it.
So this is the NOAA manual, NOS NGS3 geodetic leveling, supersedes Coast and Geodetic Survey Special Publication 239, Manual of Geodetic Leveling, published revised in 2020.
Okay, let me.
This manual furnishes instructions and background information suitable for establishing and maintaining vertical control. It presents general specification and detailed instructions for reconnaissance and benchmark setting, geodetic leveling, water and valley crossing, blah, blah, blah. So this should be totally legitimate.
Could be or is be.
Geodetic leveling, chapter 3.
The only question now, does it have anything to do with what you posted?
Well, that's sort of beside the point. The point is...
How is that beside the point? That's the whole point.
What do you think the point is of our conversation right now? I'm saying geodetic
they do this.
Measures the curvature.
Gemini Flash when they do surveying.
I'm just gonna search Earth's curvature, see if it comes up.
So if they're doing this, and then the surveying manual says they're doing something else, then they're not doing what you said.
I'm not saying I can't be wrong or wasn't wrong. My main point is that they measure curvature, and that they
don't.
They correct for it with a calculation.
They do not measure curvature, dude.
Well,
if they measured curvature
with their angle.
If they measured curvature, there'd be no point of needing an oblate ellipsoid. There'd be no point of having the WGS 84 datum.
Okay, so you understand that they don't want the curvature in their elevation maps.
Okay.
Is this kid stupid or what?
Look, dude.
Because this is this
for elevation. For elevation, what you find is for elevation, what you find is the orthometric height, which is a combination of the geoid and the WGS 84 reference ellipsoid. You don't know anything about any of this, dude.
You obviously don't understand it. I'm trying to explain it to you.
Remember what I was saying earlier about brown recluses, their stick? You literally just did it, dude. As soon as you point out in actual detail that you don't know, you say, I don't understand it.
What do you think I'm saying?
What is the what is the WGS 84?
It sounds like it's a reference ellipsoid. It's a shape of the Earth.
And no, it's not the shape of the Earth.
It's a model of the shape of the Earth, right?
It's a reference ellipsoid, and it's an imaginary mathematical surface that measurements are projected onto. Okay, but it's not done just that way because of deflection of the vertical. they use something called the EGM 2003 Earth Gravitational Model, which is called the geoid, which would be the equipotential surface of gravity if you measure 9.8 meters per second squared. Basically, imaginary mean sea level, even if the water went under mountains and shit. They use a combination of this to get something called the orthometric height, which is the subtraction of one from the other, or the addition, depending on whether the geoid extends above or below the reference ellipsoid. But the reference ellipsoid is used because they don't measure curvature. Because when they do their measurement, they take an actual surveying instrument. The first thing you do is level the instrument. Okay? And because in geodetic surveying, the plumb line is not perpendicular to the surface of the Earth because of lumpy gravity, right? And the fact that to map it, to project it, you need the plumb to intersect the reference ellipsoid at 90 degrees, but you have tilted plumb lines. That shit don't work. You don't know what you're talking about. You've imagined geodetic surveying to work one way. It's purely your imagination.
What do you think I'm saying?
I don't think you know what you're saying. That's the problem.
You said that they measure Earth's curvature. They do not.
Well, then why would they consider the reference ellipsoid in order to correct for their measurements?
The reference ellipsoid, for the purpose of that, is to preserve the celestial spherical coordinate system.
If they're just creating elevation maps and there is no curvature, then it wouldn't be
elevation relative to what?
If they're just measuring elevation with planar
relative
survey,
to what?
What do you mean relative to what? Like
relative
sea level?
To what? Sea
elevation
level.
Relative
That's
to
the
sea
geoid.
Level?
That's the geoid. That's the imaginary equipotential surface of gravity.
So you may disagree with what I'm saying.
You don't have any clue what you're talking about. In arguing about it.
I feel the
You're
same
getting
way
the same shit. You, Brown Recluse, JJ Fish, you come in here and you try to fucking bamboozle people. And I'm fucking sick of it.
It's just my perspective, you know, for sure.
My perspective. Okay, let's use Dylan's personal opinion of how he thinks the world works and not how it actually works. Let's go with that. How do you feel, Dylan? How does Dylan feel the Earth is? Let's ask Dylan, how do you feel the Earth is? Let's just go with that. Let's follow your feelings around.
It's considered a correction if you don't understand that they're measuring for they're measuring the curvature and then removing it. Then I don't know what else to tell you, man.
Because they're not doing that.
What do you think they're doing with it?
Assume.
Oh my God! I told you what.
Dylan, why'd you say they assume curvature if they're measuring it? Why'd you earlier you said they were assuming it?
They're doing both, right? They're assuming, just like I said with the refraction, right? You can take an elevation measurement with and if you don't assume refraction, you're going to get an error caused by the refraction.
So they need to assume curvature to measure it? Is that what you're saying?
No, they assume the curvature to cancel the curvature out.
What?
Of they call it spherical exceedance or spherical excess.
Spherical excess. No one's ever met.
Measurement, quote unquote, of the curvature.
Okay, you don't understand what spherical excess is.
Calculation of the curvature of the Earth.
You don't understand what spherical excess is. Spherical excess would be if you had 3 lines of sight and made a triangle, that triangle would internal angles would sum to greater than 180 degrees. This is not a measurement. You couldn't even measure this because lines of sight are straight. And 3 straight lines connected by 3 vertexes make a triangle that's 180 degrees. Spherical excess is not measured. It is made up by projecting a fucking regular planar triangle onto a reference ellipsoid. You ask what it's for, that's what it's for. So they do something called reduction of the horizontal direction. They take their measurements and they reduce them to quote unquote mean sea level. But when they do that reduction, it has to intersect the reference ellipsoid at some angle. And because they think they have tilted verticals and deflection of the vertical and lumpy gravity, for that to be 90 degrees to the surface of the Earth, okay, that means that plumb lines have to be curved. It's way more convoluted than what you're imagining it to be.
The plumb lines intersect.
The plumb lines curve
at the center. Plumb lines do not curve.
If it's an oblate ellipsoid, that's not true, dude.
A plumb line just points down. Correct?
Is it perpendicular to the surface of the Earth? Is it a straight line?
It's a straight line.
Not in geodetic surveying.
A plumb line is straight down. It is
not in geodetic surveying.
A plumb line is straight down and it's perpendicular to the.
Yeah, not in geodetic surveying.
I don't know what you're on about.
Plumb lines in geodetic surveying are curved and they don't go straight down. It's called deflection. It's called deflection of the vertical.
Okay. What are we talking about? Deflection of the vertical. What the hell is that?
It's curved plumb lines because of lumpy gravity.
You say because of what? Because of gravity? What?
Lumpy gravity.
Lumpy gravity. Oh my gosh. Indio, you know,
I don't believe this shit. This is your idea.
No, it's the way that you try to interpret it is so.
It's not an interpretation.
Yeah, it is.
It's not an interpretation.
You're looking. Whatever.
Okay, I'll read from curvature of the plumb line.
Like your pear-shaped Earth.
Deflection of the vertical changes with position along the curved plumb line. Therefore, the deflection of the vertical at the geoid does not necessarily equal that of the Earth's surface, and vice versa. In order to equate these two quantities, the curvature of the plumb line between the geoid and the Earth's surface, WGS 84, is required. This quantity cannot be observed directly because of the presence of topography, so must be estimated using a model of Earth's gravity field within the topographical masses.
Yeah, how much of a deviation
is that? What did I interpret out of that?
You interpreted an extreme level of deviation that makes you think that proves that the Earth is flat when it doesn't.
Dude, what did I interpret out of what I just said?
You interpret that the deviation is so extreme that it somehow proves that the Earth is flat.
Who said extreme? Who said anything about the extremity of it?
What is the deviation? What is the scale of the deviation? 1/8 of an inch?
You will answer questions or you will leave.
There you go.
That is your only choice.
I don't care, dude.
Bye.
I'll see you in 2 days. Fuck you.
No, you won't. Obscurantism. Will not tolerate it anymore. I've had enough. In here to fucking hide the truth.
Yeah. Just before we.
Well, hold on. One more thing. I just want to make one last post to just substantiate what I said. This is from Featherstone, WE, 6 Southeast Asian Survey Congress. The use and abuse of vertical deflections. Proceedings of the 6 South Asian Surveyors Congress. Fremantle, November 1999. I'm gonna post the diagram from there.
Okay, I can read this part here from the NOAA manual. It says the sources of error in leveling can be classified into 3 groups: those affecting the line of sight, those affecting the heights observed, and blunders. The line of sight cannot be exactly level because of the effects of the imperfections in the instrument and variations in the human eye, refraction, curvature, and tidal accelerations. The heights observed are not exact because of imperfections, blah, blah, blah. So curvature is considered an error that has to be accounted for when they measure it.
Look, dude, they're not measuring curvature. It's not even possible with the fucking instrument. They measure angles, but those angles have a starting reference position. Okay? And if that vertical line from which they're measuring a dip, because the curvature would be measured as a dip angle, okay? If you're not plumb, if that plumb is not perpendicular to the surface of the earth in the first place, you're not measuring curvature. It's like you don't understand what they're doing. Like it's like I can't. Do you not understand? They take an instrument and level it. That level is not perpendicular to the surface of the earth. Do you understand what that means? It's not straight up and down, dude.
Level is tangent to the surface of the earth, right?
Level is not tangent to the surface of the earth. Horizontal level in geodetic surveying is 90 degrees from the plumb line at the point of the instrument. You guys just make up your own shit. And try to say you're using surveying. You're not.
This is just language that I'm using. Maybe you don't understand what a tangent is. I'm not sure.
Yeah, it's my lack of understanding. Yeah, that's what it is.
I just read from you from the manual that curvature is considered an error, is considered something that needs to be corrected.
Welcome to flat Earth, then. I consider it an error.
If it's an error, then it's something that they're measuring, and it needs to be corrected for.
They're correcting it out?
That's what they use the calculation for. That's
okay, what units of measure are they measuring curvature in? That they're getting this erroneous reading?
Whatever height measurement that they're making.
What do you mean whatever? So feet, inches?
Yes.
So they're measuring a height?
Yes.
Okay. And they're like say they go to like 6 feet. And they level the instrument, and when they look through the telescope, their crosshair is looking at 5 feet 11 inches. Is that curvature, or is that refraction, or is that the tilted fucking plumb line?
That's the refraction and curvature are both part of the measurement that they make, and that's why they have to correct for those.
How do you know it's not the tilted plumb line?
That's not the accurate height.
How do you know it's not the tilted plumb line?
Well, the plumb lines at point A and point B are going to have a slight angle difference because they're at different positions. But I don't know what you mean by a curved
plumb line is not perpendicular to the surface of the earth. The first thing you do when you set up a theodolite is level it. 90 degrees is the horizontal line from that plumb, even if that plumb is fucking tilted. You just don't get it, dude. You've imagined something, and you're so stuck in your imagination, you can't even conceive of the way it actually works. It's crazy, dude. It's like you're in a fucking weird cult, dude.
Ditto.
Okay, you see that diagram I posted? The curvature of a plumb line diagram?
Let me take a look.
That's the first time you looked at it. Unbelievable.
The 1208.
Yeah, that. See that diagram?
I see the diagram.
See all the little squares? So you got dashed lines, and then you got the plumb line, and you got all these little squares. Those indicate 90 degrees.
Yeah.
Now, if I draw a horizontal line off of those plumb lines are not parallel. They're all over the place. So I'm going to draw it out. But you're not getting, dude.
This doesn't seem to be relevant to the.
Oh, yeah. Now it's not relevant.
It doesn't seem to be relevant. Tell me how
it is relevant.
Well, I gave you the document. The curvature is considered an error. They use the reference geometry of the Earth in order to cancel out
the geometry of the Earth. It's an imaginary fucking mathematical surface.
That's
imaginary.
But that's what they're doing.
Who cares? It's not the Earth. They can do all the mental exercises they want. Nobody cares.
Yeah, that's what. Yeah, you want supposedly evidence of people measuring the curvature of the Earth, but when
you haven't given any yet. All you've given evidence of is you have no idea what you're talking about. You see all these red lines in the diagram I just posted? All of these are horizontal lines. All of these red lines are horizontal lines, dude.
You keep repeating yourself. What is your point?
So, if I take a theodolite and I measure the vertical, say I'm at the top there, I'm at that top line, and my theodolite's 6 feet off the ground, and I sight in, and like you said, if I sight in at 5 feet 11, that's the curvature of the Earth. No, that's not the curvature of the Earth, because this horizontal line is pointed fucking up. You don't have a vertical that's perpendicular to the surface of the Earth from which to draw the conclusion that dips are curvature or refraction or any other thing.
So you're saying that that surveyors can't.
They're saying it.
Elevation?
They're saying it.
That it's impossible to measure accurate heights. This is the technique that people are using to produce elevation maps.
Oh my God.
Are they not producing?
So you're going to straw man. You're going to straw man what I said.
Well, you're talking about your diagram.
Who said anything about measuring accurate heights? When did I say anything about accurate heights? When did I say anything about accurate heights?
That's what we're talking about. That's why I'm saying you're derailing the conversation.
No, it's not what we're talking about, liar.
What do surveyors do?
We're talking about measuring the curve of the Earth. Remember? You tried to straw man me saying that measuring a dip off that horizontal is not the curvature of the Earth. You have a tilted plumb line because your horizontal line is not perpendicular to the surface of the Earth. And you tried to say, I'm saying they can't measure accurate heights. You are a fucking weasel. Fuck, dude. How many is it going to be today? Lying fucking snakes. Now, despite your best effort, Dylan, people that are listening, they did learn something. I did educate them on how this shit works. I did not let you fucking confuse them with your bullshit. With your fucking fantasy of how geodetic surveying works and how they measure curvature and how they correct for curvature. They don't do any of that shit in reality. Oh, Eskimo. Aren't you the one that posted that 3 picture thing earlier? Something dipped over the horizon? Eskimo Greg?
Yeah, I have nothing to say to you, man.
Yeah, that was from a video game. That was from a video game.
You're retarded.
That was from a video game, Eskimo Greg. Why did you post? Yeah, you better leave. Posted something from a fucking Steam video game
just got
and
bad
said that it
energy,
was the
bro.
curve of
Just
the earth.
Take it easy. Take it easy for a little bit.
I don't need your help, dude. I'm sick of liars, dude. It's just like a parade of liars, one after the other.
Just balance.
Who cares, dude? So, no. Stop defending liars.
Oh, they left. Man, there's like there's like 3 trolls, one after the other, right there. You know what's crazy? I heard Dylan say they have to assume it and measure it at the same time. He said we assume Earth curvature and we measure it. Like, what the heck?
They fucking admit in surveying they don't measure Earth curve. They admit it. Only retard anti-flat earthers on the internet say they measure Earth curve.
Yeah.
I'm dead serious. I've seen surveying where they said the only thing we actually measure in surveying is the gravitational potential. And that is really all they measure because that's what their instrument measures. They level the instrument. That is the spatial reference. What the Earth, look, the Earth could be gone, right? Or fucking transparent or unseen. And you could take the instrument, right, and set it up. And you could level it. The instrument itself is oriented not relative to the Earth, but it's oriented relative to the gravity vector. Okay? That gravitational vector is what you're measuring. Your surface of the Earth. Now, in geodetic surveying, all they do is map the topography relative to the gravitational vector within a celestial sphere coordinate system, namely latitude and longitude. It's 3 mappings. Well, it's 2 mappings and kind of like a filter with the WGS, with the gravitational model being the filter. The point is, doesn't work. You guys imagine it works a certain way because it's like, well, I want to measure a fucking ball, and really, this is what I would do. But the Earth's a ball, so this is what they're doing in real life. They're not doing it that way. They're not doing anything. Whatever you imagine they're doing, they're not doing.
I actually had another question. When Dylan was saying like they needed a 90 degrees for the sextant, I was thinking they used the Earth, because in order to get 90 degrees, they need 2 straight lines, right? But the Earth in their worldview is curved. So is it true, Indio, that the tangent or whatever they're using for the 90 degrees, that bottom line, is that a straight line? Because it's on a curved Earth. So how can it be straight?
What do you mean? The only time they're finding 90 degrees is if they use a bubble sextant.
Oh, okay. So are they using the Earth in that case? In that 90 degree thing?
They're using there's a level inside the sextant. It's called a bubble sextant.
Okay. They're not using the surface of the Earth as one of the lines as 90 degrees. Is what I meant.
No.
Okay.
No.
Yeah, that sounds better actually.
And then you run into the same issue as you do with because that's what the theodolite uses. A bubble level. I mean, some use prisms now, but it doesn't matter. It's the same thing. It just finds the fucking gravity vector, and and the surveying part just tells you the relationship of the topography to the gravity vector in the celestial sphere. And they take that and they map that to a reference ellipsoid. But they don't map it like a projection. They map it point-wise using curved plumb lines. So it's a mapping function. It's really kind of like a filter. That's the way I think of it. It's almost like a where they take, imagine like you're ray tracing and you were projecting your ray tracing through a filter that curved the ray trace lines to have certain relationships. That's what they're doing. They're running it through this like filter before they project it onto this reference ellipsoid.
Got it.
You gotta think there's like layers. There's the sky, and then there's the reference ellipsoid, but then there's also the measurements, right? So that's like, there's the sky, there's the actual measurements, there's the reference ellipsoid, and then there's the geoid, right? The geoid is finding, hey, what's the relationship of gravity to the surface of the Earth? It can't straight just use the sky. It doesn't, I mean, I know it's hard for these guys to believe, but it doesn't match up. And that's why they're doing all this. The reason it's this complicated is because it's hard to get a ball from flat measurements.
I have a question for the flat Earth believers.
Go ahead. Yeah, go ahead.
So, and this is just me genuinely curious. So, assuming the Earth is flat, like, does everybody, like, in this model, like, live on one side of Earth, or are there people like living on like?
Not a disc. It's not a disc.
Oh, okay. So what is?
There's no outside the Earth, dude. There's no underneath.
Okay. So everybody.
There's no edge. There's no outside. There's no underneath. There's none of those things.
Okay, so could you explain the model then? Because I don't.
Model of what?
Of like a flat Earth.
Yeah, I don't know what that means, dude.
So like
the shape is the overall shape. The overall shape is unknown. The size is unknown. But flat is not a shape. So we're not claiming a shape. We're just claiming that it's not curving, and the size is unknown. And we're not floating in space or anything crazy like that. Especially without we're not in a vacuum without a container.
Okay, so we're all, regardless of the size, and correct me if I'm wrong. I'm just trying to get an understanding. We're all like on a plane.
It's topographical plane. It's mostly water, right? So.
Right. So there is a lot of water. So we're all on a plane, and so when we look up, we're all looking at the same sky.
Depending on where you are, if you're close to somebody, you're looking at the same sky.
Well, I mean, if it's like,
look, bro, like if you were in Walmart and you looked up, would you be looking at the same ceiling as somebody on the other side of Walmart?
Well, it depends where I'm looking.
Well, you're not gonna. If Walmart's big enough, you're not gonna see what's over their head.
I mean, let's just say. I mean, that's a great example. Let's say if the Walmart had 500 feet ceilings that it was just empty, and if anybody looked up at any point, you would wager, unless there were like other things in the way, that you could see like the four corners. Let's assume it's a square Walmart. You would likely be able to see all, regardless of where you're standing within Walmart, you'd be able to see all four corners, right?
No.
Why?
Because of perspective.
I mean, again,
you ever draw before? You know, the horizon is and the vanishing point and all those things.
If there's no obstruction, you would be able to.
Perspective, I said. You know what perspective is?
Yeah, I understand what.
You know how you look down a long hallway and they converge to a point?
Right, but we're talking about like a ceiling.
Yeah, the ceiling appears to come down, the floor appears to come up, and the walls appear to close in.
I don't know if maybe you understand what I'm talking about.
Does the floor on a long hall, does the ceiling on a long hallway appear to come down towards the floor?
No, we're talking about like a big warehouse. I mean, it doesn't appear to. I mean, I've been in like giant warehouse buildings.
Okay, but yes, even in a warehouse, the ceiling of the warehouse will appear to come down.
I've never seen that.
it'll converge to a vanishing point. It's perspective. It's how just when you have a 3D world projected onto a 2D surface, that's how it works. That's how images are formed.
You ever seen a deck of clouds in the distance, and how a deck of clouds?
Right, but I'm talking about. I mean, in extreme distances, sure, but I'm talking like specifically about like the scenario in which you're like in a Costco. Like, imagine you're in a Costco, right? And there's nothing inside of the building. At any point, wherever you're standing, you'd be able to see all four corners of it. At any point.
No, like he just told you, because of perspective. I mean, depends on how big it is.
The size of the Costco, dude.
Okay, let's say a reasonable Costco within the visible milestone of what humans can see.
Okay, how far do you think humans can see just because of the air? Not curvature.
Let's just make it. I mean, we don't have to get ridiculous with it because I don't know the scientific definition of how far humans can see. Again, let's say 500 feet in the air.
I already know where you're going with this.
Let's say 500. No, okay, but I mean, you asked me the question, so.
Why can't I see the end of the Earth? Why can't I see the Mount Everest from China?
That's not what I was gonna get to. That's not what I was gonna get to, at all. So.
How far do you think you should be able to see, dude?
That I would like to discuss what I was talking about.
Okay. What?
I mean, if you want to, we can. I don't know. I don't know.
Like, listen, most Costco's they're not 100 fucking million square meters.
I know, but it was a thought experiment. It was a thought experiment.
You see the corners of a normal Costco.
It was a thought experiment. I'm just simply asking you to rationalize and think about a Costco that is, let's say, 1,600 square feet. Okay, and it is completely empty inside of it. At any point in which you stand in this Costco, if you look up, you would be able to see each of the corners, assuming there is no blockage within, like, there's nothing blinding you, like there's no light obscuring your vision, and there is no like tall aisles. Let's assume that it is completely empty. You'd be able to see all four corners regardless of where you're standing in the Costco. Yes?
Okay, I already told you. It depends on how large the Costco is.
I just gave you I told you 1,500 square feet.
Dude. That's like 20 by 20 or something, dude.
So yes?
Tiny.
So yes?
Yeah, in a 1,600 foot Costco.
Okay.
Yeah.
Okay.
It's like the size of your house.
Okay. So distance and scale matters.
Yes.
Okay. All right. Cool. We have a baseline. I like that. So.
But you have distance, but what it matters, but as far as Costco goes, things like Costco, you have things called distance cues. You have an idea of the size of objects, and because the floor isn't some uniform thing, so you typically made it for tiles, you can see from the orientation of the tiles and how they're getting smaller, how far away things are. So there's other cues we use to judge distance. None of that works for the sky because all the stars look the same distance. So all the distance cues that you would use to look at a floor, you can't use for the sky.
You can. Because why do we see different stars in different hemispheres? Why does the northern hemisphere see different stars?
You don't have a hemisphere. You don't have a hemisphere.
I understand. I understand that you don't believe that we do, but
I know we don't.
You could literally go to. I mean, have you ever been to Australia and taken a picture of the night sky and then compared that
Didn't we just do this yesterday?
I've never spoken to you in my life.
Okay, I just did this with somebody else yesterday.
I mean, that's just the biggest, like, that's just like the biggest example of how you can nakedly see with your own eyes that, I mean, if it's not a globe, like your, and I'm not going to say your model because you haven't given me a model, which is fair. There are different variations of what different flat earthers believe, and that's completely fair. But within the sphere, right, within the globe model, it is explained every single time how that could work. And the flat Earth model does not have an answer for it.
Okay, you're full of shit. Okay.
Okay.
Okay, you don't know what you're talking about. You don't have a sphere from which there could be a hemisphere.
Okay.
Just don't say magic buzzwords, dude.
That
shit don't work in here. We deal with evidence. Okay. So really simple. Okay, for the same reason. How far is Australia away from, say, Canada?
I don't know. I'd have to look it up. I don't know that.
Like 15,000 miles or something.
Yeah, I'm assuming you would have to look that up too, right?
Okay. Well, I know UK to Australia is something like 10,000 miles. Okay. So I'm assuming Canada's 5,000 miles further because it's across the Atlantic. So
I don't know. Yeah,
15,000 miles, let's say. Okay. The sky is going to appear to come down and converge into the horizon. In the ground, it is going to appear to ramp up and converge into the horizon. Now, you're not going to see all the stars. The only stars you're going to see over your head are the stars over your head. Stars that are 1,000 miles away, they're not going to look like they're over your head. Why would they look like they're over your head?
If the Earth was somewhat flat, you would. If the Earth was somewhat flat,
that is nonsense. It's nonsense. So if I walk around on a flat Earth, the stars that are over my head in Australia follow me around.
They wouldn't follow you around, but they would look. You would be able to see the same stars. You would be able to see them. They might look skewed. They might look different. But what I'm saying,
why would I see the same stars?
That's what I'm asking you. You wouldn't.
No, I'm asking you. You're making the prediction that on a flat Earth you would see the same stars. Why is that?
You'd be able to. Well, because ultimately you're looking up.
Okay.
And you're presenting the idea or making the notion.
Are all the stars in the sky at zenith?
Are they what? Sorry?
At zenith. Zenith is directly over your head.
Well, I believe in a globe Earth, so
okay.
No.
Zenith exists on a globe Earth too. Are all the stars
but the Earth is rotating
directly over your head?
Some stars are, but at different times during the day.
I can walk out from underneath that star, right?
I mean, you can like walk away and still see the same star.
Yeah, but I can walk out from underneath it so that the star is no longer directly over my head.
Well, I think that's more so the rotation of the Earth that's doing that. But yeah, I mean, like you moving would absolutely add to it.
Oh yes, the star wouldn't be able. That's not exclusive to a fucking globe, dude.
You mean to like a flat?
Yeah, to move around and to have different stars over my head because I moved around.
Right, but
that's not exclusive to a globe.
Maybe I could like explain it a little bit more on a smaller scale. Like if I look up at my
you came with a gotcha. It's fucking dumb, dude.
That's not an I gotcha, bro. I literally was just asking questions. You're just being so like really like I get it. You're very
steel man what I said. Steel man my argument.
I'm not trying to steal you.
Steel man my argument.
Questions. I'm just asking questions.
Steel man my argument. I want to make sure you're listening.
Is anybody actually enjoying this?
I want to make sure you're listening. Steel man my argument.
In what argument? You've made no argument.
Yes, I have.
What?
Steel man my argument.
Your argument was that we can move under stars.
That's
literally the only
thing. Stars over my head. That if stars are in one place over one spot, and I said this way back when we were talking about Walmart, that the lights over my head on one side of Walmart are not the same lights that are going to be over my head if I'm on the other side of Walmart.
They're not the same lights, but you can still see the same lights.
If I can walk across, depends on the size of the Walmart, because eventually, because of perspective, they are going to merge into the vanishing point, and they're going to be undifferentiable from the horizon itself.
All right, I got a great answer for you. So throughout times of the day, if you walked through that Walmart and literally took pictures in I don't know, let's say a 10 square foot square, and you literally took a picture. You took a picture.
Just pretend I didn't say it.
I'm literally answering you.
You're answering how the stars don't follow me around over my head. That's what you're answering right now.
To be fair, you didn't answer what I said. I literally asked you a question that you never answered from the beginning, and I've just been entertaining this.
What was the question?
Why do we see different stars in the northern and southern hemisphere that you can't see otherwise?
Perspective.
No, you didn't. You didn't answer that. You didn't answer.
I said perspective. The sky comes down, the ground ramps up, and they vanish into the horizon, which is the vanishing point.
Okay.
Called the vanishing point.
Mm-hmm.
Take an art class, dude.
Okay. That's great. That's great. But
it's just basic.
There are literally no astronomers that would agree with you.
Who cares?
Oh.
That's how weak your argument is. Now it's an appeal to credentials.
An appeal to authority. Yes. That's a great fallacy. I also don't go to doctors when I need a medical treatment. I go to somebody that works at Pizza Hut.
That's a false equivalence.
That I don't think so.
I do.
I think it's close, but not quite. Because if you're going to discount every single astronomer, is there any astronomer that you
the all or nothing
find any
fallacy.
credence into?
So, any more logical fallacies you want to stack on? Any more logical fallacies would you like to stack on?
Would you like to answer my question?
Any more logical fallacies would you like to stack on?
No. I have no further questions, Your Honor.
Yeah. Okay. Go try somewhere else with your bullshit, bro. One after the other, fucking dude. It's like literally a fucking parade of fucking speds.
Yeah. All right, next.
And what the most aggravating fucking thing is, like I said before, they are not trying to figure out what the truth is. They are just trying to hide it.
Yeah.
In the case of this guy, he's just trying to quote unquote win the debate.
Another lights in the sky type argument.
Dude, I answered it right off the bat. I walked to the other side of Walmart. There's different lights over there. It's real simple. Walmart's real small. That ain't true. But we're comparing it to the Earth. You ask me, why does it happen on Earth? Earth isn't the size of Walmart.
They're always looking. Yeah, this one. You know what's crazy? I actually prefer Dylan's argument to this argument because at least Dylan is looking at the Earth, or at least kind of looking at the Earth. You know what I mean? This one, he's just looking up at the sky. So
I don't like Dylan's motives. That's my problem with him.
Yeah. Hello, Nick James and Talent X. Are you guys globe earthers?
I'm Glober.
You believe the Earth is a globe?
I know the Earth is a globe. Knowledge.
Okay. Why do you believe the Earth is a globe?
Well, I don't believe it. I know that the Earth is a globe. It's knowledge.
Oh. Okay. How do you know?
Because there's facts and evidence.
Okay. Name one fact.
It's measured, and there's a picture of it.
Can you post the measurements? Let's see.
I could.
Let's see.
You want to see the?
Let's see the measurement. Yeah, post the measurement in the chat. Let's see it.
Okay. I don't have permission, but I can send it to you.
DM it to me, yeah.
Called the Great Trigonometrical Survey. The direct physical measurement of the surface of the Earth.
Okay, let me see.
You're welcome to post it in the chat.
Got it. Okay.
It's very
All right,
famous.
let me read this 1 sec.
There's a lot of coping and seething that goes on behind due to the Great Trigonometrical Survey.
Let me post a picture.
So I have read the survey.
Yeah, I'm
just you guys misunderstand what corrections are, what calculations are, what measurements are, especially clipcord. But they're not even in the voice chat. It's so weird how many people you have it.
Did they hang on 1 second. Oh, they use theodolites, right? They use a theodolite?
Yep.
Okay, wait, let me see here.
Towers and survey towers. Custom instruments.
Wait. Is this the same? Okay, sorry. Theodolite. for the theodolite, are you using you need 90 degrees, right? Like a 90-degree angle.
Well, they got over 180 degrees. It was a 300 it's about
sorry,
4,000 mile radius, give or take,
let me
a little bit less.
Okay, so when they're using the theodolite, they're measuring an angle, so they need
Correct.
2 straight lines. So can you describe what the 2 straight lines are?
Well, you can see they're triangles. It's thousands of straight lines. Do you see the picture, the blue lines on the map? If you look at the blue lines on the map of India.
Let me check. Oh yeah, let me post that, yeah.
Right. They use triangulation.
Okay, one sec, let me see.
Yeah, see, I have a little diagram of how triangulation reveals the curve.
Straight lines. Okay.
When the angle is greater than 180, angle sum.
Is there a physical? Hold on. Let me see the Wikipedia again. I'm trying to look for like a real life physical theodolite demonstration where they.
Hi, YouTube.
Where they did it.
How does that work? That is how they did triangulation.
What do they aim the theodolite at?
A mirror. A point of reference.
They're aiming the theodolite at a mirror?
Yeah. And there's 2 at the other side.
Okay.
On the other side of the line.
I don't see a mirror in here.
They're shining a mirror. That's separate. They just take a mirror. It's just like a 8x10 size mirror. They shine the sunlight at the.
Wait, in your Wikipedia, I don't see any mention of a mirror. Where's the citation for the mirror? Or is that just like a default theodolite thing?
Yeah, that's the default.
So there's a mirror like inside the theodolite? Is that what you're saying?
No. The theodolite's aimed at the other side, the other point, which has a mirror.
Oh, okay. So they're aiming it somewhere in the distance, and then there's a mirror at
right. Like when you see how triangulations reveal curvature. So they go from like point tower to tower. So you have to go theodolite on one side and the mirror on the other, and then you get the measurement.
Is there like a physical demonstration where they're aiming it at is there like one instance that shows a real life demonstration where someone has a theodolite, they're pointing it at a mirror in the distance? I just want to see it.
I don't think that's how theodolites work. You know the guy how there's usually one guy on one end. There's always 2 people, one on one side and with the theodolite. The other side's got the little stick, little mirror on it.
Okay, wait, let me see if I can find one.
And that's really elementary use of surveys. You do not know how surveys work? There's 2 people involved, 2 teams.
Look, wait here. How to find the distance. Yeah, I don't remember any mirrors. I mean, okay, here, you see this? You see this? Here, wait, look. You see this in the chat? Is this accurate?
Huh?
I just posted a.
Sure. That's similar. That's a similar triangulating. That's a triangulation of a height. That's triangulating height from the horizon or something. I don't know what that is.
Okay, so are they measuring Earth curvature using a mirror? Or how does it?
Theodolite.
The theodolite is aimed at a mirror,
right?
And they're measuring. Okay, let me be more specific. How many inches of drop was there in one of the measurements that they took?
What? 8 inches of drop.
Over what distance?
Over thousands of miles. Or over per mile or something? I don't know. The average was 8 inches.
Like, just give me one instance of their measurement, and then tell me how much drop was there.
Just the measurements themselves were just angular measurements measuring over 180 degrees.
Okay, can you give me that in inches and feet of drop over distance?
No.
No? What do you mean?
No. Why? Why do I need to do that?
That was notorious for bullshit.
Okay.
Well, again, that's a bullshit question. That's what I'm asking.
Well, I mean,
if you can't explain why you're asking a question, then you obviously have no fucking idea what you're talking about.
What you said isn't true.
Bro, what in the world is this thing showing here that Joe put in the chat?
I'll leave you guys to it. Indy is too bad faith for me. So
yeah. So tell me,
Indy can just go and run his mouth.
You have 3 lines of sight with 3 Yeah, you better run away.
Instantly.
He's another one, dude. He's another one.
Yeah. India, is it true? Do they use mirrors? You can use a mirror, right? In a theodolite measurement? That's true, right?
They used it. So Lewis and Clark, the only time I've
never heard
mirror.
of it before.
Maybe a retroreflector.
Oh, you mean off the moon? Is that what you mean?
Yeah, well, I mean, they make, for the automated theodolites, the ones that do automated measurements, they use retroreflectors to do some of the measurements.
Okay. And they aim the theodolite. They physically put a mirror out in the distance somewhere on the Earth.
Well, it's like the retroreflector that's at the end of a pole. They stick it's they're like a tripod, right? They just stick it on the ground, and they know the height of the retroreflector, and it'll make lots of measurements, right? It'll do something like, I don't know, 100,000 measurements in a few hours.
Cool.
They do this in like building surveying. I've watched them do it outside my house and shit. They put up like a 20-story building, and they would come out like pretty much every day. And there was retroreflectors on the building, like on the corners of the building, because they want to know if it's sinking or you know what I mean. And they would come out, and they had a geodetic control point. They take their little automated fucking theodolite, push their buttons, set it up, and then it would just make bunch of automated measurements, and the dude would just sit there and pick his ass until it was done.
Okay, let me ask you this. What are your thoughts on the Great Trigonometrical Survey?
The India one?
Yeah.
Oh my God, the thing's a mess. They don't even have a uniform methodology.
Damn.
Yeah, like depending on which group of surveyors, they kind of each did their own thing.
I was trying to ask.
And they assumed that the Earth was a perfect sphere.
Oh.
So the datum they use is the bezel spheroid.
I was gonna ask them for a specific instance, one point, one physical demonstration of one of the measurements that was taken during this. But it's just a Wikipedia thing.
So what they don't understand is that, or haven't heard, even though I've told these guys a bunch of times, they do something called reduction of the horizontal direction. Okay, so they take measurements. So you have 2 points. Now, is your theodolite tilted away from the other theodolite? is your theodolite at the same level as that theodolite? Because that matters, right? You have one theodolite set at freaking 1,000 feet, and the other one's at sea level. Now your calculation of that triangle will be different than if it was at the same level. So what they do is called reduction of the horizontal direction. They take all the measurements before they're entered into anything, and they reduce them so that all the measurements are at the same on the same datum. So they reduce it to sea level. So now you have a bunch of triangles. Well, what happens when you do this? When you change the elevation of the triangle, the angles relative, if the Earth is a ball, right? Now you have tilted verticals. The verticals are not in the same plane. The plumb lines, they're not in the same plane, right?
Okay, Globy.
Okay.
Welcome to Flat Earth, whoever that.
So when they reduce the horizontal direction, they have to rotate the azimuth. So instead of, like, say, pointing at 85 from true north, they have to adjust. It gets adjusted by calculation to say 86. This excess, this extra bit, is the spherical excess, right? The greater than 180-degree triangle is the result of this calculation from measuring a planar triangle and projecting it onto a curved surface. Understand? You have a triangle, and if I take the triangle and put it on a ball, project that planar triangle onto a ball, now that triangle becomes distorted, right? Because it's a curved surface. And the directions, right, relative to north, south, east, west, are slightly altered from that distortion. So the reduction of the horizontal direction changes that direction. So let's say I have a planar triangle. One line is going north south. One line is going, let's say, frickin' 85. And from the end of the 85 line, that's going, say, 230 or something. Now that makes a triangle, but when I project that onto a spherical surface, I can't maintain that planar relationship if it's projected on a spherical surface. So those directions, that 85 and 237 and north-south, right, they're all going to slightly have to be adjusted to have it on a spherical surface. Now, that's why I said they're not measuring greater than 180-degree triangles. It's the result of them reducing the horizontal direction and changing the azimuth. Because if you just think about it for a second, I have three, because they're not measuring the sphere. They're not on the sphere. They're off the sphere. The theodolite is above the sphere, the lens, right? I have 3 points. They're all not on the sphere. They're above the sphere. Now, if I make lines of sight that connect those into a triangle, that's a planar triangle. They don't become a spherical triangle until they get projected onto a sphere. The sphere wasn't measured. It was assumed.
Did you just say spherical triangle? Is that what you said?
Yeah, a so-called spherical triangle, yes. I mean, it's called a rouleau triangle, technically.
Got it.
So, I mean, someone posted a diagram of it a little while ago when I was talking about it. Well, let me scroll up, see if it's still there. Yeah. Yaga Bruno posted it. This. Here, I'll post it again. This.
Oh, there, I gotcha.
Yeah, so this planar triangle, this would be the point where the theodolites are, off the surface of the sphere, above it. But when you take this triangle and you put it down to the surface, those the directions of these of the sides is going to slightly change because of the curved surface. That's the azimuth direction, so that's like the compass, north, south, east, west. Those are your azimuths. So it's going to change. It's going to slightly change when they do the reduction of the horizontal direction. They take this planar triangle, project it on a spherical surface. and what they're trying to do is just change the azimuth. And they say this azimuth and so this azimuth change. So you've changed the angle between the lines by doing a calculation and changing the azimuth direction. And if you measure that angle, it'll end up being greater than 180 degrees if the triangle's big enough. But that's not what they're measuring. They're measuring the blue triangle, not the right triangle. The blue triangle is the measurement. The red triangle is the calculation based upon assuming the Earth is a globe.
Bro, it's the same thing that Dylan was doing, I think.
No, he said that they measure greater spherical excess. They don't measure it. They're just parroting stupid people like McToon when they say this. McToon is like the first person that really pushed this forward, and they've been freaking carrying that water of that dude just being wrong for quite a while.
Is McToon still? Is he still around? Like, is he still going?
I mean, he's taken a beating a couple times. I think he's like in stealth mode right now.
Healing.
DJ fucked him up. Have you ever heard the DJ DJing him?
I did not see DJ.
DJ went into a server and debated McToon. It's one of the worst destructions I've ever heard. It's really good. I'll post in the chat.
Yeah, I'll take a look. I just been watching too many QE videos.
Oh god.
Yeah, I've been just watching QE.
McToon was literally like begging DJ to leave. It was on a different server. I think the server's name was QOps or something like that.
Oh yeah, that's where we had the Tourette's episode and called him an asshole 80 times in a row.
Yeah.
How do you manage to sit through a QE episode? It's fucking. Can't even imagine hours of it.
Yeah. Yeah, a long time ago when he was on the other FED server, it was actually really not the videos, but like a random Glover would join, and then it was just so funny. It was like, "Are you a fan of the spinning ball space monkey religion? Okay, what is the scientific evidence of the globe?" And then they couldn't even comprehend that that it's like every question was a death sentence essentially, because they didn't realize that there's no science for a shape. And then, oh man. But anyways. Really quick, is there any Globers in here? Dylan was before we go back to Dylan, let me just see if there's any other ones in here, because I know he's here, but I want to see if there's any other Globers.
Indio. What's up, babe?
Huh? Oh, what's up, dude?
Hey, man. Long time.
Yeah, man.
My fucking Discord's all screwed up, man.
Yeah, I remember you saying that. I heard you say that. And
so, I'm getting a new computer here this weekend, so I'll be back soon.
What's going on, dude?
Sweet, bro.
What's up, Timbo? Hey. Timbo Matrix and yeah, you guys all sound the same to me. Damn it.
What's going on, man?
I heard you jump in, man. You took a break, huh? That's good, man.
Yeah, I'm back now.
Yeah.
Again.
I'll be back soon. I've just been doing my own little thing, man, doing some live streams and shit. But hey, India, that kid, man, with 182 IQ today, man, got so wrecked. That kid was pissing me off, man.
Oh my god.
I was screaming at my phone, man. I was driving, but I was like, oh my goodness.
It's kind of like that all day, man. So Yar's been here all day watching me just like take scalps, dude. It's just like I have a pile of bodies that's so high right now.
That's awesome, man. I do a lot of listening, guys. You guys been killing it. It's been fun to listen to, man. I wish I could jump on more often.
By the way, what was he saying to get you to scream at your phone? What was he saying?
Fucking, he's just would not answer the most simplest questions. And he just kept, calling us, calling us stupid, and he's smarter. And he was just getting racked. And I'm like, you fucking Mongo. Come on.
Was it another
and
one?
He's
the
20.
guy?
He goes, oh, you guys are old, and, I'm smarter than you old guys. That was pissing me off right there, man. He doesn't understand what experience is, man. He might be 22 or 7, whatever he said he was. But
was he one of those lights in the sky people, or was he like at the
He was doing lots of lights in the sky, the moon thing. You guys were talking about the moon, but he wanted to take it up there, but India wouldn't let him, man. Tried to keep it down here on Earth. And
did he have any ground thing, like any non-lights in the sky stuff, like any ground things?
No, he just had his religion, and
okay, just lights in the sky.
He was NASA. I've been to NASA. He goes, I've been to NASA.
Oh yeah, that's right.
I was like, "What? Yeah, I've been there too, man." Ding dong.
I said, "Where's the proof of the globe? And is it in the coffee cups or the frickin' T-shirt?"
Wait, he said he'd been to NASA?
Yeah, he went to NASA. Yeah, over there.
Like, what do you mean been? Like, what did he say? Like
Cape,
Ben?
I don't know. He went to whatever Cape Canaveral or whatever. I don't know. One of those.
Like an office?
No, where they got the rockets. The tour.
The rockets. So he might as well just say he was an astronaut.
Right. Anyway, poor kid. I felt bad for him, man.
It's been a parade of rhetorical gimmicks, one after the other. One will come in, they try to pretend that oh, I'm just a reasonable person asking questions. Then their mask falls off, and the rhetorical gimmicks come out. And then, and then it results in, well, you're just a flat earther anyway, so nobody takes you seriously. And, then there's the coping, and it's like a stupid cycle, dude. And it's like, they all think they're so original. And it's like, man, 10 of you just did the same thing in a row. And you thought your stuff that you came in with was clever. And you're just an NPC, man.
Wow.
All of them, man.
That old physicist was on there yesterday. Did you? I don't know if it was AI or
I missed him.
It was AI. I was talking with him. Well, he was kind of cool, man. He kept saying when he was done talking, he'd say over. It was very polite. He's a nice guy, man.
Yeah, I missed it, man.
Yeah.
I've been looking for a normal person, man. Hard.
Hopefully he'll come back. But
I haven't been trying to be confrontational either. I'm really not trying to do that. They just draw it out for some reason.
Mm-hmm. Yeah, you guys put up with a lot, man. I do appreciate you guys, and I don't know if I could ever buy you guys dinner or something, but man, you guys have just been putting up with it lately, man. It's been pretty fun to listen to, anyway. Well, I'm learning, still learning, man.
I'd say the theodolite conversation, if you're not familiar with theodolites, it's actually kind of interesting to listen to. But then, the next day it gets old really fast because then you realize it's all nonsense. But the first time you hear it, it's like, oh wow, this is interesting. Right. And you realize it's all nonsense.
And then the Sticks and Shadow guy was in there today, I think.
Yeah, that also, like, for a person who's not familiar with it, that also might sound interesting. But then, like, 10 seconds later, you realize it's nonsense again.
Total. That was that guy. It was the cop. You were talking to the cop this morning, right?
The cop.
Yeah. Maybe not you, but India. Were you talking to the cop this morning? Maybe that was a different channel. I don't know. I was flipping around. It could have been.
What were they talking about? Was it like?
Oh, he's like, he does studies on people and studies on. He's a gang enforcement officer, and they have to profile people. And he came in to profile us.
Like a detective. That would be nice.
Yeah, it was kind of interesting. He's pretty smart. He knew a lot of stuff, but he was like, you can do this in your backyard. You get 2 sticks, or maybe,
Oh, he was defending Aristotle's.
I was like, oh, dude. And he's like, yeah, most of you flat earthers are low IQ. And I was like, oh, man, poor guy.
Could he actually recite Aristophanes pretty accurately, or was he just like winging it?
No, it was just rough around the edges. He'd be like, the 2 shadows, you measure the length, and then he didn't know how to actually do it. So yeah, just part of his religion.
Did you guys mention that light source was like the location of the light source that determines the shadow angle is unknown? Did you ever mention that?
No, I don't know if they got that far. I don't know. I wasn't on the call, but I was just listening while I was packing up my car for the day or whatever.
That would be kind of interesting, like a professional. Like, imagine there's like a professional forensic or homicide detective, and they try to look at the evidence of the globe and see if it matches the.
Oh, that would be fantastic.
That'd be hilarious.
Yeah, I don't think he would be willing to do it. I don't know. He seemed a little arrogant. I don't know. We could just knock him down a couple pegs, but maybe he'll come
They have
around.
a stressful job, man. I would not want to be a cop.
Oh goodness, it's got to be tough, man.
That's a real match. That's like a alpha male type of job right there.
Oh yeah, man. Lots of testosterone.
Confronting criminals, like that's some crazy shit.
A friend of mine's an FBI agent. He's he's on a task force. He's on a task force for bad guys, gangsters mostly, and criminals. But he doesn't do like white collar criminal. It's like the guys, with guns and shit. And they took down like 38 guys in one day, like a month ago. I was like
arrested or like?
I'm like, yeah, they took they got all of them, 38 of them. I go, that was a busy day, huh? He's like, yeah, fucking A, man. Because I was in the band. I was like, well, that's a good place to be. Yeah.
That's some warrior shit right there,
man. Yeah, suiting up and going getting bad guys. It's kind of like going to war.
To be fair though, I feel like doing that would probably make the average guy feel a lot more important and fulfilled than just sitting at a desk.
Oh, absolutely, right.
But at the same time, it's like terrifying, But on the flip side, you feel like you really like are actually doing something and not just sitting behind a computer. You know what I mean?
Well, yeah, you get to see, you're getting the bad guys off the street, man. I mean, there's a lot of them out there, but there's a bunch of freaking whacks out there right now, man. I've seen so many like people acting so weird lately, man. I don't know what the heck's going on. I guess
That's what the globe does to the
Fucking
mind.
just whack, man. People are like hitting their heads against a wall, and it's crazy, man. People driving, trying to get away from the cops. It's like, you got to be kidding me, man. Yeah.
It's harder to outrun the cops if you have to accidentally trip on a spinning object that's going 1,000 miles per hour.
Right. There you go.
It's easier to catch someone on a flat Earth because there's no, you don't have to trip on Earth curvature, or you don't have to fall because it's spinning.
Man, what a world, man.
I think DB Cooper, he landed in China because of the Coriolis effect. The rotation of the Earth. While he's falling out of the plane, the Earth spun, and he just landed in China, and they never found him.
Wait, I got a question. Your cop friend, you should ask your cop friend, when you do target practice for the police with your firearm, do you take into account the Coriolis spin?
No, he's not gonna take that in.
That's what you should ask him. You should, next time he comes in here, he's cop. Yeah,
that was another gambit today.
That was another gambit today, man.
The artillery gambit.
Yeah. You explained some artillery, how they would pinpoint how, raise or lower the barrel, basically, right?
Yeah.
And have spotters out there going, oh, no, man, you missed that to the left of,
Yeah, they have
about 100 yards.
Man. You don't just fire blindly into a city.
Mm-hmm.
They have people that can see where the fucking shells land.
Right.
And they go, okay, that one was too far. That one was too short, right?
Too left,
it's
too
called
right.
bracketing. There's a name for it. It's called bracketing. So they bracket the target, and then they walk artillery into it, either forward or back. Because there's an uncertainty to every round.
Yeah, when you said that they did this in World War II, I was like, I remember saying to myself, I'm like, I didn't know that. I didn't know that's how they did it. I wasn't sure. I mean, that makes total sense. It's totally logical. How else you get a target?
Well, let me guys ask you this question: when Tom Brady makes a throw to one of the other football players who's running to the end zone,
right?
Does he take into account the Earth curvature before he throws the ball?
No.
or the Earth spin?
It depends on whether the player's a flat earther or not.
Apparently, Neil deGrasse Tyson used that analogy for a field goal, extra point or field goal or kick or something. I don't know. And he was like, the reason he missed that field goal is because of the Earth spin. I did some quick calculations, and I was like,
no, that was the reason he got it in. It bounced off the upright and in because of the Earth's rotation under the ball.
It was in?
And that's how they won the Super Bowl.
That's right. That, the Super Bowl that he was at the Super Bowl.
When you throw a Hail Mary in a football game, you have to take account in the Coriolis spin whenever you throw a Hail Mary.
I love it. That's hilarious. That's why my golf game's all fucked up, man. I mean, I have not.
Yeah,
Next time I go golfing,
Tiger Woods takes the Coriolis.
I gotta bring a compass. Make sure if they're spinning this way or that way, I gotta. Yeah. I gotta adjust. Yeah, I gotta bring a compass with me.
Yeah, he tried to say that guy. He was like, it goes one way if you're in the southern hemisphere, and the other way if you're in the northern hemisphere.
Yeah, he was pulling something up on Google when he was doing that too. I could tell.
Well, I mean, he ended up posting something in the chat, which is just like, the typical, it isn't even like the official artillery manual, which is like FM 107 or something.
Right.
Field Manual 107. Now, all these artillery manuals don't all say some shit about Coriolis effect. But then when you actually look at it, they don't actually calculate it at all. It's just like, because they're not writing it, right? They've contracted somebody out. Hey, write, a manual for firing artillery. And they're like, okay, I'm a scientist. We got to put in Coriolis effect.
Right. We'll pay you $20,000. Write the manual. Oh, okay. We'll put in Coriolis and wind and direction and humidity. I'll bring in anything they whatever. And at the end of the day, man, you shoot the shit, it gets there. That's good, man.
Well, there's an uncertainty. Just like with a bullet, right? You have a pattern, right? You have a cluster.
Right.
Even if you had the gun fixed, right? Say you had a pod and that was in you had it you had a
cement.
Yeah, you could cement it. You could cement it into place.
Right.
And have identical bullets that you all made, loaded into the gun, and fire each round. They're not going to go through the same fucking hole. Okay?
No, they're not.
There's going to be a spread. There's going to be a random spread.
Yep.
Yeah, we got a globe earther, Yakko1X. Yakko1X, are you there?
Yakko.
Yakko,
check.
come on.
Yakko, check 1 2. Open your mic. Open your mic.
He's in the chat. He's talking smack in the chat.
Chat skanker.
He's also new to the server, so.
All right. We'll give him some slack.
Okay, never mind. Yeah, continue with what you're saying.
Yeah, that's a great point you bring up, Indio, is that you cement the goddamn gun into, there's no way it can move. It's totally aimed. You set up your target and you fire 10 bullets in there. You're lucky to get 2 that go through the same hole. You would be lucky. You know what I mean?
Yeah, and that cluster, right? It's going to have a size, right? So let's say it's freaking 3 inches. Right? It's like a 3-inch radius circle.
Okay.
You can't say for certain where the bullet's going to go. You know it's going to go somewhere in that circle, but you don't know exactly where.
Right.
Okay, that's the precision of the instrument, or the uncertainty.
Yeah, I mean,
okay? But hold on. The corrections that they're doing are 1/10 of the size of that circle. There's no point in doing the correction. It doesn't improve anything.
Yeah.
So you moved it around in the circle 1/10 of the circle size.
Right. Which is negligible, huh? So it might as well be 0.
Well, it doesn't improve it. It doesn't improve it. You still have the large uncertainty, right?
Yep. Yeah,
but think about you don't know where it's going to land within a foot, and your correction will adjust it a 1/4 inch. Fucking, you don't know where it's going to land within a foot. What the hell's your 1/4 inch going to do?
Right. Nothing. Not going to do anything.
Because that uncertainty isn't oh, now you know where it's going to go within 1 3/4 inches. No, it's still, you don't know within a foot. All you're doing is adjusting it within the uncertainty. That's it.
The fact that these Mongos still bring up Coriolis, man, just defies my brain. I'm like, dude, we were crushing that stuff back in 2015. I was talking to artillery guys, airline pilots. There's no Coriolis, bro. It's just not there. None of these guys use it. Not one of them.
It does drive me up the wall a little bit that we've been researching this, right? This topic for going on a decade now.
Yep.
And they think somehow they're going to go on Google or ChatGPT and somehow find information that we missed after 10 years. And they're going to find it. And then somehow they're going to show us something we didn't know, and that they're going to prove us wrong. in their 15-minute search. Like, it's crazy what they think sometimes.
Yeah, I mean, well, I don't know if
I searched for 15 minutes. Dude, I searched for 15 days. What are you talking about?
Fucking search for 10 years, man.
I'm just talking about one particular subject. Like Coriolis, I probably looked at time in hours, at least fucking 20 hours just on that. You know what I mean?
Oh, yeah. Absolutely. Exactly. But yeah, there's no, nobody accounts for that. It doesn't happen in reality. In the physical real world, no. Man. Well, keep going, guys. I appreciate you guys so much listening and learning. I'll be back. I'll participate more this summer.
Thanks, dude. I'm glad we're entertaining you. It's our goal, dude.
Oh, dude, it's so good, man. Every day I wake up smiling, going, "All right, what manga is going to bring up, Coriolis today, or the moon or something?" I'm like, okay, yeah. Yeah, you guys went into the moon today quite a bit. You were talking about
I looked at the sun and proved that the Earth is not flat.
All right.
Well, how'd you do that? Well, I looked at the sun again. Like, shut. Like, ugh.
You should go stare at the sun some more.
Yeah, exactly.
Yeah, go for it.
Right at noon, lie on your back, stare right at it.
Hey, I just had a quick question, AI Overlord. Just
now, let me ask you a question first. Let me ask you a question first.
Sure.
When are any of these guys going to talk about the actual Earth?
I don't know when they are.
Yeah, me neither. Go ahead with your question.
Yeah, so mine is a question about something I went out and did. I took photographs, so it's like an observational thing. And just wondering if you'd be interested for me to show you it and then ask you your opinion on it, or anyone in here to weigh in on it.
Oh, definitely. If you have real observations, they
Yeah.
trump all these
Yeah.
speculative nonsenses immediately, of course.
Yeah? Cool. All right. Is it cool if I share my screen, that kind of deal? Because it's like photos and things.
See, I think you can, but some people aren't going to be able to watch it. So if you post still shots of like the key points, that would be great.
Sure. Yeah, of course. Yep.
And especially if they're photos. If they're photos, please just share them.
100%. I've got raw DSLR Canon camera photos that I can share in the side chat there. Like once I've finished like talking about it. It shouldn't take, this will literally be like 5 minutes, not even. All right, I'll put my screen up. So this is basically, I'm from Brisbane in Australia, and I traveled down to the Gold Coast, and there is this headland called, basically the tip of it is called Snapper Rocks, and I took photos from 3 separate vantage points at Snapper Rocks and Rainbow Bay across this like bay. This see how the coastline scoops out here? All these photos were taken across that body of water over to a place called Broadwater Towers, which is right here. These towers right here. So basically what I was trying to do is see if with these different vantage points, if I could get different results, like and see and compare the results between the 3 photos. So I'll show you those photos right now and like where they were taken. So I'll open up this folder. This will help. Can you see the folder, by the way? Just checking. Yep. So the first photo is the first vantage point, which I call the beach vantage point. The camera is sitting basically 4 meters roughly above sea level. I got these measurements of elevation through Google Earth. I don't know if you're familiar with, if you hover your mouse over a part of Google Earth, down in the bottom right, it'll tell you the elevation of that point. So if you see, I'm holding my mouse here. It says 7 foot at the bottom right corner. So that's roughly. It's just an estimation of like where I took the photo. So that's 8 feet above sea level. All right. So that's the first vantage point on the beach. This is the second vantage point. See how it's elevated above where the beach would be. This is up under at the rocks. And then this is the third vantage point. This was a lookout. This is about 25 meters above sea level. So just to give you an idea, it's just here, like right there. There's like this little lookout. You can take photos, beautiful photos of the landscape. Anyway, the results of those photos are these shots right here. So now this was, I believe, this was down on the beach. So on the sand, the 4-meter elevation shot. This is Broadwater Towers, which are seemingly obscured by the horizon. Now this is a higher elevation shot. This is up on the rocks.
Well, hold on, brother.
Yep.
Gotta stop you right there.
Sure.
So the word seemingly obscured by the horizon.
Yeah. Okay. Well, okay. Let's. I'll take a step back. I won't say that. I'll just show you the shots, and you can tell me what's going on. But
well, that's fair.
The first shot. Yeah.
The reason why I put contention on that is because there's a little bit of loaded language in there, and sometimes when people are looking at an observation, whether it be something like this or even a person in the way they're sitting, they'll use language that describes what they know about or assume about the geometrical relationship, but it's not actually accurate to what they're seeing. And so, for example, in the arts, we do this exercise called "Tell me what you see, not what you know." Draw what you see, not what you know. And so people actually have to deconvert themselves from this charged language and the reason why we have to do this in the arts, especially with young children, is that they'll draw things based on things they know. So, for example, I know my arms are the same length. So when they start drawing a picture, they try to draw the arms the same length, and you have to tell them, no. Your arms are the same length physically, but they don't appear the same length depending on how you're looking at yourself. And that's called foreshortening or perspective effects that you have to add in. So there's a difference between how we see and what's actually going on.
That's a fair point. I totally agree. So I won't say that. I won't use any kind of like assumptive language about where I'm coming from or what I'm expecting where you guys are coming from. I'll just show it. I'll just show you what I got, the photos. So that's
fair. That's fair. But let's agree you could use some factual things about in this thing. So, for example, I'm going to assume, because I haven't zoomed in on the image, I just have it in small.
Sure. Yep.
For example, I might be able to tell that I can see the buildings, but I can't see the shore. So I could say to myself, for a fact, I can't see the shore in this image, and that would be an absolute truism, right?
Right. Yeah. No, that's fair. So basically, this is the photo, and I can give you the raw one. So this has been edited only by color, not by anything else, other than just for clarity's sake of where the buildings are. Here's the second photo, and then here's the third photo. So same set of buildings, 3 different vantage points, as I showed you on the map here. Like,
go back to that photo you just had, please. Go back to that one photo you just had.
Yep, this one. Yep.
Yeah. All right, good.
So these have been stacked and arranged so that basically the target of the photographs is somewhat equal in each photo. See how the target is the buildings? I've arranged them as such so that they are comparatively in the same spot in the photo, if that makes sense. You can see them stacked here on the left. You can see that they're all like they've been stacked, these photos. I'll put these are the raw images if I go back. This is the raw ones. See how the buildings are changing location on the photos? But I can put them in the side chat for people to check out
Yeah,
as
yeah.
well. Yeah.
Now we actually teach this too. So, for example, if you're going to frame an image and you want the image to appear as if you're looking down, you put the horizon high in the image. You want to appear like you're looking up, you put the horizon low in the image.
Right. So, so that's the first one. That's the sea level. This is the 8-meter elevation, the second one, and then the 27-meter elevation is the third one. And they should be uploading into the chat there. All right. So,
before you go any further,
Yeah,
did you already
sure.
say how far away the target building is?
Yes, it's roughly 18.5 miles, according to Google Earth. Yeah. So I was doing like a calculation because there's that, is it 8 inches per mile squared or per mile basically? So if I've got 18.64 miles, 18.64 miles times 8 inches, is that the calculation?
No, it's per mile squared. So you have to square the miles. So it'd be, if it's 18 miles, it'd be 18 times 18.
18 times 18. Oh, okay. So 18.
Or maybe I'm wrong, but it's 8 inches per mile squared. So however you have to do the square of the mile when you do it out.
Right. Okay. I think when you're talking about a vector, like just a line, you can disregard the squared part. Because if you're talking area of curvature, yes, but if you're talking about a line of curvature,
not square miles, miles squared. The first mile would be 8 inches. The second mile would be 64 inches.
Oh, right.
Because the curve, it's a curve away, a drop down.
Right. So I'm not great at the maths on that, like, but I understand that there is like this, there is a supposed or an apparent equation that's put forward by people that are explaining curvature, right? Of that 18 or 8 inches per mile squared. Yeah. Anyway, I was just going to ask you guys what your opinion is of why, in this comparison, I'll do it here like this, like why the buildings seem like you see more stuff when you get elevated above, like, you know, you're 27 meters higher up, whereas here you're 4 meters down on the surface, like on the beach, and everything seems obstructed. Or, you know, pardon me, like putting the word obstruction in there, but it just seems as though you see more stuff when you're 27 meters elevated. Is there something going on there, or?
That would also be true on a flat surface now.
Right. Like, so.
The more you get, the more you can see.
Right. Like, I mean, so you're saying if it is flat between the vantage point and the target being the buildings, I should see the same result or different results?
No, you are seeing the results. You are seeing the results, and it's flat between the coordinates.
Yeah.
However, the question you would then have is, well, how do you know that based on the image? And I'm not saying it based on the image. I'm saying it based on that you can actually just measure the water and find out the water's flat. And then you end up with the fact that this must be happening because the Earth is flat. Now, to be fair, if the Earth was a globe, right, which of course this is what this conversation is about. You're not just asking this in a vacuum, right? This is between flat Earth, globe Earth. So if the Earth was a globe, there'd be a hump of water in between you and that location. And you could do a curvature calculation, or you could do the circle segment formula, and then you could find out how high that arc is in between point A and point B. You can then get your observer height and the line of sight to see how much would be over the other side of the curve, so to speak. Now, the problem with those equations that I just mentioned, that's a geometric reality. So the size and hump of the curve is in a specific location relative to your position. So obviously it changes as you increase your altitude. Now, here's the problem. From the same altitude, you can observe variable effects in the location of the horizon and in the objects you can see. So, for example, this is 18 miles away. Now, we have observations of boats 30 miles away. Now, at 30 miles away, that boat would be down below 400 feet of off angle that it should not be able to be seen. There is no boat that's 400 feet tall. So if I can see a boat 400 feet away, 30 miles away, that should be below 400 feet, then that tells me that there's something optical going on and not something geometric. Because if it was geometry causing this, then it'd be happening at the exact same point every time, consistently. Now, not only that, not only can I see things beyond the alleged horizon would block, I can also see alleged quote unquote blockage before a horizon should even exist. For example, at my lake where I live, I take observations throughout the year. I've shared them here before, where it is only 1,014 feet wide where I take my observations. And I can observe the boat that's moored on the other side of the dock, on the other side of the lake. I can witness that disappear from the bottom up. I can witness that go into miraging effects, much like people show me with certain things depending on the day. And it has the exact same observations that happen at miles. And so if I know this observation can happen at short ranges, at 1,014 feet, when the horizon is not even supposed to be till like 3,000 feet, so obviously it's not the horizon causing it, and I know that I can see things beyond the alleged hump of blocking, then this puts this phenomenon in the optical category, not the geometric category. So my answer to why this is happening is because of optical reasons. And that might be multitude of factors. One is you have an angular field of view. You have an angular resolution limit to your angular field of view. And if the propagation angles of the light are lesser than the reception angles of your ability to resolve them, you're not going to see anything. Now, interestingly enough, if you're looking out across the horizon, the incoming light from that object is going to be below your angular resolution limit. And on top of that, you have perspective, which is causing things to decrease, and that's also a function of an angular field of view. Then you have atmospheric conditions added to that, right? Of which I think there's like 40 factors that have a confluence to result in what you finally see. Now, on the globe Earth side, the ubiquitous factor is that the Earth is curved. And as we already said, the Earth would have to be curved a different amount every day. Now, there is an excuse for this that globers will employ, and I have to be honest and tell you what it is, and that is that it doesn't matter how many close observations you have, how many supersedery long-distance observations you have that are beyond globe geometry, because even the globers appeal that it's not about geometry. It's actually about optics. So in other words, no matter what happens, the light travels to the observer in a manner in which it goes over the hump that's allegedly blocking the object. So even the globers have to appeal to the optical category to save their world. But we already all know this is optical. So then that begs the question. That begs the question: if the globers are claiming there's an underlying geometry necessarily proven by these photos, they have to prove that underlying geometry separately.
Yeah, I mean, I'm not trying to push like my opinion on what I think's happening. It's just like, oh, I just want to see who can unpack what they think's going on with these photos. That's all it was.
Yeah, no worries. I hope that answered your question at least somewhat.
Yeah, I just found it's pretty fascinating that, so see that little bit there, that is the top of a roller coaster at SeaWorld on the Gold Coast. Let me just go back here. I'll zoom in on it. It's basically this roller coaster right here. The 3D model of it looks a bit funky, but yeah, it's a roller coaster.
It looked like a sandcastle when you were first zooming in.
Right, yeah. This one looks a bit more like a roller coaster. Maybe it's that one, I'm not sure. But yeah, there's definitely a bunch of
real quick. Was that first roller coaster made of wood?
Good question. I'm gonna see if this will show up on like the street view. Of the it's like that. It's got a lot of like scaffolding, for lack of a better description. It looks like, support structure to it. But yeah, I'm not sure which one of the two is showing up in my photos, but it's either this one in the distance here or it's this one in this photo.
Well,
I
that
think it could
definitely.
be both. It could be
No,
both.
see the one on the left, bro. The one on the left that looks like a dark silhouette. That's the dense roller
Yeah,
coaster, and the one on the
that's
right
the
is
denser
the.
one.
Yep,
Is
and
the
the one
more
on the right is the other roller coaster.
yeah. But yeah, I mean, it's just it's starkingly different. You can see, you can see the trees, you can see almost the shoreline, you can see the roller coasters, and then and this is the elevated photo, and then if you get down to down to the sand on the beach, I can't see the roller coaster. I can only see like the top half of these buildings. So that kind of it impressed me. I was like, wow, that's something, I have had someone look at this and someone tried to suggest tides or swell, and I was like, nah, that can't be right, because a swell would have to go pretty high to obstruct that much, of the picture. But anyway,
nah.
You know what's
here's
crazy,
another
brother?
effect. Look at that.
You know
It's
what's
called
crazy?
shoaling. Hold on a second. Yeah. It's called shoaling. And when you have a bay, when the tide comes in, it piles the water up in the bay. So it wouldn't have to be elevated very much because it's so much closer to you. So like 1 kilometer, like something that's 1 meter, that's 1 kilometer away, will block 10 meters, 10 kilometers away. So it's really
I'm
closer.
gonna have to look
It doesn't
that up.
really have to be that much higher.
What was the word? Shoaling?
Shoaling, yeah. SHOALING.
Oh, okay. Well, I'm going to look that up. Appreciate
Now,
it.
depending on where it is, it's worse in some places than others. So some places where it's really bad, like Corpus Christi, Texas is one place I know about.
Yeah, especially if there's a shelf. So there's like a slow gradation from the shore, like hundreds of meters out, and then all of a sudden it steep shelves. So you have the bay, and then you also have the water forcing up when it hits the shelf, then going into the gradient of the slope of the bay. So that's even worse. And you can really see it if you maintain your altitude and do like a time lapse for an entire day. You'll witness the horizon between you and the other side like change throughout the day.
Right. Well, hey, thanks for letting me take the time to show all that. Appreciate it.
Let me bring something up.
Hey, brother.
Really, did he leave?
No, I'm here. I just put
okay.
screen
Let me
down.
bring up something that's really important about that image. Is the horizon itself. The horizon's not the edge of the earth. It's not where the curve starts. It's not the edge of a ball. It's none of those things. And we know this because you can go out and you can watch the horizon for, say, 6 hours and watch it move up and down, move further and away and closer, independent of the tides, just based upon the weather and the way things look. So we got observations of horizons that are, 10 times too far. Right? So if you went out like 3 days later, you might see the horizon in a completely different place.
I did
now, if the horizon's the edge of the Earth, then the Earth would have to be changing size, right? So you don't think that's happening, do you?
Oh no, well I don't know really what's happened, but
well, I mean, the Earth would have to change size, like physically.
Yeah, oh no, well I don't think that's
that's
happening.
where the curve of the Earth starts. I mean,
this will change the topic a little bit, but is it Italy or it was somewhere in the Alps or something? This lady took a photo, or just some photographer took a photo of apparently the longest distance between like their vantage point and
in France.
A mountain way distant. Is it France? Yeah.
Yeah, it's it's from the French Pyrenees to the French Alps.
Oh, okay.
So it's across the. It's from Canigou, and there's another one, Peak Finestro. It's a little further away than the Canigou Mountain, looking toward Marseille, toward the French Alps, across the. I think it's called the Gulf of Lyon or whatever. And there's a lot of photos of that area.
Yeah.
I think the first one that I've seen is from the 1800s. They have a really, really old one looking across. The one from the 1800s is looking the other way. It's like 127 miles or something.
Yeah. And I'd imagine
When you're talking
varying
about is
results.
443 kilometers.
Right, yeah, that's a hell of a way. Yeah.
Yeah, that's like from where I live in Boston, that's like from here to Toronto or something, which is Canada.
Yeah.
It's a long walk.
Oh, yeah.
If you look up the driving distance, it's a 10-hour drive. I mean, obviously because you're driving through mountains, but it's, it's still a 10-hour drive. It's far away. Now, the people that do those, it's the same. It's like a group of people. They had a website. It's switched a couple times. It's called Beyond Horizons. They're not flat earthers, but they go out to this area and take long distance photography. In this area, right? Sometimes they're like from Marseille the other way. Sometimes like there's also they do take pictures in Italy. So like the island of Corsica. What's the other one? What the hell's the other island out there? Starts with an M. I can't remember the name off the top of my head. Oh, Mellorca or something like that. Mallorca is the name of it.
Oh, Majorca. I think I've heard that name before. Yeah.
It's like out where Ibiza and all that stuff is. It's like the same area. That must be like the flattest part on Earth because there's a lot of like long distance imagery from that area of the world. Now, supposedly, it's debatable because it's so far away. There's a 308-mile picture. There's a lighthouse on Corsica called La Garglia, and someone thinks they caught that from I think it's what's the name of the town? There's a city out there. I have to look it up. Yeah, but there's some long ones. Yeah. You're gonna need some coffee. You're gonna need to make 2 pots of coffee for that drive. I think it's Barcelona. 308. I have to find it. But tests like that, like why they're important, I don't think they're like completely dispositive as to the issue. Yes, they shouldn't happen on the flat Earth, but like I said, there's the weather conditions can do weird things. Now, I don't think that they curve right around the ball. I don't think that. I don't think there's any justification for that. Real. 325. Is the picture still around? Come on, man. So you new to this topic, buddy?
Me, Rick? Not really. I sort of came in around 2 years ago, and then I haven't really revisited it since then. But yeah, popped back in just today to listen. But yeah, I try to keep an open mind. I don't really have any. I definitely believe what I see with my own eyes, and then obviously I followed a traditional education from the education system, so all of my views are like mostly what do you call it? Like the mainstream opinion is kind of where more toward what I lean, but I like hearing out alternative points of view. You know what I mean?
Yeah. When I first looked at Flat Earth, I looked at it initially for like a week, and then I just like stopped looking at it for probably like, I don't know, it had to be 6-8 months or something. But it was like just like eating away at my mind. It was just so weird.
Yeah.
So
yeah, I asked earlier whether the movement had been like growing bigger than each year, like as each year goes by, is the growth path like maintaining, or has it been slowing down, or has it been plateauing, or yeah?
It's this is like horizontal growth, not vertical growth.
Right. Yeah.
It's more like
steady.
permeating people's idea of what's possible or not.
Right.
Like in the beginning, so I've been doing this since like 2017. So in the beginning, people's reaction was one thing. Then after a few years, they would react a different way. Then a few years, like I'm just talking about normal people, right? That like people's reaction has changed over time. There was points in time where it was like people would get violently angry, and like, you know, telling them the Earth was flat was like saying you kicked their dog. But like, you know, before that, it was like the people that were really, really, most people just dismissed it without a thought and wouldn't even like consider it even for a second.
Right.
But the people that did engage with us were like violently opposed to it. But typically because they were like activist atheists. And they thought flat Earth was religious based. So they opposed it really for that reason. And then you have another group with like, you know, they're like pseudo science nerds. I'm not saying they're science nerds of they're like I'm not saying they're nerds of pseudoscience. I'm saying they pretend to be science nerds, but they don't actually know any science, right? They're kind of like you know, the fake smart kids that'll talk about, you know, the sun's 93 million miles away, and you know, black holes and blah blah blah, right? But they like
know
if
how
you
to
drill on
sound
them,
smart.
yeah, but if you drill down on them, they don't actually know anything,
right?
You know, so they would
They're
try
just
to
rehearsed, essentially.
Yeah, they know it
well
at a very
rehearsed.
surface level, kind of like almost in the Discovery Channel. I watched on the Discovery Channel about black holes from Neil deGrasse Tyson, so I know all
Here's an
about
opinion.
them.
Kind of like Greta Thunberg. She's a lot of people would say that she's just very well rehearsed with whatever she says.
Yeah,
that's if you're a critic of her. But yeah, wasn't there a point where I'm not saying this is all of the flat earthers out there, but you know, there's been different concepts and you know theories put on it. But there was one point where they were denying that Australia existed or the flat path.
That's
was that
joke.
ever a thing? That was never a thing. Okay.
No, it was a Reddit post.
Right.
It's like a Reddit
so it was
post
like
in
satire,
2015.
basically.
Yeah, it was someone just taking the piss in 2015. Being an ass.
Yeah.
And there's other things, right? Like flat earther tried to prove the Earth was flat and blew up in a rocket, right? Ever heard that one? Steam powered rocket guy.
I haven't heard that one.
Mad Mike. So there's a flat Earth conference. He wasn't even a flat earther. He was a globe earther. But because he, flew up in a rocket, he tried to get flat earthers to fund his rockets because he was like a amateur rocket maker. So he would go to the Flat Earth Conference and try to, I'll prove the Earth is flat, pay for my rocket. But he wasn't a flat earther. He was trying to use flat earthers to get money.
His project. Right.
Yeah. Because he was trying to make a steam-powered rocket, which is as stupid as it sounds. Needless to say, he flew up in a steam-powered rocket and didn't stick the landing. And now he's pushing up daisies with his dick, as they say. But for a while, I mean, we've had to deal with like so much like stupid stuff like that over and over and over and over again. Different gimmicks and LARPs and distractions and just beyond the curve and Jeranism paid $20,000 for a laser and like all sorts of shit.
Oh yeah, I remember hearing about that
and all that.
The point that I sort of bowed out and got, just busy with other things in my life, was the point where they went to Antarctica, that group. And I think, I saw that like Dave McKeegan was part of it. He's like a, he comes from the whole globe Earth guy. Yeah. And there's a few others that went on that trip.
Yeah, it's funny because when they came back, like the very first day, I put a thing on Twitter. It was like, okay, now that you went, you saw 24 Hours Sun. How does this prove a globe or disprove a flat Earth? That post is still sitting there. No one can say how it proves a globe or a flat Earth.
Right.
And even it's funny because Duffy, because they were told all this before they ever went. It's like you can't look at the sun and prove whether the Earth is a globe or flat. It's just not even possible as a matter of logic. I can't look at like your house and prove what my house is. I have to look at my house. Right? You can't. You can have inferences and say, well, I think if the Earth was a globe, the sun would do X, Y, Z, and it does X, Y, Z, so it's consistent with my idea. That's all you can say. You can't say it proves it. That's a whole nother thing.
All humans have spleens.
Who cares, dude?
Well, I mean, wait, if I look at one person's body...
We don't do medical advice. Just go on mute. Anyway, so it's very funny that in a debate, Will Duffy, the guy that ran the whole thing, someone brought up the sun, and he goes, this is a debate about flat Earth, not the sun. So even he admitted that the fucking sun can't prove the Earth is a globe. And he's the one who went there and hosted the whole thing, which is quite hilarious. He has all sorts of problems I'm not going to get into. But if you dig down into like, all they could ever disprove with that is some claim about the sun. If you think the sun is supposed to do X, and then you go see it do not X, then whatever reason you thought it did X is wrong, right? So. I mean, it was a waste of time because they could have just measured the curve, and that would have been that. Instead, they want to spend like I don't know what it was. To be honest, I'll tell you what the deal is, and I think he's still working on it. He was going to try to make a documentary out of it, and he had a plan on selling it, and nobody wants to buy it because it's boring. And Whitsitt said he wasn't going to go unless he had that nobody could film him, no one could quote his words, no one could do anything, and that he had complete control over any uses of his image or anything. So Whitsitt hasn't played ball with them. So it's like even if they accidentally catch him in footage, he has to pay like some frickin' penalty for using him. So I think
yeah.
I'm just saying is like I think Duffy's plan was this is an investment. I'm gonna go do this, and then I'm gonna sell a documentary to Netflix. Whatever. The final experiment, how I proved the Earth is a globe. He's still trying. He actually reared his ugly head. I don't know, was it a couple weeks ago?
Yeah, he was on. Melissa Daugherty is a not super famous but prolific Christian apologist to talk about flat Earth, and he actually made this claim that because of him, flat Earth is all but stopped debating the topic. Like the dude is literally delusional. Debates about flat Earth went up after what he did, not down.
Yeah, and then after that, he did some podcast where someone like presented him about evolution. So now he went. Not only did he like, I'm a globe believer. I also support evolution because he's a. Did you know this dude's a minister? So he's a minister. He's a preacher. Who actually said the Bible doesn't prohibit lobbying, which is crazy, but you can make it that way you want. I'm just saying this guy doesn't matter. He had an ulterior motive, and whatever that is, who cares? He made the observation. Doesn't matter. We told him it wouldn't matter anyway, and before he ever did it, it was a waste of time. I asked him, and he answered. I said, "How does this prove the Earth's a globe or the Earth isn't flat?" He said, "Okay, because the Earth has to be symmetric." Says who? And then he just ghosted.
Well, to be fair to him, he didn't say the Earth was simply. He said whatever's going on in the south. And so, for example, like trees, animals, which isn't the same in the north and the south. The south is different than the north. Kind of weird.
Yeah. But the symmetry that he's talking about is symmetric is the celestial sphere. Why does the Earth have to be symmetric? Why does it have to even be symmetric under the celestial sphere? Don't. And here's where it gets even more humorous. If you ask these guys, how is the 24-hour sun predicted in the first place? Oh, they use a globe to do that. That's what they'll tell you. They use a globe. But then when you look at the formulas, there ain't no globe in those formulas. There's the celestial sphere. There's that. But you're not on a globe. The entire model is you at the center of the coordinates, right? It's an observer-centric model. So the map itself doesn't even have a globe in it. Yeah, it gets it's silly. It's a waste of time. It's a complete waste of time. We're still wasting our time about it, talking about it. It doesn't prove anything. It can't prove anything other than things about the sun. You go to a place in Antarctica, stand at this place at this date. You'll see a 24-hour sun.
Hey, I just want to butt in and say it was nice to talk to y'all and meet y'all and everything.
All right. Yeah.
I'm brand new here, so I'm a bounce, and I just wanted to say bye and good to meet y'all.
Yeah, we're here all the time.
Thanks for coming by.
Yep. Bye.
So, India, the 24-hour sun thing it's not just that. It's that it goes different directions at the North Pole versus the South Pole. So it's a little bit more the way you claim.
Different directions relative to what?
Like at the South Pole, the sun makes a big circle around you, going from right to left. And then 6 months later at the North Pole, it makes a big circle around you going from left to right.
Okay. Dude, how do you know you're at the South Pole or North Pole?
Well, how about in the south and in the far south and in the far north?
You see how that's circular?
And well, I mean, you can tell where you're at, right?
Yeah,
well,
because you look at the sun and then you designate a spot. When I go to this spot and I see the sun do this, I'm at the South Pole. Yeah, if you didn't do that, if you didn't see the sun do that, you wouldn't be at the South Pole, right?
Yeah, you could just say
you couldn't tell from geography.
Yeah, that's true. Looks all snowy both places. How about this? And there's a place on Earth where the sun is up 24 hours going from left to right, and then 6 months later there's another place on Earth, a different place on Earth, where the sun is up 24 hours and goes the opposite direction.
Oh, that's fine. I have no problem with that.
Yeah.
But I don't think that was the exact. I don't think that was the exact claim from the final experiment. They were all basing this off an AE map that flat earthers were claiming and stating that there couldn't be a 24-hour sun because of the AE map and that the Antarctica was the ice that held that in. Yeah, so I don't believe they should have been claiming an AE map to start with, but yeah.
Well, I find that is intriguing that the sun would go, and they do show it, so it's going what, left to right. So is it still going east to west?
Pretty much saying, staying the same direction. If you're at the exact North Pole, everything is south, right? But so it's going left to right. The South Pole would be going from right to left.
Yes, it's going east to west, right? It doesn't stop going east to west. I don't think.
Well, yeah, right. But I mean, it's so close to the horizon, it's just more sort of staying in the same, going, east to west.
Hey, hey Matthew.
Hey, yeah, hold on, AI. I just thought of something I've been wanting to tell you.
Day. All right.
Have you heard of AI? Have you heard of Schrodinger's horizon?
I think so.
Yeah, it's like there's a geometric horizon until you go to look at it.
Oh, dang.
It's in a superposition of states.
I don't know, dude.
Depends on the argument you're making.
Yeah, true story. Some Glovers have basically went into that. If the Earth is flat, then reality is just one big giant. Who knows what the heck? Throw reality under the bus. Globe or die. Matthew, I want you to read the screenshot I just posted. You don't have to read it out loud, but just read it, and I just want you to tell me if you agree with it. And if you don't agree, are you willing to go on to Melissa Daughtry's channel and tell him that he's actually false result of his alleged nonsense?
Just to make sure I'm looking at the right thing, the thing you posted at 36 past the hour has like 2 people. It's like tiny.
Yeah, that's Melissa Daughtry and Will Duffy. Obviously, you know Will. Oh, well, he's looking at that, Indio. I think, man, I might not be able to remember this. We're having this conversation with somebody today in regards to their salvation. And I think I told them, okay, you guys think the Earth is a globe, and you need it, and things are supposed to not be seen, right? But then you need an excuse Well, what if the Earth's just flat, and when you see things, when things aren't seen, that's what's the excuse? Dang, I butchered it. Never mind. What about? Oh, optical conditions. Okay, so if you think the Earth is a globe, the geometric horizon's blocking everything, supposedly, but you can see all these things, and then you say it's optical. What if the Earth is flat and when you can't see? So the globe says when you can see. What if the Earth is just flat and when you can't see? Isn't that more reasonable?
You can only hear like half of what you said. Your audio's cutting out.
Dang it! All right, I quit.
Speaking of optics, though, is anybody here earlier? I was talking to some people about FE core and stuff like that.
Not me.
It's an interesting experiment. Seems a little odd that they talk so much about refraction in the beginning, and then essentially concluded there was zero refraction happening during the experiment.
It's almost as if it stayed in the same layer of air the whole time.
Yeah, a layer of air that is probably like ideal conditions to cause reflection. Like, it almost makes me wonder if like the experiment was explicitly designed to refract so that the laser would be visible from low altitude across the lake.
You're saying it was designed in a way to appear flat by knowing certain atmospheric conditions.
With well, I mean, using a cold lake seems like actually the ideal way to like apply Snell's law if you wanted to make the laser refract and literally curve, like frack the ground essentially at that height. As they actually show it with a laser at the beginning of the video, like how a laser can curve.
Well, that's a nifty thought and all, but there's several of these laser transit tests, and they all appear flat. Now, you want to talk about using Snell's law? That's for light traveling from two different indices. We're talking about a laser that is traveling in the same layer of air. Of course, there can be temperature changes throughout the track that can cause refraction. But it's not as if the laser is going through two different density mediums.
Right now, I think actually more accurately, it would need to be calculated in an integral, like over time, like over the distance, continuously, as opposed to simply once. Not sure why it was done that way.
Well, what model would you apply it to?
I mean, I think like using Snell's law probably makes sense, but
no,
just,
Snell's law. Snell's law.
An integral.
Snell's law is a discrete condition, right? It applies to a discrete condition, which is a boundary between two isotropic media of different refractive indices, right? So how could you possibly apply that to a condition which would be variable?
Right. So you'd have to actually measure at points along the way. Like they'd have to like it makes it really hard to do, I think, over water. Period.
Really? So let's say that's true. Well, how would they quote unquote calculate it?
Well, as close to an integral continuously as you can. So measure it, as many times as you can, and then essentially, as you said, apply it.
Well, no. Well, why do you need an
slabs at
integral
each
in the first
interval?
place?
I'm sorry, what?
Oh, sorry, I asked the wrong question. Go ahead.
Like apply it as if each measurement was a different slab of air, and do that as many times over as smallest interval possible over the distance, so that you could get like the closest to a continuous integral essentially across the whole distance.
Okay, that's interesting. How come they've never done that in the history of measurements using optical?
You're breaking up again, but I think you asked why it's never been done. It seems very hard to do. I don't know.
No. Hold on, friend. Not why it's never been done. Why has it never been done with the application of alleged globe measurements with optical methods?
I don't know. I think
I know why.
I think y'all's community is probably the only people trying to do these experiments.
Yeah, you're correct, brother. You are correct. The globers already assume the Earth is, and so they don't actually measure anything. They apply it to a model, which assumes curvilinear gradients in a curved atmosphere above a curved. So they're already begging the question from the get. And then after they apply their math, right, it accentuates the amount of alleged curvature that the path variability would be taking. Because here's how it works. They say, I already know the globe Earth geometry. I know that this observation can't be possible if the globe Earth geometry is constant. I can't change the geometry because, a geometric object is what it is. The only thing I can change and maintain the Earth being is the path of the light. And so I therefore, ex post hoc, change the path of the light in math or on a piece of paper. That's how it actually works.
Yeah, there's probably like a whole lot of ways you could go about experimenting, and I'm sure these experiments are not common in the scientific community, but you guys kind of engender that sort of exploration, which is interesting. But yeah, I'm not sure the FP core experiment is like a good example to point to. I think actually, like, if they were trying to create ideal conditions to refract and essentially curve the light so that it appeared at the same height over that distance, that's probably like where you would go.
Conditions?
What you would.
Okay, let's say that's true. What conditions would be necessary to allegedly around a radius of 3,000 expressed in an arc segment of 25 miles in length?
Yeah, so it seems to me that actually like laser experiments like that, from the research I did, it seems like over like anything over like 6 miles, it probably isn't a good medium to do your tests in, just because of the atmosphere. Like lasers in a vacuum.
Yeah, but keep in mind, right, true story. But you know what? You know what's common is lasers curving, not downwards. There's plenty of evidence of lasers curving. There's very specious evidence of lasers curving.
Yeah.
And not only that, what would be necessary for trajectory curved, quote unquote, redirected in the downwards direction in regards to the air that it's encountering?
I'm sorry, man. It's just hard to hear you because you're breaking up like in the middle of your
mic
sentences.
is shit, bro.
Dang it! I'm sorry. I'll listen. I'll self-flagellate as remuneration and penance. Okay.
Okay. Very Leviatharian of you.
I'm glad you noticed.
Yeah. I was looking into like real world easy things to observe that would be kind of a good test, like mental test for this sort of stuff. And like I think the easiest one I can think of is like star trail photography. Like when you put like a time lapse photo of stars, like on your phone or whatever, you don't even need like a telescope. If you're in the northern hemisphere, there's a circle around Polaris, and there's no visible center of the circle in the south sky. And if you're in the southern hemisphere, there's a visible circle around essentially the South Pole, and you can't see Polaris in the North sky. And I'm not sure how flat earthers would argue that works if we're not on a globe.
Well, I just got through this with the other guy. There's a lot of loaded assumptions, mixing worldviews. So you're basically asking, how does the globe work if the Earth is flat? Which is incoherent.
I know I'm saying, how does star trail photography only show one circle, like one center of a circle in the sky, if we are not on a globe?
What?
He's saying we'd see the same stars on the northern and southern hemisphere if we were on a flat plane.
Why? Why would
Yeah, we wouldn't see.
No. Hold on, bro.
We wouldn't see only one circle of star trails, and then the other circle without
It wouldn't
a center.
change. There wouldn't be.
Why not? Why not?
Because when you breach past the equator, you're no longer able to see Polaris. And that's not a vanishing point. Like if you draw, it's not like a vanishing point thing. Like you guys have posted the street light thing for me before. But essentially, like there's a circle with a center in the sky with Polaris in the center of that circle. If you do
there what appears to be a center of rotation. Got it.
Yeah. And then when you look at the south sky in the north hemisphere, you cannot see the center of a circle. But when you are like as you go from the north hemisphere to the south hemisphere, like you can just see this. Like people all over just do star photography. They do time lapses and showed star trails.
Yep.
There's no center of the circle in the north sky when you're in the southern hemisphere. There's only a center of the circle in the south sky in the southern hemisphere.
Yep, and I'm still waiting for the part where.
Well, I mean, I already asked the question: how would flat earthers explain that works if we're not on a globe?
So you're asking basically, how can a flat Earth have 2 points of rotation? Am I correct?
2 points of rotation.
Well, yeah, you're sort of saying, well, when we're in the south, we see this point of rotation, and when we're in the north, we see this point of rotation, but you can't see either.
I would say we only observe one. I would say we only kind of observe one axis of rotation either way, and that one end of that axis is not visible when you're on either end of the when you're on either hemisphere and not like directly on the equator. Like when you're directly on the equator, essentially you can see it almost looks like the stars go like east to west almost perfectly. You see like a half circle on the north sky and a half circle on the south sky.
Which is natural when you're standing on opposite sides or almost opposite sides of a rotating sphere, not a rotating disc.
Oh my goodness, dude! I'm so glad that you put vision sphere. So we.
I mean, I feel like nobody else understood that.
Hold on, did you just use circular reasoning, thinking that you dunked?
No, I'm just trying to explain.
Pretty much.
It seems like nobody can understand it.
We understand it.
You don't even understand what you did.
Yeah, okay.
We've seen this dunk contest before.
It's not a
dunk contest. I'm actually just trying to like ask how flat earthers would explain this phenomenon.
And there's no explanation from the other side. What's the mechanism?
Prove to me the Earth is flat.
Let's not devolve.
Who wants to prove it?
Let's not devolve.
I used to believe the firmament cosmology.
Anyway, who was actually asking the question legitimately?
You muted the wrong guy, you dumbass.
You're right. I should have
No,
muted
it
you.
was the correct guy. It was the guy with wings.
Idiot.
It was the guy with the wings.
Why would I mute?
Oh, he's gonna melt down. This is great.
Yeah, whatever, dude.
Circular
Yeah,
reasoning
whatever.
guy.
Hey, hold on, old. I'm just here to help clarify because it didn't seem you guys understood what we meant. Oh, flat earthers are the biggest losers on the face of the planet. Oh yeah, your true colors came out real quick.
Yeah, that mask fell off quick. So let's back to Muffuggin. You seem to be able to keep it together. Your buddy really flamed out there, huh?
Oh, who muted Muffuggin, man? It was legit. Hey, who muted him after he got unmuted? Hey.
What is happening?
Listen, dude, my mute shotgun like shoots out 70,000. No, I can't help who gets hit.
Oh my gosh.
Okay, what assumptions are necessary that the star trails can only happen if it's growth?
So we see the star trails, and I mean, what assumption?
Stars making circles?
Yeah, stars making circles.
No, they're not.
Well, I mean, it's something you can do with like a time lapse photograph in your backyard.
Okay,
and
yeah.
Anybody can do this, and people.
Yeah,
do this
that's
all the time.
awesome. That's awesome. But they're not making circles. You see the trails from some stars going to the trails of other stars, and that makes them look like circles. But the stars themselves ain't making circles, and they couldn't in the heliocentric model because of the shut up, because of the orbit.
Oh my God.
Processes the seasons, so they would make spirals.
Okay.
Yeah, that's right. So the Big Dipper is handled points from a different direction as the year goes on around to Polaris.
I'm just talking
How
about
does
one
that
night.
change position if they go in circles?
I'm just talking about one night.
Even in one night, you're going to miss a circle by 1/365th of a circle.
Okay. So star trails appear circular when you do a photograph during one night, right?
No.
Well, I mean, there's plenty
He doesn't
of imagery.
realize.
No, there isn't. Don't make
he
shit
was
up.
connecting
The longest time lapse that exists of star trails is 14 hours. You need a 24-hour one. Okay? And you would miss
star trail would only be possible in a place like where there's no sun during the daytime, right?
And I told you it would miss by 365th of a circle. It wouldn't line up. It wouldn't form a circle.
I see what you're saying. And I'm not saying that they're perfectly circular. I hope I didn't give that impression. I was just saying that they appear circular.
Yeah, because they go into other star trails. They go into the trails of other stars.
Exactly. I know what you're saying. I'm not trying to disagree with you. But when you're in the northern hemisphere, you only see the center of one such circle. You don't see the center of the other circle. Do you know what I mean?
You don't see the circle of any circle. There's no circle. You don't have a circle.
It's not a
You have the stars taking a bunch of arcs.
But we agree
those
they're
arcs
circular.
overlap, and because you're looking at a shortened view of what they're doing, to you in your temporary slice of time, they're going to look like circles. But they're not actually making circles. You're just perceiving them that way. If you watched longer, they wouldn't be circles.
I agree. But they appear to be circular in fashion, right?
Yep, but they're not circling anything. Meaning they're not equidistant from a single point, dude.
Sure. They're not perfect circles. There's no like direct point that you could point to that is like the center point of the circle. Like this image as an example that I just posted inside chat. They're not perfectly circular. They're obviously a little they're ovular, and but there is like a point that you could say that is less spinning than the rest of the image in the center of that kind of circular
Nothing
pattern.
is spinning,
right?
bro. Nothing is spinning.
Can I?
You're breaking up hard, AJ.
No. No. Okay.
It's a little tough.
So this is the issue. You're trying to use your explanation as a description. You don't see circles, okay? You don't see rotation. Nothing's rotating. If you drew an arc on a sheet of paper, even if you drew a circle on a sheet of paper, you wouldn't call that a rotation. You're trying to insert your explanation as the description of what you see.
I mean, if I had a compass and I rotate a pencil on one end of the compass, it creates an arc, which is very similar to what you see in this image.
That's what you're asserting. You're asserting that's how it's done.
Oh, I mean, this is just a time-lapse photograph that anybody can do in their backyard right now with their cell phone.
That's fine, but you're asserting you know what causes it. Do you understand? Just like you just used the compass example to say, hey, I can cause an arc to happen if I rotate a compass. Okay, how do you know that's what's causing this?
What's causing what? The image?
Yeah, the image, dude. The circles.
So the stars do move in the sky over time.
That's right. That's right.
And this is simply like a long exposure shot.
What's the cause?
What's the cause of the stars
What's
moving
the cause
in
of
the
the
sky?
stars tracing arcs in the sky?
I don't know, and actually, I'm not sure that's a. Or,
well, you gave us what
I
you
might
think the
know,
cause is.
even
You
if
think
I
there's a
know
rotation.
exactly, or if I think I know exactly. I'm not sure that's important to the argument.
You gave
I'm
us
making.
what
In
you
fact,
thought.
I think it's
You
not
already gave
important.
us what you thought.
I think
You
it's
gave
not
us what you
important to
thought.
the argument.
You gave us what you thought.
Well,
You
why'd you
said
bring it up
rotation.
then?
You gave us what you thought it is. You said, we see the stars rotate. That is your explanation. That is your cause.
Oh, no, that's not a cause. That's an effect.
Oh, yeah. So you see the stars rotate.
Right.
Spit it out.
We see the stars appear to rotate and create a circular pattern.
They're not rotating, dude. In no definition of the word rotating or rotate are they rotating. Even in your picture, you take the star in the center, right? You can see this time lapse isn't even 12 hours. You can see it's like a 10-hour arc.
Right.
And they look like circles because they're going into the arcs of other stars.
So how do you define arc?
A curved line, an arc.
Right. Well, I mean, it's also a segment of a circle, right?
Yeah, it can be. Yeah.
Yeah. So these
you
are
said these
segments of
weren't
circles we're
circles.
seeing.
Look, they're not circles. They're pure
Well,
circles
you called
because
them
they're
arcs.
overlapping. Yeah, I said to you because you have a temporary viewpoint. That's a segment in time, right? So it's a brief segment of time, and the star trails are overlapping into other star trails. They appear as circles. But if you look at any individual star, they're taking an arc. That star itself isn't going in a circle. And any individual star would never go in a circle in your worldview. They would spiral across the sky.
Over a long
because of the
period
orbit.
time, yes.
Okay. So when you say rotate, what's rotating?
In this example, I'm treating the sky as a 2D image.
Okay, what's rotating?
He won't answer because
what's rotating is the image of the star, the light of the star.
He's rotating the camera?
No, is rotating around Polaris if you're in the northern hemisphere.
They're rotating around Polaris.
Yeah, the image of the star. Not the star itself.
Look,
just
at
the
best
image
you
of
could
it
say
as
they're
we see
circling
it
Polaris.
in the sky.
That's not the definition of rotation.
I am
if you walked
being
around your
a
house,
little bit.
if
Yeah,
you
I mean,
walked around your house in a
listen,
circle,
I feel like
you
we're
wouldn't say
having
you
like this
rotated your
really
house.
deep, like epistemic, like discussion about
It's
what
not
rotation
epistemic, dude.
means. But like,
No,
I'm just trying
it
to
is
like
important.
have you look at this image.
Yeah, and I'm not going to have you insert your
understand.
fucking explanation as the description.
Motherfucking, why are you afraid to say that you believe this is caused by the Earth spinning? Why are you so afraid to say that?
Or the sky spinning?
Yeah, because
I'm not afraid to say that. I'm not afraid to say that that's what I think is happening, but I don't think it's important to the question I'm asking.
No, I feel like the question is a little bit lost now. We've sort of lost track, but that's what I was going to try and simplify it maybe earlier because I was a bit lost as well. But okay, I know that the conversations that's occurred, your point was that you believe that these stars are rotating around in the north around Polaris. Your question basically was, why don't we see Polaris from the south? Because you were saying, why don't we see that central point in the north from the south? And then you were saying, why don't we see a central point from the south to the north? Yeah?
Yeah, exactly. And the vanishing point argument doesn't really apply because it's further down, as you guys would say. It's further down than the vanishing point where Polaris should be if you're in the southern hemisphere, especially if you're in the deep southern hemisphere.
You know that.
So the question is, why can't we see
ahead,
Polaris from the south?
Sorry, what was that? I think you guys talked at the same time.
Let AJ go.
Oh, I was saying, so basically your question is, why don't we see Polaris from the south and why don't we see Sigma Octavis from the north? And I think you actually answered your own question when you said that another flat earther had given you an image of perspective and angular resolution to a streetlight.
Yeah, the vanishing point argument. And I was just saying I don't think that applies because the center of the circle, the Polaris kind of point, would be far below what you guys consider to be any vanishing point if you're in the deep southern hemisphere.
You mean below? Below what?
Well, you guys say that things get smaller and go down, right? That's how you describe
they
the
appear to go
vanishing
down.
point thing, right?
Appear to go down, but the vanishing point, you don't go under the vanishing point.
Right, Polaris, in my example, Polaris goes far beyond the vanishing point.
Says who?
It's simply observable in all the star shell photography that's out there in the internet.
So it's simply observable that Polaris goes far beyond the vanishing point.
Yes.
Okay. Describe exactly what you observed to see that. Exactly.
The arcs.
No, the vanishing point. Polaris. You said it would be far under.
Yes.
Okay, we need you to substantiate that.
The arcs are a part of a circle, right? An arc is a part of a circle. That means that the circle is has a center, right? So what I'm saying is, to point to the vanishing point in your model would mean to point towards the horizon in my model. But to point to Polaris when you're in the southern hemisphere, the deep southern hemisphere, would require you pointing to the center of a circle that makes these arcs that's far below the vanishing point.
Says who?
Yeah, listen, real quick, bro. You're mixing the world models, okay? You're literally committing
I'm using one to talk about the other because, yeah. I mean, the argument applies, like the vanishing point argument only really applies, I think, to the flat Earth model. I'm trying to talk in y'all's language.
Listen, if the Earth, doesn't matter what the shape of the Earth is, you still don't have an infinite resolving field. Okay, that's just a fact. It doesn't matter.
You have an infinite what?
Resolving power.
Oh,
okay.
You mean like
so the
resolution of a
whole
camera?
reason. No, not even. Resolution of a camera is in the.
I just don't know what you mean by resolving
saturation.
Power, sorry.
Right. So you have an angular.
Regular criterion.
I'm sorry. What criterion? Hit me with
the
the
Rayleigh
layman's term.
criterion.
Hit me with the layman's term. I'll be honest.
The inability to distinguish 2 points of light. You know how a car is like very far away? It's got 2 headlights, but they look like 1 headlight.
Oh, I see. Okay.
Okay, so that.
Yeah. I think
you have to be able to distinguish You have to be able to distinguish the stars from the horizon, and actually be able to distinguish as unique objects or unique visual features. When the angle between them is too small, it's impossible.
I think I chose a good argument then, because I think this kind of avoids that problem.
The problem's unavoidable. It's a physical limitation of the wavelength of light. I don't know what you're talking about.
Not of the question I'm posing, though. We really have to distinguish individual points to be able to see that the center of the circle that makes an arc is below the vanishing point.
Yeah, but that's fair. But you're only really below. Hey, let me ask you this, friend. Do you think the streetlights go below the street?
No, which is precisely why I think this is an important question I'm asking.
Right. So a literal light, right, affixed to a pole. When you look down the street, poles get shorter and the light approaches the ground. Now, if you had an infinite street that you look at, eventually the lights themselves wouldn't, and eventually you wouldn't even be able to see that.
Which is why I'm not talking about the Polaris itself. I'm talking about kind of its position based on the arc. I'm not saying you can see or can't see, like Polaris.
Right. Yeah. Right. So you're creating a geometric relationship in 3D space for this alleged arcs relative to Polaris, dude. When all you have is apparent locations in your field of view. So you're mixing categories. You're mixing visual spatial field with the 3-dimensional geometry. You're making a category error.
I am simplifying from 3D to 2D, I know.
No.
It is a simple fact. It is a simple fact that you can't see
it's a straw
the
man,
center.
dude. Straw man. You don't understand. You don't understand what you don't understand. You're mixing Euclidean geometry with projective geometry. That's your problem.
Wish I was better versed in geometry.
Then why are you making a geometric argument?
I'm just saying I observe this phenomenon.
But real quick.
And this phenomenon is easily observable, and it doesn't seem to match a flat Earth model.
What phenomenon?
The Polaris, star trails made by the Polaris end of the sky are not visible in the southern hemisphere.
How far? There is no southern hemisphere. You need a sphere for that.
In my model, right? So this is tough because I want to talk about particular latitudes. But how do I say that to you
don't
guys?
really know anything, do you? Okay.
I really don't. I'm just talking about a phenomenon that
this is the first problem you're making. You're positioning yourself on Earth using latitude, longitude, North Pole, South Pole, things like that. Those are the celestial sphere. They are not the Earth.
So
they are not the Earth. You understand what that means?
I do understand you guys don't agree.
You can't be on the equator. You're under the equator.
How do we talk about locations with
You said latitude. Did you not just say latitude?
Yes, I did.
Did you not say North Pole? Where's the North Pole? Listen, let me ask you this. How do I know when I'm at the North Pole? What do I look for?
Well, I'd venture to guess Polaris would be directly
above. I look at the stars, not the Earth?
Kind of hard to look at the Earth and determine your location. Kind of hard. I mean, that's why sailors use sextants.
Yeah, so I can't find the North Pole using the Earth.
Maybe there's a way to do it magnetically. I'm not sure, actually.
No, you can't, because the whole coordinate system is based upon the sky. So when you say,
here's my question.
No, listen, dude.
How do we discuss locations on this Earth together?
Because you said when I go to the south. Because what you said when I go to the southern hemisphere, I can't see Polaris. But if you define southern hemisphere as when I don't see Polaris. What does that mean?
I see what you're saying. So maybe I just say Australia then.
Okay. And what does Polaris look like from Australia? Can't see it. What do the stars look like? Do they appear to be circling Polaris? No. They look like they're, if you look south from Australia, you're just going like basically almost left to right across the sky.
Well, no, if you're an Australian and look in the southern sky, you do see a circle in your star trails.
If you look south. I'm talking about if you look north.
And if you look north, you see star trails, and they appear to center on a point that is below the vanishing point.
No, they don't. You can't see it from that point of view.
But you can
can't
see
it from that location. No, you don't. You're just making shit up. Bro, there's plenty of images on the internet of star trails from the equator, star trails from the so-called northern hemisphere, star trails from the southern hemisphere, and the arcs they take across the sky. Okay? The arcs they take in the south don't arc around Polaris.
What do they arc around?
Behind you. South.
Nice job, burning away old.
You're saying they all arc, but you're saying in the northern hemisphere they arc around Polaris?
Yeah.
So
and at the equator, it appears to go straight left to right.
You're saying then that somebody on the equator, or can I say that? Can I say equator?
Under the equator.
Central Africa, could be looking at a star that both someone in the northern hemisphere and the southern hemisphere could also be looking at.
You don't have a hemisphere, dude.
Okay, sorry. That someone in North America and Australia could also be looking at the same time, and it would arc around what? It would arc around Polaris for the person in the North America, and the person in South America, the person in Australia would see it arcing around the opposite.
Yeah, they would look in the sky, and that's what they would see.
So okay. I see what you're saying.
Now, you're taking a leap of logic and saying, hey, because I see the stars do these things, that means the Earth is the sphere. You understand? That there's not a celestial sphere.
I'm actually not saying that at all. I'm just asking how flat earthers explain the phenomenon.
There's nothing to explain. Well, I mean, you can't even state what you see accurately without trying to insert your explanation as a description.
I feel like I've explained it very plainly.
Well, no, you tried to skip over the part where you actually have to explain it and just insert your explanation into the description and say, yeah, this is what we observe, as if your explanation is the evidence for the explanation. No, you have a hypothesis on what creates these arcs. Okay? These arcs are caused because I'm on a big ball, that ball's spinning. And when I look up, I see the stars do this, that, and the other.
And what is your explanation for these arcs?
I don't have an explanation because I don't care.
Well, if you don't care...
Because they have nothing to do with the shape of the Earth. And nothing about them can prove the shape of the Earth.
I would say that they get closer to proving the shape of the Earth than having no bearing on it.
It's literally impossible to prove the shape of the Earth looking at the stars. It's not just... It's logically impossible.
Really?
Yes. Oh, yeah, it is. Sure is. Matter of logic, it's impossible.
And why is that?
Because it would be an inductive inference.
I had a gentleman in here earlier.
In which, listen, all inductive inferences contain the logical fallacy of affirming the consequent. Okay? If P, then Q, Q, therefore P. That doesn't exclude all other explanations. There's an infinite number of possible mathematical models for any arbitrary data set. And in fact, that model, the mathematical model used to predict star trails, sunrise, sunset, all these things doesn't even use a globe in the first place. See, you have an explanation. So you have an explanation, but the description doesn't match the explanation.
This isn't a room where you guys say that we can't make a determination. This is a room where you guys say
by
there is
measuring the
no
Earth.
curvature.
That's right. You measure the Earth, there's no curvature.
So then, using your model, explain the arcs and how they're observed.
I'm not using a model. I'm using measurements.
Look,
I'm not
use
going
your
into it.
measurements.
I'm not going into
I can
abstract.
explain it. I can explain it. So simple. It's so obvious, dude. So what do you want me to explain again real quick? Just so
Oh shit, that was
funny.
funny.
You to explain why the stars look like they do X, Y, and Z if the Earth is flat.
Okay, so let me explain it. The Earth is flat. The stars appear to do something because the stars are moving. There you go.
Oh man.
Wow, that was so hard. Wow, that was easy, bro.
Look, listen, brother.
So
we could make
deeply
up
unserious.
we can make up any explanation, and we'd have the same evidence you have for your explanation. Not a fucking thing.
Let me go again. Let me take another try. Hold on. 3 strikes you're out. Okay, come on. All right.
Why is it
The
always
stars. Hold on, brother. The stars are an 11-dimensional manifold
That's a good
of a
question,
sentient
man.
agent singing
Let's
into
ask
the
a
ether.
question.
There you go.
Did you hear his explanation?
No, sorry. Go for that again.
The stars are on an 11-dimensional manifold.
Oh boy.
What? It's an explanation.
Yeah, if they were on an 11-dimensional manifold, look like they make circles in the sky, 2 different points of rotation depending on the observer-dependent location relative to the axis. I know that's true because they look different depending on where you go on the Earth. Therefore, the stars are an 11th-dimensional manifold. See?
Who's like the Jesus of flat Earth? Who's like
You
the
didn't- you
who's like
didn't-
the
you
Neil
didn't even-
deGrasse Tyson of flat Earth? I want to talk to them.
Repeat back just what AI just said. Because AI just illustrated why your whole nonsense is just bunk. He used the same method to prove that the stars are in an 11-dimensional manifold. He used the same logic you do.
What is an
And you
11th-dimensional manifold?
It's one more than a 10-dimensional manifold. Duh. Holy crap.
This is like so deeply unserious. I really would like.
No,
who's
it
the
is
Neil
serious.
deGrasse Tyson of
It is
flat
serious.
Earth?
No,
Who is
the
he?
funny thing is,
Who is she? Who are they?
Listen, the thing that I know
Bragmont.
what's funny is that you think using sound logic is unserious.
You think that my question earlier is on the equal footing of saying, okay, stars 11th dimension manifold. What is the 11th
No,
dimension
your
manifold?
rationale.
It's one more than a 10th
No.
dimensional manifold.
Your rationale for reaching the conclusion that the Earth is rotating or the stars look a certain way because the Earth is a globe is the same logical structure as the one he just used. It's affirming the consequence.
I haven't affirmed. I'm just asking a question, like how you guys explain this given your model. That's literally it.
He just did explain it.
Okay. Let me try and make it even
You
simpler
don't get
for
it,
you, 'cause
dude.
I feel like you really
Explanations are useless. I could come up with any fucking explanation. It doesn't matter. I could make up anything.
I'm not sure that that's the own that you think it is. I think it's more of a cell phone.
No, it is the own because it's showing you the flaw in your logic for reaching the conclusion that the Earth is a spinning ball.
You're basically doing
you're
like
using the
sophistry.
same
You're basically saying like, hey, guess what? No argument's ever going to be good enough.
No, I agree with you. Listen, I agree with you
that
that India
methodology, inductive, that inductive methodology can't prove anything. And it's well known, it's been known for 1,000 years.
True story. And now, listen, I'll critique Indio that he did do a cell phone, but he was doing a cell phone to show you that that applies to you as well. So that all of the selves get owned. They use that type of reasoning. That includes yourself, sir.
So to summarize the conversation, I said, hey,
yeah,
this doesn't make sense to me given your model. and
It
then you
doesn't
guys
make
said
sense to me. That's
no
your criteria.
explanation can ever be an
What
explanation.
model? No, hold on,
hang on.
brother. Hold on.
Who
Go ahead,
presented a
AJ.
model? Who here has presented a flat Earth model? I believe
You don't even have a
the
model.
model you're
Yeah,
referring
you guys
to
say no
is the
curvature.
model. Hang on, the model
It's not
you're
a model.
referring to is the model in your own head. Yeah.
You guys say vanishing point. You guys say
It's
no
not a model.
curvature.
Those aren't models. The
So-
vanishing point exists because the 3D world is projected onto the 2D surface.
To what model do you guys believe in?
None. We believe in reality. We haven't abstracted reality away.
If you've abstracted reality away, then how can
We
you
have not.
say
You have.
I have?
With Guffin,
Dude,
if you want to
couldn't even
empty your
describe
mind,
what you saw, dude.
true story. You'd fail my art test, which is draw what you see, not what you know. Then you'd have to get remediated art classes. But anyway, with Guffin,
I would
empty your
simply
mind.
take a picture of star trails with a lapse of photography.
Yeah, and then you
Yeah, we
call them
know.
circles.
Yep.
And you would call them rotating circles like a retard.
So I want you to pause for a second. I'll tell you the closest thing to a flat Earth you're ever going to get.
I really
if you
thought we
want
were
me to
going to
tell
have
you.
like a good conversation here.
No, I'll tell you, brother. I'm trying to tell you the flat Earth model, but you for some reason everybody.
Okay. What
Especially
you have a
you
blind
guys
spot
believe
for your
in?
own behavior, McFuggin. You have a huge
I know.
blind spot.
We all have blind spots. That's what I was trying to
Yeah,
ask.
well, I pointed out your blind spot, and you're being willfully ignorant. Okay, I pointed out like a dozen times. You're using faulty logic to reach conclusions. You are so in the abstract and in fantasy world, you think explanations
I haven't
are
reached any
descriptions.
conclusions. I came here with a question, not a conclusion.
Then why did you say you see stars rotating in circles around a central point when that's not what you see? That's not an accurate description of what you see. And you still think that. You still think you see that. Not realizing that you inserted
Do you
your
not see that?
causal mechanism. No, in your mind, in your imagination, that's why you think it happens. But that's not what you see with your fucking eyes. You understand? There's a difference in what you see. So I'll give you an example. This is a perfect illustration. Have you seen a solar eclipse?
Yeah.
Yes.
Did you see the moon go in front of the sun?
Yeah.
Yes.
Are you sure about that?
Yes.
Okay. You can't see the moon during a solar eclipse. It's a new moon. So there you go. You just inserted your explanation as a description of what you saw with your eyes. You didn't see a moon. The moon is the explanation on why you saw what you saw. You guys are so far gone, you don't even realize that you're doing this.
I know.
You know what's funny, Indio? If I asked
Now
them,
tell me
if I
again
asked
that
them
you
to
saw
draw,
the moon. Hold on, I want this guy. Did you see the moon during the solar
about
eclipse?
it, dude?
Did you see a moon during the solar eclipse? Yes or no?
Yes.
I
You
saw
saw
a
a
black
new moon.
dot. I saw a black dot.
You
okay?
saw
I
a new moon.
I saw a black dot. That's
You
all
saw
I
a new moon.
All I saw was a black dot.
Did you see a new moon? Yes or no?
I saw a black dot go in front of a white dot, and then it got dark around me. That's what I saw.
Okay, but you didn't see the moon.
No, I don't know what I saw. I saw a black dot go in front of a white dot. It got dark around me.
That's not what happened. You made all that up. But you're going to double down and say you saw the moon?
No, I'm going to say
solar
that I saw a
eclipses
black
only
dot
happen.
go in front of a white dot, and then it got dark around me.
Solar
I have a
eclipses
video
only
of it.
happen.
I have a video of me.
Yeah,
I
solar
went to
eclipses-
Tennessee, like it was like fucking
That's
7 or 8
great.
years
You can
ago.
have a video or whatever. You didn't see the moon.
I saw a black dot go in front of a white dot,
That's
and then it got dark
fantastic.
around me.
That's great, but you didn't see the moon.
Okay, what did I see?
You saw the moon
It
block.
doesn't matter.
Doesn't
You
matter.
didn't see the moon.
Doesn't matter.
Well, you didn't see the moon.
What if I did?
Well, that means you'd be seeing in fucking ultraviolet.
Let me ask you a question. You're standing in front of a really, really bright, blinding light, and I see your silhouette. Does that mean I didn't see you?
Well, it depends if you saw me before the silhouette happened. You
He
can't
he opened
see.
his eyes while you were in front of the bright light.
It's a new moon. Do you know what that is?
It's a black dot?
No, dude. A new moon. The moon's not fucking visible. Are you guys stupid or something?
Yeah.
No, I would like to be able to debate though without yelling.
No,
at
seriously,
each other
you
and
get
being
stupid.
aggressive.
Well, there is, and you say, oh, yeah, you're comparing someone standing in front of a lamp and asking for a silhouette. Well, at the beginning of a solar eclipse, there is no silhouette of the moon. There's like a black thumbnail that enters into the sun. There is no object creating a silhouette. If the sun's shining behind it, right, you say?
And the months leading up to a solar eclipse, you can see the positioning of the moon in the sky, working its way closer and closer to the sun.
Yeah, that's horseshit. You're making that up. You're making that up.
No, I'm not.
Yeah, you are making up because I'll show a video. I'll post
Why you
a
gotta
video
yell
right
at
now.
me?
Look, because you're making shit up, and I hate that shit.
No.
People have actually done this.
You don't
Taking
think
a
anybody
goddamn
can track the moon's movement? Like the
yeah,
astrology
people
has been a
can
thing
do
for
it,
thousands
and
of
people
years.
have done. People have done the thing you said was done, and what you just said happened doesn't happen. You made that shit up.
Galileo did that shit.
That's not how eclipses are predicted. They don't use a globe. They don't use a heliocentric
I
model.
didn't say they
You're
predicted
making
it. I
shit
said
up
you can
because you're
see the
dumb.
moon.
You're
I
making
said you
shit
can
up
see
because
the
you're
moon.
dumb, dude.
You can
What's
see
crazy?
the moon
He's gonna
travel.
He's gonna even before you allow you to post what you were gonna.
He's not letting me
post
speak.
up.
Look, because you don't know your own model. I'm not going to sit
I don't
here.
have a model. I'm not talking about models, man.
Galileo did not
observable with
predict
the human
eclipses.
eye.
Look, Galileo did not predict eclipses.
I'm not talking about predicting eclipses. I'm talking about being able to predict where the moon's gonna freaking rise and set in the sky. If you look at it every night and you record its location along the horizon
You
of
mean
the
on
sky
the horizon?
with the naked eye, no tools, no nothing. It's just every day you watch the moon rise. It rises here. Now it rises here. Now it rises
Yeah, so
here.
what, dude? You can
now
do
it
that with a
rises here.
stick.
Yeah.
They still don't even get the reason why you even said it.
The reason is because you can track the moon's movements, and you know that it's like the moon that's going to go in front of the sun.
That's not even the point he was making, dude.
No, look.
I just
the
don't know
moon
why
is
everyone's got to yell, man. I just came here to be like, chill. I want to. You heard me
Because
earlier.
you're not actually listening. Like coming in here and talking.
Okay, let me ask
is
you.
Just rage
This
bait.
is why I'm yelling. I'm going to ask you. Tell me, Steelman, one thing I've said to you. Repeat back to me one thing I've said.
One thing you've said is that you didn't see the moon.
Okay, there we go.
In a solar eclipse.
And then when I said, "Did you see the moon?" and you said, "Yup."
And you guys were also talking about an 11th.
Did you see the moon or not?
Manifold, which is used in string theory and M theory.
Yes, ChatGPT tell you that.
Yeah, I actually had to look it up because I don't know that level of but like I still don't see how having 11 points to describe a location.
You don't understand the argument. Okay, you don't
agree with what Dylan just said in the side chat. We have to be able to agree on observations here.
Yeah, and that means accurately describing them in the first instance.
Yeah, like the star trails.
Right.
Yeah, which you can't seem
like
to accurately describe.
Dimensional manifold.
That's so ironic that you said like the star trails when you still can't accurately describe them. This guy can't accurately describe eclipses. He still thinks he sees the moon.
Like send another picture.
That's just rage baiting, man. That's like seriously gaslighting on a whole.
Yeah,
other
you
level.
can see. Like, look, where's the rotation?
But that's
Let's talk about your picture.
That's a static image, my friend.
Yeah. So, are they rotating in a circle?
No, it's a static image.
That's a time-lapse image.
Okay, you're just going on fucking mute, dude. I'm not playing games with you. Gonna be a pedantic douche. Now, you didn't understand the argument. That you don't. Do you know what affirming the consequent is?
I'll be honest with you. I came in halfway through this argument, so maybe.
Do you know what affirming the consequent is?
No.
Okay. It's a logical fallacy to the form. If P then Q, Q therefore P. If I eat pizza, I'll be full. I am full, therefore I ate pizza. Right? That's illogical because I could be full because I ate French fries or chicken noodle soup. Okay? Now, when you say stars will make circles around the center point if the Earth is a globe, or if Earth is a globe, stars will make circles around the center point. Stars make circles around the center point. Therefore, Earth is a globe. That's affirming the consequent. And AI did the same thing, but with 11 dimensions. If the Earth is flat, Earth is stars in an 11-dimensional manifold. We see if they make it circles around the central point. We see them make circles around the central point. Therefore, the Earth is a flat, and the stars are in a 11-dimensional manifold.
If the central point means that the stars are in an 11-dimensional manifold, then what are the 11 locations that, the 11 numbers that pinpoint
You're missing
the location of any star?
Dude, you're missing the point. The form of the logic is flawed.
Okay, let's forget about the stars. Let's forget about the moon.
You have to make a logically sound argument. You understand that? Are we using logic and reason here? Or are we just fucking winging it?
Yes, if you stop interrupting me, you can hear my logic and reason.
You're trying to defend affirming the consequent.
No, I'm not. I'm talking about something totally different. I said forget about the
I should have used...
Forget about the 11th
Listen, friend.
Yeah, you're talking about the substance of the matter, dude. Instead of dealing with the problem with the soundness of the argument.
I don't even know what your argument is, bro.
Yeah, we know.
No, you could chart the surface of the Earth to any shape, and then have an observer-dependent instance as a dot on any point on that shape, and then have an expression of the celestial sphere as a location, and then permutate them simultaneously. So you essentially have a trillion upon a trillion points, right? And then you'd have a near infinite dimensional manifold. Doesn't matter.
So here's a question that I wanted to bring up. We were talking about not being able to see the moon and the rotation of the stars being because of an 11-dimensional manifold. Okay. What about the fact that the sun rises in the east and sets in the west, man? Every day.
No? How does that tell us the Earth is flat or a globe?
So the sun is spinning around a flat Earth?
How does it tell us the Earth is flat or a globe? What the sun does.
Well, explain how the sun would rise in the east in the same.
How about you answer my question instead?
In the west.
Instead of me explaining. How about you answer my question? Why are we wasting our time on this if this question can't answer the question? Is the Earth flat or not?
Question. It's really, simple, man. The Earth is round because when it sets
now you're gonna start chanting.
West, when it sets in the west, it moves around the back side of the planet and comes back up around the east side, and then you
it's a cool story.
Daylight. You can see it.
Yeah, but the Earth measures flat, so it's not a globe.
I never
see
said
how easy that is. No, the Earth measures flat. So if I measure the Earth and it's flat, doesn't matter what the sun does. The Earth's not a globe. Lasers.
Lasers.
Yeah, lasers.
Okay.
See, there's a reason you guys want to talk about the sun, moon, stars, and everything but the Earth. Because if we talk about the Earth measures flat. In that everything about the sky is that there's a celestial sphere model that you try to say the Earth is the sphere, not the sky. The Earth is the sphere.
Have you written
when all you do is what?
Have you written any papers on your findings?
What do you mean?
I mean, you have such great insight. You must be valuable to the scientific community. You must have written some papers.
What does that matter?
Well, that's the scientific process.
What kind of argument is this? Most peer-reviewed research
papers,
is wrong.
Then they can be peer-reviewed by your peers. And
most peer-reviewed research is wrong. Why would I want to do that?
I mean, respect.
Well, hold on, Indio. Hold on. Yeah, you just skipped the part of experimental validation of what you're going to write up first, right?
Not at all. No, I'm interested in that. Experiments are
McFuggin
great.
just said you backed down when he mentioned
I just don't
refraction in
understand
regard
why
to
you're
Epicor.
being so aggressive to me. I feel like you're fighting me, man, and I'm not trying to fight
What?
you. I'm
Who
trying to
backed down?
Because you're being dishonest.
I'm not being dishonest. I'm trying to explain things to the best of my capability.
Yeah, by not listening.
I'm listening. I
Yeah,
heard
okay.
everything you've said, but you've been yelling at me, which kind of makes me retain maybe a little less of it.
Now, if I directly measure the Earth being flat, does it matter what the sun, stars, and can anything about the sun, moon, stars falsify that?
The Earth being flat? Well, it depends on your model.
No. What is it with models? You don't even have a cold model.
If the Earth is flat, what is everything else in our solar system doing?
What solar system? You don't even have a solar system.
Hey, real quick, bro. I just want to throw this idea out there. Maybe retarded, but I just got this intuition based on the post that McGuffin made earlier, and it looks like a vortexual tornado, not like star circles. So what if the celestial sphere is a pseudosphere, constant negative curvature? Oh, get wrecked. All right, go back to your conversation.
Yeah.
Dude, I have spent a lot of nights out in the wilderness, man, just looking at the stars with no light pollution, no time-lapse cameras, no bullshit. And I can see the movement of our planet throughout the
You're not on a planet, dude.
He can see the movement of the planet by looking at something that's not the planet,
bro.
Were you laying face
you
first?
can. It's the backdrop that we're moving against. What's out there does exist, you know? I mean, when you
You're
look
in
up
totally
what's out there does
fantasy
exist.
land, man.
Am I? So you're telling me stars don't exist?
No, we see them. They exist, yeah.
So then when you watch the stars move across the sky at night, I mean, you ever just sit on your back?
That's right. I watch the stars move across the sky. Correct.
So
why is that?
Which way are they moving?
They're moving. That's right. The stars are moving.
Is it
we aren't moving
every day?
We look, brother. The stars are moving.
Okay, so the whole universe revolves around us. We're stationary in space, and everything else moves around us.
It's not revolving around us per se, not in the way you think.
So I'm trying to understand here. So we're not moving at all.
We see the sun move. We see the moon move. We see the stars move. They're moving. We're not moving. We are stationary. The Earth isn't orbiting the sun. Okay, planets are not orbiting the sun.
The universe isn't expanding.
The universe is not expanding.
Oh God!
What makes you think the universe is expanding?
That breaks my brain to think about.
It breaks your brain that your fucking fantasy bullshit is not real.
I can yell at you. And
hold on the fuck, bro. Hold on,
but
brother.
I'm not
I
being
just want to ask you, dude. I want to ask you a sincere question. I don't want any bullshit.
Yeah.
When have you ever observed the universe expanding?
Oh, you can see it through the James Webb Telescope. You can see it through. No, seriously. Seriously.
Hold on.
The further out you look, the further back in time you're looking.
Oh my Jesus!
Whoa, whoa, dude!
Cool story, dude.
No, it's light travels
hold
at
on,
a certain speed, right? You already know this. I know you guys are smart enough to know this.
You're right. I apologize for yelling at you. You're fucked up.
I know you're smart enough to know this shit.
Look, we know the story. They're just fucking stories, dude. What can't you understand about that? That you've been told all these stories. They're cosmological stories, right? They're stories just like they told 1,000 years ago about what the stars are and about what the heavens are, what that all means.
So we just take
There's no difference between what they said then and they say now.
So we just take how many steps back to how many thousands of years ago before we had any idea?
Just one step back to reality.
Back. There's been no steps forward.
You mean hundreds of years of technology are just discredited?
What technology?
The last 200 years, we've had massive technological advancements.
That have to do with the stars?
Including the ability to see light that comes from 100,000 freaking million light years, like millions of light years away, dude. Like,
why?
No, you said it wrong. You said it wrong. You were supposed to say a million years from.
you realize what I'm saying? It's not.
We realize you're just repeating a story you heard. You have no idea what the evidence for those claims are.
The science is called the story is called science. And
the story is called science.
Those claims have been made through lots of research and
dude, you have no idea what the basis of those claims are.
So why are they lying to us?
You have no clue what they are.
Why are they lying to us then? What's the point?
Who's lying? They're just wrong.
And how do you know you're not?
Look, because I use sound logic and they don't.
It all seems pretty logical to me.
What's the logic? They said a story, you believe it?
No, I've seen models that work.
Oh, models that work. Give us a model that works. Model of what?
Hey, you ever watched The Dark Crystal?
The Muppets? The Jim Henson shit?
The Dark Crystal.
Oh, that was a good movie.
That was.
What does that got to do with this?
The Great Conjunction. What else?
You remember Olga?
Yeah,
no, not the Great, not the Great Conjunction. None of that astrological bullshit.
Oh, dude,
remember Olga? Olga had the like.
Oh my god! No, I gotta mute you, bro. Okay, because I'm the nerd and you're not. So, showing the Great Conjunction. That's the whole reason for stupid. All right, go ahead.
Dude, it's so cooked, man. Dude, you're cooked, bro. You've taken. Look, you've been hearing all these stories. I've heard them all too. But different than you, I looked into them and said, "Hey, dude, is there actually any evidence for this shit?" And it's bullshit, dude. All of it. The entire cosmic distance ladder, bullshit. Redshift, bullshit. CMB, bullshit.
Let me ask you this then: if it's all bullshit, then how are we able to accurately calculate the trajectory of freaking asteroids?
Okay, I don't know where you got that information.
They don't
use a dynamic model to even do that.
They use mathematics and redshift.
Okay, I'm going to tell you how that's done. They use something called it. Why are you fucking interrupting me?
Of impact.
Why are you interrupting me?
They have no idea.
Bro, put the meth pipe down.
Why are you interrupting me?
Because you guys are hand waving dishonest losers. That's why.
What did I hand wave? You don't say very specifically.
All of it just now.
All of it. No, specifically what?
How many teeth do you have?
Let's go back through the recording. You just made a list.
Okay, you're banned.
Oh, you're banned.
You can be next.
Do it.
Fucking
Shut up,
dumbass.
fish.
Redshift is fake. I looked into it. Yeah, you looked on Facebook. You found Redshift was fake. Good job, dude.
No, I go by what Halton Arp said, who is Edwin Hubble's PhD student.
Right, so
you know who that is, right? You know Halton Arp.
So opinion is more important.
You know who? No, it's not an opinion. It's not an opinion. He wrote the Atlas and Compendium of Unusual Quasars and Galaxies back in the 1970s.
He put his opinion into a compendium. Nice job.
It's not an opinion. He worked
you care about
at
testimony
USC.
more than
He
you
worked
care
at
about
USC
science.
Berkeley. He worked at
It
USC
doesn't
Berkeley
matter. It's an
at the
argument from
Wilson
authority. It's a
Observatory.
logical fallacy. Good job, dude.
No, yeah, okay. So you actually have nothing to refute what I
Argument from
said.
authority. Nice.
It
You're
is
gonna
an
reduce your
argument from
position down
authority.
to
I'm
absurdity
giving you
on
the
your
evidence.
own, bro. On your own.
You said I'm
did it
giving
to
you the
yourself.
evidence. I'm giving you the evidence. You're just a troll. Beat it. Beat it,
Why
McCarthy.
you're so angry, man?
This dude's a troll. Did you call him here?
No, I don't know who that is.
That's
I'm here
floundering,
alone,
by the
dude.
way, Indio.
I'm
if you
here
don't know.
alone.
Yeah, so okay, where was I? Okay. So the way you think planets and all that shit are predicted doesn't use gravity, doesn't use math, doesn't use any of those things. See, this is something that you guys, when I say you guys, I mean Globe Earth, there's a lot of you people that are like into science but don't know anything about science, don't know anything about physics, just like watch the Discovery Channel, maybe watch fucking Neil deGrasse Tyson a couple times. know everything is a very superficial level. You don't know how any of it works. You have no clue. Okay, so you probably think motions of planets, where they are, where they appear to be, all these things. They have some model where they're modeling the planets with gravity and orbits and all this shit. That's not how it's done. They use something called Keplerian orbital elements, which is a kinematic model, which is just based upon time and period. There's no forces. There's no gravity. None of that shit. None of that shit in the model for predicting this shit.
You believe that we've gone to space?
No. Why would I believe that?
Do you believe that we've tried to go to space?
I believe people probably tried a lot of things. People certainly tried to go as high as humanly possible. Why would I believe in that outer space story? Why should I believe in any of that?
Well, I mean, does your cell phone work?
What's that got to do with anything?
Satellites?
My cell phone doesn't use satellites. I connect to cell towers. This is just embarrassing. Dude,
where do
you should not talk about this topic.
How do you think cell towers relay the data?
They're connected by cables that go under the fucking ground to data centers. They don't use satellites, dude.
Satellite phones?
The idea, like, I haven't actually talked to somebody that thought
Starlink.
I haven't talked to somebody that thought satellites connect to cell phones in almost a decade. I can't fucking believe you're this dumb.
No, there are satellite
You
phones.
should not be in here. You're too dumb to be having this conversation.
No, I'm not. You're an asshole, though.
Yeah, no, I just have to call it the way it is. If you think fucking cell phones connect to satellites, you're dumb as rocks.
Satellite phones do? Do you know what Starlink is?
You mean an Iridium phone?
No, Starlink.
Yeah, Iridium phones are satellite phones. Starlink is not a satellite phone.
No, I didn't say
Starlink is just the satellite internet.
My
but
point
you know
is
what?
that satellites exist.
Satellites don't exist, not in space.
Yeah, they do.
How do you know that?
Work?
How do you know that?
How does Starlink
It works
work?
by radio waves, the same way radio waves have always worked.
What?
The same way radio waves have always worked. There's no ball in the way of the radio waves. Right? So the longest transmission, okay,
shortwave radio,
is how long? Is how far? The Earth was a ball. How far can you send a radio signal? Well, they were doing it in 1918, 10,000 miles. How were they doing that?
10,000 miles is like a fucking freckle on the Earth.
A freckle. So they were in the United Kingdom talking to Australia.
Yeah, it's a freckle.
Now you're just being dishonest.
Well, I feel like you are when you say satellites don't exist.
Why would I believe they exist?
Because we use them for communications.
Who is we?
Earth.
Who? Tell me the last time you used a satellite to communicate.
I'll do it right now, actually. Hold on. Give me a second.
Oh, my Jesus Christ.
Now watch.
You think your GPS connects to satellites too?
That's not what I'm doing.
Some brain dead's giving me a headache. McFucking is still posting that bullshit.
Yeah, he is. I asked him if he was presenting it as the stars moving, the Earth moving, or just enthusiasm along explosion photography, and he said neither. Just an observation that we can all agree on. So yeah, that's my
apparently not. Apparently we can't agree on it. He thinks it's something else. He thinks arcs are rotations. He thinks frickin' arcs are circles. He thinks spirals are circles.
Here you go. This is a satellite tracker. Communicating with satellites in live, real time.
Yeah, and how do you know that, buddy?
Look at it.
Oh, look at it. It says, I'm talking to satellites. Hey, dude, I'm going to go to the website. It's a live stream of fucking Nessie, the Loch Ness Monster.
Am I allowed to get angry and loud like you?
Your standard of evidence is shit, though. You'll just, look, bro, you just believe anything you want to believe. Literally.
So I
believe, I like this worldview.
I'm starting to believe that flat Earth is just a argument fucking meta that people use to argue and yell and get angry. Because I'm not doing
we haven't
any
even
of that.
talked
You're
about
still
flat
yelling
Earth.
at me.
We haven't even talked about flat Earth. We
I
talked
know
about
exactly
everything.
my point. So now we're just looking at basic personality traits.
Oh no, you're going like now you're just going meta. Okay, I've asked you how many times did I ask you why should I believe in satellites, and how many times did you answer?
I just gave you a website that tracks.
I asked. Okay, so now 5 times I've asked you.
I just gave you a website.
Why should I believe that fucking website has satellite data on it?
Well, let's put it this way. Why the fuck would Elon Musk be launching so many fucking rockets?
Why are you asking me a question?
Why?
I asked you a question.
Why should you believe in satellites? Because they're fucking used. It's a part of fucking the current technology that we have in the modern day. We have this technology. We've had it since Russia launched Sputnik.
Okay. How do you know that? Now imagine I'm an Indian, right? I'm an Indian I've been living in the Amazon rain. But listen. I'm an Indian that's been in the Amazon rainforest for the last 100 years, and I come out and I find you, and you're like, dude, there's shit up there. We have satellites, and you go, well, we have Sputnik and all this shit, and he goes, the fuck's all that shit? How's that proof of satellites? All you're doing is telling me a story you heard. That's all you're doing.
And all you're doing
is stacking claims. So there's a claim.
You too.
You're repeating. No, I'm not. I haven't stacked any claims.
Yeah, you have.
What claim have I made?
You've claimed that satellites don't exist. You've claimed that we've never been
No,
to
I asked
space.
you the question. Why should I believe them?
You've claimed that the Earth doesn't move. You've claimed that the stars are moving.
Why did I say the Earth doesn't move?
You said that we're not even a planet.
Why did I say the Earth doesn't move? Did you ask me that?
No, I didn't ask you that.
There's a very good reason. Because all attempts to measure the motion of the Earth have failed.
Look up at the stars in the sky.
Look up at the stars. Well, the Earth could be geostationary, and the stars could be moving.
Right.
So there's the So this is the part where you said you believe in science, and I'm going to show you don't actually believe in science. You believe in stories. So there's the Michelson-Morley experiment. There's the Michelson-Morley experiment. There's the Rebka-Pound experiment. There's the Aries failure experiment. Okay, I can sit here and list experiment after experiment after experiment where the motion of the Earth was they tried to detect it experimentally and failed for 100 years. And hundreds of scientists saying that the motion of the Earth can't be proven and has never been measured. But listen, you don't care about that because you're not interested in any science. You're interested in fucking story time. You know the science is the experiments, right? It's not the stories. It's the experiments and their experimental results.
What experiment have you? What experiments?
Michelson Morley.
No, you. What experiment have you done?
What the fuck does that matter?
Because everything else is just a story.
Look, the experiment is not the story because you can replicate these.
Well, what experiments have you replicated?
I've replicated measuring the Earth to be flat.
How did you do that?
Well, I went to the beach
with
and
a laser.
He said it himself. Everything else is a story. He said it himself.
He doesn't really care about any experiment or any empirical evidence.
No, I want to know what experiment you've done because you're so.
Why? I filmed a boat for 30 miles.
Yelling at me, man. Like I listen to these things a lot. Actually, my friend is really into this. I'm usually pretty reasonable about it.
No, you're not. You're the fucking most unreasonable person here. You're a fucking phony.
Still.
Yeah, because you're a phony, and I see right through you. Yeah, you are. You're a phony phony.
What am I faking?
That you actually you're actually just calm. You have no opinion. You're just here to listen.
I didn't say I have no opinion. I definitely have an opinion, but I'm being calm and I'm not yelling at you.
Who gives a shit? You're dishonest as fuck.
You're cursing and
I've asked you the same question 5 times.
Kid, bro.
I've asked you the same question 5 times. You still haven't answered.
Which one?
Which one? I don't know. Actually, there's a whole bunch of questions.
Yes.
And how many have you answered? None.
How many of you answered of mine?
Everyone. I don't dodge questions. Ever.
You ask questions that are loaded as fuck. Ask me the main question again. The one that you said I didn't answer 5 times. I'll try to answer it. I will do my best. If it's possible.
What I asked you was, why should I believe in satellites? You didn't give me a reason why I should do anything.
I did. I answered that 3 fucking times. I said because
you said because we use them every day. You don't use them though. You're just making that up. So you have a fantasy view of the world and what you're doing and how you're operating in it. That doesn't actually exist. You think you're running around with your satellite cell phone, using a satellite GPS. All this shit, dude, is a fantasy in your head. And what I'm telling you, and what I've been telling you is, the way your explanations of how the world works don't actually match how the world works. I explained to you, hey, dude, said, you don't think the Earth moves. Yeah, there's a good reason for that. All the experiments show that the Earth doesn't move. Now, you'd rather believe the story, but science is empirical. But you said you were for science. Well, then you have to be for the empirical evidence. But you don't seem to be for that. You seem to be for, oh, magic science guy told me this, told me about black holes, told me the fucking universe is expanding, told me this, told me that. You don't care about what the empirical evidence is for an expanding universe.
I just asked Google, is there an experiment that shows that the Earth doesn't move? And it said, sorry, no relevant information found for that search.
I named the experiment.
Show me a fucking experiment that shows the Earth doesn't move.
I'll quote Einstein instead of Google.
Nope, just give me a link. Something I can search, something I can do my own
Michelson Morley.
Information that I'm missing?
Michelson Morley. Well known, dude.
Share me a link.
But Michelson Morley, go on to Wikipedia.
One guy.
It's 2 guys. Michelson Morley.
Oh, Mike.
It's the whole reason they came up with the theory of general relativity is because they couldn't measure the motion of the Earth. What are you going to look at anyway? You won't understand it. Never looked at any scientific shit in your life.
Actually, that's where you're wrong.
Yeah, okay.
Science is my favorite.
Then you have heard of Michelson Morley. It's fucking basic. They teach that in fucking freshman.
Dude.
Yeah, they teach that in freshman physics. They teach Michelson Morley in freshman fucking physics at university.
They were trying to detect the ether.
You are one of these people that like to.
They're trying to measure the motion of the Earth through its static, through the Fresnel's ether theory.
You
don't
like
say
to
bullshit.
to make yourself feel more relevant.
Didn't disprove
you like to belittle other people to make yourself feel more relevant.
Dude, no. You're a bullshit
Yes,
artist.
that's why you're in here. That's why you thrive on this.
Yeah, okay. Listen, brother.
I bet
you
if I
can't
come in tomorrow,
psychoanalyze
you'll be
me, bro.
talking to somebody else like this.
Dude, stop being a
Goddamn right I
snowflake
will.
every
This is how I
5
talk.
minutes. Just relax, dude. Stop being a snowflake, please. Complaining for someone who's so cool, you're complaining a lot. Just calm down.
Being yelled at.
We'll have to unmute Fish or something.
Being yelled at. Well, you don't answer.
Relax.
Maybe you should take the criticism instead of fucking being all butthurt.
Maybe
you don't actually know any
there
science.
Calling people assholes and retards and
you don't know anything.
Hey, it's me, Goku. I hate beaners.
You don't know anything about
that. It's fucking racist as fuck.
Look, the fact remains is you don't know anything about science, scientific method, scientific experiments. That nitwit that just said that was about the ether, that's nonsense. Fucking nonsense.
Wow.
They weren't trying to detect the spinning of the Earth. That you
They were trying to detect the motion of the Earth in its orbit.
No, they were trying to detect the ether.
Don't tell me fucking no, okay?
I mean,
have you read the paper? Have you read the paper?
Yeah, I've read probably more of it than you have.
You read more of it? Okay. When was it? How'd they set up the experiment? Tell me experimental
They
setup.
have actually. I got you.
Shut up, dude.
Man.
Shut up. Tell me experimental setup. Tell me experimental setup. Tell me experimental setup.
The experimental setup.
Shut the fuck up, dude.
You don't want to get on his bed, son.
Tell me experimental setup. Don't fucking look it up, you weasel.
They use beams of light, and they use beams of light pointed perpendicular to the expected motion of the Earth and parallel with it. So that if light was traveling in a medium and the Earth was traveling through this medium, then what they were expecting to see was a change in the speed of light, either added to the motion of the Earth or subtracted from the motion of the Earth. They were trying to detect a change in the speed of light from these two beams in order to show that the medium of light that the Earth would be traveling through,
based upon what?
Has a velocity which
what
would
was
have been
the basis? Why did they think that they would detect a phase shift?
Because they believed that light must have a medium.
But there had to be a base. That doesn't mean just saying they believed it must be a medium doesn't tell me anything.
If they were trying to detect,
but just the existence of a medium in and of itself does not incorporate a phase shift. Okay?
If you were in air, for example, and you make a sound, the sound of the traveling through the air is gonna add and subtract to the velocity of the air.
Okay.
So it's the same principle. They were trying to detect
not the
that
same
change
principle.
in speed.
They weren't trying to use the Doppler effect. They weren't trying to use the Doppler effect. Good try though of making shit up you don't know anything about, Dylan.
You don't understand what they were doing.
Okay. So there was something. There's something called the Fresnel effect. There's something called there's something called the Fresnel effect, the Fusel effect. If you have a medium that's in motion and you shine light through it, there'll be a phase shift and light will be deflected in the direction of the motion of the medium. Okay? So if the Earth is in motion, the light will be going through a medium with a motion, and light will be deflected, causing a phase shift, depending on the axis. You don't know what you're talking about.
You don't know what you're talking about.
I will quote Einstein myself. I'll read the quote. This is the whole reason they come up with the theory of general relativity.
Oh my God.
Quote from quote to address.
You have your
How I
alternate.
created a theory of relativity. I was thinking of this problem in my student years. I came to know the strange result of Michelson's experiment. Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect. If we admit Michelson's null result as a fact, it was the first path which led me to the special theory of relativity. Since then, I've come to believe that the motion of the Earth cannot be detected by any optical experiment. So, signed Albert Einstein, go fuck yourself.
You said it right there at the beginning of the quote. They were
that
trying
it
to
cannot be detected. That it cannot be detected.
What he's specifically
That it
talking about
cannot be detected. We don't need the fucking Einstein whisperer. He said it.
With these optical methods, by trying to detect the motion of an ether, you think Einstein didn't think the Earth was spinning?
Okay, that's irrelevant. He
Well, you
said
can
that the
take
motion of the
call
Earth
out of context
cannot be
if you don't
detected.
understand what he's
Dylan,
talking
you're not the Einstein whisperer. I'm going to
You're-
go by
you're
what
taking his
Einstein.
quote
Shut
out of
the fuck
context.
up, dude. Shut the fuck up. You're not the Einstein whisperer. I'm going to go by what Einstein's words were and what he said, not Dylan's fucking Dunning-Kruger interpretation of them. Irrelevant whether they thought it was there. The argument is the reason the motion of the Earth has never been measured. Period. And now they say it can't be measured because there's no such thing as absolute fucking space in the first place. But all that's destroyed by Newton's bucket. You guys are fucking children, dude. Fucking children. Yeah, look, it doesn't matter if it's an optical method or not. If there's no absolute space, then the motion of the Earth can't be detected. Because it has to be spinning relative to something. Okay? Newton's bucket. Okay? If you have a bucket, you fill it with water, you spin the bucket, surface of the water will become concave. Now let's imagine that there's nothing in the universe except for the bucket of water. And you spin the bucket. What are you spinning it relative to? And why is the fucking bucket, why is the water surface becoming concave? This means there is absolute space. My voice is cracking because I have laryngitis. I've had it for like a week. Good try, though. You can go back and look recordings a week ago. Same thing. Oh yeah, Fish, you're gone now. Good job. You'll never be back.
So the Earth isn't moving relative to the sun?
There's no evidence the Earth is moving at all.
Days, years, months?
There's no evidence that the Earth is moving at all. But don't you get, dude?
Seasons, the precession?
We see the sun move.
The wobble?
What wobble?
You don't know about the wobble? The seasons are created by the wobble.
Oh my god, dude. Those are just stories, dude.
They're not stories that's the reason we have summer, winter, fall, summer.
Oh my god, dude.
Can I confirm something? Yeah.
Please, someone else talk to him. I gotta take a leak, so someone else talk to him.
So you're saying seasons occur because the Earth has a wobble. We know the Earth has a wobble because seasons occur.
Nice play on words. It's
Well,
like,
no, I'm
do
asking
you
you
know
to
what you're
clarify.
talking about, or do you know what you're talking about?
No, it wasn't a play on words. It was a question, yeah?
Obviously, the seasons occur because of the wobble, because of the positioning of the sun.
So how do you know that it wobbles?
Because you can see it. That's the reason that. Oh my
I
God!
don't see
Not
no
only can
wobble.
you, I do.
How do you see a
You
wobble?
got to pay attention. You got to pay attention to what's going on around you.
How do you see the wobble?
I'm going to say stars, and you're going to say that's bullshit. The stars are moving. Okay? Like, look, anything that has ever been said, any scientific argument for what we know about physics and the solar system, the universe, flat Earth.
Tell us about these stars wobbling. I need some
There is no scientific. There is no scientific evidence for the. There is no scientific evidence for the. There's no scientific evidence for what you're claiming there is.
Neither
The
for what
scientific
you're
evidence
claiming.
to do with the universe and the planets and the stars. What
And
scientific
certainly
evidence?
not for
I'm
what
glad.
Indio is.
I'm epically glad that you pointed out there's no scientific evidence for what we're claiming. If you listen carefully, we ensure people that there's no scientific evidence. It's a question of geometry, my friend, not science. You're in a category error, and you've made a very big mistake.
Mm-hmm.
Most excellent. You've understood. Good.
It's a lot bigger than geometry, man.
So,
Yeah,
so this is not a question of science. You're claiming science is a question of geometry. I know.
Well,
you just
no,
have to
let me
measure
just
it.
get this. Let me get this much then. If the Earth
So
is
what
flat,
science deals with shapes?
Let me ask a question. If the Earth is flat,
Yeah. What field of science deals with shapes?
I remember this.
Geometry.
So not science then. Excellent. You've learned something today. Good boy.
It's mathematics. Yes, I know. But let me ask you a question. How does your geometry of the shape of a planet
you just said what field of
explain?
science deals with shapes, and then you said geometry, and then you said not science, but you just called it science.
I
You just
said it's
that.
mathematics, actually.
No. I'm not talking to you. I'm saying the other guy who just answered that question.
So it's not science.
No, you just said what field of science, and then you said geometry. You said so not science.
Listen carefully. He was claiming a field of science. It is not. It's a tool used within science.
So it's part of science.
So no, it's a tool used within science, and you don't even need to use it all the time.
But why are you offended?
It's just a tool.
Wait.
I'm not offended.
Wait,
You're claiming. Well, why is this idiot talking? Shut up. Silence. Let the other one talk. You were claiming that the shape of the ground is a scientific inquiry. It is not. It is just a question of geometry, a subcategory of mathematics. All we have to do